the problem that we have with it is, do you really think it's the idea that Elon Musk wouldn't want to spend a few $1,000s on the parts to throw it into space that we have a problem with?
No, I'm saying like what makes it so unbelievable that the question was worth asking a second ago? Like, yeah, you guys really believe this car's in space? Like, why? Yeah, why is it unbelievable?
Because it looks fucking retarded.
What looks retarded about it?
Everything.
No, that's not a good answer. Come on, be specific.
Be specific. Everything.
Okay.
Like, have you ever played a
so helmets don't exist.
Okay, so nice straw man. I didn't even hear what you said, but I know it's a straw man by how you asked.
Okay, I said helmets don't exist. Cars don't exist. Helmets don't exist and cars don't exist.
What a weird straw man.
Well, I'm trying to find out. You're just coming up with these vagaries.
Before you
saying things like everything. Well, you know what's wrong with flat Earth? Everything. Everything's wrong with flat Earth. There you go.
Is there anyone in here that honestly thinks I don't believe in cars while driving one?
I don't know. You might not believe in them. You're a flat earther, aren't you?
You don't know if I believe in cars while I'm driving one.
I don't know. What you can avoid believing in due to your whims. You're saying that this is just everything is wrong with it. No, you can come in here and say, okay, the colors are wrong here. Why are the colors wrong?
No one can do anything with you. If you're going to make the argument that you think I don't believe in cars while I'm driving one, we can't have a serious discussion.
You don't believe in jet fuel, or are you one of those? I'm not sure.
And well,
why are you surrounding me?
Yeah, before
over and over.
Did I not supposed to ask you?
Before this, because this is getting kind of chaotic, I just want to say one thing very quickly. I do not think that the image, the GIF that was posted is real. Actually, I'm almost certain that one is not in space. But I could be wrong. I mean, I've been wrong a couple times today about
every time you talk.
Yeah, that's right, Jeremy. I've been wrong every time I talk.
Every time he counts saw blades, he's definitely wrong.
Yeah, that's right. I was wrong. I was wrong about who had the most saws, and I'm very.
Is there anyone in here that doesn't know what a sawzall is?
I know at least one person. Kosho.
I know what it is.
Now you know what it is.
Well,
all right, Jeremy. Maybe you can be more. Maybe you can be more expressive. What do you think doesn't look real about this car? I mean, don't just say everything.
What do you think I don't think that GIF. I think the GIF they posted is specifically not real.
We found glitches. There's glitches.
No.
I
mean,
thing.
the one
also,
you guys posted, it just happens to be not. I mean, this is not. I don't think this is taken in space.
Kosha, you're saying that one that New Perspective posted is not the official footage of this ridiculous car in space?
Yeah,
I'm pretty sure that was the official footage.
That's it, buddy.
I don't think it is, man. I mean, is this like a super timeline?
Why wouldn't you crash?
That's how I recall it. That's all I can tell you. I don't know.
This would have to be like a fucking 6-hour time lapse.
No, it's one of the funny things about it is that when you speed it up, the Earth bows and changes shape as it's going in the background.
Yeah, why is the car spinning around? This is not a legit picture. It's not legit.
No, as I recall,
so what do you think somebody made that in their garage and then tried to pass it?
No, they did. This is edited. This is edited from when it was in the what do you call it?
No, dude, that's it, man.
No, dude,
that's how bad it is. It's that fake
footage
that even you can't think it's real at this moment.
No, I'm asking why is it spinning around then?
Because it was spinning. The spaceship was spinning.
Wait, so is the claim that they made fake footage of it too, but then actually did it, and you can't tell the difference? No. Is that the claim?
No, that's not the case.
Wait, Mike, you said the spacecraft was spinning?
Sounds like it.
Yes.
Why was it spinning?
They put it on a rotation. I don't know why they chose to do that.
Mike might be right. If it was rotating, then I definitely think that this could be real. That was the only reason I thought it wasn't legit, was because it's spinning around. So it's like it's got to be a 6-hour time lapse or something. But
that's all it takes.
That's how I remember the original.
If the craft was known to have been spinning around, then it makes sense. Yeah, of course.
Look at the studio lighting on the car.
Well, I don't think the studio lighting. If it's
ever played a game called Gran Turismo?
Oh yeah, I played that. Yeah.
You know, Gran Turismo. You know how the cars look when they're going past the street lights. And,
oh yeah, the lighting. Yeah, I remember all
that. This car appears like a Gran Turismo car.
Yeah, kind of does.
See the local studio lighting on the car? That's not the sun. That's supposed to be the sun. The sun would be blasting the entire car. It wouldn't be a local lighting effect that sweeps across the car.
Yeah, we see the same thing on the Apollo 11 mission where they were on the surface of the moon, and where they were standing was all lit up nice, and then it faded out to black as you looked farther in the distance. That wouldn't happen if they were where they said they were on the moon, and it was actually the sun lighting up what they were standing on.
I'll just finish my point quickly.
Yeah, go ahead, Crypto.
The point I was making, and the Kosho agreed with me, it looks to me very much like a high-definition game car, and rather than a real car. And that's why I think it looks fake as shit. Because I've played Gran Turismo for hours and hours and hours, and it looks just like a Gran Turismo car.
What are they trying to do with high-definition video in a video game? They're trying to match reality, right?
So
you'd have to tell me where they deviates from where Gran Turismo deviates from reality. No, it doesn't make reality.
So then what the fuck has this got to do with anything?
I am trying to, you're saying it looks like it, but now you got to tell me where it deviates from Gran Turismo, or where Gran Turismo deviates from real life.
No, I'm not going to tell you anything based on your framing of the debate. I've already said what I have to say.
I'm sick of talking to you, so have a good day.
Well, hold on. I think Mark's making... Oh, go ahead, man.
Mike's already tried to strawman me 3 times. He's trying to say that I don't believe in jet fuel. I've never mentioned jet fuel until he mentioned it. He's trying to say that
if you actually listened, I asked you a question about that. I said, you don't believe in jet fuel. And I said, then I said at that point, do you believe in jet fuel? I actually asked for clarification, but you were too busy talking over my question to get clarification. So you can go and stuff it up your ass.
Well, no, you can just fuck off. You have tried to strawman me very dishonestly 3 times.
He did.
I haven't done any of that to you. I've done none of that to you. Why do you do this?
I think he left.
He needed to leave because he was obviously claiming something was real that looks fake as fuck.
It doesn't. What really irritates me though is that he's trying to categorize me in a certain way so that he can then defeat like some pathetic argument I never made. Why bother?
That was obvious.
No, you don't even believe in jet fuel.
That's why you should never take the tag of being a flat earther, because you get caught up in all that bullshit.
Yeah, but that's not the problem. I disagree.
That is a problem.
Yeah, I know, but I mean, I don't know why. Anyways,
you do know? Okay, good.
I don't know why we're talking about that, but I disagreed with what Moyak said though to you before about I don't know. I'd say you don't believe in cars, but his question he just asked you, I actually was thinking kind of something similar was. Because you did say it looked like Gran Turismo. I was like, yeah, it kind of does. And then I was thinking to myself, like, but why does that mean it's fake? Like, why isn't Gran Turismo trying to make it appear like it's real life? Like it's like a real...
Trying to.
It's trying to, but it's never going to be fully able to do that, in my opinion. So if you've played hundreds of hours of Gran Turismo like I have, versus driving cars for hundreds of hours like I have, you can tell the difference, right? So that's the point I'm making. And I don't really understand why that requires so many stupid strawmen. That's what irritates me. Why can't we just have an honest discussion about this shit?
That's what we're just.
You don't even believe in cars, Crypto. Come on.
That's what I'm doing right now. Is I'm trying to discuss it because, like I said, in Gran Turismo, I make games and I put lights and simulations and stuff, and it's going to look very different if you just have a light source and you have the car or whatever, and you don't have the atmosphere like we have. It's going to look different. In those cases, it's very possible when they make Gran Turismo, they don't put in the things that kind of make the atmosphere, change the glare, make it look more realistic. But you're also not going to get that in space either. So, like I said, there's eerie observations that the moon picture we just saw and Tesla in space are showing. But I don't think that means it looks fake because it's eerie. I think that's kind of it's what you expect.
So just real quick, Kosho, that when that glitch where they cut to the studio, was that edited in by a flat earther, or what's the claim on that? Like where they cut to the studio, was that like added in to make it seem fake?
It's actually much simpler than that. Unfortunately, I don't want to be offensive, but that is only an issue if you have the lack of understanding of what you're even viewing, because it looks to me like
I can only be offended if I understand what you're saying. What do you mean?
Well, you're looking at. You understand where it came from, right? Like it was attached to a rocket, then what do you call those? Those covers came off. Then their covers aren't there anymore.
You know what I'm talking about? Like in the middle of the car supposedly flying in front of the Earth, and they cut to the studio shot of the car, and then it's like a little snippet, and it cuts to the car in the studio, and then goes back to the Earth shot. You seen that?
Yeah, I've seen that, but I don't think that's what it was. I don't think that's actually what's happening. What's happening
so you're seeing
you're seeing it in the shell, and then you're seeing the shell come off, and you're seeing the Earth behind it. If somebody has it to where you're seeing the Earth behind it first, and then you're seeing it again, it's just because it was cut.
Okay, that's what I'm asking. That's the claim. Okay, I didn't know if that was.
No, I mean, it could have been cut. It could have been cut by them in that way. It could have been cut by whoever made the video in that way. But either way, that's not the studio. That's the fairings.
They cut it with a saw blade, Kosho? Sorry, I think throw that in there.
I think a chainsaw.
So there is so then they do have a studio that they put the car in that kind of looks like it could be faked with that studio. But what's the reason for the studio then?
I don't know what you're talking about at this point.
Oh, okay. So there's like a studio.
The fairings are a part of the rocket. They're there to protect.
No. I don't think you're understanding me. There's a studio where they have the car tilted just like it is in space. And I don't know if that's just some kind of like made up thing that they actually have a studio where they could do the 3D shot of it and fake it all. But I think that's a real studio where it looks like they could have faked it. And then there was like a little edit that looks like that was like part of the live thing where it's just like a snippet of the car. But what would be the reason for having it like angled in the studio if that studio exists?
Do you think that was a studio, or do you think that was maybe a staging area?
Well, staging area, whatever you want to call it.
Yeah. Because if it's a staging area, then it starts to make sense. They would have the craft ready to put on the ship. And when it's put on the ship, it's going to be angled the same way it is when it gets off the ship. When it's on the ship.
Why would they need it to be angled like that, like as if it were?
That's how it's going on. That's how it's going on the craft. Like it's.
What about the green screen?
It gets put on the nose of the front of the rocket. That's how it's angled.
I don't think you don't understand. There's like a studio where it looks like there's like lights and like a whole thing, like the backdrop and everything. It looks like what you would need if you were going to fake the footage.
No, those lights that you're talking about, those were the lights from the blast when the fairings came off.
No, you don't even know what I'm talking about. There's like a picture of the car in a studio that looks like it has all of the fixings to fake the whole thing.
And it's in the staging area, you mean?
Well, what's the staging? What's the difference between the staging area and a studio?
In a studio, one is there are two different purposes. One is
what's the staging area for?
To where the car will wait before they put it on the front of the rocket, and one is where you film movies.
Oh, so it's a weighing station, is what you're saying?
No,
I think the point is, Kosho, is that there's no way a car can be in space and then in a studio or a station and then back in space again and it be legit.
I don't think that occurred. That's what I'm saying. I think that the blast that you saw was when the fairings first came off. I think any footage that shows otherwise was, for any reason, maybe maliciously, maybe for whatever reason, cutting it for some reason, it's going back in time.
Yeah, but my point is that
originally, it didn't happen like that.
Even if it didn't happen like that originally, my point was why is it they need a studio that looks like the perfect place to fake it, not just like a weighing station to show how it might fit on a rocket.
Look like a studio, dude. I'll take a screenshot. It doesn't look anything like a studio.
Okay, maybe we're talking about different things. I don't know.
What about that green screen meme? Is that something someone put together, or is that an actual picture?
That's just a thumbnail.
Oh, I see.
And NASA actually don't use green screens; they use blue screens. And I'm trying to think what the company's called.
The chroma key screen with the grid.
Yeah, it's like a blue screen with like white lines across it.
Yeah, it's called chroma key or something.
That's not how chroma key works. You don't have a pattern up behind you in order to chroma key out a screen.
Well, I don't know anything about chroma key. I'd never said chroma key. All I'm telling
Clearly.
you that they tell you that this is what they use.
I mean, we could see him using the blue screen with the grid, whatever
Yes.
that's
What is
called.
the grid? What is the purpose of the grid?
Well, they say it's to provide better 3D context. But I don't know. I'm not an expert in that.
Not even 3D context. And to be
All right,
very
well,
sure, what they actually did was they published this video publicly to show people what the grid was for.
Because they got caught when they pushed George Bush through in a wheelchair. They got caught using it. That's why they probably
didn't get
published it.
caught. They live streamed it. To say that that's a blue screen, that you chroma key something onto, is completely ignorant of the process of chroma keying.
Are
you sure it was live streamed, or did they just put the live stream logo on the bottom of the screen and you just believe it's live streamed?
Hi, Joby. Thanks for nothing.
Talk to him, Joby.
Yeah, just because it says it's live stream doesn't mean it is live stream. You Google.
I've seen all those shows, man. They're just videos for them to teach kids different shit. Like they teach them different physics. They show them spinning balls and spinning frisbees and all shit like that. So it makes sense that George in the background.
And as George Bush is being taken around, their mission control or whatever, you can see this exact same person with this exact same background behind him doing this exact same thing that he's doing in this video. It's not hidden, it's not secretive, and it's not somebody got caught.
Sure, buddy.
They got caught.
Yeah, these are in all the videos. Like I'm saying, if you go onto their website, because they have like a series where they show all these different physics, demonstrations, and this is not like edited out or anything. This is in the shots. I just wanted to post a picture from this is a screenshot. So the thumbnail that's in that video, the green screen, I don't think that exists anywhere. I've never seen that actually with the thing. But yeah, in this place, you see how it doesn't look like a studio because it's not. It looks like a staging area because it is, right? That just means that it's waiting. That, it's ready to be put onto the ship. Yeah, I mean, actually, it looks like a weight room.
I haven't actually seen this like snippet that they're talking about. I've just seen like the actual footage of the car supposedly in space. But I was just kind of trying to clarify what the argument was. Does anyone have an original live stream, quote unquote, or are we just arguing over nothing?
In that video, the raw video, what is that? What happens there? At like 25 seconds. What is that?
Talking about from the you talking about like what New Perspective just posted?
Yeah.
No, New Perspective. That's what I'm saying. That shot that you're looking at right there, that is inside the fairing. Those are the fairings surrounding it.
The fairing? What?
The sides of the spacecraft that's protecting it from the atmosphere before it leaves the atmosphere. Once it leaves the atmosphere, they can release that so that the car is not going to be. It'll be aerodynamic and shit.
So do they have shots of it like being loaded in, like a continuous shot of it being put where it's supposed to be, and then the thing launching up? I mean, if I was going to do something of this nature, I would make sure there's no reason to doubt it. I would make sure every single thing is like totally continuous. And yes, we did this. Don't doubt it because it's fucking real.
He's not even at all worried about if people doubt that he's actually putting things there.
No, I think
if it doesn't work for fake, how are you going to know it's real?
Right. The entire purpose of this is not to appease conspiracy theorists. It is just to put something in space.
No. I mean, but there could be lots of regular people that don't even care about flat Earth or any of that. That just look at that and go, right.
Yeah, but why don't they at least make it look believable?
I don't think he cares if people think if they believe it or not.
Well, no, you could tell when he said it looks so fake it must be real. It's total gaslighting.
Well, I don't remember what the question was.
What was the objective? Hey guys, we're getting lost in the weeds, but what was the actual objective for this?
It was a testing. It was testing the Falcon 9 or the Falcon Heavy, whichever one.
Right. They had
It's
other
not-
ways to test it. They could have tested it with any other kind of cargo, but they picked that cargo specifically for publicity.
Yeah, don't they
I
usually? They
forgot
usually
the
put up
official
bricks,
excuse
right?
for the tires not blowing up and the paint not peeling and all that. What's the special excuse for that? I mean, reason?
That's not expected to happen. So
Right. The tires on Earth are, when you blow up something to 30 psi and there's 14.7 psi outside, what's actually going on is gauge pressure of 30 psi out in space would be 45 psi, and 45 psi on a tire is fine if it's not going to be on the road.
yeah, and they probably didn't
No
have
problems with
that
temperature at all. No problems with temperature.
Not really, no. Steel belted tires.
I read an article about the worry about the material. So most of the material,
The tires
is
weren't
actually
made out of
fine.
rubber. Sorry, hold on a second. I feel like that was a little deceiving.
Well,
when you try to
that's
say
what I'm trying to
steel built
respond to,
tires.
dude.
Were the tires made out of rubber? Hold on, Coach.
Yeah, which is a solid, right?
We'll respond to what you're asking.
Tires were made out of rubber.
Right, which is a solid, right?
Temperature in the area they were in.
Dude,
the tires are made out of rubber, which is a solid, right?
The temperature in the area they were in.
Depends on how you see. Temperature and thermal energy are not the same concepts. I know what you're getting at.
Yeah, sure.
Sunrise,
What's the temperature in the area they
sunrise
were in?
and
Are
the
you, if you're
shade.
scared of this question, that's fine.
I'm about to answer it if
move
you let
on.
me.
If you're scared,
I'm about to answer it if you let me.
into it.
I am about to answer it if you
Stop
allow
tap
me to
dancing
answer
around.
the
Let's get
question.
to it. What
If
was
you
the
would
temperature
instead
in the
stop
area they were
talking
in?
and allow me to answer the question, I can do so. All right. So in the sunlit areas and the shadowed areas, the temperature can differ by hundreds of degrees. However, temperature and thermal energy are two different things.
So, do you know the temperature they were in or not? Stop fucking
Jesus
tap
Christ, dude.
dancing
I
around
can't
and
really
being
make it any
fake.
clearer for you.
Now
You're
you're going to
ignorant
talk
ass.
over me? You're going to talk over me. Dancing around it. Do you know the temperature of the area they were in or no?
Yeah, and I explained that the difference is hundreds of degrees. However, temperature is not the same thing as thermal energy. There are two different
temperature
concepts
varies
at
from
play
hundreds
here,
of
and
degrees.
if
From
you
what degree
continue
to
to
what
believe
degree?
that there's only one concept, such as temperature, then you're just ignorant.
As if you
Temperature varies from hundreds of degrees. From what degree to what degree? Do you know or not?
Jesus Christ, dude.
If you
It
love
doesn't even matter what the numbers are. As I've already explained, the hundreds of degrees difference doesn't matter because the thermal energy difference in the surrounding environment isn't that much.
Run from the question. Run
There's
away.
no molecules
Run away.
to transfer that thermal energy up there.
Well, I think that he doesn't know.
Run away, keep dodging it. It's fine.
I think he doesn't know because all he has is
You're
what he
not
gets.
doing anything. You're just repeating that temperature is the problem when I'm explaining to you that temperature is not the problem.
So you're scared. It's fine.
I'm not scared because I keep telling you thermal energy and temperature are two different concepts. You can keep running away from that point and pretend that temperature is the only thing you need to consider. You're scientifically illiterate,
my
Jeremy.
question.
You just need to own your illiteracy.
Do you know the temperature of the area they were in or not?
Yeah, and I explained why that doesn't make a difference.
So you don't know the temperature of the area they were in. It's
Jesus
fine.
Christ, dude, you're an idiot. You're just an idiot.
Guys,
names.
You wouldn't let me finish what I was saying for some reason. Maybe you couldn't hear me, Jeremy, but I was trying to respond to what you asked before you had even asked it, dude. Actually, was in the middle of responding. Or not responding.
Know the temperature of the area they were in, Kosho?
No, listen, dude, because I'm not going to fall into the same round and round thing that was just happening. So I'm going to explain it in the way that I was in the middle of explaining it.
A roundabout thing if somebody just answers the question.
Yeah, you guys were saying the same thing back and forth to each other over and over again.
Yeah, because I'm asking a direct question.
I'm going to explain the way I was going to explain it, and the answer is going to be in what I was saying, okay? Because I was
a direct question. He obviously can't answer it or is scared to answer it. So I'm wondering if you can answer it.
Yes, I can. It's going to be embedded in what I'm saying right now. It's embedded in the thing that I'm trying to describe, dude. I'm saying I read an article when this happened. I'm actually looking at that same article right now, okay? And this is what the article describes. It talks about how people have the same things that you're saying, and you guys are saying that oh wow, the car should get torn up in space. And then you have a bunch of physicists in this article describing actually what would happen and what you would expect. And so what Doofus is saying about the difference between temperature and just the energy or the heat, it's going to make a difference if you're talking about different materials. Things like metals are going to radiate away the heat as soon as it's reflected onto it. So the temperature.
Just save it. Just save it, bro.
No, dude,
Just
listen to what I just said.
You're
last thing I just said.
He wants to remain illiterate.
Is irrelevant.
His entire purpose here is just to be illiterate.
Hold on.
He wants to be illiterate. He doesn't want to hear any sort of explanation given to him. No explanation will ever leave his brain because he wants to be illiterate.
Jesus Christ.
Direct question you guys are scared to answer. Stop calling me illiterate.
I'm in the middle of answering.
You're just being ignorant.
God damn, dude. There's no point in doing this, dude. I'm actually talking to you, answering your question directly.
Can Doofus stop talking?
What I said, because
I don't know what's going on here.
Just listen to the words I'm saying. But be prepared to feel foolish after you hear that I'm saying what you're saying, dude. I'm telling you that the problem that you're not considering is that there's different material on different parts of the car. So obviously the metal is going to be the most obvious that in space. The heat that is that's hitting it in the light side when it's that 200 degrees or whatever. That temperature though is irrelevant because it radiates. It's not persisting. It's radiating away just as quickly because it's the metal. There is things like the cushion and the seats, stuff like that. Like that will they were worried that like the seats that there might be wear and some of the what do you call it, the thread. Over about a year or so, it might look a little crappy, like the thread in the seats. But other than that, it's going to take millions of years for the car to wear down. So, yeah, this is the type of stuff you guys are talking about is just not something it's going to affect the car. The temperature is irrelevant if it's not retaining the heat.
Bro, I'm not even listening to you, dude. Do you have a temperature of the area they were in, or no?
Yeah,
if
200
not,
degrees, 200 degrees below zero and 200 degrees above zero. Yes.
If not, I don't want to fucking hear it.
I mean, I answered your question, and you're right. You don't want to hear that because you haven't heard it, dude. But it's been answered.
No, I didn't hear a fucking temperature in degrees come out of your mouth or Doofus's mouth.
Yeah, that's what I'm saying. You're not listening. I literally just gave you 2 temperatures. I just gave you 2 temperatures, dude.
He doesn't want to hear it. He doesn't want to hear the numbers that you said, that you definitely said, that I heard you say. He doesn't want to hear those numbers.
Me, dude.
Possible
you're talking over me. Last warning. Fucking warning, bro. Stop talking over me. It took 5 minutes to get a fucking temperature out of you guys. A simple question. What's the temperature? You guys fucking tap dance around it. And you're scared to answer it for some reason when it was just a simple number in degrees.
Right. And what's the relevance once you have that number? What are you going to use it for? You're going to tell me that the tires should disintegrate under those temperatures, right?
Hold on, dude. Your phone's messed up, dude. That's why you think we were talking over you and stuff like that. No one was talking over you before.
This has talked over me every fucking time.
I mean, he maybe did, but you did. You ended up when I was
spiraling out.
I told you the
question of what's the fucking temperature.
I told you, dude.
This is the games you guys play.
No, I said right when I told you last time, you screamed and told me I didn't tell you.
Of tap dancing around, I finally got a fucking number in degrees.
Yes, I said -200 and positive 200. When it's not in the sunlight, and when it's in the sunlight. Now there's a next question: is what does that mean? Well, it doesn't mean anything to most of the car because most of the car is going to radiate that away almost instantly. So the temperature is not irrelevant. Is irrelevant. Context to describe what's how it's going to be deteriorating or whatever. It's not like it's in a an oven or something like that or boiling water. It's radiant energy. And the radiant energy to most of the car is going to radiate away just as quickly.
Right. To illustrate this point more clearly, say you have a block of aluminum and a block of foam. You would use it like you could make a mattress out of it. If they're both at the same temperature and you put your hand on each of them, the metal, even though it's the same temperature, will feel far colder than the foam. There's a difference in how materials react with temperature, and what they do in their surrounding environments, that their environment is different. Temperature is not the be-all, end-all number you need to go by.
I wanted to ask Kosho how he knew about what he was just describing, about how it's not just about temperature. Because basically when we form conclusions or like have absolute beliefs, we've pretty much, a lot of the times we've had demonstrations, and I was just wondering, has there been a demonstration of this in space?
I should have prefaced that because I know sometimes I sound like a 12-year-old or something, but I'm a little bit older than 12, so that's not a new concept to me, that there's different types of heat and that radiant energy is not, like, there's no reason for you to expect it to be retained for some reason. The reason why in the atmosphere, like Doofus was just saying, like I was just saying before too, if you have something that you're heating, if you have something in a car and you have the sunlight heating it up into the car from, through the windshield and shit like that, and even if you have the air conditioner on, right, it's still going to heat that thing up because it's radiant energy. That's very different than if you have something. If you have something that is literally engulfed in that heat, like in boiling water, it's gonna obviously retain that because it's in the fucking medium.
Do you have temperature gauges and like dials and
you don't have to go to space.
An instrument like
know this.
Gauges to like demonstrate all this? Did you do this?
You don't have to go to space to know this. Yes.
Oh, okay. So you never demonstrated in space. Okay.
No,
cool.
You don't know. I tell you that that's not a requirement. So whenever I first understood it, it's not because I went to space and found out. It's because I understood the difference between radiant heat and convective heat.
Well, I know the difference between unicorn shits and unicorn farts. Doesn't mean they exist, though.
What's the difference?
Yeah, thanks for that completely useless analogy.
There's actually a real difference between radiant heat and convective heat.
That was a great analogy, by the way.
Different temperature and radiant heat, and but he's never like demonstrated himself. Or
I just gave you a fucking perfectly good example of when I things I've definitely experienced. I've definitely sat in a car with the air conditioner on and definitely still got heated by the sunlight that was radiating into the car. And I definitely have put my hand in hot fucking water for whatever reason. Okay, so these are things I've definitely experienced.
But supposedly these are
given another example of like an aluminum block and a block of foam. Those are two different materials with the same temperature that you can experience different effects from.
Yo,
those are real world
examples. Hold on 1 second, please. Can you hear when other people are talking?
I know. I started talking when it was silent.
Who started first? We're not little kids, mommy. He started it first.
Right. When I start talking, I finish what I'm saying.
Yeah, if you hear two people talking at the same time, you need to stop because we can't hear anything.
So that also works for the other party, right? So if I start talking when it's silent and I finish what I'm saying, the other party starts after me. What do they have to also do?
They need to stop. You both need to stop. I'm telling you right now because you've done it to me multiple times already tonight, and you're a habitual overtalker. So knock it off.
Yeah, I'm habitually starting and not stopping when I would, start normally.
People are talking. You can't hear anyone.
If you start talking and someone else starts talking, the answer is to both stop talking. And then you decide, oh, you go ahead. And the decision is made. It's like a talking stick. One person has the talking stick. Right now, I have it. So no one else does. I'm going to stop talking in a minute. Someone else does. If two people speak up, it's not proper for both of them just to bowl over each other because then you just get two people over talking. Both have to stop and say, hey, man, you go ahead. It's a talking stick. So just one at a time.
It's a prisoner's dilemma. It's actually a good example of a prisoner's dilemma.
Okay, so I wanted to respond to Jeremy's example of him being in a car and him obviously feeling the radiant heat, right? But I also understand that in space the temperatures are more extreme. So how did he verify this, that the temperatures are more extreme?
What are you talking about?
Supposedly the tires are supposed to explode and paint's supposed to melt off. Why is this in space?
Because you said that and that's what was supposed to happen? Or why was that supposed to happen? I don't understand.
No, there was some flat earthers in here that were making those claims. I don't know.
Yeah.
Cool.
I wouldn't go with it then.
Are you denying that there's extreme indifferences within direct light and out, or within a shadow when you're outside this atmosphere?
Yeah, those extreme differences can either mean something, mean a pretty big deal depending on what material you're talking about, or it can mean next to nothing depending on what material you're talking about.
So do you have
You've tested these differences, right? You've tested these differences, and you know the difference.
Yeah,
you have a smorgasbord of all the different scenarios, of all the different materials, and all the different heat variants.
Do you know how they tested them, or how they purport to have tested them? They used a vacuum chamber.
Oh, there you go, boys. Let's pack it up. Welcome to Flat Earth. I need no more. All right, great. Vacuum chamber. Thanks, vacuum chamber. Flat Earth.
Right. So how do you propose
chamber
on Earth they would test these things before sending them out to space?
What about your space missions? Shouldn't you already have this data present?
You don't need a space mission to know this stuff. That's what he's saying.
How do you propose they would test it before they send it out into space?
Hey, just use a vacuum chamber, bro.
Yeah, okay, good. So now what's the problem? That's right, there's no problem.
That's not a problem.
Well, you think a vacuum's the only difference between our atmosphere and the supposed outer space?
Yep, pretty much.
Really?
That's not even the difference that the difference we're describing is between the convective, the way that heat is transferred. Like when you're sitting out in the sun, you're getting radiative heat, but you're also getting convective heat from the air that's heated from the sun. And when you're in your car and your air conditioner's on, you're still getting the radiant heat from the sun, okay? And in space, there is no convective heat at all. You're only ever going to get radiant heat, and you're only going to be subject to that when you're getting light shown on, directly shown onto you. Now, just because the amount of energy that is hitting you doesn't mean that's the same thing as you experiencing temperature here on Earth, because the reason you're experiencing temperature here on Earth has a lot to do with the medium and how much energy, how much heat is in that, in that volume of air.
So does the radiative temperature increase the closer you get to the sun?
I'm sure it does. Yeah, why?
Well, there's an increase.
Thermal energy difference.
Hey guys.
Well, you haven't gotten any closer to the sun.
So you guys said vacuum chamber, but the answer I was kind of looking for was, hey guys, we have an ISS that we've dumped billions of dollars into, and we have all these devices and gauges and instruments to do this, because we have every 45 minutes we have sunset and sunrise and temperature differentials, and we could test this, but obviously you guys aren't privy to this fact, right?
Well, they don't have a Tesla Roadster on the ISS last time I checked.
Oh, okay, cool. Then we'll just use a vacuum chamber. Cool. Back it up, boys.
Yeah, no problems.
What is the question? Essentially, what are they trying to test for?
I don't think there's a question.
Oh.
There is a question. You just need to solve.
I'm just saying, you've never demonstrated this in space, so you have no demonstration available. So all you're talking about is this cold
when you
storage.
study thermodynamics, like let's say you're in the 1800s, for example, and no rockets have gone up at all yet, and you're studying thermodynamics, you don't need to go to space to study it, to study the difference between convective heat and radiative heat.
It's almost like the same thing as the radius. So it's almost the same thing as the radius. So we can't drill
it's not even close to that, and that's not even close to anything that
you're interrupting me.
Sounds like
I didn't get to finish, but go ahead. It's almost the same thing, like saying, okay, I didn't drill to the center of the Earth, but we're figuring the radius of the Earth is 3959. The same thing you're doing with that.
Are you sure you understand the claims that are being said here?
No.
I'm not sure that
I'm just giving other examples.
I don't need.
If I measure the circumference of a basketball, I can figure out what its radius is. I don't have to poke a hole in the basketball to figure out what its fucking radius is.
Yeah, but
how do you measure circumference when you don't have a dip angle, though?
Other ways? I was playing.
Well, that's a nice lie. Moving on.
Yeah, that's what I'm saying. I wouldn't.
Yeah.
I wouldn't. Because that analogy is not even necessary about it's just like the radius or whatever, because it's nothing like that. We actually can get absolute information about the differences between radiative heat and convective heat without having to go to space.
Yeah, we moved on to your R value. How'd you get that?
No, we didn't move on to that. Somebody randomly brought that up as an example.
Well, you've already gave us the answer. It wasn't sufficient, so I don't know why you want to stay on this topic.
All right, that's fine. If everyone's fine with you just coming in and then
does it for us?
something else, then we'll do that.
Remember when you used to have like 20 or 30 numbers in your head? Your nonsense continuously.
I've been here. I was listening in the YouTube channel. I have to say, Kosho and Doofus, bro, the sophistry when Jeremy was asking you the question, it was fucking brilliant. Cool motherfucking nose.
Did I answer?
So we can also add you to the category of people that don't know the difference between temperature and thermal energy. Got it.
I answered his question, and I did it in a generous way as well, because
I'm sure.
I was being interrupted when I started to explain what I continued to explain, which also had the answer to what he was asking in there.
What's the relevance?
I told him what the temperatures were. I told him why the temperatures were irrelevant, and I explained what the issues that would actually happen to the car would be.
What is the relevance, Doofus, of the difference between the temperature and the radiation? What's the difference? What's the relevance?
Well, as I mentioned before, a very simple example, we have, say, a block of aluminum and a block of foam like you would use to make like a mattress or a pillow or something. The two of them are the same temperature. When you touch them, they feel like they're totally different temperatures. Why?
And what does that have to do with what Jeremy's asking?
No. Answer the question. Why? Why do they feel different?
We're not going to go from me asking you a question to me having to answer a question for you to answer my original question.
Yes, we are.
You made it a point.
Why is a block of metal and a piece of foam feel completely different?
Of pointing out two differences. In which case, Jeremy was not asking you, right? He was simply asking you for a temperature, and you made it a point that there's a difference between what he wants and something else. Now, I want you to elaborate, right? So everybody can understand what is the point of you saying that there's a difference? Explain to us why you felt the need, right, and why it is logical. Just explain to us what's the difference between the temperature and the other thing that just explain to us why you needed to say like that.
He said thermal energy.
Yeah, why does that block of metal and that block of foam feel totally different?
Yeah,
why?
It's called density, bro. Two different mediums.
Okay, cool. So the temperature is the same, but they feel totally different, right?
So because the rubber is different than the aluminum rim that's different from the metal fucking rotor, right? You're telling me that because these three things are different, somehow they're gonna interpret degrees different, but nonetheless, if you fucking heat it in 400 fucking degrees, it don't matter the differences between the rubber and the fucking metal. All of it is all gonna burn eventually. So it doesn't matter. It's fucking sophistry what you're doing.
The reason it matters, and one example is in chat that I posted a video. That is a 2,200 degrees Celsius object that you're able to hold in your hands.
Doesn't matter. Not the point. Not the point of what's being asked.
It does matter.
If I put my oven in 400 degrees,
yes,
does it really matter? Does it matter what I put in there?
Yes,
rubber, aluminum. Let me finish. It doesn't matter. It doesn't matter what I put in there, right? Of course, it is going to interpret the heat different. Yes, of course, this is logical because it's the material and how the atoms are composition. We understand that.
Well,
but nonetheless, if you put it in the oven, it will still burn. All of it, right? So what the fuck are you guys talking about?
Not at all, dude. If you have 400-degree water boiling, and fucking a lot, and you have a 400-degree oven, you can actually put your hand in the oven. You probably put it in there for fucking 10, 20 seconds. Okay? It's a very different experience when you put your hand into the fucking water. Okay?
And
these are two totally different mediums. They're how you're going to experience the temperature is going to be totally different.
It's insane how you guys describe space, the place that it's possible nobody has gone to. How is exactly how Earth is? I mean, it works. It seems to work exactly the same. How Earth works. There seems to be no difference between whatever the fuck is out there and what's over here. Well, the point was that if they're supposed to be 0.17 to negative torr, right? A very powerful vacuum, and some guy just put
negative. The laws of physics are the same whether you're here or in space. The laws of physics don't randomly change.
Can I finish? It doesn't randomly change. How about if you put something in water? Would it randomly change from how it acts in the air?
Right, thermal transfer.
So it does change. So it does change. So it does change.
No, it doesn't change because the same concepts apply in all scenarios. You're just thinking the temperature is the only thing that matters, which it doesn't, as I've explained several times with real-world examples.
No. This is not the point of what matters or what doesn't matter. Jeremy asked you a question on temperature, and you sophistry your way into convoluting the motherfucking question, and you think that we don't pick up on that shit. All of us know exactly what you guys are doing.
Matrix, we both said the temperatures. At least I'm pretty sure I heard Doofus say it first, and I said it later. The two temperatures. And I mostly described why that's irrelevant and how that's irrelevant and what actually matters.
Because and it doesn't make any sense. That's what's needed. And none of that makes any sense.
An explanation. That's why we did that.
None of it makes any sense. None of it makes any sense.
It doesn't matter if it makes sense or not, though. It doesn't matter because it's what's true. And we know it's true, not because of space, but because that's the way thermodynamics works. So when you have heat, you're applying heat onto something, and you stop applying that heat onto that something, and that thing doesn't have any, it's like a metal or whatever. When you stop applying that heat, that object is going to radiate away that heat. It's not going to be, you're not going to go up to it later and it's going to, still be hot from when you just shined it on there. Because that's not the way that, that's not the way that going to work.
It depends on the consistency of the medium. This is why
I'm not talking about it in a medium. I'm not talking about in a medium.
Why you have, you're talking about an object.
It's insanity what he's describing. He's literally describing.
Why do you think what do you think the difference is between radiative heat and convective heat? If it's not that,
so you guys are telling me that whatever they
incredulous, that's fine. He can be just incredulous and use that as an argument, which we all know is invalid.
That's cool, Doofus. So you guys are telling me that it doesn't matter the material, right? That whatever you put and you rapidly heat it up and cool it up, heat it up and cool it up, that is gonna maintain. It says composition structure.
I'm not saying that, dude.
Well, you guys are trying to say that because the heat it gets intense and then it radiates away due to shifting of whatever the fuck.
No, the radiate. Here's the truth about it. This is what
Culture, you have to stop interrupting. You have to stop interrupting, Culture, right?
You gotta make your point then.
Listen, as far as I know, I'm a mechanic, right? And I custom build shit. I deal with materials, I deal with heat, I deal with metals all day, right? When you heat up, the molecules expand, the composition changes a little bit. You're telling me that hitting the same material constantly with cold, hot, cold, hot, cold, hot, cold, hot, as rapid as you guys want to describe it, that the composition of the material is going to stay exactly the same and it's going to do absolutely nothing. Is that what you guys are saying?
Matrix, there's a lot of people in here, so that's why I'm just saying. I didn't mean to interrupt you, but if you just didn't have to say all those extra words, like I know what your point is, right? So just make it short or whatever. But I was also going to say we don't have to get aggressive about this either. But I just described to you. I mean, I was trying to describe to you, which for some reason Germany never let me finish about what actually was going to be the wear and tear on the car, because there is expected wear and tear on the car, and it is due to the kind of things you're kind of describing. That's why it's not. It's just not going to explode just because it's up there. But in a couple of years, the material that's on the seats and some of the tires, are going to start weathering in a way because of the radiation. That's true, but it's just not going to be the effect that you'd expect. And most of the car though is going to take millions of years before it's weathered in that same way.
So hypothetically, what would happen if I were to put a balloon in an oven that's been burning for 4 hours at 400 degrees? What would happen? What would happen when I place a balloon in there?
Why would you put it in there?
It doesn't matter. What would happen, Kosho?
For how long?
Let's be very clear.
Notice how they don't want to answer the question. Notice how they're going to avoid answering the question.
It's very important that you understand.
What would happen?
It's not It's very important you understand that space
What
is
would
not
happen? Don't give me bullshit, doofus. What would
It's
happen?
very important that you understand.
I don't want to
that
understand
space
anything you have to
is
say.
not Jesus Christ, dude. It's very important that you understand that space is not an oven full of air. That thermal conductivity is totally different in space
Are you
than
sure
it is
about
in
that?
the oven, specifically because the air is present in your oven.
Are you sure about that? Because last
Absolutely.
I heard, Earth's atmosphere exceeds far past the moon. So
Not in
what
any,
what
not
depth
in
are
any
we
real
actually
Air
talking
way.
is in an oven is much, much greater than the same amount of volume that is up there in space. If you want to play games with me right now, you can, but that was stupid.
Yeah, it's
So
obvious.
stupid that you guys can't answer the question. And
No,
it's an
I did
obvious
answer your question, man. That's what I'm saying. Let's stop being combative, dude. It doesn't have to be combative. If you would have listened, I answered your question immediately. Okay? I'm just wondering why you're asking it. Because it's not the same thing as Doofus is just trying to say to you. It would be silly to put a balloon in an oven because, of course, the heat is retained by the air that's in the oven. Okay?
But the silliness of the question doesn't matter.
Hold on, Matrix. Hold on, Matrix, because that's not the kicker. The kicker is the reason why that's not what's happening in the other place is because in the other place there is not this medium to contain that heat. The heat is contained in the medium. It's being stored in the medium that is now giving it kinetically to the balloon, which is not happening in a case when there's no medium there. So the heat might still be there, and it's possible it could eventually have an effect on the balloon. It's just not going to have the same effect of if it was being engulfed in a trillions and trillions of fucking more than trillions. I don't know how many.
Is there a set temperature to space?
Excuse me?
Is there a set temperature for space?
I mean, whenever people say they're like, 2.3 degrees Kelvin or whatever the exact number is, what they're saying actually is if there is no sun really close to Earth star, really close to you, so the only source of heat you have is the cosmic background radiation, that's the temperature you'll get.
Yeah, but this has
other than that, there is no consistent temperature of space because it completely depends on, for example, are you right next to a sun?
Yeah, but that's not what he's asking. I think needs to be answered by what the difference between what that temperature even means. Okay, because what temperature is going to pertain to is basically the average energy. Like if you're talking about the heat, like the heat, then there's going to be a lot more overall heat when there's a lot more particles there. But if there's only one or two particles there, and the average temperature is whatever temperature you want to give it, it doesn't really mean much, right?
What's the difference between heat and temperature?
Well, the difference is the average, like I was just saying, like the average energy for the molecules or whatever's there, and the heat is going to be the actual amount of energy.
For example, it takes a certain amount of heat to increase water by 1 degree, but it takes another amount of heat to increase, for example, steel by 1 degree. So heat is about the amount of energy, heat energy, and temperature is like the kind of effect you see, the degree change you see. That's the big difference.
It's a kinetic effect, temperature.
Yeah. Well, there's more things to look at it, but that's the main thing.
All right, so what's the difference between kinetic and thermal then, since you guys want to play around like this?
So kinetic, go ahead.
No, go ahead. I was actually just blank a little bit.
So the way I would explain it would be if you think about kinetic. Kinetic is like a whole amount of objects moving in the same direction together. That's when you get kinetic energy, while thermal energy is a bunch of particles moving back and forth relative to each other, bouncing against each other. So it's both movement. It's both movement, but one is about their movement, like moving against each other, vibrating and pushing against each other, and the other is them moving together as a group, which is kinetic, of course.
So can you have a pressure increase with kinetic versus thermal?
You don't get a pressure increase from kinetic alone, but you do from thermal. Like imagine, for example, if you hold a tank of gas, if you increase the temperature of that tank, then yes, you'll increase the pressure. But if you just move that tank back and forth, it's not going to change the pressure of it.
Well, moving the tank back and forth would be more like potential versus kinetic.
No.
I'm not quite sure what you mean by that. How would that be potential and not kinetic?
Potential.
It's all kinetic.
Potential versus kinetic. There's two forms of energy, is there not?
Well, potential, we usually talk about, the main way we talk about potential is gravitational potential. So if you lift something higher up, it has more potential energy. But if you move it left to right, then that's completely out the question. We don't really. Yeah, but it's not changed its potential in any way. It's only changing its current kinetic.
It did change its potential when you lifted it.
Yeah, but okay, leave it on the ground and slide it back and forth. Same thing applies. You're not changing it is getting kinetic energy because you're moving it. The whole thing of moving gives kinetic energy, but it's not changing the pressure of it in any way. And the potential is staying the same because it's still on the ground. Or a table, wherever the hell you want.
By temperature and pressure mediation alone.
I mean, that's a claim you can make, but it doesn't explain all the phenomena we see.
Well, explain. I haven't heard an explanation yet. Only descriptions.
I didn't. Was that me, Robert? Yeah, you were roboting.
The conversation goes nowhere. Somewhere. We're not explaining anything. We're not demonstrating anything. They're explaining the difference between the heats.
For example, I mean, one demonstration I literally gave it to you of how we can differentiate between heat and temperature is the fact that you need a different amount of heat to heat like water by 1 degree and steel by 1 degree. That's a physical thing you could do yourself to see that temperature and heat are two different, or not different, but they're two different concepts. No. They are related, I mean,
temperature
but they
is
are different.
A unit of measure. That's all I'm hearing.
Yeah, but so
heat
what?
Heat is an actual physical thing, where temperature is just the relationship between that heat and the said object. It's a consubstantial relationship.
Heat is a physical quantity of energy.
So when he tries to obfuscate away from answering the question accurately by saying thermal energy or heat in lieu of discussing the temperature and differences, then it seems like he's kind of being pedantic in a way.
No, because temperature and thermal energy are still two different concepts.
Yeah, describe the relevancy of the temperature. I don't know, in some place where there's no medium. Like what does that even mean? It means
it means there will be a temperature regardless. It's a unit of measure.
It doesn't mean the same. It doesn't mean the same thing as it would mean in as it means in any two mediums, any two different mediums, or a medium versus a no medium at all. It's gonna have very different meanings.
Can you show me something having no medium? I've yet to see that.
Yes, a vacuum chamber.
Oh, okay. So a vacuum has no medium. That's what you're saying?
Yes, that's why it's called. That's why vacuum is vacuous. There's no medium there.
Insignificant medium.
So you're saying.
I'm assuming he's not being pedantic.
You're saying that a vacuum actually exists, a perfect vacuum where there's no medium. This is interesting.
I'm dropping out of this. I'm dropping out of this. I thought you were being better than that, but a vacuum chamber is known to be virtually a vacuum and not actually a vacuum.
Virtually.
You're right about that. Okay. Because the medium that's in there, that temperature is going to cause no issues. Okay. So I don't know why you wouldn't use that as a vacuum. And that's why there's no point in discussing it with you.
Vacuum is just a negative pressure, right? But that doesn't necessarily mean that there's a lack of medium.
No negative pressure. There's no such thing.
Really?
Yes, there's no negative. There's a negative. You can have a negative pressure differential, but you cannot have negative pressure.
Well, I guess
you can just get closer, and you can get closer and closer to zero, though.
Right.
Which is
so. With that being said, you can never get away from a lack of a medium, as Kosho tried to explain. That's just nonsensical.
The space between molecules
you can
is a lack of a medium.
You can approach no medium.
Yeah, exactly.
Right, and you when you pull a vacuum and you pull a progressively stronger and stronger vacuum, you witness the change in relationship between temperature and thermal energy and how the conductivity changes as you're going toward that vacuum. So you can plot out what a perfect vacuum would do, no problem. You don't actually have to have a perfect vacuum to see what it would do.
I can't believe we're still arguing at this point in time. You know, we're talking about, like, you know, we give the example of the oven and the boiling oil. 400 degree boiling oil, 400 degree oven, and I don't get burned when I stick my hand in the oven. All right, why is that? Because it takes time for that heat to impart. Now, if I have a really, 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 really low pressure with very little time, medium, I'm going to be only imparting so much heat from that atmosphere that I'm in, and so much radiant heat that I'm going to be getting. And the question is, how much will I be able to radiate away in that time? It then becomes a mathematical formula. Can I survive in 2,000 degree atmosphere that's 10 to the minus 6? Yes.
It's like you can hold your hand over a flame for a while, and without getting burnt. You can even extinguish the flame with your fingers without getting burnt. But if you hold your hand over it, you're going to get enough heat to the point where you can't dissipate it, and your hand gets burnt.
I use the example of my my grinder in the garage. 2,000 degree sparks are hitting my hand, and yet I'm not burning because I'm able to radiate few particles that are hitting me. I can radiate that heat and take it away with my blood faster than it can impart to my skin and cause damage.
Yeah, because otherwise you would open the oven and then suddenly burn to a crisp, because the air that comes rushing out your oven is 400 degrees.
Now,
So
I got a
luckily
question.
it's not. Yeah.
So if you had a vacuum and you increase the cubic volume of that vacuum, would there be a change in pressure?
I mean, if you had a perfect vacuum, no. If you don't, which you usually don't, then yes.
I mean, why would you invoke a perfect vacuum when no one has a perfect vacuum? I don't understand these types of things.
Well, he didn't listen to anything I said. That's awesome.
I'm not talking to you. I was talking to whoever was responding to me. Gummy.
Right, and as you can track the progress toward a perfect vacuum and the relationship of how thermal energy is dissipated, you can determine what a perfect vacuum would do without having to have a perfect vacuum.
So let's just say we had a near perfect
basic
vacuum.
Concepts, basic scientific reasoning, and somehow you guys, 10 years old, walked into an advanced physics class and can't figure it out.
Yeah, thanks for that. You stick with your space expanding into the vastness of nothingness, reaching the outer extremities of the universe, and I'll stick to reality. How about that?
Right, stick to not knowing science. Got it.
If you call science abstract concept, then have fun with that. But that's not science. Science is all about explanation.
As abstract
science is an abstract concept, you idiot.
Not at all. Science is supposed to be about explanation, something you guys are failing to do.
This is also an abstract concept.
Not at all.
Right, so I'll clear this up for you. So if I have a weather balloon, or anybody else has a weather balloon, and sends it up 100 plus thousand feet, and they measure less than 0.1 psi, that's a vacuum up there. You could say it's not there, but you'd be lying.
Well, you can validate.
I think a safer position for you guys to have taken with the Tesla car in space would just be like, oh yeah, you know, it's Elon. Maybe he is trolling. Who knows? Because my friend who really believes in space, he thinks that's totally fake. And it's like, you know, well, if that's fake, it doesn't necessarily mean everything else is fake.
I mean, a lot of the things Elon does, a lot of the things Elon does are just publicity stunts. A lot of the things he does, and
exactly, that's what
I
you
think
should have
that
just. You should have just said we don't know that it's real. Maybe it was a, then it'd be more believable.
But the
Yeah,
thing
that's
is,
not
like
what's being
Kosho
said
said,
here.
we have no reason to believe it's not real.
It seems perfectly reasonable that he would do it. It seems like there's no reason that he wouldn't do it, or there's no reason that he couldn't do it. And it seems like it's perfectly within his means to do it. He's saying he's doing it. I see that he's done it. There's literally no reason for me to think that it didn't happen.
No, I'm not saying you should not believe it.
Kosho, sorry, is that what you go off when you to decide whether something's true or not? Is whether there's a reason?
All the things I said. If all the things I said check off, yeah.
Right, so when somebody murders somebody, but it seems unlikely that they would have done it, do you think the cops should sit around and say, I don't think there's any reason why that person would have murdered that person. He's good. He's non-guilty. Let's move on. Is that what they do? No. They actually try to get to the truth of the matter. Because you might have a subjective thought about a reason that somebody may or may not have, doesn't mean that that's correlated with the truth.
Well, Gio, you chose to listen to only one thing I said instead of the entire thing I said, which actually is the reason. It wasn't one of those single reasons. It was the entirety of those reasons. The reason that there's no reason for there's nothing that makes that impossible to happen. He has the means to make it happen. It's something he would do. He said he did it, and I saw him do it. Those are the two most important ones, okay?
So a billionaire who has a fake space company and as corrupt as they come, you somehow think he wouldn't have a reason to fake putting a space.
Get over yourself.
Yeah, my point was that, it just, when you guys like totally buy this one, it makes us feel like, wow, you're just buying everything. Because other ones like maybe are a little more questionable than this, like a little more believable, but this one's so unbelievable, it lowers your credibility when you say you believe other things.
All right, well, here's the fun part about that. That same delivery system was able to put other things into orbit we can verify are still there. So whether or not he faked that one or not really doesn't matter.
How do you verify that they're still there?
Put into orbit, and that's fine.
What's this? How do you verify?
Yeah, what have you verified in outer space other than your imagination?
GPS. We had this discussion before. You couldn't address it.
Belief systems, huh?
GPS is not a belief system. It's a set of signals coming from above. They're inside the cell phone bands, between two known cell phone bands, 700 megahertz and 2.1 gigahertz. So it's sandwiched in the middle there, GPS. So it's clearly not about the wavelength, as Gio was trying to make it out to be before. And if I go to the bottom of a parking structure, I can have full cell service and no GPS service. How does that work?
Because GPS propagates and penetrates material objects differently than cell.
Okay, you missed part of what I said. Cell networks can operate at 700 megahertz and 2.1 gigahertz, which is either side of GPS. If cell networks work, then GPS doesn't. It's not about the wavelengths or how they propagate.
Yeah, there's no difference in the technology penetrating things. Radio waves are radio waves at a given frequency.
Yeah, there definitely is. Cell signals can go through,
coming from above.
Cell
so now
signals
what?
will go through mountains.
Yes, lower frequencies can go through mountains much better. And even high frequencies can bounce over mountains. Like you can hit an object and reflect it in.
Well, here comes the fun part. Say you were to get a GPS SDR, some sort of software-defined radio. You know the code that's going into the thing. You built the thing. These things exist. These things also measure Doppler shift. Those things are moving at thousands of miles per hour relative to the receiver. So it can't be ground-based towers because I've never seen a ground-based tower whiz by me at 8,000 miles per hour.
And if you wanted to go down the hypothetical that it was changing frequencies because it knew where you were so that it could pretend that it had passed you and now it's got Doppler shift the other direction. You could make that claim, but then it would do that for everybody, even the people that haven't passed yet.
That and the fact that GPS is a one-way service. The signal's coming to you, your signal's not going back out to them.
Okay,
So
well,
there's no way
I
they
mean,
can know
this
where you
part
are.
of the conversation started with you saying that you verified something in outer space, and then you concluded at you think GPS signals are coming from above you. So somehow you think that verifies something in a fabricated medium that you've never been or tested anything in.
They're coming from above. They're moving at thousands of miles per hour.
That doesn't
A balloon's
verify
not going to do that. A ground-based tower is not going to do that.
That doesn't verify that anything's in outer space.
Okay.
Well, yeah, at least
What
we've been limited.
what is going to be up there that's moving at thousands of miles per hour? What could it be?
Cool story, dude.
What is it? What could it be? Could it be a balloon? Of course it can't be a balloon. What else could it be? An aircraft? We've never seen one go that fast. So what?
Not many aircraft fly at 30,000 miles either, or 30,000 kilometers.
Just got to play denial. That's all you got to do is just play denial the whole time.
So you got
I
anything
can
else other
understand
than
most.
GPS?
What do you want from the laundry list of things that we've showed you that indicate the
Well,
Earth
I mean,
is
we
spherical?
asked you something of tangibility, and you're invoking GPS, which you've never gone up there to verify that there is something up there to begin with, which was the whole crux of our conversation, or Geo's question.
Okay, cool. You didn't listen to anything I said. Got it.
Yeah, I heard everything you said.
Okay, so what about receiving signals that are moving at thousands of miles per hour did you not hear?
I'm not talking about your signal. I'm talking about you going up to high altitude to validate anything. Have you ever, what's the highest altitude you've been up to validate something?
We've eliminated balloons and aircraft and ground stations. So right now, I'm going with probably something that's about 30,000 miles away, moving at the speeds in question.
Let's ignore what the signals are or where they're coming from or how fast they're going.
You don't
Let's
know
just
where they're coming from.
Let's
because
just
you haven't
pretend that
validated.
let's just pretend that we have to go up into space to physically see the object in question in order to verify the signals we're receiving are doing what they're doing. No, what I'm receiving is what I'm receiving. You can pretend it doesn't exist. That's what you do.
You're receiving what you're receiving. You still haven't validated anything. If you did go up there and validate it, then that would be validation. If you don't have validation, that's fine. You can just say, you know what, guys, I don't have validation, but I believe this for XYZ reasons. But to claim you have validation when you don't is deceptive.
Okay, so you have not validated North Korea exists. Then we can just conclude that North Korea does not exist. That's the argument you're using.
Tactic. Is that
No, it's not, because it's the same exact kind of logic in air quotes. To say that we have to physically see something in order to verify what it is we're receiving is complete and utter horseshit.
Extraordinary claims require extraordinary evidence. I can
Right, it is extraordinary evidence to receive Doppler shifted signals that are moving past me at thousands of miles per hour. That's extraordinary evidence.
The mechanism by which GPS works is mutually exclusive with only working from satellites. There's no way at all, 100% unfakeable.
Do signals bounce off of things? Do signals bounce off ionosphere?
Do they Doppler shift at 8,000 miles per hour?
You know, big speeds. Yeah.
That's not how signals
bounce
work.
and travel at crazy speeds. They bounce, don't they? Unless you're claiming we're getting line of sight all the way to
because
Australia.
If you change the directionality of the antenna, what you end up with is not a Doppler shift. So just moving something and having it reflect off of different places, even though it's not a suitable frequency to bounce off the ionosphere anyway, which makes this whole scenario stupid in the first place, then it wouldn't really do what you want it to do.
That's what happens if you know a little bit about the subject.
Can we bounce it off the ionosphere? Not at that frequency, and it's stupid. Don't. Just don't.
So that's all you got is satellite?
That's all I
Amongst
really
everything
need.
you
Because
described
as
to
you
you.
might have heard before, if you have a
I
GPS
mean,
SDR,
that's always
what
the
it
dog
returns to
tactic.
you is,
It's always
oh, for shit's
satellite
sake.
GPS. That's all for you guys, bro.
Okay, so as I mentioned before, if you had made such a GPS SDR and were able to return the data from the GPS, that raw data is Cartesian coordinates. When it's transformed into WGS84, we verify for sure then that the Earth can't possibly be flat.
Right, and then you wrap it around a model, and that's your proof. Nice try, bro.
Okay, you didn't actually understand what I said, but thanks for the effort.
What does Cartesian coordinates mean? Is that like a grid?
It's linear coordinates, X, Y, and Z. That's what comes back from the calculations from the signal's distance from you. When you have to get the final coordinates that the user will end up seeing, that has to be transformed into WGS84. That's not a flat surface that it's being transformed onto.
Why does it have to be? Can't you just take the coordinates and use it like a grid?
You could. It would just look ridiculous.
Flat, right?
What it would do is it would give you
look
points.
Ridiculous.
What it would do is give you points along the outside of a sphere. There's no altitude. It's just raw XYZ coordinates.
Isn't that what everybody uses when they got a map in front of them? X, Y, and Z coordinates?
Nope. They use two angular measures and an altitude. That's not X, Y,
So you're
and Z
telling me
at all.
I can't navigate. You're telling me I can't navigate with a map with, grids.
That's not exactly what I'm saying at all. That's fun that you tried to make it sound like that's what I said. No, what I actually said was you get back two angular coordinates and an altitude. Those things together is what you use on the map to find out where you are.
Thought we use a sextant, right, to find out where we are.
What's an
angle? Now we're going to switch to sextant.
How do you have an angle on a curved surface?
No, I'm not switching.
Yeah, we were working on GPS, so Cartesian transform into WGS84, but now we want to switch to sextants.
No, we're not switching to sextants. You're talking
I'm
about
not switching.
An angle and an altitude, and I'm asking you, how do you have an angle on a curved surface?
Okay, grab a ball, any ball, right? Set one great circle on that ball to be the equator, right? Any amount that you move by angular amounts away from that will be your latitude, and along that line will be your longitude. There you go, two angular coordinates on a spherical surface. Those are angular coordinates.
What is an angle?
Oh, Jesus Christ, dude. Don't ask the question, what is an angle? You don't have to come here and play the idiotic game that you have to ask me, what is an angle? There's no reason to ever ask someone, what is an angle? That's a very stupid move.
Well, Doofus, hold on.
You're talking curvature and angles in the same fucking conversation. Are you insane?
Yeah, Doofus, you seem to be hold on, Doofus, you seem to be on a second, please. You seem to be resorting to a lot of insults. I get it's a bit of a heated conversation, but I ask you to please stop doing that. And then in addition, it's actually a valid question because you're referring to something that isn't an angle and calling it an angle. So instead of trying to condescend and call him names, why don't you just try to get clarification? Because it is true, you're calling something that is an angle that isn't one. So that is a valid question.
Okay, explain why the amount around a circle is not an angle.
Isn't that called a radian?
The amount you travel along a circle, its proportion. Explain that, why that's not an angle. Right. The proportion that you move around a circle. Explain to me why that's not an angle.
Yeah, that's called a radian. Angles are...
it's not called a radian.
Spheres.
It is not called a radian. When you go halfway around a circle, that is pi radians if you want to use radians, or it's 180 degrees. That's an angle.
You can't have an angle on a fucking curved surface. I don't understand what's so hard about that.
All right, so there's not 360 degrees in a circle. A circle is clearly curved.
Are you talking about a circle sphere? Do you realize the difference?
Yeah, a circle is a cross-section of a sphere. So let's try this one more time. Why is the proportion that you move around a circle not an angle?
We're talking about a sphere. Why are you invoking circles?
The cross-section of a sphere is a circle. Do you understand?
No.
Jesus Christ, dude.
No, your cross-section is not a circle.
The cross-section of a sphere is not a circle. This is the new heights of flat Earth, folks. You have to deny basic geometry and pretend it doesn't exist.
Yeah, excuse me, I was speaking. 2 dimension and 3 dimensions are different. You can't, they don't segue.
All right, anybody else here want to tell me if a cross-section of a sphere is not a circle? Who wants to tell me that?
I disagree with the flat earther. I agree with you.
Uh-huh. Even if he's totally stupid.
Sorry, sir, can you repeat what I just said? Can you repeat what I said?
Did you say agree or disagree?
I said I disagree with the flat earther, and I agree with you.
Okay. I think that's
I'm
probably,
going to make the same argument.
probably part of the communication got lost.
Is a circle 2-dimensional or 3-dimensional? Let me ask that.
A circle lies in a 2-dimensional plane.
Okay, so is a cross-section of a sphere 2-dimensional or 3-dimensional?
If you do a 2-dimensional cross-section of a sphere, you end up with a 2-dimensional shape. Obviously. If I was going to say, if I take a 2-dimensional cross-section of a cone, I would still end up with a 2-dimensional shape.
Well, to be fair, you added the term 2-dimensional cross-section, which is different.
Yeah, bro.
It's not.
Yeah, bro.
Okay, show me a cross-section that's not 2-dimensional.
Well, you could take a cross-section of a sphere and end up with a hemisphere.
No. Those are sections, not cross-sections.
And just to be clear, I think that Hank may have agreed with you about what you were saying, but I don't think that he'd agree with your conflation with the actual point.
All right, so let's try one more time. If I have a circle, which is a cross-section of a sphere, regardless of what Dice Low says, and I go around it a certain amount, that is a proportion around that circle, which gives you an angle. So if I go halfway around the circle, I went 180 degrees. Now, back to the basketball. If I have that equator that I previously defined, and I'm moving along the equator, I'm defining longitude as an angular measure. If I move away from that equator, and great circles that are perpendicular to that first great circle, that's a line of longitude which gives you your latitude. Now we got 2 angular measures on a sphere.
I've done this physically with strings on a ball. I'm able to get angles and I'm able to determine locations from it in my room.
So how come we're not talking about measuring the surface? Is this the flat Earth conversation?
We're talking about WGS 84, which is 2 angular measures and an altitude.
It's just a model.
Right. So when GPS returns coordinates relative to WGS 84, and we find things that are certain altitudes from that reference, pretty constant, then we can conclude that there's curvature present. If there's a specific part of that that we didn't quite... What's that? Hank, your internet might be acting up. Or it could be my internet. Is anybody else hearing me?
Unfortunately.
All right.
Yep, refreshing them.
I would sincerely hope that if somebody's been researching flat Earth for years, that they would have figured out what longitude and latitude are by this point, this many years into it.
We haven't figured out that sticking your hand in boiling oil is worse than sticking your hand in an oven at the same temperature. And we haven't learned that you can have degrees on a sphere. It's amazing.
I mean, I'd be all for segueing into the sextant topic at a later time. So I gotta go. Just keep in mind the sextant you used horizontally.
I made a pseudo sextant in my house using a globe and some strings, and I was able to determine the location based upon those angles. It was repeatable. I don't get it. Obviously, it works. At least conceptually. You guys
I'll just say that if I were listening to this and I didn't know anything about the topic, at least from my opinion, maybe it's just because I'm biased, but it sounds like, you know, the tactics and the attitude and everything you guys display sometimes, even if you do believe it, it makes it sound like you're just defending it and you don't believe it.
Well, the fact that I went out and tested it by setting up my globe with some strings on it, found a ground position on the globe, was able to find an angle from that, which was able to be determined. And that works. So as a concept, it works.
What about that? I'm talking about like the insults and the tactics and like the way that you like talk about people. And I'm talking about like the actual test. That's a little more believable. I don't know why you'd have to test it if there's no reason to doubt it. But at the same time, yeah, that's good that you did that.
Flat Earthers keep on saying that it doesn't work.
No, yeah, I'm just talking about like the attitude, maybe more so from what Doofus and you sometimes, I guess.
There's a long history of people who ignore what he says, deflect, dismiss, and as such, you're not going to exactly be always at your best calmness.
I'm just giving you advice, like strategy wise. If you really want to sound believable, you don't need to insult. You know, I mean, it's just it sounds like you're trying to cover it up. When the conversation goes to insults and conflation and, you know, trying to avoid certain questions, it just seems like a strategy more so to win the argument rather than to find the truth. You know.
What avoiding of concepts? I mean, sometimes there's a little bit of an avoiding of deflection, because that's a lot of times what the tactic is to deflect off of what was an uncomfortable topic to a new topic. Like we just saw with, well, what about sextants when we're talking about GPS? Boom. Immediate segue to that.
I don't think GPS is really your guys' strong suit anyway. I don't think anyone was trying to avoid that. I mean, you can claim whatever you want with the GPS, but we have like no real pictures of satellites in space and no real pictures of the Earth from all those satellites. So, I mean, GPS kind of really doesn't work for you guys.
Like if I see a flashlight across a lake from me, I can tell it's a flashlight by the way it's being wielded, swung back and forth. Now, I could be wrong, and there could be some elf over there with a glowing light coming out of it. But at this point, I'm going to assume that that is a flashlight that I'm seeing over there because it's meeting all the criteria of a flashlight.
Yeah, go ahead. So I want to point out something. In the Civil War, right, we had hot air balloons and cameras. So we had, you know, so-called satellite or high-altitude imagery all the way back in the Civil War. Has technology increased? Quite a bit, so, right? So, why is it so difficult to think that there might be some sort of let's say a nuclear-powered plane, right, that flies around up there perpetually and is broadcasting signals, right? How do you know it's following around the Earth perpetually? Sorry,
I don't have a problem with
how do you? Can I get my question out first before you answer?
Yeah, you can.
Like, how do you know that it's like falling around the Earth perpetually in this orbit that you talk about? And, you know, if the guy from Hubble, you know, if he hasn't never seen it, he's never seen the Hubble telescope floating around there. Not verified. So the thing about truth is it's verifiable.
It is verifiable. Like the guy with the flashlight at the other side of the lake. I can tell that that's a flashlight. I don't need to go over there and see it.
Yeah, come to find out it was just a firefly.
Can you verify the Hubble telescope for us? Can you verify that it's really there? You got a live cam on that thing?
What?
I mean, if it was an expensive equipment, the first thing I would do is strap a live cam on there, right? That's the first thing I would do.
You ignored it. You have everything that you've requested every single time.
Can you verify there's a Hubble telescope? Can you go there and see for yourself?
I can verify the satellites. I can't necessarily have to verify Hubble himself. I could see something there.
Can you verify the satellites for us, please? Show us how we do that.
Get a good telescope. You're going to only see it as like a little blip of light.
Why would it be a blip of light, by the way?
What?
There's no lights on the Hubble telescope. Why would it be a blip of light?
You're going to see a blip of light. You're going to see reflection off it. Light reflects off of things. You know that, right?
Where? How can light reflect off the satellite if there's no light?
There's this really bright thing up in the sky called the sun.
The sun. So the sun is always shining on the Hubble telescope all the time.
No. Sometimes it's in the shadow of Earth.
So it wouldn't be a blip then if it's in the shadow of Earth, would it?
It'd be a blip, a tiny, insignificant light in the sky.
No, you said no light if it's in the shadow of Earth. So either there's a light or it's not. We have to decide that.
When you're let's slow it down for you a little. When it's in the shadow of Earth, you can't see it because it's dark. When it's in the light and it's reflecting light, you can see it. It's sort of like when you turn your flashlight on and you're outside, you can see, and then when you turn it off, you can't see.
Okay, let's use your critical eye with this. Let's use logic. Okay, so you can show us then when it's in the shadow of the Earth and when it's not. Can you demonstrate that, please? I do want to verify for myself. And you do know this, right? So this is science, right?
What is the value of looking at it in the shadow of the Earth when you can't see it? So you're now saying that it's gone, it's disappeared? What are you trying to say?
I'm trying to confirm what you say. I'm trying to confirm there's really a satellite up there. I don't believe it, but I might if you show it to me. If you could show me how to confirm it.
When you do it when it's not in the shadow of the Earth, you don't do it when it's in the shadow of the Earth. Why would you do it when
you
it's
can tell all of us not in the shadow. I'm sure you can tell us when we can see it. Can you do that, please, in Livestream?
Yes, I'm going to go right outside and buy a telescope.
I want to test the science. I want to test the science today.
Get a telescope. Or go on and talk to one of your local radio astronomy clubs. You wouldn't believe me if I showed it to you. You go do it yourself. It's not a hard thing. I'm not asking you to spend $1 million.
I might believe you. You have to try. You have to show me confirm what you're saying. Don't just say stuff.
Go talk to your local astronomy. You won't believe me anyway. I dealt with
Can you show us this blip right now? Where is it?
No, I can't show you this blip right now. I don't have a telescope on me. Do you have a telescope on you?
I have one in my storage.
Can you show me navigation working on a flat surface?
So no confirmation of Hubble, just stories and people tell you stuff. I have a question. Have you ever seen the Hubble telescope in your lifetime?
Okay, you can get off your duff. I've seen satellites. Have you gotten off your duff yet and actually looked at, let's say, I forgot where I was going with this.
Just answer. Have you ever seen this Hubble in your life in real?
Oh, yeah, that's right. I'm sorry. Have you ever gotten off your duff and gone to your local radio astronomy club and tried to find a satellite with them? Because you will not believe me. You'll say it's a blurry light. You'll say that I fabricated it. You'll say it's CGI. Whatever your particular method of denialism is, you'll use it. The only one that you can't deny is your own.
Bro, we know that they got stuff in the sky. We know. Since the Civil War, they've been able to put stuff in the sky. That's not the question.
Yes, but
How
you
do we
can't put it
verify
that
that
high.
it's
You
falling
can't leave it
around the
that
Earth?
fast.
How do we verify that it's falling around the Earth?
I don't know if you can verify that until you figure out the shape of the Earth, because you're stubborn and won't look at any of the evidence. You're kind of screwed there. But you can determine how high it
Well,
is.
here's the thing, bro. You're accusing us of being bigoted, right? But we've already changed our mind on cosmology. You're the one who
Oh, wow.
hasn't yet.
That's
Right?
brilliant. You changed your
So you
mind for
got
the
the
wrong
anchor
idea.
bias.
Beautiful. On bad
You got the
evidence, you
anchor
changed your
bias.
mind.
You got the sunk cost bias. And you got the confirmation bias. Now, we both have confirmation bias. But I don't have sunk cost bias. And I don't have anchor bias.
I learned about GPS to a sufficient level where I believe that it's possible, not only unlikely, but impossible to fake with the information that's provided. That in and of itself requires that the satellites be exactly where they say they are, the distance they are, the speed that they're moving, or that it does not work.
Or they could just be
It
reporting.
is absolutely 100% unfakeable. They have to be 12,000 miles plus or minus, depending on how far they've traveled away from you. But 12,000 miles up at the shortest distance. And they have to be moving 17 or speed they're going at that distance. They have to be going thousands of miles an hour. And it is impossible to fake, because what you get when you get a GPS equipment is you get a almanac message. The almanac message is what's used to determine your location. It gives you the location of the satellites, and that's used instrumentally to determine the distance from the satellites. When you go and look at the time delay between the known location or the identified location and your location, you can now trilaterate your position. That is unfakeable. The system would have to know where you are. And since it's an open system that's transmitted to everybody on the same frequency with the same locations of satellites, that information would be only right for you if they faked it. They could lie to one person on Earth. Anybody else's GPS on Earth would be wrong. We don't observe that GPSs are wrong. So we know that. Go ahead. Oh, you're roboting.
I have observed GPS was wrong. Oh, is this better?
No, generally speaking, you do not observe GPS being wrong. You've observed a few instances where there was an interferer, when there was whatever. I'm talking about never, ever would you get a right position, except for if you were the one person on Earth they were trying to tailor that message to.
GPS works off of towers. I've had a cell phone
Absolutely
for years,
not.
and I've been
Absolutely
delivering
not.
pizza.
I build towers.
Are you gonna let me
I have
finish?
tested the frequencies. Oh, by
Are
all
you gonna let
means,
me
go ahead and
finish?
blather on. Go ahead and blather on.
Right. Right. So I delivered pizza for a long time. Done it for many years, 20 years to be exact. And when I first started delivering and first got the cell phone, with the GPS, I would go out so far that there would only be like 2 towers and my location would be way, way off. And then I would have to drive back towards town, call the customer, get directions, and completely ignore the GPS and go by the directions from the customer because there wasn't enough towers out there. Now, unless you're telling me that there was a GPS satellite shortage, right, when I move out of town, and then when I move back in town, the GPS is now back over my head, I don't understand how you can explain it. Like, I don't understand how you could explain that. So,
I'm just waiting for you to finish.
well, my mother's calling.
Oh, good. In answer to his question, if anybody else is interested, there is 2 parts of GPS system, especially with phones, is that there's a mapping system. The mapping system downloads to your phone, sometimes continuously, sometimes you can download maps ahead of time. But if you're going with a real-time dump of the maps, as soon as you run out of cell phone coverage, your map will stop updating.
It'll still,
However,
it'll still
GPS
it'll still track you along with the GPS signal, though. Even if,
however, the GPS will still function.
yeah, but it'll still track you on the. It has enough map to cover. It has enough map downloaded that the GPS signal will still be able to take you where you need to go.
It depends on the system, but yes, the older systems, how much they dumped into memory at any given time was not the same.
Hank dropped out. Did he say he was reconnecting, or did he say his connection was going out?
I think he had a call going.
Okay. Yeah, I think people say that iPhones just kick them right out of Discord when the phone rings. Or
I wish it did. I find that really annoying when it calls in. It doesn't let you get to the menu to freaking hit your mute button.
I mean, your answer to what Hank was saying, if what you're saying is the case, then the issue would have not been the GPS. The GPS would have still been tracking on the map it had, or still would have showed your location. It just would have not had the map part loaded for that area.
It really depends on the software. I can't speak to his specific system. I can tell you that I have, in my years of using for data collection, which means I would collect data at like every couple of meters down a road, collecting for cell phone networks, and I have never found massive outages. Sometimes you get into a tree canyon in the olden days. The receivers do seem to have gotten more sensitive over time. But they used to get a lot of frequent outages if it rained too hard.
Yeah, that's kind of weird because I've been talking to these people on the internet for like 7 years now, and they can all verify that there's definitely outages. They tell me I'm 5 seconds. So we were apparently communicating, to the moon and back with similar technology, right? Because radio, Tesla, Sony, right? So
no, nothing similar about it except for its radio waves.
So the waves change?
No, I said there's nothing similar about it except for that it's radio waves. The technology by which GPS works is not going to give you the same results as trying to get a scratchy voice over the ocean with a spark gap transmitter.
So it's all about sending and receiving signals, right?
In the case of GPS, it's all about receiving signals. There is no sending. Not one bit, not a shred, a iota of data goes back. Especially when you have a standalone GPS, which is what I had for the first 5-6 years of GPS.
From the satellite and not from the towers. Why is it when I moved away from the towers, back in the 2011 era, that I lost signal to the GPS?
All I can say is I haven't had that problem. I don't know of anything except for the fact that the mapping software. What kind of a system were we talking about? Are we talking a cell phone or like a Garmin?
Yeah, Metro PCS cell phone 2011.
Okay, cell phones are in a continuous state of downloading maps. When you lose the cell phone network, the map stops downloading. However, if you look at your GPS coordinates, they will keep on changing. You could even go back and look at those coordinates and map them out and see whether they were accurate. But I will wager that you were still getting your GPS coordinates and it was still updating, but you had no more map, or the map was wrong for where you were, whatever.
It was my location on the map that was wrong. And it was a stupid customer who likes to name their driveway a private driveway when they only have one house on the stupid driveway. So that's what the problem was. The lack of GPS signal to my phone, or you're saying it's the inability of my phone to translate that data, but the map doesn't change. The data is what changed. So I'm assuming that I wasn't getting data from the satellites. I was only getting data from the towers. But
I can only tell you, I have not experienced this, so I can only hypothesize what was happening with your system. I have driven.
Yeah, me too.
From New.
But what was the variables? The distance to the towers.
I have driven from upstate New York to North Carolina to West Virginia, Pennsylvania, all those areas, and my GPS has never skipped a beat. You know, except for the moment when I'm in a tunnel or a tree, a mountain canyon or something.
That works on a flat plane.
No, actually, it doesn't work at all. Again, you got to go back to the raw data, and the raw data that feeds this thing is not capable of being fabricated, and it does not work on a flat Earth. Unless, of course, you're saying that the satellites are 30,000 miles away on your flat Earth, then maybe you could get some semblance of accuracy. I don't know. I'd have to really think about whether you can make a system work like that with similar information.
You just made a wild assumption right there that it can't be fabricated.
No, it can't be fabricated. Cannot be. I challenge anybody to even come up with a hypothesis as to how it could be fabricated.
You don't know where that information is going. You think it's going to satellites floating around the Earth.
You have
what if they're
30
going
addresses.
to helium balloons, satelloons, that NASA has over 1,000 of floating up there?
Doesn't help. Doesn't help you one bit.
Data.
Doesn't help you one bit.
To make it seem like it's a satellite floating around, but really it's just a satellite.
That does not help you one bit because the satellites are mapped out. There is a coordinate that's associated with it, and I'm not sure how it's actually coordinated at this point.
I'm glad you're honest.
In the almanac,
confirm that coordinate. You can't confirm it's coming from satellites in space. I'm glad you said you don't know.
You can confirm it's 30,000 miles away, and that there's no way of no alternative answer to that.
You cannot confirm that.
Sure as shit can.
You can't even show me the Hubble. I actually show me the Hubble. You said I should go to my local astronomy club.
Don't need to. We're getting data from this thing, and we only get, let's say, for the GLONASS system, you're only getting 30 coordinates, 30 mapped balloons, if you want to call them.
Your precious data could be coming from a satellite above your head. It does not have to be coming from quote-unquote space.
Those 30 mapped balloons, as you want to call them, is all that you have to work from. You can't have thousands of balloons. Thousands of balloons don't answer it because each balloon would have its own unique coordinate and its own unique distance from you. In reality, that's what would happen.
They have
if I have a balloon that's 10 miles away,
they confirm that, not 30. You're just interjecting nonsense. It's confirmed that there are thousands of satellites confirmed from NASA, not 30.
Not that it will, and no, that is not what I said. If you could get your head out of your ass for one moment and stop talking, you might actually learn something. But you don't really want that. You just want to raise questions and keep your ignorance at maximum.
Just tell us how you can confirm that it's coming from space.
Is it possible? Is it possible for us, so-called flat earthers, to ask you guys questions without you guys being condescending and saying that somehow we're stupid for asking questions or whatever? Is it possible to just answer the question or not to answer the question?
Thank you, Matrix.
Well, it would be nice.
How do you confirm it's coming from space? I'm listening.
It would be nice if somebody actually listened to the answer once and tried to understand it, rather than trying to come up with an alternative before you understood what's being said. That childish behavior makes us get typically upset. There's only a few gems out there who can actually manage to keep their cool under these conditions.
But if you understand it, if you understand it to the point that you're able to explain it to somebody, that alone should be enough to ease your mind, right? Because somebody else's ignorance shouldn't affect you. So I understand that you might get a little frustrated, but you have to understand that person that's asking you potentially isn't as brilliant as you might think you are, right? So you don't need to insult the person, just answer the questions, and if you can't, don't answer the questions. I mean,
thank you, Matrix. We're asking you a fair question. How do you confirm that they're coming from space? How do you know they're not coming from satellites, which are much more local?
You can eliminate the idea of satellites by the things that I said before about the fact that there's 30 distinct positions. Only 30 positions. The almanac message gives you 30 positions. That is all that is in the almanac message, is 30 unique positions. Not 1,000, not 10,000, not 1 million. 30 unique positions. With those 30 unique positions, you receive perhaps 8 signals from those 30 possible satellites, which are constantly changing to the next one in the chain of 30. Now, with that information, all you have, again, is 30 satellites to work from. you determine your distance from those satellites. If it was a balloon that was 100,000 feet away from me, or 200,000, or 1,000,000 feet away from me, it would have a different delay. Now, if I have 1,000 balloons, all with unique coordinates, they will all have unique timing characteristics and how long it takes for that signal to get to me. They will also have a unique relationship to all other people using that system. If one person is 10 miles away from me and receiving the same balloon, he will get it at a different timing. Now, I cannot fake the location of that balloon and get the timing results from it. That would give me an accurate result within microseconds.
This special timing you're talking about, this microseconds, it's the same technology that Nixon called the moon.
And also, it's your response.
There was no microseconds involved with the Nixon call. The Nixon call was just a straight up, not continuous wave, modulated signal that was sent up to Nixon, to the astronauts. It's not the same as having a timing delay that we're going to use for navigation, where we have to be precise to the nanosecond in order to find out where we are within a couple of feet.
Go ahead, Hank. I think I'm done. He just spiraled into nonsense.
Okay. Can you clarify
forgive me for interrupting.
The 30, you said that there was 30 positions or 30 satellites up there. Could you just clarify that point for me, Moya?
There is 30 unique GPS satellites for the U.S. GLONASS system.
And I heard Godric say that.
Question.
I heard Godric say that NASA says that there's more than 30. Now, is that true?
That has nothing to do with GPS. There are different types of satellites that do different things, just like there's different kinds of cars that can do different things. Like I can have a car that can carry a family of 10. Or a van that can carry a family of 10. Or I can have a car that can only carry 2 people. Satellites have their own functionality. There's a GPS satellite, which is in a geosynchronous orbit. I forget. The moving orbit. There's a web of them that goes around in all different directions around the Earth, and they all interweave between each other, essentially. And then you have the geostationary satellites. Geostationary satellites are good for things like satellite TV, where I have a dish that I aim at the satellite, and I aimed it 20 years ago, and it still gives me information after 20 years from that same direction. No breaks in service except during thunderstorms. Worked for 20 years without even a hiccup.
Can I ask a question?
These are different functions.
So, yeah, I just wanted to say that there's this cosmonaut. He's got the world record for traveling through time, right? And he's supposed to be like a fraction of a second younger than when he left, because he spent like almost 3 years on the ISS, right?
Sure.
So why do you have to reset the GPS satellites every 8 minutes because of space-time warping and time dilation?
Because they are precise to a level.
Yeah, he was up there for 3 years, and it was less than a fraction of a second.
Yep, it's only a fraction of a second. A fraction of a second is tremendous in navigation when 8 microseconds equals a mile. I have accuracy to a couple of 100 feet in the worst case scenario. And with full precision, I have a couple of centimeters, about a centimeter of accuracy. So the timing difference in that is going to be a world of difference. He also has not, now every 8 minutes they have to adjust a little bit to keep your timing lined up so that your precision is dead on balls accurate to the to the nanosecond. You don't understand the difference between that? If he was a nanosecond older, what difference does that make to his world? Or a nanosecond younger? It's not going to be perceivable.
Nano. If it's not perceivable, why are you talking about it?
Because it's perceivable at the levels when you're trying to use it for navigation.
Can you confirm that once more? Just confirm for all of us. You can confirm nanoseconds.
By what means do you wish to have this confirmed?
You can take the means. You can choose. With the question's on you.
I'm asking you. Do you want to talk about oscilloscopes? Do you want to look at?
You can confirm it any way you want. I'm asking you to confirm it. That you're talking about nanoseconds. Yeah, you're talking about these 30 satellites that are up there somewhere. Can you confirm this?
Yes.
Okay,
and
go.
not right now. Sorry. I can tell you about the things that I've seen, which is
how much time do you need?
Made. Oh, I'm sorry. Was I talking or were you talking?
You said not now. I'm just asking how much time do you need?
I just wanted to know if I'm talking or you're talking.
You're talking. Go.
Oh, good boy. Okay, so I've seen people who have set up their own, as you described, a software programmable receiver, software programmable antenna, whatever you want to call it. You can do this and you can build your own GPS from scratch and you can look at the messages at the raw level and do this. And I'm not going to go and spend the money on it. You may, if you really don't believe that it works this way. I am perfectly confident and comfortable with the fact that the people I've spoken to are honorable people and have actually done the test. I've seen the equipment for sale. I can purchase it. It's about $250 if you want to spend a lot on it, and you can go and actually run the formulas yourself. I am satisfied that I've seen the numbers, and that's what they received through the antenna by the methods they've shown it to. I can show you a video of somebody making their own software programmable GPS and show them receiving the information. If that would make you happy.
Okay, so let me explain the fallacy you just made. You trust your people,
The fallacy,
you're honorable people. Here's the thing: science doesn't rely on trust. It doesn't rely on knowing.
It absolutely does. It absolutely does.
It doesn't rely on trust. You have to confirm
absolutely relies on trust.
You have to go to the thing that you're turning it to confirm it. If you can't, that system that you're talking to, it could send you any kind of reading it wants. It could send you a reading to make it think you're on a globe.
Nope, you built the system yourself. It can't do anything but what you told it to do.
Building a GPS system does not confirm that there's GPS satellites out there. It can give you any kind of reading.
It tells you what's coming in. It tells you what information you have to work from. There's a logical proposition.
Unless you control that system, you cannot confirm it's legit.
There is a logical proposition that you have to make at this point, which is, I have this information and this is how I'm getting my position. We know that because I have written the software or I've observed the software, whatever. I see the software and how it's getting information. So I have the almanac message and I have the timing delay. That's all I have to work with.
I'm getting data. Hang on. I'm getting data. I'm getting timing. Therefore, satellites. That's what you're saying.
I know that my system is not transmitting back to someone to tell me where it is so they can fabricate data to me. Now, I'm sitting here in my house with my software programmable GPS, and it's giving me a coordinate. When I move, it gives me a new coordinate. Now, I'm by pure reasonable deduction, I am satisfied that that is the method it's working by because I've seen it. I have control of all the features of it. I know there's no hidden information, no secret information, no method for my software to even talk to secret information. And that information still gives me my location.
You're just making explanations. You can't prove it. I can give another explanation. It's coming from a satellite or a cell tower.
No, I can't prove anything to you. I can't prove anything to you. Really?
So that's my explanation.
You guys have set yourself up to a position where you cannot know anything without doing it yourself. So you are now bound and determined to do it yourself because if I do it, that will not be satisfactory. You will say that somehow I am fabricating or misreading or miscalculating the data. You have to get off your duff and actually do something in order to validate it.
You haven't done it and you can't show us. That's the thing. I'm just asking you a simple question.
Yeah, I'll tell you where my satisfaction in GPS came from and eliminated the possibility of local balloons in any fashion, like anything between 0 and 100,000 feet, is my knowledge of radio frequency from 30 years in the cell phone industry. My measurements that I've taken of GPS with receivers by hand, just the GPS, not taking it from a GPS unit, but from a scanner. I've been scanning through an amplifier, measured the signal, and I found that there was no local source for that signal for perhaps, I don't know, almost all of Virginia and all of West Virginia and the southern half of New York State through Long Island and northern half of New Jersey. For all of that area, I have never seen a source of GPS that ever got stronger than a negative 125 dB signal. Now that in and of itself tells me that there's not a local source because as you approach a local source, the signal gets stronger. It doesn't get stronger. It always remains weak. Impossible to do on a radio system.
South America had LTE coverage, blanket coverage over the continent of South America with 12 satelloons.
That's wonderful. So
that just
not,
shows
this
you,
is not a this is
there.
not a coverage issue. It's with those 12 satelloons, as I went to the extent of those 12 satelloons, like let's say I got about the halfway point, 50 miles between them or 100 miles between them, the signal would get weak. And when I got right underneath the balloons, the signal would get strong. It would go for satelloons, at maybe 5, 8, 10,000 feet. You would see the signal rise like up to negative 70 dBm.
How do you know?
Negative 80 dBm. You don't see that. You never get close to one.
How do you know that? How do you know that LTE satellites would get weak that fast?
Because I deal with LTE, I design LTE networks, and I know that LTE signal, which is radio signal, gets stronger as you approach it, and it rolls off in a 30, like I forget what the number is, like 39 dB per decade rate. So basically, what happens is it's the inverse square law. So
let me ask you a question about that.
Fair enough. I'll give you that. I can see that point. I'll give you that, bud.
Let me ask you a quick question about radio wave propagation. Is it longitudinal or transverse wave propagation?
I don't know.
Okay, fair enough.
Don't use it in what I do. Longitudinal or I can't even really put that into my lexicon the way I use cell phones, the way I work on them.
I can't believe you talking all this shit in your knowledge. You don't know that if they're transverse or longitudinal.
Okay, can you tell me why that's important to me in my realm?
Because that'll determine the speed or the lossiness of energy
and the strength of signal, if any at all.
I always deal with ground-based signals. So I mean, I'm not dealing with. I'm dealing mostly in the 0 to 10 mile range from any given base station. The biggest obstacles to my signal, of course, are trees, mountains, buildings, and terrain. So I don't really have a huge problem with that. So let me see if I can find out how I can even apply that to what I do.
Right, but we're talking about supposed satellite signals, not local signals, right?
Well, I'm just trying to look up how you can apply latitude. Maybe I use another name for it.
Bro, all EM waves are transverse. I don't even know why you had to even think about that or look it up, man. But hey, I did a video on satellite. I did a video on satellites because I was studying into them and stuff, and that's when I found out about the LTE and a long time ago, man. And now I can't even find that information, which is kind of crazy. It's probably still out there somewhere. But anyway, he was saying about the satellites, they're all linked, and they were saying they're all linked because of the anomalies, like the South Pacific anomaly, the South Atlantic anomaly, like the whole entire eastern seaboard of South America. You get bad information, and they're saying it's because it's the Van Allen radiation belt dips down real low there, and so their way around that is they sync with another satellite, at least one, and they go by both of the satellites, the closest one, and they whichever one's information is right, that's the one that gets sent to you. So all the satellites are.
What system are we dealing with?
Satellites.
Satellites is not a system.
I don't know what system, man. I don't know what. I think it was. Shit, I have to go find out, man. But the thing is they were saying that all of them, man. That if we didn't do that, all of them except for the ones in synchronous orbit, all the ones that are supposedly in orbit, they have to link up because maybe not all of them, and I don't want to say that because I'm not 100% sure, but he made it sound like damn near all of them. But anyway, that's their way around all their problems is to link up with another one. So if they're in problem areas, they can look at.
Can you help me with that? Like, what was his?
The point of this is the point is you never know what you're getting if you're linked to another satellite, because the whole east coast of South America is anomalous, so you're counting on one of them to get a right reading. It's like and then if you're on the other side, there's a South Pacific anomaly. It's like everything in the South is a fucking anomaly, man. Why are all the anomalies? You believe that the Van Allen radiation belt's dipping down low over the southern hemisphere?
You got a better reason?
Yeah, the information they're getting is right. It just doesn't match their model, so they're fucking calling it wrong. Calling it an anomaly.
This is why I ask you what the technology is. Are we talking about GPS? If we're talking about GPS, then I'd be really surprised to hear that. Now, if we're talking about satellite TV, and you're having trouble getting your satellite in from one satellite, you have to split your your signal between two satellites. That's a totally different proposition. I don't know what you're talking about.
I'll find out for you.
Yeah, that's cool. Thank you.
I'll try to find out, but it wasn't satellite. It wasn't TV, but it might have been GPS. But I don't want to say and be wrong, so I'll go check real quick. In fact, I'll post a video because he describes all about satellites. And dude, there's so many excuses. It was like I thought the guy was trolling satellites. I thought he was like a flat earther, just explaining satellites. But come to find out, he's just being honest about satellites, and he describes them and their functions and the problems and where the problems are. And it's just so many excuses. It's comical. But I mean, there is explanations or excuses, whatever, for everything. But so I'm not going to lie and say there isn't. But it's a little bit suspicious, man. If you watch this video, it's kind of short. It might make you. It's a head scratcher, in my opinion. I'll post it.
Okay, I think I got something. You had mentioned the longitudinal propagation waves and stuff. So it's a terminology that I don't use. I use vertical and horizontal for what that is, and we do use that. You can control your signal. You can even determine whether you can receive a signal or at least attenuate an unwanted signal a great deal by
sound waves are longitudinal. Sound waves are longitudinal, but the EM radio waves are transverse. Ain't that right?
What I was reading here, let's see. Transverse waves oscillate perpendicular to the direction of propagation, while longitudinal waves oscillate parallel to the direction of propagation. Longitudinal, got it. Transverse waves oscillate perpendicular to the direction of propagation, while longitudinal waves oscillate parallel. Okay, so does it even to radio waves even that almost sounds like you're talking about pressure waves, like from a sound wave, how they come in, how there's a low pressure, then high pressure, and low pressure.
Yeah, basically is pressure wave.
Yeah,
it basically is. You're right. It basically is pressure wave.
So all radios
longitudinal anyway.
So then, from my perspective, I don't ever have to deal with this. Radio waves don't work the same as pressure waves. So it's my ignorance in it is not an impediment to me accomplishing my task.
Nah, you failed. You failed the test, man. You don't know nothing about anything. Just kidding. Don't.
Yeah, I find there's when
hey, is that your career? I mean, is that your career? Working with signals and
yeah, I've been building cell towers since building in some form cell towers from design, not like building these circuits, but design, assembling them, choosing the antennas that we're going to use, aiming them, dealing with coverage holes and stuff like that. I've been doing that since 1987.
Let me ask you a quick question. Is it true though, if you touch like something that's way up toward the top of some of the big radio towers, if you're at the top, you touch something grounded, it'll zap you?
An AM tower can kill you. basically that whole antenna is charged. The whole radio tower is charged with 50,000 watts. As far as a tower, when you're climbing it, the whole tower is is grounded, but you could have something that's floating above ground, and you could probably get a zap from it, either from the other radio sources or just from the possibly, I guess, from the potential difference from the ground to the top of the tower. So I would say yes, you could probably get a little zap from it, or all the way to a really bad zap, depending on what the cause is. Like an FM tower, where you got, again, 50,000 watts, but that's not the whole tower charge. But if you had that antenna isolated from ground and you touched it, and you became the path to ground, it'd mess you up. It's 50,000 watts through your body. It's like 25 microwave ovens. And I've always made the tower monkeys climb the towers. I've never climbed them. I've done it a couple of times just for giggles, but don't tell my company that. They would have been mad.
I just posted that video about the satellites and their anomalies, and it's also got a lot of good information about the path of the signals and where they have to go through. Every satellite is every signal goes to this one division. Like, I mean, it's not one place. But it's
is this video something I can go into? Is this video something I can go watch like in a short time?
It's 13 minutes. It's 13 minutes. So you put it on 2 times speed. Yeah, check it out and tell me. I'd like to hear the responses to my question. Yeah, very good. Hell yeah.
I'll see if I can answer them. I mean, satellites are not my 4K, but I do understand a bit about radio propagation. All right, let me go.
Yeah, cool.
How do I end this?
I wish we could play videos. I don't even really know how to do it on Discord. But I'm gonna ask him when he gets back. Why are there 2 points of interception before the people who own the satellites receive their own data? You know what I'm saying? I mean, I'm not saying about signal strength. Obviously, you can locate. You can. I mean, unless everybody's lying about that, I have no reason to believe they're lying. But you can check for signals and satellites. I mean, signal strength and how many satellites are in range and shit. But I'm not an expert on the subject, but from researching it, man, it's just a lot of questions, man. Like the information, like the orbiting satellites, it's just so many problems. How come the whole they call it the the South Atlantic anomaly? It's the whole east coast of South America except the tippity top. They try and make it sound small, but it's not. It's everywhere. It's blankets freaking South America, man, unless you're on the other side of it, and then you get some accurate readings. But I don't know, man. I'm just getting into maps and shit. It's weird, dude. Everything about maps is hard to explain. It seems like, man, New Perspective posted a video with the sun and the different times of year, like when the sun's down toward Capricorn, up toward Cancer. He shows it, like doing a figure 8, and he don't mean that like every day. he means seasonal. There's a spot right after the equinox that it kind of takes a jump. And in the video, he's like, if you pay attention, you'll see it like make a jump in the sky kind of. And I've noticed that before. Didn't really think nothing of it, so I don't even really have to go look, the time of year, because I've already noticed that, like, where not in one day, just where I was like, damn, the sun fucking moved down. It's moving that way fucking quick. I thought it was right there, just something I noticed over the years in this subject, and it wasn't enough to really ever talk about, but it got me thinking, and I'm trying to do the map, and I'm checking like the times, the sun times, and it all, but I don't know if it could do that. In other words, it's spinning around when it's in the northern hemisphere, Cancer, but then it turns it makes its figure 8 right when it passes the equator down toward the southern hemisphere, and it starts going the other way. But I'm having trouble. Like, it was interesting, and it worked out with the time zones and shit, but it's I'm having trouble like mapping it. So I'm looking at all the times. I live in South Florida. Okay, I mean, I live in North Florida on the Atlantic Ocean, and I'm sitting here checking the map, and where we were going to buy a property is up the East Coast, but on an island spot right north of us is like Amelia Island. It's all island, a spotty, patchy, swampy island, but towns in the middle of all that shit, Fernandina, Amelia Island, and everything, and it's showing it north. Okay, and it's showing me looking like a little bit south of east when I'm standing at the coast as far north as I can go until I hit the jetty where the St. John's River meets the Atlantic Ocean. Anyway, I'm sitting here checking it. That's where I surfed, and it never made sense to me. So I went on Google Earth. We couldn't find the place we were trying to buy, and because we were trying to follow the roads, but we couldn't do it. And I'm realizing that it's wrong. It's totally wrong. Because if I'm standing on the shore looking east, or even a little bit south, but east southeast or east, Fernandina and Amelia Island, they run parallel. The road going to them runs parallel with the jetty on each side of the river, where the river meets the ocean, which is facing east or either east southeast, and it goes about 30 miles, 40 miles east, or either east southeast. It runs parallel with that jetty where the town is, but it shows it right above us. And I'm looking at the times, and I'm going to make a video, man. As soon as I get a chance to go down there, I'm going to go with a drone where I can get up higher and show where the stuff's at and show what Google Earth is showing. What Google Earth is showing is wrong, and it just seems like critical information because I'm right here on the coast. So I'm at Florida. So my angle to the Atlantic Ocean is very important because it's the route that all the planes from the north take, going down south to the southern hemisphere, or down, anywhere down there. It's pretty much going over Florida, and then everything leaving. Everything going west, like, is going. A lot of stuff from Florida, Georgia, is like using the Gulf, like going to Texas and shit. So anyway, the angles are kind of critical where I'm at. It shows the way the map shows Florida kind of sticking out, that and then once you get north of Florida, it shows the everything going north. Everything going east and north. It kind of it widens, but that's not what we see when we're there on the coastline. And south, it's showing it, kind of it's a little bit wavy, but it shows it kind of coming out, and that doesn't even seem right. But I'm not 100% sure on that. Like, the south might be right, but it just doesn't seem like we're facing the way it's saying, man. So I got to check all the declinations and stuff, because if anybody who checks SunCalc, or is going through any of this stuff, just remember that it's not given magnetic declination. So if you want another way of looking at it. You know, check the compass, because if they tell me my declination's off by a little bit where I'm at, but when I pulled a string line and pulled 90 degrees from compass north, the sun, you know, split the string line on the equinox. So how do I have declination when my shit was dead on? You know, so it's dead on and I have magnetic declination. There might be an explanation, but I'm just kind of scattergunning what I'm doing. I'm trying to do a map. So I checked like Plymouth, Massachusetts. Okay, it's west of me and north. Okay, but that ain't what we see when we're looking up the coast. But maybe it's just a local turn and it's just throwing me off. That's why I want to get the drone and go up as high as I can and see how accurate the map is. But it really doesn't seem to be accurate, man. But if the angle of Florida is off, that changes a lot of shit, man. That changes a lot. Because like I said, all the routes going south go over Florida. And that pretty much determines the angle, the way we see Florida. And its angle determines the angle you're going south. So it just seems like there's got to be some changes made to what we have pre-existing. And it's a hell of a process, man. But it seems like more people would be interested in making a map, man. I feel like we could do it. Just need help, man. A little bit of help and some interest. Some other people interested in the topic, man. To me, it's hard to even debate when I can't even give a fucking map. I mean, I'll stand behind the E map. It's decent. Just there's just some adjustments need to be made because of the distances in the southern hemisphere. But most of it works. Antonio Subrat's before he died, I think he has the best map, man. He made a map, and it was in his book that he was selling. He was selling Book of the Sun. He wrote a book, but he made a map, and it's pretty good. Whether it's exact, and no map's ever going to be exact, I don't think, in my opinion. But it was pretty damn good, man. It fixed a lot of the problems. I think it made Australia and South America a little bit closer, but it was still a jump. But seems like that's where we should be focusing. I don't know if anybody's even fucking listening, man. I'm just talking, filling the dead air. But I was checking. Yeah, well, I was checking the time of Plymouth. Okay, so it was I guess, man, I forgot the distance, but it was about 1 degree further west than I am, one or 1.5. So I looked at what time the sun came up, what time the peak sun was, and all that. Then I was like, okay, let me find something east that same distance, because it should pretty well match. You know, something west of me, 1.5 degrees. The sun, if however much earlier the sun rises, well, then 1.5 degrees west of me should be how much later the sun would rise, and peak time and everything else. But it just seemed inconsistent, man. They did not line up. In fact, they were off by about 30-40%. But one of them was further north. But and another thing about the map is I got a garden, and I'm looking at the planting times. And so it tells you, and it has a picture of the United States on the pack of seeds you buy, and it has different layers. There's like 4 layers cutting across America. You know, like down here in the South is like orange, and then a little bit north, like Georgia and South Carolina, all the way across to California is pink, and then there's 2 other zones. So it tells you when to plant according to your color. Well, my color, I'm far south is in America. You know, Florida's down at the bottom, so I'm in the most extreme, and that same zone cuts up fucking the West Coast all the way to Oregon. So if you live on the whole other side of the country, as opposite from Florida as you can get in the United States, is you plant at the same time. It's the same schedule. which is baffling. Like, hold on now. If I just go a few hundred miles north, I hit another zone, and then I go about another 400 or 500 miles, I hit another zone, and then another 500-600 miles, whatever, I hit the northerlymost zone, of the American planting shit in America. Except for the one at the bottom wraps around it. It just baffles me. Like, how can I be on the same, like I have the same climate as the northerlymost westerly state in the fucking country? It's baffling how we have, I don't know. I'm still trying to get explanation on that one, how we have the same planting climate and we're on opposite ends of the fucking country. So that tells me that it's something's up with that. And when you start checking all these times and stuff and look at the sun time, it just shows you, man, they could draw basically whatever the fuck they want. You'd never fucking know. You'd never know except locally. But as far as the way it ties in, you wouldn't fucking know, within reason. But they could almost, it could be anything, man. It's like, as long as you have everything local, fairly close, then as far as like continents, the way they connect, shit like that, man, there's so much leeway. It's crazy, man. It could be way different, man. It's making me think like even consider that moon reflection map from that one guy, I think FPV Angels or whatever. It seemed a little out there, man, but it was like crazy. It matched the way he did the flipping it with like a parabolic flip. Dude, it's insane how good it matched with the whole fucking world, man. It's pretty damn close, man. As far as all the little islands, I mean, like not the teeny ones, but the major islands. Like it had Cuba, it had fucking Florida. The shapes for the most part were the same, but it had New Zealand, Australia, just every little fucking, I don't know, man. It kind of tripped me out how that map can explain damn near fucking every major place on Earth, man. It was that's a little bit of a coincidence, man. If it's I mean, it's a bit extreme if it is just coincidence. Let's say that. In other news, I took the I've been taking these batteries. Shit, I've been taking these batteries apart and getting lead and shit. But the negative, I was saying before, the negative plates are good. I seen a video where the guy took the negative plates out of two batteries and joined them to make one battery. It fucking worked. I don't even believe it, dude. It worked. So basically,
I find that you respond a lot better when I talk to you, and I'm not on mute. I muted myself.
Yeah, okay. I was just filling dead air, man, while you was watching that.
Yeah, I watched it so far. I'm only about halfway in. I was watching it. The anomaly actually, that's not so much as it's not like giving you wrong data, like the miles are longer or something like that. It's random shit. Like it resets a computer, it puts a wrong bit to the wrong position, it causes the computer to crash. Stuff like that. It's not like it's saying that you're off 10 miles or, always in this direction. It's random type shit, which would be random inaccuracies, not some kind of a coherent left-hand turn or 100 meters to the right.
Though. It did trip me out because it's consistently fucking unreliable in that area.
It's consistently unstable.
Not for one reason. Oh yeah, not for one reason.
Yeah, the computers can just get fucked up by it, which, then they got to reboot, wait for it to come back online. Or if it gave you a wrong number, it could, say that, you're 1,000 miles from where you're supposed to be. That kind of shit.
My question is if they go ahead. Sorry.
Yeah, I'm just saying that's randomness isn't what you're looking for in the South when you say, I wonder if it's an error that's causing to account for the fact that the southern hemisphere is bigger on the AE map. No, I don't see it doing something like that as described.
Yeah, but it's possible that it's possible. Like, to me, I mean, well, just put on your flat Earth hat for a second and just entertain me for a second. If the Earth is flat, we would have to. There would have to be something like that. If the Earth, if they're trying to make it a globe, like follow me the way I think for a second. If the Earth was a globe and it's really flat and they're making it out to be a globe, there'd be, that's one of the areas there'd be problems there. They'd have to come up with something to fucking explain that, to people, to normal people like you who track satellites, or even if you have a satellite up there, if you have something up there, whatever, balloon, fucking satellite in orbit, there'd have to be a problem in that area. And it just so happens there fucking is, so it's just a little suspicious. It sounded like a lot of excuses, man, but I can't prove any of that shit.
Right now, GPS, I don't know if I'm sure it still has the problem with possible reboots. So like where you would see a satellite there 1 minute and then because it's rebooting, all of a sudden you don't see it. So that might be some of the reason for outages and stuff like that. Where I went from 4 satellites to 3 and now I can't get a position. And then that corrects itself after it reboots. But that's the only thing I could think of with GPS that would happen, because GPS works a little bit on a different thing. Like the refraction through the atmosphere, I'm not sure how much that would affect GPS, although it would have some. But I think that's all calculated, baked into the numbers. The refraction's already baked into the numbers.
But that just tells you there's a master command in every satellite. There's a fucking master command that's not your computer. So they say it's there. They have an explanation for it.
Yeah, that's only telling you where the satellite is. I mean, they basically, with the master command, they're going and they're saying, okay, we just checked it with laser range finding and whatever else. You're not where you think you are because of the odd gravity wells around the Earth and stuff. So you're 10 feet off of the coordinate that you should be if you were just following a straight line or a perfect arc. So we're going to adjust that 10
if it was only 10 feet, I don't think it would be a problem with that many.
Even if call it 1,000 feet, GPS is reliably within.
Like the whole thing, shut down and fucking pop up in another place and shit. Like fucking disappear, drop. It's totally dropped. My question is they say they have the command computers and all the satellites, and then the regular computer, and so they have backup, and they can cross check the data and give you accurate information. And I'm thinking, so basically that's telling me that every satellite has a command computer. And how would the fucking command computer know if the other one fucked up or glitched or even cut out or popped up somewhere else or whatever, that all the problems they could have?
What do you mean by pop up somewhere else? They don't pop up somewhere else. They move based upon the gravity wells. So I'm basically, at least according to the model, and what they understand it to do. So let's say there's more gravity in this one location because of some geological feature.
But how about drop altogether then? Like if it drops altogether, or if it gives you unreliable information.
I don't see that happening. You basically all you're trying to do with these satellites is know where they are. I mean, even that system with the Doppler shift, the main thing that the military ship needed to know is where that satellite is. And what they do with these ground stations is they say this satellite is here. It's not going to jump 100 miles to the west instantly. It's not going to jump 300 miles to the east instantly. It's going to drift off course by, I don't know, a few hundreds of feet. I don't know how much. But it's not going to be this amazingly
consistently off. But my question is, and it could drop off altogether.
No. What do you mean drop off altogether? You think it's
that was one of the things he said? He said where sometimes, hold on, let me go watch. He gave 4 things that he's saying it does this, and this. I mean, it wasn't just a few hundred.
The satellite can go down. Right. The satellite can go down. It can crash. It can give wrong information. I didn't hear 4, but those are the 2 big ones. Is if the computer crashes, that satellite's gone. It's not going to appear again for however long time it takes for a reboot. And if there's ground intervention needed, like where they have to inform that satellite of all of its information, like it's here, give it all its basic telemetry back. That could take, maybe 15, 20, 30 minutes before that satellite comes back. So you'll have to go to the next satellite.
Hey, I'll be back in just a minute, man. I'll be back in just a minute because I got to double check all this. If it was just a few hundred feet inaccuracies, I would have never made that video. But let me see what his claim is and see where the misunderstanding is here. I just want to watch that part and so we're on the same page. But if you're right, you're right. But
I only made it halfway, so it's after halfway. While you're going, I'll go and look at some more of it.
Roger that.
Yeah, I don't know if Brian's still here, but I did look at it. I was more than halfway through. I didn't see any place where they characterize the actual distance. They talk how much the Van Allen belt shifts. That's thousands of kilometers.
Yeah, but he said it could be drastically wrong. He said it could go wrong. He said a little bit, or even drastically wrong information. It can cut off.
Right.
Malfunction, and
yeah.
But anyway, so yeah, it doesn't exactly. You're right.
Yeah, so the satellite, and it could be drastically wrong, but the thing that I think about the satellite is, I'm guessing the satellite with this system, it seemed like a Doppler-based system, so I'm not sure if it worked like GPS, where it gave an almanac message and said, "Here's where I am" to the ship. I guess it would have to. So yeah,
did you see the military part though? It's crazy. It's crazy that it has two intercept points. That's crazy that if you put up your own satellite, then you have to install their fucking their command, and it gets, and the information is routed through their shit because it's their fucking signals. They got the head, they call it headquarters, the fucking the Navy.
Yeah, command whatever.
Yeah, there's like two intercept points. So literally, I mean, when it boils down to it, whether it's legit or not, they're in control of the information we get one way or another.
Yes. Now, like one thing that I saw was kind of interesting is that the brute force method they use for the computers. It's like, well, we put 3 computers up there, and they're all running the same code. And if 2 of them come up with the same answer, I'm going to guess that those 2 are right, and that the other one just had a glitch. Be interesting to know how often that glitch happens to more than one computer. But a glitch will not happen. Will not be the same in both computers because it's going to hit
I mean, but who knows?
transistor and fuck up this one transistor, and it's going to give you a wrong answer, and the other one's going to get another transistor fucked up, get another memory position, and it's going to give you a completely different number. So
when it could be just a default, man, where they know where it's at, they know where your shit's at, and they fucking say, well, this is where the master computer says you are according to this. We've seen this before. It's just messed up that if you can pay the money to get your own satellite sent up there, but you don't have as much control. You don't have total control like you think you would. I mean, you do have control somewhat, but ultimately it's still filtered through the military, you know.
Really depends. Like if it's not a navigation satellite, you only need to know a rough location for it, and you could talk to it. Like some of these CubeSats, you could have 100% control of that because they're just dumb. They don't have any thrusters. They don't have anything. They just sit up there and transmit all day long. And so you can have it transmit radiation levels or temperature readings, which is kind of useless, but you could measure temperature. Does pressure of near zero?
But if you're gonna have reliable location, though, if you're gonna have reliable location signals, you're gonna need their shit. You know, I think.
Right. If you need precision, yeah, you're gonna need one of the several laser range finding stations around the world that keep on updating the position of those satellites.
It to me, man, I always kind of default back to what you call it, Long, the governor of fucking of Louisiana, when they were doing the bill, the satellite shit, and they signing that bill. He said he thought it was as crooked as a dog's hind leg, but he said but after reviewing the bill, it's that's an understatement. That's being kind. He said it's crooked as a bag of snakes. The shit that they had done, man, like the shit they had planned, you know, it's almost like he's almost saying that it's a fucking scam, you know. But I don't know, man. It's hard to deny, you know. I don't know, whatever's up there, it works. But and I'll say this, man, I know there's shit up there, because I lived in Cedar Key for a little while, which is on the other side of Florida, just adjacent or just diagonal to the East Coast, north. So there was no signal. They didn't even have a phone tower. It was a small little town with just like 500 people. Right. And they didn't have cell phone towers yet, and I got caught out there, you know, almost 30 miles out in a storm, and but
my GPS kept on plodding along.
Yeah, it worked out there, man. It worked every time I went out there, and then they wound up getting satellite signal and shit.
I had an interesting problem with GPS when I was out in God, what was it? Near Lynchburg. There was I'm guessing something that was blocking me from getting the GPS, so it could have been a local blocker, jammer, or it could have just been some noisy transmitter in there that was generating bands in the band of GPS. But what happened was I was cruising along down Route 64, and I'm going along minding my own. Oh, it's Waynesboro actually. I'm going along 64 in Waynesboro, and all of a sudden I am doing 1,200 miles per hour in my GMC Jimmy, and it's like I don't think I'm going 1,200 miles per hour. It was the worst glitch I ever got from GPS. It's like, holy shit, hold on.
Yeah, that's why I was trying to explain to I was trying to explain to him that, look, if the distance, you can't prove your distance by using speed, or you can't prove your speed using distance because they're joined at the hip, you know. So if the map is wrong, let's just say if the map's wrong, you know, once again, not saying 100% for sure it is, but if it is, and it's a further distance that you're going, just going to say that you're going a little slower, you know.
See, I'm going to compliment you on something. You seem to grasp some of these topics but you're always looking for the alternative answer. But you seem to be on the edge of grasping a lot of this stuff, and it's just like, God, I just wish you would spend your efforts to trying to fully understand something and not try and find the alternatives until
it's
after
not that I don't understand, man. It's not that I don't understand, and I would even say a couple things seem to be a reach, but it ain't like it's like everything is a big reach, man. There's some shit where, in my opinion, man, when the example comes up, I'll point it out. But where the globe model is somewhat of a reach, man. It's a good debate, man. I personally think that I think God knows the shape of the entire earth, man. But I try to stay open minded, man, and I try to understand as much as possible. And
well, I think you're one of the guys who's working the hardest. You actually get off your duff and you do stuff. Yeah,
I'm trying to make a map, man.
I'll compliment you on that. There's a lot of people who just come in and naysay, and we'll say, "Oh no, that's not how it works," and be done with it. But you do putter around in there. I think some of your conclusions are a little bit wonky, but you are definitely getting off your ass.
I just try and throw them out there as possibilities, man. Because I think like this: if the Earth is flat, then it's got to be such and such, or this has to be such and such. And but I don't know, man. It's dude, this world we live in, though, man, is God. It's so hard to pinpoint anything down for certainty, man. It's like weird, like almost any little thing you do, experimental wise, like there's anomaly, like there's always other explanations or possibilities. It's like in this world, nothing is 100% certain, dude. It's hard to pin anything down.
What we're constantly pushed into as globe defenders in this world. I mean, most people just take it at face value. Yep, the satellite works. It's cool. It's working by this method. Okay, I understand that. That's fine. Happy, good day. Now, when you try and get down to the precision levels that, hey, I want to measure at 100 feet. I want to measure the curvature. You know what? It gets real freaking hard down those levels. Shit just does not play nice. And that's anytime you make any small measurement. Small measurements, big measurements, they both are subject to the same problems. It just becomes exceedingly difficult to test things that are really far away and really small. So your confidence can go down with those.
That's a great example, dude.
Yeah. And so like when you ask me, how big is the universe, and they say 13.9 billion, I push the I believe button because I don't give a fuck. Whether it's 13.9 or 14 or 35 billion light years, or hell, a million light years, I don't really care. But when it comes down to things that are really close, like the moon, I think that's in our realm of extremely reasonably understood distances, measurable, verifiable, and that's where I'm starting at. Moon, sun,
or the cosmic radio or the microwave background. That's
good luck.
That's supposedly the limit of the heliocentric universe, right?
I think that's the limit of what we can see. I think
let's bring it back to reality, man. let's at least bring it down a little bit. Let me ask you a question real quick. How would you describe, like, how when you're away from the city lights and shit, like it's a whole different sky, man. It's crazy when you're out of the city.
Light pollution.
How would you describe the night sky is compared to the city, being out in the country?
I'm out in the country, but you know what? I got the grocery store that's like 3 miles away, and they light up that goddamn parking lot, and it does. I even have localized pollution. I'm not by any means.
You've been out in the sticks though, and seen up.
A
flashlight looks like a laser beam almost. Well, how would you describe that? Looking up, man. How would you describe it out of curiosity?
I don't know. I mean, it's more vibrant. There's more stars. It's crisper and cleaner what you see.
In my
that's how I would describe it.
In my experience,
Yeah.
I've been down to the southern coast of Delaware where there's almost no light pollution, and the night sky at times can have so many stars that it is difficult to identify any constellation.
Now, the reason I say this is because I want to defend my stance a little bit. Because when, like Neil Armstrong, and I'm not just going to use him as an example, but other people, I mean, you got to admit this is conflicting information. He said it's it's a black void. When we look at high altitude footage, it is an eerie looking fucking black void up there. You know, that's how I would describe it. And then you look at other astronauts have agreed with him, that one Filipino astronaut, but then other astronauts say that it's bright as shit and stars everywhere, man. And they say that you could see the freaking whatchamacallit. But then in that interview, Chris, you could tell that they didn't see any stars. And but Chris or Collins said that he didn't remember seeing any, and he was in the freaking. He never landed on the moon. He was supposedly circling around the whole time. So he would have. What are you doing if you're just circling around for 3 days, bro? You got to be looking out at the heavens. But he didn't remember seeing any stars. That's a little head scratcher there, man. Because when we look at the stars out in the sticks, I would never explain that as a black void. You know what I'm saying?
Right. I think what I would say with that is, like, when you talk about people on the ISS. Now, I can't speak to everybody. I haven't heard most of the modern tales of what they've seen, but the people on the ISS, I've heard a couple stories of them, and they don't typically see it. But the cupola on the ISS is facing towards Earth. So you also have the interior lights inside of the ISS. So I would say that looking from there, unless you actually shut off the lights inside and you waited till you got to the night side of the Earth, and you're still facing the Earth, so 90% of your vision is obscured by this big ball. I don't know how many stars you would see in that situation, but I don't think they turn off the lights very often in the ISS.
And as
they
far
can do
as
it for
the moon
special.
missions,
The moon missions, you got this big bright ball.
Right.
You've got sunlight coming in your portholes, and you got
Exactly.
interior lights.
All of the moon missions, as far as being on the moon, they're on the daytime side of the moon, and the moon is reflecting light at them. They're wearing visors that are cutting down the light that they're seeing. So, of course, you're not going to be able to see stars easily.
Yeah, but what kind of got me was the fact that he says in Sicily, that's the area between Earth and the moon. And he even says that. He says in Sicily, or the area between the Earth and the moon, on the way, he didn't see any stars. And when they're looking at the corona on the moon, and he said we couldn't see any stars, okay, without special, he said, but as far as planets go, he wasn't sure or not. He said he heard that we could see planets, but he don't remember seeing it. He said, I don't remember seeing any. And then Colin said, I don't. And then he's like, as far as the stars and all that, Colin said, I don't remember seeing anything at all. That was like, what? That was a hiccup there. Like,
wait,
I don't know what
you were just saying. They couldn't see any stars unless they, and then you cut off your thought. They couldn't see any stars unless they what?
Unless they had special filters.
Is what he said.
I mean, as I understand it, unless they look through a specific periscope that's designed to not, essentially it blocks the sun, so that you can see. The portholes on the spacecraft are going to get sunlight as they do. The interior lights are going to be on, so you have to look through this device in order to get a dark.
Yeah, but there's if you're up in space though, there's no atmosphere, so there's no earth shine. You know what I'm saying? We can see the moon. Right. We can see the moon in the daytime, even with the atmosphere lit up.
Yes. They can see the moon.
But once you get out of the atmosphere, you're in black. It's
right, but you're not in black when the light is shining on your spacecraft and coming.
It's always shining on you, man. If you're
right,
just
unless you're in the shadow of the Earth.
Unless you're in a shadow eclipse area. So you might as well say you're always in the sun.
If you're looking at the illuminated moon from your spacecraft, your eyes are going to adjust to the brightness of the moon, and you will not be able to see the the stars, which are so much dimmer than the moon.
You couldn't say that for sure, but
I
according to Massimino,
because that happens on Earth.
According to Massimino,
compare the stars that you see. Hey, compare the stars that you see on a full moon night with the stars that you see on a new moon night.
Yeah, even when it's dusk, I can see stars sometimes. A couple of them anyway, or planets.
Planets.
You know, at dusk with a full moon and a dusk sunlight in the distance. But when you're in the pitch black, what if you're not looking? I mean, the whole point that I was trying to make is that Collins didn't remember seeing any stars. And what else would
when
he
was
have
he
had
in
to
pitch
do?
black?
What?
When was he in pitch black?
He was orbiting the moon, so half of every however many minutes it took to get around, half that time he was on the other side, right?
At what distance was he orbiting? I don't know that.
I'm not sure,
I mean, it might be an exceedingly short period that he's in the moon's shadow.
Yeah, but 3 days. I mean, well, if he's going around the moon, the way they landed, if he kept going, then he's. I mean, I'm under the impression that half the time he was on the dark side of the moon. I mean, they talked about the dark side of the moon. Anyway, 3 days. I understand, but you see what I'm saying? Like a reach. Like there's globe explanations that are a little bit of a reach, and this just happens to be one. We've stumbled upon it. Like because Massimino says that even with the sun up there, as long as you're not looking toward the sun, that you could see the Magellanic fucking cloud, all this other shit, and other astronauts say it's a black void and shit, and you know,
I can only hypothesize what happened and why it's not. I mean, these guys went to space. They think they went to space, at the very least. What they see and what they observe is going to be subject to the conditions it happened under, and they didn't seem to question the situation. So I'm going to just I don't know what to tell you.
Well, that's about as honest of an answer as I've heard in a long time. You know, I'm trying to give straight answers to, like, you know, like I'm trying to eliminate certainty in this conversation. Like I'm certain of anything. I'm certain flat or anything. I'm just trying to look at some of the topics with from a neutral perspective and an honest perspective, man. That's all we can do, man. If we're gonna get anywhere in this debate, you know, if we're gonna learn anything, we got to listen to each other.
The thing that I find, you know, weird about the whole concept of, you know, the method by which you're coming in, you know, with the statement of, well, if the Earth is flat, how could this possibly work? There's so much to learn in the realm of what is purported to be reality, and I can spend my whole life in that and not scratch it. I don't have time. Obviously I do. I'm wasting my time doing this, but I don't have time to go and try and rebuild my cosmology without any good reason. And it just doesn't seem like there's a good reason to be making that jump. I don't mind somebody else doing it and coming up with an answer, but I wish somebody would come up with an answer that, like, that had some merit, you know, some.
Well, then you're definitely not gonna do good as a flat earther or a globe skeptic, because I'm trying to build this shit from scratch, man. I'm trying to look at a map. You know, that's kind of driving me nuts because it's not easy stuff, man. And it's like, God, it's I'm finding anomalies before I even get out of my city. Like just leaving my city, I'm finding potential fucking anomalies, you know, that they might not be nothing, man, but it just from what I see in down at the ground in the directions I think I'm going, it's like I'm already finding problems. I ain't even fucking left the state, man. It's like but I don't want to make any claims until I look a little deeper into it, bring my drone out there. But did you hear me earlier talking about Florida? Like if it's angled any different than what we're told, it probably ain't, dude. Okay, but if it is, and if the coast ain't stretching off to the west above me, United States, you know, further north you go, if it's a different angle, that's going to have some heavy implications, man. And to me, it's possible, unlikely, but possible. And I'm going to check that out. And as soon as I find out, I'll report. But it just seems like, man, parallel with the river that feeds into the Atlantic Ocean, parallel with that is a road that leads to Amelia Island, Fernandina. It's about 30 to 50 miles west. But on the map, it shows us. It shows it above us, directly above us. And I'm like, there's no way, dude. I'm right here at the mouth on the limits of our city. And I'm looking at the road. I can see a couple miles, but I've traveled that road so many times. It's the only way to get there without going all the way around and shit. And it's like, I could be wrong. I could just be getting twisted. But if the angle is not accurate in Florida, to me, that's going to have some big implications and a good starting point to make a map, like a flatter type of map, man. But it drives me nuts, man, trying to figure this shit out. It's driving me crazy, man.
Yeah, I've enjoyed, this, from the learning standpoint, like GPS, I like I said, I legitimately have tested the signal strength. And it wasn't to prove flat Earth or round Earth. It was just as I was going around in the early days of GPS with our receivers being iffy at best. They were crappy receivers. I went around and tested the signal all over God's green Earth. I'm talking really thousands of miles. And in that time, I was like, again, I wasn't looking for it, but I never saw the signal get strong. And it's like, wow, that's now we got into the flat Earth debate. I'm like, you know what? How I know how radio signals work, just when you get close to a tower, the power increases. It's the inverse square law, and that it almost never fails me. And I never go 10 miles away from a site and see the signal come in at minus 25 dBm, and I never get within 100 feet of the site and have the signal not peg my scale. So these are things that, like, experience wise, really preclude me from making the jump. And I've given it honest, I think everything that's been asked of me, I try and be as honest as I can with my experience to answer it. And I try and make it known when I'm talking about things that I don't know about, where I'm just hypothesizing. I'll say keywords like I think, or this is how I understand. For things that I'm not, really familiar with. And
we ain't experts. We're all the experts in our fields, man. I was going to say this: GPS aren't GPS geosynchronous? Like, don't they?
I hate that word. They move around the Earth in a multitude of different orbits, different directions.
Oh, so they're not they're not geosynchronous. They're not like so in other words, a satellite that's over me now. Or wait a minute. Let's say I was in Cedar Key. Like when I said that I had signal and there was no tower, so it had to be something up there. So when I was there, the satellites I was reading, are you saying that that I would be reading new ones?
You're reading new ones every couple of minutes.
Okay, so as far as GPS goes, they're always in motion.
Yes. And that's kind of understandable, because the only place that you can have geostationary is over the equator. These things go near the poles. They follow a path sort of like the ISS, but some of them are coming from I don't know what the word is, but some of them are coming from east to west, and some are going from west to east. In that trajectory between the poles. So they crisscross like an atom. There's the signal of an electron around an atom. They're just sort of spinning, going all around the Earth in multiple different axes.
Right. It's a hell of a system.
It is. That's like when I find out how it really works, like where they have to take in relativity into account and stuff. It's like, wow, that is so freaking cool.
One of the main guys claims he debunked it, man. One of the dudes who's one of the top dogs in the fucking in the satellites and shit claims that relative bullshit. He has an I can't man.
I don't remember what he said.
He has an
I know he's
alternative
talking about it.
explanation, man. He has an alternative explanation, but it was.
I don't. He may have an
But,
alternative
Body
explanation,
ain't
but I don't
behind
know
that.
if he excludes. Like I think his is another possible answer, but I don't think
he
it
wasn't a flat
excludes the
earther.
original answer.
He wasn't a flat earther. He just was he just was saying that as far as a load of bullshit, but he was a globe earther though.
Oh yeah. Anybody who works with satellites is a globe earther. That I think is going to be 100%.
I wish I remember because he was saying why that he was given his idea of the real reason why.
Was he like Was he like an energy state guy that
I forgot,
just implied that based on speed that the energy state of the cesium clock?
No, he's a glober, man. He was
no,
a glober.
I know.
He had a different
explanation.
He had a different
explanation
of why they had to continually update. And,
right.
And I forgot what it was, but it sounded reasonable, but I forgot what it was to even repeat. So I apologize.
Okay, that's why I was trying to feed you something like was he like an energy state guy, where he's just saying that because like the velocity, the cesium atoms, also react differently because of how fast they're moving or something like that, instead of being a time dilation.
I'll try and remember, man, but I don't even know if I should have mentioned it.
That's fine. That's fine. I know the guy you're talking about.
That's what I was talking about, man. There's always there's always an alternative explanation, man, and there's always skeptics in every field. I was asked who at the beginning of this subject when I first heard about it, I was wondering, who would I go to? Who would be the people to go to? And I was thinking about like reading into Einstein and like Neil deGrasse Tyson and all this. And but after being in this for so many years and everything, it's like, dude, we are the experts. If you want to know about a flat Earth or globe Earth, models or something like that, we're the experts, man. Because everybody else who's not in this debate doesn't know near what we know, and we're the ones diving into it and seeing every side of the story and the skeptical points, the contention, and every subject. We're the only fools we're the experts pretty much in this topic, man. The people in the debate who've been in it for a while.
I have found when a PhD gets confronted by a flat earther, it's usually a pretty funny event because it's like, as the PhD, you're not used to.
You're just thinking common sense, man. You're not thinking about a globe model, right?
Questions.
It's so weird, dude. Because before this debate, nobody even really thought about the Earth even being a globe or flat or anything. It's just it is what it is. In the back of our head, we're thinking globe, and but we never really thought of the implications on a day-to-day life experience. So we're going to answer the questions, just common sense explanations, and it just happens to backfire when you go deep in the topics. But talk about my so, like I told what you call it. If I ask everybody in the world who's never heard of this debate, what would happen to a line floating on the water if I pulled it down 7 inches in the middle?
Yeah.
Yeah, if I pulled it down 7 inches in the middle and pulled it tight from each end, what would happen to the but Globers in this debate, have a different frame of thought, so they're naturally thinking about the curve, actively thinking about the curve, so they're going to think that it's going to go down, 14 inches or whatever it is. In your head, it's going to go down. But before this debate, you probably would have answered that when you pull it tight, it's going to come up higher, level with the other sides, right?
Yeah, I think one that I thought was interesting was the scenario where you put the scale on the ground and the line on the ground. And as I started thinking about that, I'm like, oh, you know what? As you tighten that up, the line is actually going to get heavier, even though it's lifting up initially, because as you start to pull on the ends, it's the scale is actually now bearing all the weight of the line that was being supported by the ground.
Right.
And then
so
there's a
initially it's
magic
going to get
point.
heavier.
Yeah, and then there's this magic point when it should, if you could get rid of all the sag, then it would get lighter.
That's why he's got to try and find a way to mount the scales flush with the ground around it, if that's possible. But yeah, it's.
But then I think if you do that, you're actually dealing with such minuscule force at that point that because basically that line is supported by the ground every inch along its path. So if I was to pull down on that with tons and tons of force, well, you now got to distribute that tons and tons of force across the entire length of that line. And when you run the amount of force that's pulling that sag out with towards the ground, it becomes a minuscule force. And then, like, I liken that to, like, if you take 100-foot rope and you pull it as tight as you can, and put it right on the ground and pull it tight, like a ton of force either direction, you can go to that middle of that line and you can lift it up a quarter inch, no problem, even though it's got a ton of force.
I agree, man. That's why I'm going with the fishing line, dude. Because when I pulled it over land, I was shocked because I pulled masonry lines for a gajillion times. I can't even count how many fucking lines I pulled on numerous jobs. And once you get a long distance, you have to tie it around another stake because it'll start sagging after about 75 or 100 feet. It's noticeable sag. And when I pulled that fishing line, it was nothing like the fucking string line, dude, which is made for pull and tuck. It was so much better and sturdier. Of course, it still had a little sag, but I pulled it 570 yards and it only had a few inches of sag. I couldn't believe it, man. But even still, that's nowhere near a few miles or something like that. That's why I was trying to think of a way to do it to where sag didn't matter, where no kind of force mattered, where I could even them all out close enough to get a direction, right? But it's not easy.
Every time you want to try and do something like this, it's like you get defeated by reality, because you go and say, oh well, what if I just put it in water and it's neutrally buoyant? Well, what does neutrally buoyant mean? Is it within 10% of the buoyancy of water at 75 degrees? Is it within 20% or 1%? And then if you start calculating that, if it's 1%, that means that it's lifting up 1% of its own weight in buoyancy or sagging by 1%. Well, 1% all of a sudden becomes a real substantial problem, because you got you have 50 pounds of line out there. 1% of 50, that means it's got a half a pound of force on it pulling down.
Right. When you're talking reality, shit does change, bro. You're right about that. That's why, but I've scaled it up, and so I know that the whole challenge is going to be getting that line set where we want it, and then to have time enough to pull it and break it, and see what happens. That'd be the whole challenge, and if it's possible or not would be the fact is, can we manipulate that line down the length of it? Will we be patient enough to fucking? Well, I know it's going to take a bunch of teeny, picture a cork as a float. Now picture picture a cork cut into 4. So you got 4 pieces. So I'm thinking of a bunch of teeny little floats, man, using buoyant line. But yeah, it's like you're saying with the buoyancy, even if it's buoyant, it's still going to fuck off in different directions and shit. So think of a bunch of teeny little floats and think of like a split shot that you put on your line. If you're brim fishing or bass fishing, think of like cutting that into 4 and having some real small little weights, man. So I was thinking about spacing them out as needed. First just getting the line across the 3 miles. And then starting each side 1 foot underwater. Each end is 1 foot underwater, okay? And then so we're going to try and pull it fairly tight. I mean, the line that I got that's 200 pounds, it's insanely strong, but still, when you're talking them distances, it's going to be a bitch to level that line out. So I'm going to try and put it down 7 extra inches in the middle. So it's going to be a foot lower than the water all the way across, but then we're going to transition it down where it's 19 inches lower in the middle, 7 inches lower than the 12 inches in the middle, and try and transition it to either side, as best as we can. And then
when we get it, try and do this over the initial test.
I don't know, man. I got a place in Orlando, man. To be honest, a guy who another flat earther says he has a spot. I haven't really seen it in real life, but there's one spot that I've seen that's it's the very end of a creek There's a straight line, like at the end of the Guana River. It's not really a river, but it dead ends. That's the whole challenge is finding somewhere close, So I might have to travel a little bit. So I want to have everything prepared, and I want to have adequate help. But it's hard when I went to do it. It's kind of got to me that I couldn't get even two people out there, one person on each side to even run the 1 mile. So I got frustrated and said, "Fuck it, dude." And did a little GoFundMe, and we talked about it forever, and nobody fucking pitched in. I'm like, so apparently nobody even gives two shits about this shit, man. But me personally, I still want to do it. So I'm eventually going to do it, man. When I'm not so busy.
I like that test. I kept on thinking with the neutrally buoyant line. Like I ran a SAG calculator, and on like a 1/1000th of being perfectly neutrally buoyant. So I said, like, if I took a kilogram line, that it would be off by 1 gram, either floating or sinking. So you just take the line, you make a coil of it, you shake all the air out of it underwater, and you just sit that line in the water. And if it goes up or it goes down, you measure the amount of force that it's going up or down with. And then you could kind of guesstimate whether it would work or not. Using your weight method, I don't know how you're going to get the precision you need, but yeah, that'd be interesting. But one thing I'll caution you about, as I've thought about the problem, is make sure you spend enough time at a given tension for the line to do whatever it wants to do in the middle, because that line is going to have to be pulling its sort of like sideways through the water, and in order for it to reach its equipotential level, you're going to have to wait some time in between each tug, as you increase the tension.
Dude, hold on a second, man. Excuse me. It sounds like a fucking nuclear fucking war off in the distance, man. Like
thunderstorms?
Like no, it's some kind of firing, like or the fireworks, but it's going crazy. It's louder than when the city does them. It's crazy, man. It must be some kind of festivity, man. But sorry to interrupt.
The Russians.
Yeah, dude, it's loud. It definitely made me interrupt there at the end. Like, what the hell is going on, dude? But
I've been interested in this, and like every test, like the tests that I under laboratory conditions are the ones I like the best. But anything that I've looked at from a standpoint of I think it'd be wonderful to make your own little LIGO setup. Take a 4-inch PVC pipe, and then just over the next 3 miles of 4-inch PVC pipe, or even a mile of PVC pipe. Take that thing, put the water up to an exact level inside of it, level the pipes up the whole length, and then you'd have a nice reference that you could look down, sight down with
Dad. Let me say something real quick, dude. That's my other idea. Is to get some 4-inch PVC and couple it together where it's airtight, but put like 5 screws in each one, because that PVC is pretty damn stiff, man. And even though I know it's going to be somewhat flexible, but if we line up the screws at each link, pretty much we can know if it bent and how much it bent if we mark it. The thing that gets wait, real quick. If we just float it, if we float it, we lay out a straight line, like a couple miles or even a mile, and we float it, and then we turn it on its side. But you're right. When reality hits, man, there's a lot of fucking practicalities that are tough to deal with. Go ahead, dude. Sorry.
Well, even that, like I thought about that, and I said, what? If I got myself, 50 or, got everybody who has a vacuum pump around, and I put a vacuum fitting on this thing, and I put one of those GoPros at the end of it. I paint the inside of the pipe black, and I shoot a laser through it. Does the laser make it to the other side when floating in water? That would be a great test. But when you start talking about a mile of PVC pipe, you're talking real money again.
Yeah, you are. And you could probably, claim some of it. You could probably sell some of it and get some of the money back. Probably reclaim some of that. But I was thinking, dude, if it was a worldwide effort, like if more people joined this thing, if they had never slowed it down or whatnot, or if it just for whatever reason it slowed down, if it just kept gaining force like it did there for a while, if we had enough people, we can like city and just tell everybody come out and bring a fucking ladder, right? And we make a line up to the White House, right? And all the way from like 100 miles away, where everybody's holding hands and everybody's marching to the White House to prove it, and everybody's holding hands and everybody has a ladder, right? And 100 miles long, we're as far apart as we can get before we let go of holding hands. You know, we're hanging on tight, and then at the same time, everybody climb up the ladder while still holding hands, because if we were holding tight and linked over 100 miles, there's no way we could all keep holding hands. I was just thinking of anything, dude. But then if you think about shit like that in reality, it's like, dude, if we are all holding hands and we climb up a ladder, we're just going to be fucking holding hands up a ladder. We're not going to get further apart. That's ridiculous, dude. How could we possibly get further apart if one person's on the other end 100 miles away, and just from going up, you're not going to get
you got to remember that you got to remember that the thickness of the fingers, the skin on the hand, every person that's holding the next person, if they had to hold a little bit tighter, they're actually further apart. And so you could make up all these distances with just a couple, you know, just those little changes in how far a person's arm is stretched and stuff. So now you got to have people.
Yeah, it winds up being where you'd need more people though. But once you find out that that the globe Earth and the flat Earth over 100 miles is only like 10 fucking feet difference, you know, then you're like fucking yeah, it would be impossible, you know. But and it also depends on how you think. Like me, I think we're just going to be holding hands up the ladder. But somebody thinking about a globe might be like, dude, no, you're not going to be able to hang on. There's no way, because it's going to be 10 extra feet. But me, man, but if you ask somebody who's not in the debate, they're going to answer that you're just going to be holding hands, standing up the ladder. That's my opinion for somebody who ain't in the debate. But one other thing that my main point that I almost forgot was that when you start thinking about that, if the difference in a flat Earth and a globe Earth over 100 miles, the distance is only 10 fucking feet, then man, that shows you how we're not going to prove shit with distances or maps or shit like that. Because dude, how could you get accuracy of 100 feet in straight line distance anywhere on Earth? There's nowhere you could do that. And then the further you go, the more the margin of error goes up. And so it's happening above you. It's just so close. There's hardly there's no straight line distance.
That's one of those things, though, that
you know.
That's one of those things that you just said there is, I'm astounded when I look at geodetic surveying, and you can claim every type of mistake you want to get, but when they get from the Gulf Coast to the mountains, let's say in fucking Colorado, and they come up with a height for that mountain, I'm just astounded. The number of measurements they had to make to get there, and then to get an accurate result within, you know, a few centimeters, is like, wow, that is precision so far beyond my my ability. Like when I go to build a cabinet, you know.
Yeah, but it's all based on average. There, man. It's based on averages, and it'll change when they go to do it again. I guarantee you, if another company goes out there, they will get a different answer. No two people ever get the same answer, man. It's crazy.
They don't get the same answer, but they, over those distances, they're only, let's say that everybody's answer for Mount Everest, they did this at 100 miles. They did the measurements and calculations for that, and they came up with it, and I think they were within a meter. So within 100 miles, they were able to get the mountain's height within a meter. That's astounding accuracy. And
how are you checking that? How are you checking the height to see if it to be even off the meter?
Well, there's several ways. I mean, there's gross methods that you can use, which is, you know, you can go up there and you can use a barometer, and you can say, okay, I can see that I'm definitely around 29,000 feet. So that's like something that has like a precision of, you know, probably maybe 100 feet.
I'm
then
aware of the
use
ways to do it. You know, the most realistic would be triangulation and all that shit. But then you got to have some baseline assumptions and stuff, you know, to go with it. But
Right,
that's
but if
what I
everybody's
was about earlier, man. When in reality, man, it's like so tough to pinpoint anything down to a perfect science, man.
And now we've got this thing that gives us millimeter accuracy, or a couple of millimeters of accuracy, GPS. And that's the baseline that I'm using right now to say that they were dead on balls accurate when they did it back in the 1800s. It's like, holy shit, they were fucking close.
Yeah, but
and that was a measurement from sea level carried from, not only the last 100 miles was done optically, it was, probably 200-300 miles to the ocean.
They use least squares method though. Out in the field, they use the least squares method. So it's all depends on independent local fucking averages. You know,
but they got an answer that was accurate,
precise as they can get. It's just still not
as precise as they can get, but it's still very precise. And then when you use GPS, which is independent of those methods, I think that's astoundingly accurate. And
but
GPS,
like I said, when you're using least squares, it's not going to prove anything. It can't prove anything if it's using the least squares method because it's all independent, no matter how accurate it is. So here's the question: is the fucking satellite, are they curving? So if I'm putting them down as curving, even though it's so close between a flat Earth and a globe, within anything you ever do, it's the distance between anything that you could see is so close you'd never even be able to tell. But even if you want to try and get super accurate, man, then you got to ask yourself the question: is the satellite going straight overhead, or is it curving? So if it's going,
well, again, you would need to have something that coincidentally always gives you an answer that happens to correspond to the other method, that's the thing that's where I think precision comes in. When I have two spectrum analyzers, these can be highly calibrated equipment, but I had no facilities for calibrating and no budget for calibrating. So what I would do is I would use the method of two different devices. And if the two different devices came up with an answer, you know what? I'm pretty damn sure that they're right. I could do that with three devices. And just if it was a random error, then I would expect one to be high, one to be low, maybe two to be high and one to be low. Then I'd take the two of them. If they're all different numbers, then I'd say that they're all out of fucking whack and they need to be checked. So that's my rudimentary calibration.
I feel you, man. It's just it's so fucking similar and local and close up distances. It's so similar. It's difficult. If nothing else, it's difficult trying to come up with a method that doesn't use signals, because that's kind of like light. Because then, we could claim refraction like y'all, and with lasers, like even though we have some long distance ones, it's fair to claim refraction, no matter how I could get stubborn and I could show like a bunch of lasers and stuff like that. But, I mean, it's still a point, whether I agree with the fact that the light's refracting around the ball are enough to make it appear flat and be a globe. I mean, whether I agree with it or not, it's still, it's a possibility. And so I'm not going to completely overlook, no matter how likely some people might think it is, or I may think it is, it's possible, man. It's fucking possible that the light is refracting like that. So I got to keep an open mind on that. So that's why we're trying to think of a tangible same thing with signals. Like, it's possible that there's refraction or something going on, no matter how likely. It's still using, that's why we're trying to think of a tangible test. It's just so difficult, man, to come up with a method.
It's not difficult.
Let Coach show in for a second. He's been trying for a little while.
I just got here, to be honest. But okay. That's very nice of you, man. But two things. One is me, and because I'm not sure what you're talking about right now, if it's either refraction or if it's long distance test. But in either case, me and Mr. Bandsaw last night, we actually struck a deal, and I'm actually doing his test with gelatin, curved atmospheres, curved refraction because of curved mediums. It's gonna be pretty big. But if you're just talking about doing a straight line test and that kind of thing, there's always been an answer to this, man. We all know the answer. We probably could say it in unison. But you guys aren't happy with it. That's the problem. But there is a test that will give you. I
mean, I start thinking like that sometimes, man. But then, like last night, I was looking at some of the old laser tests, dude, and I'd seen about 7 different good ones. You know, there's a bunch of them, but there's a few real good ones, man. And that fucking 21 mile over the train tracks, dude. It's like, dude, there's some crazy good laser tests, man. It's like,
no. You thought that was the word? I don't know. That's not the word we'd say in unison. Lasers? No, I'm talking about GPS, dude.
Yeah, precision. I know, but that's still using signals, you know.
No, but it doesn't matter though. That doesn't matter because so whatever the method it's using it, all you need to do is confirm. So you can use it. Let's say this is what me and Eggshells are trying to do. Take it to some specific location, like the corner of your desk. Like draw out your phone and locate your position using this method, and then do the same thing again 3 hours later, and then maybe the next night. And if whatever the accuracy you get for all those, or the precision, I'm sorry, that's going to determine what precision you're getting. So if you're getting precisions within 1 centimeter, and then you can consistently do this, you're going to be able to make a very long straight line there's no errors at that point. There's not going to be any errors that are going to be they're hidden or something like that. If you're making straight lines locally, then if you're making exact positions locally, then you can make straight lines infinitely. That's gay. That's gay? First of all, it's 2022, bro.
I'm not talking like the homosexual gay, man. It's gay.
Well, it's not gay, dude. Everybody knows that's why it sucks. So that's why it sucks, is because everybody knows that it's accessible and it's definite. There's no way. It doesn't matter how.
Yeah. Wait. I got a question. How far is each GPS satellite ranging that they're using?
But that doesn't matter. That's what I'm saying. Once you confirm it.
Yes, it does, because they're using least square. They're using the surveyors use GPS, use least squares method. So it's all based on basically the local averages. So it's very it's very precise. But as far as linking to each other, it's averaged like the tangents. It's all local, man. And so
it's actually not using least squares method.
But the thing is, if you're getting precise points, you can graph that out however you can take a piece of paper and just draw your data, get these 2 points, jot them down, and draw what a straight line would look like, which is just connecting 2 points. And then now that you know those 2 points, try to find points along that same path between those 2 points on the surface. This is a very simple version of the test. You can then compare points along that line and see how far above or below that straight line they actually are, whether they're on.
Yeah, but is the satellite? Hold on, is the satellite? Is it going straight over my head, like I think it is, or is it curving around an Earth?
The satellite has nothing to do with this, dude. Well, I told you, once you've confirmed that you're getting precise positions, the methodology for how GPS works is not at all relevant. You can use
it's got to have a baseline.
Giving you exact positions.
It's got to have a baseline. It's got to have a reference point. It's got to reference off each other. So you're trying to use your model to prove your model. It's like,
no, dude, you're not listening, man. It's like I'm not sure if you're not trying to listen or if I'm just saying it wrong. But
let me say something real quick, man. Before we get derailed. When before you joined, I was talking about we were joking around. And I was talking about like what I was thinking about at the beginning of this of when I hearing about flat Earth is like getting like if it had kept momentum and and everybody jumped on board and considered it. And I was thinking about like a whole movement of people. We make a line from going all the way to the White House, like stretching 100 miles, and we're holding hands. And everybody comes to the march, the rally. And we stretch 100 miles. Everybody bring a ladder. So we're all holding hands. And at the same time, we count 1, 2, 3, go. Everybody climbs up the ladder and there's going to be gaps. We're not going to be able to keep holding hands because we're going to get further apart on a globe, but it'd have to be a crazy distance, like 100 miles. But if you thought about that, dude, in reality, we're still going to be fucking holding hands. We're just going to be up the fucking ladder, you know?
All right, let me ask you a question, sir. Okay? Let me ask you a question. Let's pretend that you have a rope, okay? A rope that is tied across the entire equator. There's a rope that goes all the way around the equator. It's just a very perfect rope. It's this rope of people holding hands, whatever you want to call it. It's on the surface of the ground, though. It's a big rope going around this the surface. And you lift it up 1 meter off of the surface. So that was on the surface, that you lifted up above the surface 1 meter. 1 meter everywhere. Okay? How much rope do you think you need to add in order to increase that height?
I mean, we just got to fucking... How far off are we going to lift it?
You're going to lift it 1 meter.
So, I mean, why don't you just use something like a mile so I can just multiply that times this times pi, you know?
I'll give you the real answer, dude. It's easy. It's 2 pi. That's the answer. So if it's 1 meter, you lift it off the ground, you're going to have to add 2 pi rope, about 6 meters of rope. And so when you put that together, that's 6 meters. Let's say the people got up on a ladder.
Yeah, that's what I was getting to, bro.
Yeah, but that when they get up on the ladder, that 6 meters amongst all those people is going to be spread out.
Yeah, it's not going to do that. Yeah, you didn't let me finish, and I just let you carry on. But I was going to say, in reality, that and plus the distance over a flattened globe, over 100 miles is not even 10 fucking feet. It's just barely under 10 feet. So we'd never know any fucking way. And that's also why I was asking you. If you're trying to think about getting distance over 100 miles. Your fucking margin of error, there's no way to find a spot straight enough with enough precision to be able to narrow it down within 10 feet without modeling it. You're using GPS, you know.
Dude, I already told you. This is the part that I don't understand. You got to pay attention to. Is that if you've measured locally, you've confirmed that in that spot you have a precise position. You check it over and over and over again 100 times. It's giving you the exact same position every time, okay? Because the method you're using, so you're sure you're within a centimeter. You do the same thing with some point 100 miles away, okay? With the precise position. If you connect what do you call that? Establish a straight line between those 2 points. It would be should it be just above the surface? It would just be connecting those 2 points. You can then go from, imagine there's a great circle or a straight line from one point to the other point. You can go anywhere in that straight line, in that path of that line, and measure the surface of the ground or the surface of the water, and you can be sure that straight line you constructed is just as accurate as those points were. So it's not going to be, it'll be, that straight line is going to be a centimeter thick or a centimeter radius thick. But it's not.
I never seen nothing that accurate, man.
Outside of that.
I never seen nothing that accurate over, except for just up close and local.
Yeah, but that's what you're not. That's what you're not getting, I guess, is because it's not. The points are absolutely measured within a centimeter. Absolutely, the straight line that you're establishing between them. This is mathematical. So
okay, so there's no variables.
It's perfectly a straight line. All you're doing is you're measuring points, and this is a straight line that should be established.
I'm good with the straight line thing, man. That's not gonna. I know. We're not gonna have a dispute, and we're not gonna have a dispute with straight lines unless we go down south.
There's no straight lines. No matter where you go on Earth, you can make this straight line. What I'm saying is that you would compare this mathematical.
Wait, what'd you say? What'd you say about anywhere on Earth? What?
You could do this anywhere on Earth.
Yeah, I know, but what's the problem as far how far of a straight line are you talking about? It
can be half the Earth. It doesn't matter. The point is that you would measure.
How are we gonna test it though? We're gonna triangulate or what?
No, you would not. You would measure points along that path. So think about Stanley's Bridge. That is a great example because they did this on Stanley's Bridge. He measured points at each end of the bridge. These are your 2 precision points. He had precise points for those 2 points. He then measured points all along the bridge, and including in the center. this is the same thing I'm talking about. You would just connect 2 points. It could be 100 miles apart. It could be whatever you want it to be. And then you connect a point, and then you measure points along that path. And what you're looking for,
yeah, I'm with you, boy.
What you're looking for is if those points along that the path of that line, if they rest near that line or somewhere far away from that line, because they should rest very near that line.
So you're a humpist. You're a hump earther, right? You believe in the hump. You believe in the hump.
It's a curved earth.
Dude.
It looks curved. A quick question, or a quick statement, and I'll let you guys go back at it. But you had said something about the ladder people. The 100 miles of people is 528,000 feet. With the average, arm span, let's say holding hands, I chose 6 feet. And I said
right.
times 0.25 inches. So that basically that's 88,000 people all holding hands. Now with those 88,000 people all holding hands, if they move apart, they're holding hands, but they move apart a 1/4 inch each. That represents 1,800 feet.
Yeah, it's not practical, man.
Yeah, 1,800 feet of distance.
Yeah, but
you can increase.
Yeah, but in reality, if 2 people are on the ground, and no matter how many people are holding hands, if you climb up a ladder, you're just going to be up a ladder holding hands. That's reality.
Right.
I mean, I know that we think that it's globe looking up at the heavens and all that, and looking the way light does and shit, but in reality, it's just not, dude. It's just when you think about a line going over a lake, floating on the water, if you pull it down the middle and you pull it tight, it's going to fucking straighten out. It's coming up in the middle. That's just reality, dude.
That's
my reality anyway. That's my reality.
Built bridges where they know that's not true, because they I forget which bridge it was, but it's like a rope ladder bridge or rope. I'm sorry, not rope ladder bridge, but suspension bridge, whatever. Anyways, yeah, and they knew that the top parts were going to be slightly further away than the bottom parts, and so they accounted for this.
Golly, why didn't I think of that?
Yeah, what is the White Stone Bridge? It's supposed to be like an inch or 2 wider at the top. And I think that one's that's testable, but could you get together permissions to go and test it on an active bridge like that?
Honestly,
but I think it is testable.
No, honestly, dude, that's okay. Check this out, and Moyak, you'll appreciate this. Nobody else in here will, but if you did the GPS thing, what's 2 cities? You live in somewhere, Moyak, but you don't live up north. So like New York City, and what's another city? Philadelphia. How far away is it? Maybe 100 miles?
I don't know. 100 miles, yeah.
Okay, let's say it's 100 miles. So you have these 2 cities. You take the 2 tallest buildings, 2 tall buildings, and you just take each building and you measure perfectly the 4 corners on the ground floor and the 4 corners of the top floor, and you ensure that this is like a rectangle, like a perfectly rectangular prism, and just for both cities. You're like, okay, great. Now measure the bottom corner of one of the buildings, the building in New York, and then measure the top corner of that same corner, but the same building, and then do the same thing in Philadelphia. Measure the bottom one and the top one, and then what you're looking for is a difference in distances, just like you're describing right now, because there should be a difference in distance from the top, the difference between the top floors and the bottom floor.
Yeah, so it'd be like a 1 degree tilt, or 1.5 degree tilt over, or 1 1/3 degree tilt over 100-foot building or 200-foot building. That's all the buildings you're thinking of.
That's what the book?
It's going to be a couple centimeters.
Yeah, I forget what it is because I haven't done it in a while, but yeah, you're right. Couple centimeters.
Yeah, reality is a motherfucker, ain't it, man? When you start thinking about proof, like practical proof, tangible proof, instead of optical.
I think it's the best ones. I don't know.
It's not easy, man, to think of a way to nail it down.
No,
reality's got as a motherfucker, and reality does not like to be nailed down. It's weird.
Dude, I'm telling you one that I know it to be concrete, absolute. I mean, it's at least worth the shot. Like, what kind of phone do you have, Brian? What kind of cell phone do you carry?
Bro, you can't use a model to prove.
No, seriously, what kind of cell phone is it though?
It's not sure, man.
Is it new?
It doesn't say. No, it ain't new.
No, it's not new. Okay, well, Eggshells has one. A couple people have one, like Galaxy Note 20 or whatever like that, or Galaxy S20, S21, and then there's the A Plus or something like that, or One Plus. These phones, they have the dual band frequencies that I can use to do differential GPS measurements. And
bro, get off. You got to get off GPS, bro.
No, but
I'll never. I'll never.
Brian, you're sitting here saying,
if you go to GPS, I'm just going to go back to lasers, bro.
Brian, you're sitting here saying, I wish this should be so easy. It's so hard for us to
listen. You say
this is a precise way.
Let me say something though, Coach Show. You say my laser beam is refracting or whatever you say it's doing. I say your GPS signal's doing whatever the fuck that shit's doing. We got to think of something practical, man.
I mean, listen to me, man. There's nothing to forget about the signals. Forget about the GPS signals. What we're doing is we're determining if our positions that we can get are accurate. If you can determine that your position, that you're getting accurate positions with this method, you're like, damn, it consistently gives me centimeter accuracy positions.
Yeah, but we got to go 100 miles, bro.
If it doesn't matter, if you can determine that though, Brian, then you don't need to talk about how it's.
There's nothing that accurate, man. I don't believe that there's.
It's more accurate than that.
It's got to be modeled, and you can model it to match a fucking model and get it as accurate as you think you can. But if you got to go 100, hold on. If you got to go 100 miles to measure a 2 centimeter fucking difference and over 100 feet, I mean, what do you think's magic about this GPS model,
Brian? First of all, your questions are. It sounds like you're not understanding what I'm saying, but I know I didn't mention this part, which is there's no model being referenced, dude. What I'm talking about is getting the raw data from the GPS, doing the differential GPS measurements with that. The raw data doesn't reference a model. You don't need there's no model at all.
The raw data is just the time, right?
The raw data will give you the distance. We'll give you the XYZ data.
So just times, but even
exactly.
Raw data,
it'll give you the time, but then the Rhinix files, which
the
displays
satellite
it for you, will give you the XYZ data.
But you can't just have a satellite just nowhere. You've got to put it. You've got to chart where your signal's coming from and where it's going to. Okay, or to figure out where it's going to. You can't. You say raw data and you make it sound like it's a blank canvas, but it's got to be charted. It's got to be coming from a place. So in other words,
you're going backwards.
If I'm doing celestial navigation, bro, if I'm doing celestial navigation, it's what I learned right off the bat. When you think you're just gonna do like 69 miles a degree, but you can't do that with a star because you got to find out where the fucking star is first, right? Same thing with GPS. If wherever you're getting your signal from, it has to be somewhere. You're saying raw data, though.
Yeah, no,
there's no such thing as raw data.
Brian, if you and me were doing a test, we said we need precision. We need to find something that we can get precise positions. Okay, and you had one method, I had one method. My method was GPS. You used something else, but we tested them. And we said, okay, is this giving us our precise position? Is this exactly where it says it is? Or is this exactly where we say it is and where the GPS says it is consistently? If we determine that, if we determine that, Brian, then we don't need to talk about how GPS works or where it's coming from.
You're saying, but according to what? Whether where it says we are according to what?
Base station. Go measure it at a base station. Say I'm at this base station. This base station location is known, or just measure the same location twice.
Then we got to know where we got to also know where the signal's coming from, right?
Brian, no, that's not the point of what we're talking about, though. What we're talking about is determining if it's giving us precise positions. If you've determined that, then you don't need to talk anymore about how it works because you're using it for that fact. You're using it because it's giving you precise positions, not because you're trying to prove satellites.
So how is it giving you a precise? Let's start from super scratch without getting retarded.
But you're missing the point, man.
Well, I want to go through this with you to see which one of us ain't thinking right. And maybe we can get resolved. So I'm not talking about every single. I'm not going to try and talk about every single variable, but let's just say,
Brian, that's not relevant because the only reason why we're using this is because we need something that will give us precise positions. It doesn't matter what it is.
You got to find out how it's doing that, though.
No, we don't. And if it's giving us precise positions, we can move on to our actual test. Our test isn't to figure out how GPS works.
How is it giving you a precise? I challenge that.
That doesn't matter. You're just changing the subject at this point. Because
actually, let me try for a second.
Yeah, please.
Let me take. We go and we test, and we take a 100-foot measurement. We take his measurement. We find out it's precise within a centimeter on his desk. Now we roll out a ruler and we go 100 feet away, and we measure to the end of that ruler, and we find out that it's still within a centimeter over 100
that's
feet.
Empirical. That's empirical.
Now,
okay, go ahead.
Now I can keep on doing that a few times. I typically would think of something like that. I would spot check it. Like I'd make sure that in New York it gets 1 centimeter accuracy, and then 100 miles to the west, 100, and then I go 1,000 miles. I try again, and I do another 100-meter test over there. So
in reality, we can measure distances with rulers. I definitely agree, but here's the problem: if me, you, and Kosho did that as best as we could for our whole entire lives, we would get a different answer every fucking time we tried to measure some kind of straight line on Earth. We tried to do a straight line even over 10 miles. We'd get a different answer for 100 years.
Like if you went
GPS. Okay, so we got to talk about GPS. He said raw data for GPS, but you've got
the raw data for GPS. Hold on, let me finish. So you've got this. You've now validated.
There's no such thing as raw data, bro.
Stop. Hold on. We've now validated that over 100 meters, this is accurate. And we go back there the next day and we find out that the desk is still where it says it is. And then we go 100 meters away from there. It's still 100 meters away to the centimeter. And now we can kind of rely on that system. That system is within a centimeter over 100 meters. And every time you go out and test it, you're going to find that it's within that tolerance. And
that's reality, right?
I'm right. So now
that proves it's flat. That proves a flat base. That proves a flat line, right?
No, that proves that we're 100 feet away from each other.
Right, and then no matter how far we go, we're just going to keep adding 100 feet every time. It's gonna.
No. All I'm validating is that the methodology gives accurate distances. I'm also not using the map. I'm not using the map at all. I'm not using one.
Well, you got to position your signal.
I do not need to use there's a coordinate system around Earth that does not require the map. In fact, in order to get
GPS is a relative. It's a relative coordinate system, bro. Everything's relative to each other.
It's relative only to the center of the Earth and the orientation of the Earth, if I'm not mistaken.
Right. So there you go. So if you're making it relative to your model, then you're saying you're pointing your distances. Hold on, if you're pointing your distances like they're coming from the center of the Earth, then locally they're gonna fucking match it and be indistinguishable.
No.
We're not.
That's not what he
said.
Not
doing that. The coordinate system that you get from that just orients your coordinate system. Now, once your coordinate system is oriented, and we know that whatever method they're using, it is oriented. Now we go and we start taking measurements from it. We always get within a centimeter accuracy.
Listen, I'm not trying to give you a hard time. Listen, just so y'all know, I'm not trying to give you a hard time. I'm trying.
Yeah, you can rip the map out of your GPS. You can just take the coordinates from a computer.
Okay, from a computer. Okay, let's start there. So you're gonna need. Okay, so right now we have a blank piece of paper, and we have I have a GPS receiver.
Yes.
And I have I have a tower that I'm getting.
You're receiving the Rhinix files.
Okay, what?
The Rhinix files. You're receiving the Rhinix files from the GPS.
Say that one more time.
You're receiving the Rhinix files. Okay, so that you can get raw data, or you can get the Rhinix files, which is a better display. It's like it's kind of laid out, like the times and which satellite.
We're going to use this raw data. We're going to use this raw data.
Yeah. Okay? This is the one data.
Now we have a blank piece. Hold on, we have a blank piece of paper with nothing on it, and we don't know where the signal's coming from. We got to mark it on this blank piece of paper. We got raw data, so we're just going to draw a dot of where the signal is coming from, and then we're gonna so it's going to give me a time. It's going to give me raw data. It's going to give me a time that it took, so that's going to interpret that into distance. Okay, so then I could put another point.
Ryan, none of this is relevant, dude. We're not discussing how it works.
Why do you keep stopping me when I'm trying to understand? So you could get through my head if you would go with me.
Yeah, but you understand. Mike was trying to explain too that we're not. No one's trying to prove that the ISS is. I mean, the
I'm not
GPS
talking about ISS, bro.
I know. I said the GPS is coming from satellites, or
I'm not trying to say it's coming from satellites. I'm not saying it's coming from satellites.
I know
I'm saying wherever.
Ryan.
I said tower. I said a tower or a satellite. What you pick, okay? But we got to draw a point on a blank piece of paper. We're using raw data, and trust me, if we do it like this, you'll be able to explain. But right now we're starting off with a blank canvas, raw data. So you got to draw a point on a blank piece of paper of where the signal's coming from. Okay,
this is how we start. To you, but you're saying so many things, dude. Because you don't have to worry about where the signal's coming from, because when you get the XYZ data, you use the coordinate system. That the only thing you know about the coordinate system is that the origin point is the center of mass. That's the only thing you know. That's really the only thing you know. The origin system.
What gives you the audacity to start with? What gives you the fucking audacity in this conversation? Maybe not in reality, but in this conversation, Kosho, what gives you the dude to reference to the center of the fucking earth? We're trying to prove
about the center of Earth. I said the center of mass is what I said, and also what gives me the audacity
we're having an honest conversation.
That's the standard that you're using when you're using this. When you're using the GPS system and you're getting XYZ coordinates, XYZ doesn't mean anything, as you said yourself, if you don't reference something. So they're just that's the reference.
So you're using your model to prove your model.
It's not. It's not using the model to do this. It's using GPS. The GPS system uses XYZ coordinates. You want to know where those XYZ coordinates are in reference to? They're in reference to a center of wherever those signals are coming from, wherever they happen to be orbiting around.
There's something could be a little bit higher and a smidge further, dude. You're talking about tolerances that are fucking insanity. The only time they're accurate is locally, and they're fucking, dude. It's you got to have coordinates. You're saying raw data.
That's what I'm saying. Yes,
make it sound like it doesn't matter, but you're using.
You have to have coordinates. I agree with that.
Yeah, you're using a coordinate system, so you got to
exactly.
So that's my whole point. You can't.
Yeah, but that's what I just said too. You have coordinates. When you get the data, you'll see there's XYZ. There's XYZ coordinate. Okay, cool. And then you decide, okay, what is that in reference to?
Welcome to flat Earth.
It's not welcome to flat Earth, dude.
It's not, because it's not going to give you. It's not going to give you drop data. It's going to give you fucking. It's going to give you XYZ. It's going to give. It's not going to give you Earth curve drop data.
Dude, let me just make sure that you are on page what the point is, dude. The point of using the XYZ data for us, for our test, is because we want to make sure that we can get these points. We don't even have to reference the center of mass when we're doing. We just want to make sure we get a point in one location, and it gives us the same point over and over again, so it's accurately giving us a point, and we get a point in some other location, and they're going to be XYZs. And you can go into GeoGebra, or you can go into some sort of 3D calculator, or the 3D graph calculator, or whatever, and you can type in these points. And then you can construct a straight line between them, and you can see every point that lies on that straight line.
Welcome to flat Earth.
You can measure in real life any point in real life in between you and that other location, and you can plot that in that graph as well, and you can see where it rests on that graph.
Flat Earth, brother. Thank you. Welcome to flat Earth, brother. It's XYZ 2-dimensional coordinate.
XYZ is not 2-dimensional, dude.
I'm just kidding.
What the heck? Listen, man. This the XYZ thing, the coordinate system thing, that stuff works because we don't have to. We don't have to talk about if satellites are real or if the GPS comes from anywhere. We just need to make sure that it's the most consistent measurements.
The whole system is all relative. The whole thing is relativity on its face, because everything is relative to everything else, and without something else, you have nothing at all. And my point is that if you're talking about, it's going to tell me that level. If you're going to tell me level is 10 miles away, I'm level with something, and it's going to show up as level. But then you're going to also have to tell me there's Earth curve. So wait, if it's 5 foot higher, but if it's not level and it's 5 foot higher, is that 5 foot of Earth curve? The point is it's using local. You can get good accuracy locally, But when you start stretching out, expanding, and then it's all fucking relative. It's all how you model it. It's all in the coordinates you put it in and what you relate it to, man. That's my point.
But if I found out that the test that I was saying, where you measure 100 feet, you find out it's within a centimeter, and you keep on doing that. You go within 200 feet, and you find out that it's within a centimeter, and you go 300 feet, you find out it's within a centimeter. Now you know that the system that you're using is always plus or minus 1 centimeter. Doesn't matter the distance. I mean, I could go 100 miles and find out that it's plus or minus a centimeter. Doing this 100-foot increments.
Right.
And so eventually I now know that no matter what I do, this thing is giving me accurate results within 1 centimeter.
Right.
So
yeah,
now
it's using straight lines. It's using straight lines and XYZ coordinates, man. It's going to tell you level is level, man. It's.
No, because I could actually do this up a hill.
If you want to, you can put curvature corrections in it, and like they do with the fucking surveys.
Let Mark finish real quick.
I could also do this. Yeah, I could also do this up a hill. So I'm not. I can find out that it's in 3D space. It's accurate. So
wait, how does it know if I'm going down a hill or if it's Earth curve?
That doesn't matter. That's
going down a hill. No, it's not irrelevant.
But listen for a second, Brian. If you were that worried about it, go ahead.
I'm not worried, bro. I'm trying to show you that it's all relative.
It's totally irrelevant because all I'm trying to do is validate that when I pull a piece of tape between two places and I'm going to call that my baseline for accurate, and I find out that tape measure always matches my GPS within a centimeter, whether I go up on a slope, whether I go down.
I know. I say welcome to flat Earth, bro.
So now I find out that this works. Now I can use this method to find out if it's flat because it gives me accurate results.
And your flat baseline distances are always accurate. Welcome to flat Earth, bro.
But that's
what about your flat baseline? Why do people keep on saying the flat baseline?
Hold on, because he's talking about because if I'm not using a flat baseline and Cartesian,
why do you use a flat baseline?
Or no, XYZ coordinates. Okay, so how are you to know if I'm going down a hill or
just do it over water?
Because
you got to fucking do a map it.
Do it over water.
You got to map it. Because
how could the satellite do it over river?
How could the satellite distinguish?
Go to New York and go to London and do it across the fucking ocean.
I'm just saying, dude. I'm just being practical.
You're just saying, but you're not thinking it through.
You're not listening, man.
What are you talking about? I'm not listening. Y'all, I'm hearing everything you're saying.
You're saying,
what are you telling me that I'm not hearing?
Whether I'm going down a hill or not.
Zanik, back out.
Zanik just got here, so I should honestly be quiet for a second.
I'll turn it over to somebody else, man.
But I'm just saying, Brian, I'm just saying that the reason I say you're not listening is because this test doesn't matter. These precision points, no matter where you put them, because those points are going to be as accurate as a centimeter. The straight line that you construct between them is going to be, a centimeter radius column that is going to be accurate all through. Every point is going to be within that column.
That's why I keep welcoming you to flat Earth, bro. You're fucking saying it over and over and over.
That doesn't mean anything, dude. It doesn't mean anything right now because you're not listening to what the actual test is. The actual test is you then go somewhere between those 2 points. So you go on a boat or you go fucking in the middle of the ocean in between those 2 points, and you measure from right there the surface of the water and the point there, and you compare it to the line you constructed, that column that you constructed, and it should be within that column. If it's not within that column, it should be right outside of it. If it's fucking very far away from it, that tells you that there's the Earth has a hump there.
So welcome to Hump Earth.
Welcome to a curved Earth.
Hump Earth.
Curved Earth.
Hump is. I always.
No hump if you're on the ground. If you're on the ground, there's no hump.
He just said there's a hump. What are you talking about?
If you're above the Earth, then there'll be a hump in the middle.
I'm gonna pass it to somebody else, man. I'm not gonna talk to Zanik until you.
Because you just will lose every time because it's just common sense.
No, you gotta admit you lied. Humble yourself. We'll talk.
I lied about what? What did I lie about?
You lied about coming in and saying fucking that you never said there was a fucking video that showed the glass cracking when you came up.
I said I didn't remember that.
You went back and forth.
Video. Yes.
You never apologized, bro.
Yeah, I didn't have to apologize. There was no lie.
Because when you came in, you said there was.
I recall there was a video I saw. I remember them doing this where they brought some sample under pressure to the surface and it cracked. I forget the details.
Anyway, I made the video of Zanuck lying, and I haven't made the second video. I haven't posted it yet, but I have him going back and forth.
Go ahead.
2 different times.
I didn't remember the
conversation, bro.
I didn't remember saying anything about it. I had no recollection in my mind of that until I heard my voice. Then I remembered.
Hey, Brian, do you really think he's lying, or do you think that maybe
just watch the video?
No. I don't have to watch the video because I know the whole thing. I've already watched it when it was on. We played the other day, but I don't think I told you. I don't think that Zanuck's actually lying here. I think that maybe you don't believe that he saw this, that he has access to this kind of video. He's seen this video anywhere, but it doesn't sound like an unbelievable claim. So it's like,
and believe me, I have been searching for that video ever since we spoke. So I'm not lying. I am very challenged. And I want to pursue finding that video. I will find it eventually. It will show up because it happens, and people talk about it all the time.
So how did they scoop up the water? Let's do this again. How did they scoop the water?
They put the water in a jar.
How?
A container. Just open it. They had an open jar. They had an open jar, and they put it on.
Did they dive down and do it? How did
they
use
do it? With one of the robotic things, the robotic submarines.
Did an actual hand take off the lid?
No, it was a mechanism, like a robotic arm that put the screw thing, rotated it.
The robotic arm took the lid off the jar.
Yeah, they had 2 arms, and it had axial three-axis rotational control.
The other day you said a diver did it, man.
No, the diver.
Remember I questioned you, bro?
Yes,
remember I said if they were down there. Remember me saying, listen, motherfucker.
Hold on.
Remember me saying if they were down that deep, it would kill them?
Shut up! Shut the fuck up! Divers do it all the time. That's not what we were doing.
Remember me saying that if they were down deep enough, the water to compress, they would die.
It doesn't crack.
He's lying again, dude. He's a liar.
It doesn't crack going from 100 to 200.
You're muted, Brian. You're about to be muted. Can you guys control yourself or what?
Yeah, sorry, man. I was just saying
the diver was not. That was not a different instance. Completely different situation.
Last show we had it out because I said that if the diver was down that deep for water to compress, he would die. Now you're saying it's a robotic arm. Last time we were arguing about whether the diver would die or not.
Now you're forgetting. Go back and watch the video.
I can't. There was
a deep water test with a robot, and there's also divers that do that all the time. When divers bring the bottle up without, from just where they were underneath the water, there's not enough pressure there, differential, for it to crack a glass jar. But if you did have a balloon or something, that can be seen dramatically in its size. But with water, because it's still not compressible that much, still compressible, by the way, 3% or 4%, if the Marianas Trench was used, would allow you to see a massive pressure differential, so much so that it would crack a glass container. Yes. What's so hard for that? What's so hard about that to understand? Seriously. Hello? Kosho.
That was pretty good. Yeah, dude. I don't know how to. I got so tired.
I love the way they just change stories, mix and match information, and then bring it to their convenience. Whatever they can say would disprove
how we change stories.
Yeah, you change the story. I said there was a deep water. There was no diver. There's no divers that dive down 2,000.
Coriolis with the bob, Zanuck.
You already know I'm right about that, and you're right too. By the way, Jeremy, I'll give you credit for that. I'm not going to go ahead with Bob. I didn't change Coriolis. I said I was look at it, from all directions. This is when you know you're winning because everyone's scrambling. I told you, Jeremy, very clearly. I told Bob this too, and I gave him all the outs he needed. He didn't take the bait. What he said was, yeah, the way Zanuck describes it, I agree. But he didn't like the way I described it because it was correct. He didn't like it because it was correct. It was any rotating reference frame when you're viewing motion, you will see Coriolis.
Tell us for story changers when you're a story changer.
I'm not going to. No, that didn't change anything. I repositioned it. I used
repositioned it. I almost got your obituary done. It's fine.
You're not writing any obituaries, dude.
I got Zanuck saying that the bottle exploded as they were putting it on the dock and broke all over the dock. I got him recorded saying that that it was a diver who did it, until I said, dude, the diver would be dead. Dude, he's changed his story 5 times. I have it. I just got to get the video out. And this is give me the motivation. Now he's saying that it was a submarine. She mentioned that last time after I said the diver died. He's like, no, it's a submarine arm. When I said, what is it, dude? A submarine with a mechanical arm like the ISS? And then he agreed with that after talking about the diver and me calling him out on that. Changed his story so many times, it's a joke.
Yeah, Xanix's a smart dude, man. Smart dude. You guys are jealous a little bit.
Man, all he's got to do is humble himself.
Probably why they have him muted.
Or find the video.
God, you guys.
I'll back off. I'm gonna back off the mic, man.
You guys are in trouble now, bros.
But I just wanted to, if he humbles himself or if he shows me the video, I just want to see the video that he says is out there and everybody's.
For what it's worth, I agree with Xanic, man. Like I told you, dude.
Yeah, I don't want to yell and scream and talk over anybody. I told you there was 2 stories. I didn't remember that. Okay, so someone just talked over me just now. Jeremy, was that you?
Yeah, you said you don't want to scream over people and yell and shit, and I don't believe you.
You just so as I'm saying this, you talk over me. Okay, real quick. There's 2 stories. One's deep ocean. That's where the glass cracked, and then there's divers who do this all the time. Now that's a much more challenging situation to actually judge the differential pressure because water is so incompressible. Not absolutely, but it takes a lot of pressure to compress water. But it does get compressed 1 or 2% at the 1,000-foot range and about 4% at 30,000 feet, like the depths of the Marianas Trench, for example. That's not where the robots were. They weren't in the trenches. They were 1 or 2,000 feet down. And they sample the water with a robotics system. Like, I don't remember exactly the details. Remember the video? They brought it up and it was cracked. I don't know if it was cracking on the way up or cracking at the dock. I don't remember all that. All I remember is there was a video. Now, the point here is, and Kosho also would agree, is that hold on. We all know, this is just basic physics. When you compress water by 3% or 2%, it takes pressure to do it. If you have a container that's confining that water and you bring it to the surface where it's not able to compress it at 2% compression or 3% compression or density increase, then it will put the force on that jar. And if that jar can't handle the 3,000 or 4,000 PSI, it will crack. It's that simple. It's not rocket science, guys.
You don't got to say it will crack. You've seen it.
It will crack.
It
will crack.
Remember, you've seen it.
Yes, I saw that. Yes, I saw it. I don't remember exactly. Dude, this is so long ago.
Dude, I listened to you, and now I go to talk, and you listen. You said you've seen it. Okay, at this point, I could care less if it cracks or not. I care less about you saying that you've seen it and changing your story around a few times. At this point, I just want you to say that there's not a video, or show me the video. Humble yourself, or show me the video. One or the other, bro.
And that's what I've been looking for. I haven't found it because the internet is littered with videos now. It's hard to find stuff.
Said everybody's seen it, bro.
Hey, you're talking over me.
Yeah,
I'll find it for you, and I'll bring it to the table here. But go back and just for the point of this conversation,
come back.
You're worried about catching me in a lie. I'm worried about educating you on how pressure works with liquids.
Bro, pride over principle, man.
You see the difference? You're catching me. You're trying to catch me on a flip up, and I'm trying to catch you to learn something. You're talking over me again. You're doing it again.
Dude, you come here and you wreck the fucking room every time you come here because
it's all my
you say
fault.
anything to win a debate. If you humble yourself, I'll be more than happy to have a conversation with you if you prove to be honest and humble.
I was honest and humble. I said I saw the video.
Go find the video that everybody's seen.
Talking over me again. You're doing it again. Every time I talk,
I got a request, bro. Go find the video you said everybody's seen, or humble yourself. That's my special request.
He said he can't find it, man.
I'm looking for it. I'll let you stumble
because it doesn't exist.
If I could do the test, dude, I'm talking again. You're talking over me.
For fuck's sake.
Look, I don't remember the details of it. It was a very long time ago, but I did see it. I'm continuing to look for it. And when I find it, I'll bring it to the table. In the meantime, I'm trying to help you be educated about.
Wait, now you don't remember the details.
There you go again, talking over me again. See how it is? It's not me, it's you. It's you, not me.
Now you're saying that you don't remember the details. So which is
I've always said that. I've always said that.
What detail don't you remember?
Details. I told you the general. There was a glass container. You're doing it again. There's a glass container brought to the surface and it cracked. I don't remember if it was on the way up, on a dock, on the boat. I can't remember. It wasn't on a dock, but it was on the boat.
The video that I recorded remembers. It remembers you saying that it was before it got to the surface, and then it remembers you saying that it was on the dock.
Yeah, I don't remember what I even said, and it's been even longer since I said it to you. But when I find the video, I will show it. You're doing it again. When I find the video,
bro, you keep changing
you're
your
doing
story,
it again.
bro.
You're doing it again. You're doing it again. So when I find the video,
you're doing it again. Go find the video. Don't come back.
You're doing it again. I'm in the middle of a sentence, and I can't even finish the sentence.
Quit talking and go find the video.
When I find the video, I will bring it to the table.
Go find it. Quit talking until you do.
Shut up.
Why are you behaving like this, man?
You act like a little petulant child.
Dude, he does this every time he comes in the room, man.
No, when I come in the room, I try to educate people like you on basics.
I can't wait to post another video.
Basics.
All I need is for people to watch you lie through your teeth, bro. It's not cool.
What are you going to make a video on it? You got a YouTube channel, Brian?
I posted Zanuck. It says Zanuck versus Professor Walter Lewin, and I can show Wikipedia. I was checking about buoyant force. They're saying since water doesn't compress, the buoyant force doesn't change as you go down in depth. But besides the point, I'm more worried about talking to an honest or a dishonest man. There's a lot of people here who have
your video is dishonest.
With who they'll be honest, man. They'll be honest.
Your video is dishonest. You're taking what he said.
Go find the video.
Can I speak? Can I speak? Yes or no?
Yeah, go ahead.
You took a video and made something out of context, taking completely out of context. Just because water is said generally it is incompressible doesn't mean that it is incompressible. It is not. It can be compressed by 4% at the pressures reached as deep as the Marianas Trench. Do you not agree with that or not?
Maybe. Here's my point. My turn.
So who's the liar? So you're the liar now. So you're the liar now. You're the liar.
I have you coming in the room the other night. Saying that there was no video, and you never said there was a fucking video.
I said I never said anything. I didn't say anything about that. I said I didn't know anything about it.
What are you going to do when I
didn't remember I had any conversation? I didn't remember having ever seen a conversation with you about it. I didn't remember that conversation at all. That's honest truth. Dude, I have thousands of conversations. You think I remember every fucking little one, especially one 4 or 5 years ago?
Just go find the video.
If you find the video, I won't realize. Your video is misleading. You're using a professor because you outlined it on the screen there, and he said water is incompressible. And I'm telling you that it's not a lie in the context for which he said it's incompressible. You're over embellishing the truth here.
Keep lying through your teeth, Zanuck. Okay?
You're the one that's lying. So water is incompressible, and water can be compressed.
There was a video when you came in the other night.
Water can be compressed. If that professor was here, I would slap him with the tooth and he would agree with me.
Through his teeth 3
times.
Would
you Zanuck or would you fold like a cheap suit? I think you'd fold.
No. I would say, what do you mean by that? You know water is, all liquids are compressible to a certain extent. And he'd say, well, for this stupid freshman class, I have said it's incompressible because that's how we're having the discussion. That's good enough for them. But he knows that it's not true.
I don't care about the liquid at this point. I'm talking about your lying.
Water is compressible. Water is compressible.
I'm talking about your
pressures I'm talking about. Stop.
You keep talking about the point
over me.
I'm talking.
Stop talking over me.
I just listened to you, and then I go to respond, and you fucking start talking.
In the middle of a sentence again.
Hold on, Brian. Let him finish. Zanuck, you got 30 seconds.
Thank you. 30 seconds. So anyway, water is compressible. I don't care what this professor said. He's wrong, absolutely, positively. But in the context for which he's talking about it, he's fine. It's right. It's okay. But in our conversation, completely wrong. Any liquid that is brought down to those pressures will be compressed. And if it's in a container, it will stay compressed in that container. If there's no air gaps, and as it rises to the surface, it will breach that container if it's not strong enough to survive the pressure required to have a 3% or a 2% or even a 1% density increase due to pressure. Thank you.
Time.
All right. I'm going to say this one more time. I got him flip-flopping back and forth. Okay. Thank God he this show's live and everything's recorded, because this allows me to pinpoint and pin people down for what they say. At this point, I don't care what the fuck happens to water. Excuse my language. I could care less. I'm going to show a video of this man denying that he ever even claimed there was a video when he first came in the room the other night. If he wants to humble himself and say, you know, I did say that, but I forgot. He denies even saying that. After denying saying that, he's like tripling down. And dude, it's a joke. I just want to see that he's an honest man, and then I'll have a conversation with him, man. But at this point, he's going to show me a video and say that nobody's, you know, that everybody's seen it. We all know there's no video, whether it happens or not. There's no robotic submarine arm bringing jars down, and he don't remember when it explodes. You know, it's all a big freaking game to him, man. And to me, man, this is a fun conversation. Shouldn't be stressful. Let's keep it honest. And that's it, man. Be looking out for the video.
If that professor was here, Zanuck would fold like a cheap suit on him. That's what I think, Zanuck. I don't think you'd stand up to the professor, your professor daddy. I think you'd fold on him and be like, "Oh, okay, water's incompressible. You're right."
Wow. I'm watching the video even now. It's like the things you're saying even then. I don't remember that video, by the way, just to let you know. It's been so long. But you're saying things that are so stupid, like water is incompressible. And if it's you, then you got to believe in black holes if it is. And then you even got Jeremy or someone coming in and saying, or percentage, or someone's yapping in the background saying, yeah, well, everything is compressible. Then you say, oh, do you believe in black holes? I mean, dude, you're so far off the rails. It's unbelievable. Yes, water's compressible. And I gave you the values. I went through the efforts of giving you the values on that video. You played them. And then you're mocking it. You know why? Because people mock what they don't understand.
Is that true?
Like I said, man, bring this news to NASA, man. Imagine how many lives you'll save.
Look,
when they
you're
go
a
to
liar. You make a
Why
video.
You gotta interrupt me, dude? Why you got to interrupt me, dude?
Because you do it to me.
Look, tell NASA, man, that you can fit an extra fucking 2 gallons in their 100-gallon tank. And then when they go to Mars, dude, that'll save a life, dude. An extra 2 gallons, man. All they got to do is compress the shit out of it, and in a 100-gallon tank, they could fit 102 gallons. And fucking they could save. Imagine the lives it'll save. So
how do you do that? By the way, how would you get 2 gallons into a 100-gallon tank?
You make a video about it, then you forget about it. You say that it's a robot. You say it's a guy on the dock. That's
so you can't
make
give me
shit
the answer.
up.
You can't give me the answer. How would you make a 100-gallon tank take 102 gallons of gasoline or water?
You don't.
You can actually, but go ahead. How would you do it?
Well, I refer to Walter Lewin, and Wikipedia says that you can't compress water.
Well, you can use me as a citation on this one. Why don't you quote me on this too? All you have to do is compress that container with the liquid to 2,000 or 3,000 psi, and you will get.
Bro, you could end all this. I wouldn't know how to do it. You could end all this by finding that video, Zanuck, that everybody.
Well, you can use a series of pumps that can actually achieve that kind of pressure, liquid pressure in a container.
When did this conversation happen?
I don't know, dude. I have no recollection of that conversation at all. So I got to tell you, all he's doing is telling me, insulting me for not being able to remember something that was 2, 3, 4 years ago. I don't even remember this.
You are a habitual story changer, though. You'd have to admit.
No,
right?
I modify stories so people can understand things, but I don't change anything. What did I change? The bottom line is I saw a video, something cracked because of the pressure. That's all I remember.
So modifying is not changing, you think?
No, changing and modifying are fine to stories to make them more understandable to people like your buddy Brian. And also to make peace with people like what I did with Bob. I changed my story a little bit with him because I didn't want to.
That's called.
I did, Jeremy. Why are you talking over me, Jeremy?
It's called brown nosing.
Why are you talking over me? Call it what you will, brown nosing, kissing his ass. I have respect for him. I don't want to throw it in his face. He's wrong. He's not a specialist in Coriolis. Most physicists are not. And I have the answers to it. He doesn't. And you want to use the equations? He's wrong.
There's a lot of tough talk coming from.
And I'm not going to tell him. I'm not going to tell him that. Embarrass him in front of everybody. All right. I'll do it behind his back. I'll do it behind his back like I'm doing right now. No, he had a very.
You know I'm right here, you asshole. Right?
He's right. Listen. He had a very narrow. I know. I saw you there. He had a very, very narrow view of looking at it, and I gave him a broader view. He saw my point. I saw his point. We moved on. Jeremy, all you're doing trying to do is shit stir.
Yeah, I don't have any problem in anything Xanax
I didn't
said.
even know he was here.
I did.
You didn't know he was here, Jeremy?
No,
I swear to God,
You didn't hear what he said previous. You didn't hear what he said.
I didn't hear that. No,
previous.
I didn't hear that.
No, I know Zanuck was just trying to jerk my chain. No, I absolutely agree with Zanuck. I think he's correct.
No, I have all
My
respect
example-
for
my
He
example
compresses
of the
his
guy in the
stories.
park. So my example of the guys throwing the ball in the park and the guy in a roundabout in the middle of them, that is the Coriolis effect then.
You can look at it that way, yes.
Oh, so you're changing your story. Okay, you're a story
No,
changer
no.
too, that's fine.
Bob was
You're
very
such an
clear
asshole,
about
Jeremy.
Jeremy.
Bob's
Bob was very
agreeing with
clear
you,
about
dipshit.
how he described it.
Changers.
Hey,
No,
Zanuck
remember-
compresses. Hey, Zanuck compresses his stories like 102 gallons of water in a 100-gallon tank, man.
You're right, I
Jeremy's
do.
just mad. Jeremy's
By the
just
way,
mad that
Zanuck,
everyone's in
I
agreement.
put an article about compressing water in the chat.
Oh, I'd love to see it. Thanks.
It's right in the chat.
Dude, Jeremy,
Live stream tech.
You just want them to fucking. You're just upset that you can't get them to fight, dude. Everyone's
I know, you just
agreeing
want
with
us-
each
you just
other.
want the battle. I
Be
just
happy,
love it.
bro.
You know, and you're texting me, telling me that I'm cowering down. No, I'm telling him the exact same thing
You're
I
actually
told you
sending
before.
messages like that?
He was, and I'm telling him that. I'm talking to Bob also afterward, and the whole thing's just a shit show, and we know this. You're being very funny. You know what's funny, Jeremy, is that you're the smartest guy in the room here on the flat side, because I have to say you actually get it, because your questions are good now. There was one question you didn't answer that Dr. Bob had asked you, and you did. I don't think you answered incorrectly. I think you refused to answer it. But at that point, you'd convinced me that you kind of understand Coriolis. Then I start thinking to myself, so where's the problem? If you understand it, and we all are on the same page, where is there a fight?
I'll tell you where it is, man. Because I'm the one who taught him Coriolis, well. But anyway, the issue that he has, because what we said about the merry-go-round, we all agree about that. Okay, Jeremy though, we described that as being two different reference frames. Okay, and that's fine because it's being described from either reference frame. It's correct in either reference frame, right? He though has the idea that there is an actual path and there's an actual reference frame. Like
Right.
there is a reference frame where everything is actually happening in, and then there's every other reference frame.
That's the problem right there, right, Kosho? Because what he's and I think he knows this. He doesn't have the ability to kind of separate these two ideas. That his actual reference frame, what he means, and I'm speaking for him, and I shouldn't do this, but I'm going to anyway. Means the inertial reference frame. That's what his definition of actual means. I mean, it's actually going straight. Yeah, from an inertial reference frame, it's going straight, but it's actually curving.
Exactly.
It's actually curving from the non-inertial reference frame as well, the one that's rotating or accelerating.
Hey, Zanuck.
Yes.
Zanuck, can you explain something to me?
Sure.
So today, the moon's almost full, and the sun is in the sky. I'm in California.
Right.
How does it stay full the entire time if the sun is behind the Earth?
The better question is like last week.
I'm not done. Tonight at 3 a.m. when I get up for work again, it's still full.
Right.
Now, technically, the sun should be completely behind the Earth, and the moon should be in our sky on the other side of the Earth. So why is it that it's full the entire time? Go ahead.
I can answer that easily if you can't.
Go ahead. No, go ahead. I can answer it easily too, but I hear you, Bob. Go ahead.
Okay. The orbit of the moon is tilted 5 degrees to the celestial, or the plane of the solar system, the ecliptic. Sorry, I had a brain fart there. But it's tilted 5 degrees to the ecliptic. So if the moon is above or below the ecliptic, you're going to have a full moon. The only time that if the moon was at the ecliptic, that would be called a node. And if you had a full moon during the when the moon was at the ecliptic, you would have a lunar eclipse like we're going to have in a month. By the way, how do we know it's going to be in a month?
Normally, you're on top of the ball. Normally, you're standing always on top of the ball, except for when they're talking about their eclipses and shit.
Brian,
you can't
Brian,
figure
come on.
something out.
Come on.
Don't try and talk about astronomy to people who actually know it.
Yeah, he gave you a really, be respectful. Like, it was a real good description, actually. And by the way, the better question, Krypton, was just last week when we saw, and this is, I hadn't seen this before, by the way. The moon, I mean, it's happened many times. I just never noticed it before. The moon was coming up in the west, and the sun was still high in the sky, and it was a half moon. I mean, it was a quarter moon, actually. All you saw was a line right down the middle.
How do you explain that?
Well, very easily. And not only that, not only for the reasons Bob said, is you can actually angle. So you know that for it to be half, you know it has to be directly in opposition to the moon.
I think you guys are missing.
Can I finish the sentence? Is it possible to finish the sentence?
Go ahead.
Okay. So directly in opposition to the moon, which means from our perspective, there's a 90-degree angle between us, the moon, and the sun. And if that's the case, we measure now an angle from us to the sun, and we'll see an angle of 89 point something, like near 89.8 degrees.
89.86, I think.
Right. So that angle difference tells you that the sun is over 300 times further away than the moon. It's so far away, the angle is so slight that it is able to be 90 degrees opposed to the moon, but illuminating the moon up.
So you're telling me.
I almost got to the end before you did. Okay,
go ahead.
So that's how you know how far things are away, ratio wise. And the main point here is that you have to respect the fact that these things are so amazingly far away.
You have to believe they are.
Large. Yeah. So incredibly large. Okay, thank you.
So here we are. So if the sun is on the other side of the earth, coming up now, rotating back from the east coast, but the moon is still its same shadow, quote unquote, from the earth reflecting it. I'm sorry, from the sun reflecting it. Then how can that moon still have the same shine as if when the sun was in the sky above it? For instance.
All right, seriously, what did I just explain? Say it back.
You missed everything Bob said.
I get
you
what
missed
you're saying.
everything. Wait, before Bob talks, you missed everything Bob said. You missed everything Bob said. He's still seeing you light up. Stop lighting up.
Hold on.
You missed everything Bob said.
Listen.
Everything.
Listen, Zanuck, just listen. If I took a basketball, and I put a tennis ball on the other side of it, and then I took a light bulb, and I said, look it, the moon, this tennis ball is lit up because the light is shining on it. But if I took the light on the other side of the earth or the basketball, how is the moon still lit up?
You can't use real life examples with them. You can't use real life examples.
If I took the basketball.
Yeah, you can. Hey, put the basketball.
Zanuck,
put the basketball in the next county.
Don't derail me, Zanuck. Listen. The light is on the other side of the basketball, and the tennis ball is still lit up as it was when the light was on the other side of the basketball. It makes its rotation, and now it's rising opposite of the ball, of the basketball, and the tennis ball is still its same formation of brightness, because we were apparently knowing it to be a reflection of the light. This is why I question you guys every fucking day.
The Earth is not as large as the orbit of the moon. You're thinking that the Earth is going to block the light on the nighttime side from the moon. Talking over me. That's going to fix everything. Just talking over me is going to fix it.
Okay. Right. With that being said,
let him talk.
The light from the sun from reaching the Jesus Christ, dude.
Yeah.
You think the Earth is going to block the light?
Does that mean the moon speeds up?
The moon, even though the moon is in 3D space, not blocked by the Earth.
Guys, one at a time, please.
Does that mean the moon speeds up?
Well, you got to block a Krypton. You got to shut him up for a second. Put a mute on him because it's being ridiculous.
Wow.
Tilt the direction of the moon 5 degrees up, and it's no longer being blocked by the basketball, right?
Does that mean that the moon speeds up?
No, it means that the moon is off by 5 degrees, and it's very far away from the sun, and it's very far away from the Earth. And these distances make a difference in what you're trying to explain with your basketball and a tennis ball in your room with a flashlight. And then, of course, you got Brian saying, see, they'll never bring real life examples. Dude, the real life example would be
You guys are full of it,
hold on.
You're full
The real
of
life
it.
example would be something in your city, center of town, out in the next county, 10 miles away.
You're full of it.
I went ahead and
That's
I put
your answer? I'm full of it, really?
a picture up because I know you can't visualize this. So I put a picture up to show you. Just imagine, try and imagine the sun on the right, from the right side of that image instead of from the left. That explains it to you very nicely right there.
I'm just glad we got that Coriolis shit straightened out, Bob. I feel much better now. Now that I know
Can you have an angle to a
we're both
curved
on
line?
the same page.
Can you have an angle to a curved line?
Please,
maybe.
Please, Jeremy, answer this question because then we'll all be family.
Nonsense.
Jeremy,
I'm
please
not really
answer.
worried about an angle to a curved line.
Jeremy,
I'm not really worried
counting
about
on
an angle
you.
to a curved line. I don't know. I've already told you 3 days in a row. I don't know.
Okay, well, you haven't learned anything in 3 days, then have you?
I'm speaking
We have learned that my
logically
example
and
was the
visually of
Coriolis
what we
effect.
see.
Come on, Jeremy, you can do it. Please answer the question. There's no wrong answer, by the way, Jeremy.
You can have an assumed angle, but you can't have a fucking angle because the baseline would be curved. You can assume
That's
a straight
because you're an
line.
idiot.
You
So
can assume a
I'm not talking to you. I'm talking to
You can
Jeremy.
assume a tangent.
I love Dr.
You can
Bob.
assume a tangent, but you can't. What the whole point is, can you prove the tangent? You can assume the tangent all you want. Can you prove it?
Yes.
Absolutely. No problem at all.
Well, let me read something about an angle to a curved line. They said it's abstract. The angle between curves is in most cases defined as the angle between the tangents at the
Googling,
point of
Bob.
intersection. From a heuristic point of view, this is unsatisfactory. I mean, people obviously have issues with this.
Nobody
What's
has
your
an issue
point?
with it.
Bullshit. Shit. Fucking the
It doesn't
software
make
won't let you
sense.
do it.
It
Engineering
doesn't make
software
sense
won't
that
let
the
you do it.
light
Bob.
behind the basketball will cast the same
Wait, we're
light
changing
upon
subjects.
the
We're talking to
tennis
Jeremy right now. Hang on a sec, Krypton.
Yeah,
All right,
I put the image
whatever.
of it up there. Just imagine the sun's on the right side of the
No,
image
go
instead
ahead,
of on the
Krypton.
left.
We're
Krypton, go ahead.
multitasking, aren't we? This is a
Let's
We're not
multitasking group.
multitasking. It's a shit show. Let Krypton
All
go.
conversations at once.
That can happen.
Jeremy, curved angle.
Go ahead, Krypton. Krypton, go ahead.
Here's what I'm saying. It's apocryphon, but Zanuck loves to distort my name all the time. I love him, but I hate him. But anyways, that's a whole other story. We've been going at this for 3 years. Anyhow, listen, we have a moon that's getting the same shine, even though it's on the opposite side of the shine. Come on, wake up, people.
All right. Why aren't you looking at the image that I just put up?
I'm looking at it. I saw
Okay,
it.
so what? Okay, now instead, do you agree that the sun is on the left side of that
That's
image?
a half moon. That's a half moon. It's a full moon, Bubba.
It is not a half moon, you outer
It is a
asshole.
fucking half moon. I'm looking at a half moon.
I'm looking
No,
at a
you're
half
not.
moon.
Are you looking at it from the Earth?
That's not looking at it from the Earth. The Earth
It's
is
a
right
half
in the center.
moon, Bobby. Come on.
The Earth
It
is right in
definitely
the
isn't.
center of that. You're looking at the orbit of the
Now,
moon around the Earth from the outside.
Okay, Bob,
you can't
Bobby,
even read
Bobby,
you can't
Bob.
even see an image.
Bob, what you posted is not what I'm explaining. Put the moon on the other side of the Earth, where
No,
it's in the
put the
shadow.
sun on the other side of the picture, and you see exactly what you're talking about.
Listen. Let me explain again.
No, I'm not going to
Today.
listen to you. You're going to put the
Today.
sun on the right side of the image, like I told you.
That's a
and then
half
you're going
moon.
to see it.
That's a half moon. That's a half moon.
It's not a half moon.
It's not a half
Can I
moon.
try?
No.
It's
The
mostly a
picture
new
you
moon
posted.
anyway.
Hold on. Let me quote you. It says, "What determines when we have an eclipse?" Right?
No.
That's what. That's what I'm looking at.
Posting
Hold
a
on.
picture for you.
Hold on. It says here, since you can't visualize it, here is the picture. Just place the sun on the right side of the image, and there it is. You posted that, right?
Yes. And that's
a
what I
half
just
moon.
told you again. Now,
That's
have you
a half
done
moon.
that yet?
That's not a
No,
half moon.
wait. That's a half moon.
It's not
No,
a half
it's not a half. You're not listening to him. Don't read the pictures for your reference.
I'm
He's saying,
looking at the fucking picture. It's
put
a
that
half
moon.
moon.
Put that moon.
Okay, you're
Put
an
that
idiot.
moon on the right side, and what would
You're
we
just an idiot.
see?
since you can't see the Earth in the center of that
If
picture,
the moon is
I'll go ahead and change
behind
it
the
for you.
Earth, it's behind it because it's nighttime. It's behind it. What the fuck? You guys don't understand that.
Can I try? Can I try?
Go ahead. Go
to
ahead. Go
address it?
ahead. Go ahead.
All right. So let's go back to your example of a basketball in a tennis ball, right? How many basketball fit in between the basketball that represents the Earth and the tennis ball? How many basketballs you have in between them?
Well, on your calculated fake science, it's going to be a lot, right?
Fake science?
Exactly.
About
Exactly. So
25.
You guys say
that's the model. That's the model you're criticizing, right? You're challenging that model. So let's use that model so you're not strawmanning it, right?
About
you're right.
25.
Yeah, you're right. You're right. You're right.
25
You're right.
basketballs.
How many basketballs?
I don't know about. Well, 20 would be 160,000, right? So 25, let's say, just to get us in the ballpark.
If the moon is on the other side of the Earth, the other side, meaning it's darkness, meaning
I wasn't done yet. So
I'm sorry, go ahead.
the tennis ball is on the shadow of the basketball. So like a lunar eclipse, right? What happens if you tilt that direction of the moon just 5 degrees up? Is it still going to be in the shadow of the basketball?
It's not going to be where he's describing there.
Well, but the orbit of the moon is tilted 5 degrees, right? So
let me ask something. Hold on. Let's think practical.
You didn't answer the question.
Let's think practical, Bubba. Hold on. Listen. If I'm standing, let's bring it down to really small, simple terms. If I'm standing at the right side of my house and I got the sun shining on me, and then I go to the center of my house, now I'm in the shadow. It's dark because the Earth is now blocking the sun from me because it's in direct line of a shadow. Then I go further to the left. Now I got the sun on me. I get it. That makes sense. But the fact that when I'm in the shadow, I still have the same presence because somehow, some way, the sun is able to go around the shadow of the Earth and lighten me up, then I get you. It makes sense. But in reality, it doesn't make sense.
But I wasn't saying that. I was asking a question that you didn't answer. You didn't answer the question that if I tilt the tennis ball 5 degrees higher than it was compared to the basketball, if it would still be
5 degrees
under
will
the
not
shadow.
cause a full moon. 5 degrees will
Why
not
not?
cause a full moon. There will still be a shadow upon the moon because remember, it's behind the Earth, bro. Wake up.
My God. Really?
Isn't that gonna look almost exactly like a full moon?
How does the moon all night till the early morning have the same full moon effect if it's circulating behind the Earth in its shadow and then around it?
All right, now look at the image now, because now the little YouTube play button is not in there. You can see the Earth, you can see the moon. You see how we're looking at it from the side? It's not a half moon, you moron. Now, instead of looking at the sun from the left side, imagine the sun's over on the right, so the shadows would be opposite.
No.
If you're on Earth,
Wait.
you'll see a full moon.
Hold on. Wait. Don't imagine it. Let's speak reality. It's not. Do you get me?
Well, I just showed you how it happened. You can either take it or not. I don't really care.
No,
that's how it happened.
You're off, Bobby. You're off.
Well, can I add something? Can I, Crypto? I think I might find that. I think I'll find the weak link here. When it's in that shadow area, from looking at this picture that Dr. Bob showed you, you're forgetting that it won't be in the shadow, even though it would be aligned with the shadow. It'll be off left or right, and if it's off left or right, it'll still be illuminated by the sun, even though it is in line horizontally or laterally with the shadow. Does that make sense?
No, it doesn't, because it's in the shadow.
Yeah, he can't figure it out.
The shadow, you know the shadow only has. Okay, hold on. The shadow has a circumference of 25,000 miles around in this picture, correct?
You guys,
It's a tube.
Here's a problem.
Can I finish? Can I finish? Don't change the subject. I want to keep this a challenge. I need you to shut up for a second. Seriously. It has. I'll tell you. I'm not going to ask questions. You know what? I'm not going to ask questions.
There's an old saying.
I'm not going to ask questions. I'm just going to tell you. It has. It's like a tube. Think of the Earth as. Think of the Earth shadow. Krypton.
The old saying is, make it make sense.
I will make it make sense. Just give me a chance.
Yeah, go ahead.
No, you're not going to. He can't make sense of it.
Because you're behind.
Don't waste your time with him.
Come on, give me a chance. Just 5 seconds, 10 seconds. Maybe
Refer to the picture I posted.
You're behind the ball. The moon is behind the ball.
Think of the shadow as a tube. Think of the shadow as a tube.
Okay. I'm looking at it.
Okay, it's a 25,000 mile diameter or a circumference tube that's going out, following that center line, that orange line there. That's a tube. Now the moon is going to go. It's going to approach the tube, but it's not going to ever touch the tube. It's going to go alongside of it, and it's going to go beneath it, and they come out the other side where this arc, the orbit has been shown to be. So since it's in line laterally with it, that you may say, oh, it's getting blocked by the Earth, but it's not, because it's over past the tube. It's not next to the tube. It's on the other side of the tube, so it's not being blocked. So from the Earth, it looks full still, because remember, the Earth has a tube shadow, and it's not hitting the tube. When it hits the tube, you know what that's called, a Krypton? It's called an eclipse.
Why doesn't it?
You can't. You're not getting it all, are you?
Why doesn't the moon? Listen. In its rotation,
he can't picture it.
Listen.
I thought the tube was a great idea. Okay,
listen.
you guys let him
fucking dyscalculia.
All right, I'm gonna.
Why does the moon? Listen. Why does the moon, in its movement with the Earth, why doesn't the shadow change?
It actually, technically, it does slightly change.
It doesn't. No, you're lying. Visually.
Dr. Bob can probably back me up on it. I don't know for sure, but I think it moves a little bit.
Why does it? Listen. Why does the shadow change when it's going behind the Earth and the sun is on the opposite side? Why doesn't it change?
What if I told you that path of the Earth is taken never touches that tubular shadow? Never goes through it.
But it does.
No, it doesn't. It doesn't actually, because if it did happen, we'd have an eclipse every single day. Every single period of the month like this.
That's my point. Oh my God. Zanuck, wake up. That's my point. Every day we should have a fucking eclipse of the moon.
But we don't. And we don't because it doesn't.
He's channeling Sleepy Warrior in his misunderstanding. That's just epic.
I know, right? It's so much fun. Listen, picture I like the tube, my tube comparison or analogy. The tube, it's not ever, that path of that orbit, it never touches the tube. That moon never touches the tube.
To those who have an ear, let them hear. To those that
never
have an ear,
touches the
let
tube.
them hear.
Zanuck, can you refer to the most recent posting?
I'm so busy trying to picture the
To
tube.
those that have an ear, let them hear.
The most recent. Livestream 1 text.
Right. Oh, come on, man. There it is.
There's your tube.
The sun on the Earth will block out the moon. The moon should go dark when it's behind the Earth.
Well, look at
it doesn't.
Look at Doofus. Look at Doofus. Oh my God. Look at Doofus's picture. He's basically just drawn out and put the moon. What I was talking about, it never touches the tube.
So the problem with this picture is that he's got it. He doesn't have the back half of the moon shaded.
Right. But just kind of shows where it is.
If you could shade the back half of that moon, that would be better.
Right.
I can't with the phone. Sorry.
You did that on your phone?
Yeah.
You're a better man than I.
A Krypton. Oh my God! Don't give us all headaches. You have to understand. You have to understand that if it's off.
No, he doesn't. He's a flat earther.
I hope that one day,
are you a flat earther?
Father above. I hope that one day our Father above pokes his head in the firmament and makes all you guys realize that you were all misled.
I mean, we're not going to be convinced by somebody who can't get 3D concepts down.
Yeah, he can't.
Here's a 3D concept. Basketball, tennis ball, light. Put the light on one side of the basketball, put the tennis ball on the other side. It will no longer have the same shine that it had when it was in the view of the light, as opposed to behind the earth and then to the left of it. And now it has a new shine. But you know what, you guys, I love you guys. Real talk, I love you guys. But good luck in life. Good luck in life.
I bet you that Brian and Jeremy understand the picture that I posted. I bet you.
I think so too. I think everyone accepts this picture as a great description of what's happening, and they get it. And for some reason, you're not getting it because you don't understand 3D. It's almost like you're colorblind, analogous to understanding things in a 3D environment. This is a 3D environment, and you're looking at it from a 2D perspective. And that's why you're having a problem.
No.
Really?
No.
Okay.
It's called dyscalculia. They can't envision it.
So this you know what's funny? When you guys
what's funny? Tell us what's funny. This is funny, by the way.
When you try to explain things that make no sense. For instance, what about when the Earth is in its rotation, quote unquote, and then you have the moon, and then you have the moon having this shadow that's coming vertically downwards, so you have like a smile that's on the south of the moon, and then your guys are like, yeah, that I could go to Solera, and it's going to show me that somehow, some way. What's that called? What is that called when the moon has
a waning moon?
Yeah, when it's on the bottom,
Oh, no,
and you
he's not
say
talking
that,
about phases.
and you say that the shadow, the Earth on the moon.
Oh,
but it makes no sense because guess what? The Earth, the sun to your left, or in my case, to the east, is rising. The sun's in the sky, and the moon is to my right, to the west.
This is painful. You're hurting
Really?
my brain.
Yeah. And want to know why, Zanuck? Is because you cannot accept that fact. You can't accept that.
No, I have
when the
a very
sun
good understanding of.
Apparently is casting a shadow on the moon, yet the moon is blocked out, quote unquote.
Well, let's go back to the original.
Yeah. Let's get away from that because that makes
no. I don't think you understand the vast distances and the angles and the 3D environment that we're looking at. What if we go back to that moon in the sky above my head?
You guys always have to go to crazy
above my head
amounts of miles away
before the sun sets.
Yeah.
It's lit up, and you see half of it. You told me earlier that you agreed that the sun was 90 degrees opposed to that object, so that we can see half of it being lit up. Really, the quarter moon is what we're saying, but half of the moon lit up.
So hold on, Zanuck, real talk. 30 days from now, will the
So you
moon...
don't want to go there. Okay.
I'm going to try this. 30 days
Why
from now.
can't you play with me? Play.
I'm playing with you right now. Listen.
No, I get, but I said something. Now you're saying something else.
Not 30.
Completely unrelated.
15 days from now, when the moon now has a new shadow on it, and it doesn't make sense because we're still seeing the sun in the sky, and the moon has the same half, shine to it. Even though, let's rewind from that. Today, I saw a full moon almost with the sun in the sky. In 15 days, I'm going to see half a moon with the sun in the sky. And then another 15 days after that, I'm going to see a full moon with the sun in the sky. This is what I don't get with you guys. I don't get you guys.
That's not going to happen, though.
No, it happens every day. Oh my gosh. Do I have to take pictures and post them 15 days from now?
Yes, because you'll see a full moon, and 15 days later, you'll see a new moon, not a half moon.
Oh, okay. No. In like 4 days, you're gonna see a new moon, a sliver. In 4 days, and then like 2 weeks, you're gonna see. You're right. Hold on, I stand corrected. In 2 weeks, you're gonna see like.
Can you tie your shoes in the morning?
Wow. No, I use Velcro. I'm stupid. I'm retarded.
You're just doing this to fuck with us, aren't you? Come on.
I love you guys. All you guys. You guys are so funny. You guys are so funny. I'm just saying, why do we see the moon with the sun in the sky full, and then we see the moon again with the sun in the sky half, and then we see the moon in the sky with the sun in the sky sliver. You guys have to recognize the moon has its own fucking thing going on. It has nothing to do with the shadow, bro. Wake up. Wake up.
So it's self-illuminating?
I don't know what it is, to tell you the truth. I cannot.
I went ahead and
explain
used
that.
a basketball since you seem to understand sports equipment. And I went ahead and, the basketball is the earth, the camera's the sun, and the fishing reel, that's the moon. Okay?
Okay.
Now, if you're on the side of the earth, which would be sunrise or sunset at the terminator line, you would see the full moon and you would see the sun. Case closed.
No, it's not case closed. Because let's fast forward to when we can see the same thing, but now the moon has a different shadow upon it. But technically,
that's called the moon's
it should
phase,
have,
and it changes by day, not by minute. Okay.
But technically, it should have the same full moon because the sun. If I see the sun in the sky, the moon should be full, regardless.
Okay,
I don't care what you say.
No, it shouldn't.
Really? Wow.
No,
oh
really.
my gosh. Okay.
You can see a half moon in the sky. You can see a lot of different things. Where's the moon? In the northern hemisphere, where's the moon? Is it north or south of you? If you look at an east-west line, is it to the north of that or the south of that east-west line?
It goes southeast to southwest. Where I'm in California, Southern California. That's where it's at.
Okay, so it's south of you. All right. Can you see a half moon during the day?
Yes.
Great. Can you see a full moon during the day?
Yes.
Great. That's fully explained by the tilt of the moon's orbit compared to the ecliptic. Not a problem. And there it is, right in front of you.
No,
I've shown you in a diagram. I've shown you with a basketball. I can't show you anymore. If you don't get it, you're not going to get it. That's fine.
That's what you've been programmed to believe. You're saying when the sun and the moon are in the sky, sometimes it can be full.
Dude, I just did it.
Half.
It's not a program or a belief. I just showed it to you. I showed you exactly what's going on.
Let them hear. To those who have ears, let them hear. That's it. That's all I'm going to say. Because
you don't have any ears, kid.
You guys are in some deep belief that this is what is, but logically, visually, you see it not to be what you say it to be. Come on, man.
I just showed it to you visually. Seriously, man.
On a side note, I'm not saying it's flat. On a side note, I'm not saying the Earth is flat.
All right. Well, good luck to you in your endeavors.
I'm just saying it's not a 25,000 circumference because it doesn't make sense on your model. Bottom line, it doesn't, and it won't. It will never make sense.
Well, if you don't understand it, nothing makes sense to you, my friend.
That's fine.
It's definitely in the
look,
model.
Look at Bob. I love you, Bob. We had really good conversations. I'm just saying, there's something that doesn't make sense.
And this is the biggest problem to you having a conversation with somebody. You cannot bring yourself to understand what they're talking about, and it's been explained very clearly to you.
No, that's not that logically that doesn't make sense, Bob. Come on, wake up. It doesn't make sense. If
to
I
you,
can
maybe
see
it doesn't. I think it makes sense to everybody else.
If I could see a full moon when the sun's out, and then I see a half moon when the sun's out, and I see a sliver when the sun's out, that's telling you something, bro. That's gotta spark something in your mind to realize that the model that you believe in is not accurate, because you cannot have A plus B equals C when it
Yet it
doesn't.
explains it perfectly, so I don't have a problem with it, and I'm not going to discuss it anymore.
It doesn't explain it. It doesn't. I'm sorry, it doesn't. It doesn't. I will leave. Look at. Let's agree to disagree, because I will not believe what you're saying, because that's not reality.
It doesn't require your belief.
Hey, you're right. You're right. It requires what I see, and logically,
ignorance is a choice, my friend.
Well, hey, we all can stand and say whatever we want, but when we see something with our own eyes and it doesn't make sense, We have to question it. Bottom line.
All right. So if you take those observations and you match them up against the actual model instead of your version of it, then you find that it does actually fit the model.
Yeah. Okay. It fits the model. Okay. Now we're dealing with models. Okay. You're right. And honestly, real talk, I can't argue the model because the model's been constructed for hundreds of years and it makes sense. If you build a box, listen, if you build a box and you tell me it's 4x6, I can argue that because you constructed a box to be that. But logically, if there's any doubt in my mind that now it doesn't make sense, I question it. Let's go from there. Because there's too many things that make me question the model. And that's the problem with this.
You don't understand the model well enough to question it. That's the point.
I understand. Bro, we all went through public.
What is the formula for the circumference of a circle?
Is it pi r squared? No, I'm wrong, man.
Nice
I'm
try.
drunk. Don't listen to me. It's something like that.
That explains a lot. Thanks.
Yeah. It explains a lot, but realize that logically, when I'm not drunk, I see things and it doesn't make sense. It cannot make sense. Like it doesn't. It just doesn't make sense. When I can see a moon and the sun in the sky, and it's one thing, and then 15 days later, I see the moon and the sky in the same position, and now it's different. That doesn't make sense. Wake up!
When are they in the same position?
It's diameter times 5, and he ain't thinking like a sphere, man.
Well, I'm glad you looked that up.
I didn't look that up. I answered that on the spot for you on Jose's the other day. You said I was right. You said you was proud of me, man.
Yeah, I can say that Brian Leakey would definitely know the circumference of a circle. I don't know how much else though.
Now, are we not like assuming that the Earth is a circle at that point?
Nope.
No. Okay. So when I can see so when I can see something that's 50 miles away from me, technically I shouldn't be able to see it. That doesn't spark any type of logical reasoning.
You should be able to see it.
What?
If you can see it, you should be able to see it.
Even though logically it doesn't make sense?
Makes perfect sense. It has to do with a lot of other factors. Your observation height, the height of the object. How far away are clouds on the horizon?
How about...
How far away is the moon on the horizon?
It depends.
Depends
on
what?
Its position.
What position? So what's the range? How far away is the moon when it's on the horizon?
It depends where I'm at and the moon itself.
That's obvious. That's what I'm asking you. What is the range of distance to the moon from your location if the moon's on the horizon?
I say thousands of miles.
How many thousand?
I don't know. I don't have a measurement long enough, a measuring tape long enough.
All right. So, you know what a racquetball is or a baseball?
Yes, sir.
If the Earth was the size of a baseball, how far away would the moon be?
I don't know. I can't measure it with a measuring tape.
Okay, so it would probably be 40 or 50 inches away.
Well, you say that based upon what you've been told that it is, right?
No,
Am I
based
wrong?
upon what it's been measured to be.
Exactly. What has been measured to be. Now, let me tell you this. If
about 240,000 miles.
If some guy came up to you and said, this flashlight that is in a distance is 100 yards. And if you're just going to believe him, then you believe him. Yeah.
No. But if he says, I've measured this at 100 yards, and here is how I measured it.
Because he physically measured it. Because he physically measured it. He physically measured it. Now,
no, he doesn't have to physically measure it at all.
Wait, no, hold on. He physically measured the light.
I'm not going to argue with you about putting a tape measure to the moon. I think that's a stupid thing to talk about, and I'm not going to waste my time with it.
Yeah, because it collapses the whole theory. I get it.
You don't have to measure it with a tape measure to know how far it is.
Really?
There are many other ways of measuring it.
So let me ask you this. Once upon a time, the moon was a certain distance.
Start it over again without the once upon a time.
Listen to me.
No, start it over again without the once upon a time.
Once upon a time, the moon. No,
See you later.
let's even use the sun. Once upon a time, the sun was a certain measurement away. And now, 91 million miles later, it's now a further distance than what they actually thought it was. When you give me those examples, I tell you that they're all full of shit. They have no idea what the distance is because no one can physically measure that. Wake up. Wake up. That's it. Just wake up. At least allow something to spark your brain to realize if you're just going to believe what someone says.
Well, you can go on. I'm not going to address it because you started it off with once upon a time.
Okay. I won't say once upon a time. I'll say in history, recorded history, the sun was a certain distance. Okay.
Yep.
And now, 91 million miles later, we have a new recorded distance. So how do you even give?
It's 93.5 million miles, and better measurements is the answer.
How?
We can measure things better than the ancient Greeks.
Okay. Then with that being said, I stand corrected. I'll shut up.
Okay.
But those who have an ear, let them hear. That's it. That's all I'm going to say.
Grow some ears.
That's it. Because a man and textbook can tell you this is that and that is this. But no one's measuring it physically.
You can measure it yourself.
With math on a paper, equations, formulas. You can do all you want. But at the end of the day, nobody knows. Guess what, Rob? Guess what, Bobby? Guess what? 500 years from now?
Did you call me Bobby?
Will be Bob.
Thank you.
500 years from now, we're not going to be here. And there's going to be a new measurement. Because we are stupid compared to them. The same way.
Years from now, there probably will be a new measurement. It may change by a matter of meters.
Want to know why? Because 500 years ago, we had a measurement. And it was inaccurate to today's standards.
When did they do the first? When did they do the first transit of Venus measurement?
How did they get the measurement of Venus?
Why do you need the measurement of Venus for a transit of Venus?
You tell me. One based on parallax?
You don't. You use parallax. So when was that?
I just said that. So we're going to use
you
something.
needed a measurement of Venus.
But who measured Venus? Who measured Venus?
Listen to my question. When did they do the first transit of Venus parallax measurement?
You're talking about a textbook answer. You're talking about
a historical answer.
You're talking about something you've been told. This is what it is.
Wake up. If you're going to argue the history, you have to know the history.
Wake up. Wake up.
Yeah, he can't even answer basic facts. I'd ask him how they did the parallax of Venus, but he'd be fucking clueless.
Yeah, I'm clueless because, want to know why? Because I don't give a fuck at the end of the day. Want to know why? Because you cannot tell me how far Venus is. Because you never measured it. Fuck parallax. That's bullshit, bro. That whole idea, that whole philosophy is bullshit because you never physically measured it. You're giving me theories. You're giving me calculations, but nothing is measured.
How much would a 93.5 million mile tape measure weigh?
You're not. Yeah. Still, you're assuming that something's 93 million miles away. Oh my God!
We have plenty of different ways to measure it that way. So tell me how much a tape measure that long would weigh.
I think that's the question of the year, Bob. How much would a 93 million mile tape measure weigh? There you go.
Yeah.
More importantly, more importantly, how do we even measure 93 million miles away without even measuring it?
Well, Bob, the claimed transit of Venus and the parallax of Venus, that one's an interesting one. It's actually assumption on top of assumption. It's like an assumption sandwich.
Oh, really?
Assumption sandwich.
Please tell me how.
Thank you.
Please tell me how so. How do they do a transit of Venus? Go ahead.
This is how they acquired the astronomical unit?
No, tell me how they do a transit of Venus. What's the measurement involved? Yeah, I didn't think so.
We can have a conversation, but I'm not going to do condescending question answering, but we can discuss it.
It's not a discussion.
you said there were assumptions.
Question. How do they do it?
But what I'm saying is we're not doing condescending quiz time. If you'd like to have a discussion, I'm happy to do so.
I'm asking you a simple question. How do they do a transit of Venus?
That's not a discussion.
Okay. Well, then we're not having a discussion.
Okay.
So then the claim that it's assumption on top of assumption also disappears.
Nope.
Yep.
That's gone nowhere.
Yeah, if you don't want to discuss it.
Seems like Bob isn't willing to have a conversation
that's not
based on condescending.
If you'd rather not discuss it.
This is a live
I'm happy to. Just tell me how they do it.
And what is
Start
the
off
second
by
assumption
showing me
I'd like
you know
to
what
get?
the transit of Venus is. Tell me how they do it.
Well, which one are you talking about? Parallax? Or are you talking about how they assume the size of Venus?
Okay, which one's a transit of Venus measurement, which is a parallax measurement? How did they do it with the size of Venus? I'll tell you what. I'll give you your choice. You tell me how they did either one of them.
I'll tell you how they did it. Inaccurately.
Actually, they were both pretty accurate. So,
but
Jeremiah Horrocks did it in 1761 using the size of Venus. So how did he do it?
No, but how do you get a distance from something that you didn't get a distance from? Come on, man. God damn.
What's the basis of both of them?
It's
part of the basis is assuming the size of Venus.
Okay, that was Horrocks in 1761.
And that involves
okay, so where did the assumption of the size of Venus come in?
It's really even more than an assumption sandwich. It's like an assumption triple cheeseburger.
Yeah.
Because even assuming the size of Venus, even that assumes that Venus is a ball and that the Earth is a ball and that it's out in some vacuum.
We already knew that.
So it's even the deeper layer.
And we knew that it was 0.72 astronomical units from the sun. And since it was between the sun and the Earth, we knew it was 0.28 astronomical units.
And who measured it?
Right. And when you say we know that, just because you say we know that doesn't mean you have a fact.
Who measured that distance with physically?
You have an assumption that you're starting.
Who measured that distance physically?
Not really. If you look in greatest elongation, you actually could look this up.
So it's a theory. It's a theorized. It's assumptions, right? Because guess what? Guess what?
It's an assumption.
Bob,
it's
guess
model.
what? Bob,
it's an asserted model.
Bob, guess what? If I was at work and I assumed that a piece of iron, a beam, was so far apart from, the connector headers, if I assumed it, would I be accurate or no?
Well, if you had a 20-foot piece of iron and you had a mark on it exactly halfway from end to end, would you understand that mark is 10 feet from each end?
But you know the difference? I can measure that mark physically.
Okay. So, in other words, you want to put a tape measure on it. That's the only measurement you'll accept, Gio?
Because it's physical. Come on, wake up.
So you can't measure anything else. All right.
No, you can't.
All right, go ahead and have a look at this image that I'm putting in chat right now.
Okay. I'll look. I'll dabble.
Thank you very much. Give me just a second.
Okay. I'm just saying, without a physical measurement, you can't tell me the measurement. If I told my apprentice, my kid, hey kid, go give me a measurement, and he just stood where I'm at in my position, he's like, that's 40 feet. Should I just take his word? Or should I say, yo, nigga, take your fucking measure tape and give me a mark? Yes, give me a physical mark, and then we could talk about distances, because that's the way the real world works. You want to spit in a sense of assuming it to be a distance. Go ahead.
So right here, I've got a picture of a basketball. You see that?
Mm-hmm.
Okay. Do you have any questions that basketball is a sphere?
No. How far is it from you?
Okay. Now, does that basketball have a radius?
Yes, sir.
Do you know what it is?
No.
Is it still a sphere?
Yes.
Okay. So is there a way I can find the radius of that basketball? Can I measure the circumference?
You can measure the actual basketball. And
can I measure the circumference and calculate the radius, or do I have to drill a hole in the side of the basketball?
No. You don't have to do that. You don't have to do that. What you have to do is take a measuring tape and 2 right angles and get the accurate distance of that basketball, and then you could tell me it. But guess what? You can't do that with a light in your view of a sky.
Sure you can.
You're not physically measuring it, bro.
Sure you can, and sure you are. What are you physically measuring?
Wow. That's
what are you physically measuring?
The ball.
Okay. So with Horic, where you're measuring the size of Venus, and when you assume that the size of Venus is the same as the size of the Earth, how do you use that by his method to find the distance to the sun?
Let me ask you something. If I'm 10 feet from that basketball.
All right. No, I'm not. You're not answering any of the questions, so I can't really.
Just listen to me.
No, we're done talking.
If I'm 10 feet from that basketball, is it the same radius as if I was 30 feet from the basketball?
Obviously, yes.
Well, Bob, the equivalent would actually be, I mean, I think if I'm kind of following what you guys are trying to do here. I mean, Bob, if you put that basketball outside your window up in a tree, and then somebody was asking you to measure the distance to it. It's not even a great example. But the thing is, you guys are claiming that these balls like Venus are the hundreds of thousands of millions of miles away, depending on which planet you're referring to. But you have no way to even verify what that is other than the observation down here of literally a circular orb light in the sky.
No, we're fine with it.
Thank you.
No, we know how far away it is, and we know the angular size of Venus.
How do we know how far it is if we didn't measure it?
Kepler.
Oh, simple. Kepler. Simple. All right.
Yep.
Easy answer. Okay.
Yes, it is.
All right. Then.
Because he formulated a fabricated orbital theory.
All right.
Which is borne out by things that can be measured in different ways.
All right. Whatever.
Theoretically and pseudo-physically.
So Bob.
Pseudo-physically, there's that again.
Okay, Bob, listen.
Give me 3 ways to find how would you find the distance from the Earth to the Moon? Do you have any way of doing that?
Bob,
how would you find the distance from the Earth to the Moon?
If I put a basketball.
No, we're not talking about basketball. We're talking about the distance from the Earth.
We're talking about that basketball you posted. We're talking about that basketball you posted. If you took that basketball and placed it 50 yards away from you, can you tell me the circumference of it?
Yes.
Only because you know it's 50 yards, right?
Yes.
Because you physically know the distance. Now, I don't.
No, you can determine that through parallax, actually.
Listen.
Yeah, you can get it from parallax. You can get it from triangulation.
Now,
you can get it from knowing the size of the basketball. There's a lot of different ways that you can.
Hold on, you guys are talking at the same time. Hold up, you guys are talking about the same time. Let's let Bob say something because I think he wanted.
All right. All right, go ahead.
Well, the bottom line is, if you have a basketball, it depends on what you know about the basketball. If you know the diameter of the basketball and you measure the angular size of the basketball, you can tell how far away it is.
How do you know the basketball diameter if you didn't measure it?
Over me.
Go ahead.
I know. I will go ahead. You be quiet.
It's a good question he asked, but yeah, let's try not to overtalk him. Let's let him finish.
All right.
Go ahead.
So if you know the diameter of the basketball, you can measure the angular size and determine the distance. If you know the distance between 2 points and you measure the angle to the basketball, the center of the basketball, you can triangulate the distance to the basketball. If you know the distance to the basketball and the angular size, you can know the diameter of the basketball. All right. Thank you very much. I do appreciate it, Gio. Go right ahead.
Beep boop boop.
Well, I think I think what he was asking is, yeah, but you still haven't physically. And when it comes to Venus, you haven't physically measured anything about it. The diameter, the circumference, the distance, anything. It's all just assumed upon a model.
Did you miss the part where there's 2 points and you measure parallax?
Here we go with parallax. Parallax is based off a known measurement. If you don't know the known okay, for instance, let me put me back on the job site. I have a beam that's a distance that I can physically measure.
All right.
Then I can understand the parallax when I see a lamppost in my beam's view. I can say, okay, I know the height of that lamppost because here's the parallax that we're talking about. But only because I've measured the distance of my beam can I even begin to calculate that. You guys are in a whole nother world of assuming the distance of a parallax and all that, yet you never measured the actual thing you're trying to claim is a certain measurement. Wake up.
Okay, that's not how that's actually done.
He's right.
If you have a distance,
correct.
if you have a baseline to work from, and you have that known distance, like say across the surface of the Earth, then you can use that to figure out how far away something is.
So you're saying the distance of the Earth? No. You're wrong, because remember you're on the ball, so you don't have the distance of the Earth because you're on the ball and it curves down. Blah 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 blah
Sure
blah
we
blah.
do.
Hey man, have you been drinking?
Yeah, you can measure surface distances.
Yeah, he
it's fine.
has been drinking. I think I'm done talking to him. If Gio wants to discuss this
it's
a little
probably
further,
good for you to
he's
stop talking to me
welcome
because I'm making way too much sense. You're right. I'm like, even in my drunken stupor, I'm still schooling you guys. It's crazy, right?
No, I'm done talking to you.
Yeah, it's
You're
crazy.
pretending to not know geometry or basic 3D concepts. It's fine.
So are you assuming this base on Earth as spherical or flat?
Right, he's just saying he's assuming a baseline and then somehow asserting it as a solid baseline of actual measurement, which it isn't.
Exactly. Thank you.
You can't measure distances on Earth. Are we back to not being able to measure distances on Earth now?
No,
Let's just pretend we can't measure anything on Earth.
That's the problem.
Well, you haven't drilled a hole through the Earth and put a tape measure on it, so I guess not, right?
Well, the Earth isn't round, so we can start there. But anyways, so let's talk about
easy to determine the distance, the chord distance between 2 points on the surface.
You're assuming that it's a ball, first of all. Then you're
a
taking a moon or a Venus, a planet, and you're trying to say that this is a certain distance because of where I stand, and I'm taking the measurement of the land that I can see based on the angle, and then you're giving yourself an own value. That is inaccurate. Want to know why? Because you're still not physically able to measure it. Guess what? You cannot measure a horizon from you because there's refraction. So your horizon might be
the horizon's not even involved.
Your horizon might be 3 miles away. It might be 10 miles away.
He's just going over YouTube videos. That's fine.
Yeah, whatever. You guys,
you
guys can hand wave facts and truth all day. It doesn't make a difference.
Right, you can make up stuff too. The horizon has nothing to do with the measurement.
You said that we're measuring the Earth. What are you talking about?
Right. Nobody uses the horizon to figure out how far it is from one city to another. That's just something you made up.
So how do we find Venus distance? How do we find Venus distance? Go ahead.
Oh my God, dude.
Well, yeah, Doofus, I think this was started because you were talking about using a measurement on Earth that somehow correlated with Venus. So
exactly.
Right, and it has nothing to do with the horizon.
Okay, then explain it.
But the horizon is false.
Distance, something you can measure between, say, two cities that you obviously can't see from one another. You still know that distance, and it has not a fucking thing to do with the horizon.
So how about this? How about when you're on one side of Lake Michigan and you can see Chicago? Does that make an
For
effect?
God's sakes. Don't pay attention to the actual method used. Just make up some more bullshit.
Yeah.
I'm
we're not
just saying.
talking about that. We're talking about the expanse of Venus.
I'm just saying. Can you take that measurement and then find out Venus's size, or no?
That's not involved in the method. We're not going over a lake and looking at another city. We're looking at a surface distance. We're measuring the surface distance. We're not using the horizon. We're not using a lake. We're not doing some other bullshit that you made up.
Right. Then how are you relating that then?
The ultimate thing that we need.
You're the one that related it. What are you talking about? You're the one that said it. What are you talking about?
The ultimate thing that we need
No,
is
I didn't.
the port
You can lie
distance
about what I
between
said.
the 2 points and the angle. That's all we need. All right.
The angle. Okay. So the angle of this light in the sky.
Venus.
I'm going to take the angle of it.
Venus.
And now
planet
somehow.
Venus?
Listen. And now somehow. I know
when
the
you don't use the term light in the sky, we'll discuss.
Listen. I'm on Earth. I look up at a light in the sky. Somehow, I now know the diameter of the light from where I stand. Go ahead. Explain that.
No, you use the term light in the sky. We're not going to go with that. Rephrase it.
It's a light. It's a light. Is Venus not a light in the sky?
You can't. That's how you decided to respond to that instead of actually responding with any content?
Right. We could actually call it Venus instead of calling it a light in the sky because we can identify the object known as Venus.
Okay.
It is a light in the sky.
Okay. So let me stand corrected. Now, I'm on the Earth. I look up at Venus, and now I know that Venus is a certain diameter. How do I get that? From where I stand on Earth, how do I get that diameter? Go ahead. Please explain.
You guessed.
You guess it.
You guess it.
Yep.
Okay.
And it was a lucky guess, but there was no reason to believe it was true.
Wait, is that really your response, Bob? Are you actually saying that?
Wow.
Yeah.
Wow.
It was a lucky guess on his part.
Wow.
It's a starting point.
Well, it was an assumption.
Those who have ears, let them hear.
Yeah, it was a lucky guess.
It's a starting
point.
point.
The transit of Venus with parallax isn't a guess, and that has nothing to do with the size of Venus.
We are talking about the size of Venus by saying we assume the size of Venus.
Correct. Absolutely.
Okay, well there we have our first assumption. Remember we had the triple cheeseburger?
Remember.
Yeah, it was a very good assumption, and it worked out well.
Remember when I said I cannot argue a construct that you placed before me if you built a box 4x6? I can't argue with that because you have created that. And now I'm trying to find the truth in that, but nothing makes sense to what you said is true in your model. I'm trying to figure out how the fuck did you figure out that that's 4x6 when you cannot physically measure it? But you're saying
it was a lucky guess.
Go ahead.
It was a lucky guess. That's all.
Wow. Okay. Hey, guess what? All right. Welcome to Globe Earth, everybody. We're all ballers. Woo!
Now,
it's interesting to say. Yeah, it's interesting for them to. Well, see, they say it's lucky guess, but the thing is, the ways that they claim that they confirmed it later are also based on assumptions and also based on the same heliocentric model that quote unquote just happens to fit this assumed size and distance of Venus, a planet out in their solar system.
No, actually, we know a lot of things about Venus now because we've been there. For example, we know
because we probed it, right? We're gonna get into probes now. Is that because they probed it?
Been to Venus?
We actually measured the distance to Venus with radar. Okay, well, you can laugh all you want, but it's a historical fact. We measured the distance to Venus in the 60s with radar.
I'm not gonna argue with you.
You don't have an argument to make. That's
I'm not gonna argue with you
on your part.
I'm not gonna argue with you that the fact of somebody said this is fact. I'm not gonna argue with that. I'm gonna disagree with it, but I cannot argue that once upon a time somebody. Oh no, you don't like that. You don't like once upon a time. Hold on. Let me refrain that sentence. Or retract it. You said Somebody said this is the distance, and we cannot argue with that because that is what's fact. In our textbooks, they tell you this is what it is. But with that saying, on the other side of that coin, nobody has physically measured these distances, bro. Nobody.
Okay, radar
And they
is
can't.
something that's not really just, not physical.
What?
Radar is definitely a
believe
thing.
that radar
Definitely
works?
part of physical reality.
Yeah.
So
Does
you're saying,
radar actually?
hold on.
Does
So
radar
you're
actually
saying,
measure things?
so you're saying radar tells us where Venus is?
Does
Radar can
radar
tell us
measure
where anything
distances?
is if it can bounce off a signal off of it.
Yeah. Does radar measure distances?
On Earth, yeah, you're
No.
right.
Does it measure distances anywhere else too?
On Earth, yeah, you're right. On Earth,
Why does it have to be limited to Earth?
because that's what radar does on Earth. I'm talking logically. Go ahead.
No. Tell me
No.
why it's limited to just on Earth.
Because that's where we're at. We're on Earth. That's radar.
Okay, can we point the radar straight up and measure the distance to something above us?
Can you explain something to me? Why does radar?
No. Answer my question before you ask me anything.
In the
It's
Naval
called special
Academy.
pleading.
Yeah.
In the Naval Academy, why
Yeah,
or how?
Don't ask me anything until you answer my question.
What's that?
Can we measure straight up with radar?
Yes. Yes.
Okay, great. Is that a measurement?
Yes.
More questions.
Okay, great. So if we measure the distance to Venus with radar, is that a measurement?
Did
Or the
we
moon?
though?
Or the moon?
Did we though?
Yes.
Okay, so you're saying we shot out a radar to Venus. How long does it take the radar to hit Venus? Do you realize? Hold on, real quick. Do you realize if I shot a radar shot out to Venus, by the
How
time,
far would that take?
hold
How
on,
long would that take?
listen.
Well, let's let him answer it. Let's let him answer it.
By the time the radar reached Venus and the Earth spun, motherfuckers in China would get the receiving signal. Do you not agree with me or no?
No, I don't.
No, it wouldn't.
Really?
Doesn't work that way.
Wow! You guys are on something.
How long would
You
it
guys are
take a
funny.
radar beam to hit Venus?
You guys are on something. You guys are funny.
How long
Wouldn't that
would
be
it
about-
take a radar beam to hit Venus?
Would that be about 8 minutes, Bob?
No, 2.
You would, no.
It's
2
about
minutes.
it's a little over a
Really?
quarter of the distance to the sun, and the sun's 8 minutes away.
But that's assuming that the sun is a certain distance. Come on, bro. You're
No, we
all
measured
No, the
that.
signal came back.
assumptions.
No, we
No, the
measured that
signal
too.
comes back. It's not an assumption anymore.
Yep. So if we bounce a radar beam, if we fire a radar beam at Venus and get the answer back in 4 minutes, we know how far away Venus is, right?
But what if it hit an asteroid in the way? What if it hit a rock in the way? What if it hit what if it hit
You think
something
we just
else?
did it once, you simpleton?
What if it hit something else, not Venus? Because guess what? When you shoot radar, it hits a solid, right? What if
All
we
right,
hit
isn't this characteristic 4 of science denial?
what? Hold on. What if it hit the Van Allen radiation belt, filled with asteroids and rocks? What if it hit that and then
There's asteroids and rocks in the Van Allen radiation
How
belt?
do we know? How do we know it hit
Oh my
Venus?
God.
How do we know it hit Venus?
This guy's too dumb to talk to.
I'd like to say one thing about that. It takes 4 minutes, so whatever it's hitting is at least that far away.
2 minutes out, 2 minutes back.
2 minutes. That
So
sounds really
that
close.
means that whether it's Venus or not, whatever it is, it's ton far away, and it seems to coincidentally align with when we see Venus.
So what would you guys
All the
say?
time.
What's your best citation for what you thought? Because obviously I know you haven't bounced radar off the moon. So what's the article or the thing you found on the internet that most convinced you that they did this?
You're presupposing the medium. You're presupposing the medium in between us and Venus. That's one of your major assumptions.
Exactly.
So why do they do calculations based
Exactly.
on
rather than
fabricated
just
speed of light?
Is that citation police speaking?
All right. Now, Gio, rather than just try and waste time by demanding a citation, go look up bouncing radar off of Venus. You'll see.
No, I'm
this
just asking
citation
you,
right there.
since you're the one who's saying you're convinced.
All right,
I'm just asking you, what's the best one?
citation up for you?
What's the best one that you found that really convinced you? That was the question. It's not a debate point. I'm not trying to roast you or anything. I'm just asking, what's the one that I'm inquiring? What's the one that you found that really convinced you of it? The best one.
Yeah, that's a good question. Because obviously you guys are like on something.
He's about to get you one. He asked, right? So now the polite thing to do would be wait for him to come back with the citation.
Yeah,
the whole team that
correct.
was doing it, the whole team that was doing it didn't even believe it. There's one guy that talked him into it. It's bullshit. Sleeping Warrior went over this a long time ago.
Hey, is that you, Citation Police speaking?
Sleeping Warrior went over this a long time. I thought we put this to bed years ago.
Citation
There you
Police.
go. There's just one of many citations. All right.
Oh yeah. Can I reiterate that the model that you believe in has been very, very well, if dare I say, mastered to where every question that can be brought up can be answered in its own assumed, calculated position of everything that
Dude, you're
exists.
sloppy drunk, man.
I'm
measured,
sorry, but
not calculated,
time,
measured.
But at the same
Yeah,
time,
just say that
I
it's
feel like
just
I'm
say that
making
it's made up
sense.
again. I know
All
we
right, so
know
I'm
your
gonna-
opinion.
He's actually complaining that you answered his question.
Yeah.
Okay, so Bob gave an article from something called thehindu.com, and but okay, and then it says here February 10th, 1958, I'll go say it quickly. MIT, they tried to do it at MIT. Basically, it says that the quote-unquote weak radar, random noise, so the results were ambiguous. So they got nothing from that. The next one, they claim the UK's Jodrell Bank in 1959. It was unable to repeat it. No good, nothing. But wait, we have a new contender, the final one. It had to wait another 2 years. It was only on March 10th, 1961 that NASA freshly launched NASA, just a couple years old, the early NASA's Jet Propulsion Laboratory successfully bounced radar from Venus. So it was NASA that claims to have done it. So that's where we're at so far. Everybody else failed and got no consistent results that are usable at all except NASA's claim.
So you think that's the only time it's ever been
Everybody
done?
after NASA.
I'm
I'm just reading the article you sent. You said this was the best one. You were going to
I
say
said
the best
that's
one
one
that
of many.
convinced you that it was real.
No, that's
We
one
said
of
that
many.
was one of many, Gio.
Okay, well, the question was for the best one. If he posted one of many, this is something called the Hindu. It looks like a.
I'm not going to give you. I don't have a
newspaper.
best one. I have a preponderance of evidence, and there are many, many, many radar bounces off of Venus.
Okay, well, so far you've presented two that failed and one from NASA. And
No.
there's no even data on it.
Who the hell cares if it's from NASA or not?
Wow.
There's another one that I just put up.
We care because we know NASA lies. That's why.
So you say.
You presume that NASA lies. That's your opinion.
Did you guys see the video? Thinking about NASA, did you guys see the video of the astronaut? He hits a soccer ball, and then he tries to bump it with his head, and his head goes through the CGI. Did you guys see that?
Amazing.
Yeah, we can get on that topic later. We can finish this transit of Venus topic.
Oh, yeah, okay, that's fine.
Now, all of these radar returns actually match the transit of Venus measurement as well.
Okay.
It also, the other way that you can find it by looking at the distance from the Earth to the Moon.
Another assumption.
No, it's not. That's a measurement.
Yeah,
No.
it is.
Any competent ham radio operator can find out that distance.
Yep.
No. Hold on. Let me correct on that. A ham operator. They will bounce quote unquote a signal off the moon.
Yep.
But that is not necessarily true. That's not as true at all.
Okay.
What is your evidence that
That's
it's
your
not?
opinion. Got it.
Because they don't know the
in science we use evidence. So what's your evidence that these thousands of Earth-Moon Earth bounces?
Because you have no idea what the signal's bouncing off of, bro. If I threw a ball,
an object 240,000 miles away.
Listen. If I threw a ball in the sky and it bounced back,
where the moon is.
If I threw a ball in the sky and it bounced back, what do I have as evidence of what it bounced off of?
Well, it seems to be every time that the moon is in the sky, these things occur where they bounce back from something that's about 240,000 miles away. It's pretty
Which is
convincing evidence that every time the moon's in the sky, we get this bounce back, right?
It's assumed. It's assumed. If
All
you
right.
can,
Well, how would you measure that
if
distance then?
you
Every
guys
time
can
the
be
moon's in the
honest,
sky, right?
Yeah.
if
How
you
would
guys
you
can be
measure that
honest with
distance
yourself,
then?
what if there's something before the moon that it bounces
Every
off?
time?
Then the moon's further away.
Every
Yeah, and
time?
it follows the moon all the time.
What about the ozone layer? What if it bounced off the ozone layer
Then the
before the
ozone
moon?
That's
layer is further
240,000
Is
miles
the
away.
moon
The
outside the
ozone
It'll
layer?
ozone
always
layer?
bounce off the ozone
Is the
layer.
moon outside the ozone layer?
Of course it is.
Yes.
Then what if that signal bounced off the ozone layer and not the moon? That's
Then
what
the
So you're
moon,
saying
then
the
the
ozone layer is
It would bounce.
240,000 miles away. That's fucking brilliant.
Yeah, and then it would bounce every time the moon was not in the sky too, unless the ozone
And
layer only exists
How about
next
this?
to the moon.
How about this? How about
How
this?
about this? How
Remember
about
when
this?
once
Let me
upon
ask
a
another
time?
crazy thing that is important.
How about we just make up stuff?
How about this?
Yeah,
Remember when the moon?
that's
That's
going to
the
be
way
their
to do it.
Hold on,
strategy.
yeah.
They're going to make
Let's
shit up.
yeah. You're right. Let's talk about making up stuff. Remember when the moon was not in our atmosphere, and then like a few years ago, they now say it is in the atmosphere. How about
What?
that bullshit?
That bullshit again.
Bullshit.
Yeah. Yes, it is.
Bullshit.
Yeah, can you breathe
The
on the moon?
definition
Is
of
that the
the
atmosphere that
definition of yeah, the definition of geocorona and exosphere did not change when that article was released. Thank you.
Okay. Wow. You guys are so deep in your bullshit. I hope you wear
Okay, so
boots when you go into it.
right now you have
Was
the
I wrong in
ozone
my statement? Did the
248,000
definition of
miles away.
geocorona and exosphere change when that article was released? Yes or no?
I'm sorry, I wasn't paying attention. What did you say?
Did the definition of geocorona and exosphere change when that article was released? Yes or no?
No, it didn't.
Okay, then the article was pointless. Thanks.
But that's science. That's what you guys believe in. You're right. I agree with you. It's
It
fucking
didn't change
pointless.
anything.
Yeah, it's amazing how it advances and we learn new things every day, isn't it?
God damn, you guys are so thick in it. I swear to God. I love you guys
Well, I think
so
right now
hard.
you're sitting
It's
at the
like-
point where you're
it's-
saying that the ozone layer is 238,000 miles away, and the moon is beyond that. So the moon's more than 238,000 miles away. Cool.
And radar bounces no matter what direction we aim it, whether the moon's there or not, from the same object 240,000 miles away.
So then
You
let
don't
me ask you
understand how stupid that sounds.
Let me ask you a question. How about the naval ships? When they send radar out?
Naval ships on the moon.
Yeah, how
Are
about
there
when
naval ships on the moon? Or are there naval ships between us and the moon?
Listen. How about
All right.
naval ships?
Well, another drunken.
Yes. Listen. Just listen. How about naval ships when they send out radar and they can find a ship 200 miles away from them?
They can't.
They do.
Yep.
Show me.
God damn. You want me to fucking pull out their shit? Okay.
Yeah,
hold up.
I had to go do it for Geo. You're gonna do it.
Yeah.
For me.
You're right. Hold up. You're right.
You didn't really though, Bob, because the question was, what was the detailed documentation of an actual bouncing radar off the moon to get, or Venus is the one we were talking about. That's the Venus one.
I gave you 3 of them.
That was convincing to you. Well, I only saw one. There was just one from a newspaper.
There's more out there,
It was an
and I
online
posted more in the
newspaper.
chat.
Okay, so it's only NASA?
No, but those happen to be sources that I got, and I'm fine with that. I don't care whether
that was the only
you believe
question. Like I
NASA or
said,
not.
it wasn't like a debate point. I'm just literally asking, like, what was the one that convinced you? So,
well, I posted 3 of them, and somebody else posted at least 1 more. So you've got 4 to choose from. They all say the same thing.
all right, I see. Just to be clear, I see one that's the Hindu magazine, and that one did not give any detailed information about anything. It was an article that basically said that 2 people failed, and then NASA did it. Now the other one you
so
posted,
NASA did it. There you go.
Right. Okay. So that one's nothing other than NASA did it. The next one is this the SP4? Okay, you posted it twice. Looks like the same one. So is it that one that you think?
Just look at what I posted. I mean, there's plenty of documentation out there. You can look for yourself too if you don't like those.
Okay, I'm just saying it's the one other one. So
I gave you multiple ones. Another person gave you some too. If you don't like those, you can go find your own. It's not like it's a state secret or anything.
Right, but it wasn't about. I wasn't asking it so you could like. I'm fully aware of this. I've looked at many of these sources. I can't say I've seen every single one, but I've definitely looked into this many times. the question more to you was, what was the one that convinced you? Because like I said, I know you haven't bounced radar. You haven't bounced radar off of Venus, but someone else did, and so I'm trying to see which was the one that just from something you found on the internet convinced you it was real.
Gio, I'm not convinced by any one thing. All right. I'm convinced by the fact that they did it with radar. It matched the transit of Venus measurements. It matches Aristarchus. So
okay, so I posted something, bro. I posted something for you, Bob. Click on it. Check it out. You can suck my dick. I'm sorry, I'm drunk. Just listen. Just read it.
We can tell.
Yeah. Go ahead. Just read it. Just check it out. Fuck you guys. I'm sorry. I'm drunk. But look at this is 250 miles away. Radar picked him up. They hit him with a drone. Oh my god. You guys frustrate me. Listen, you frustrate me because I love all of you, bro, and I just want to pull you out of the darkness. Your lies, your brainwashing, your programming. Come to the side of logic and reasoning. Okay, just click on that.
You were a troll before.
All right. Do you want me to go ahead and address that, or are you just going to continue your drunken rampage?
Yeah, go ahead.
All right. So, did you read the article?
Yeah.
Okay. So, what was special about that test that allowed the Navy to do that was important enough that they actually wrote an article about it? How did they do it?
What do you? I'm sorry. What do you mean?
How did they find that target 250 miles away? Did they do it from the ship? Did the radar come from the ship? What was the purpose of the drone?
To spot the enemy. To spot the. Okay, hold on. How much curvature drop is in 250 miles?
That's not the question. The question is your article that you posted. Why were they talking about drones with that? What was the purpose of the drone?
No, wait. So how were they able to do it? How were they able to do that?
What was the purpose of the drone?
Is Earth the ball or no?
The answer is in Bob's question.
In the first paragraph too, or second paragraph.
Yeah, you see, here's the problem with flat Earth. If you're going to post a citation, read the fucker. All right. What do they say about the drone? What was the important thing?
Listen. The SM-6 flies at Mach 3.5 and has a range in excess of 250 miles. 250 miles.
Which is irrelevant to how they found the target 250 miles away. How did they find the target? What was the role of the drone?
To pinpoint it.
How?
They simulated a target with
so you can't even put the pieces together on your own citation.
No. I'm telling you right now.
This is embarrassing.
So
yeah,
the drone,
this is typical flat Earth bullshit.
So the drone was able to hit something 250 miles away.
What did they mean by team up with a
Bob, why
drone?
don't you just share? Bob, this is a live stream. It's not really a roasting of someone. So why don't you share with us the information if you have something to share instead of doing the condescending?
It's not my information. It's his.
Right. Well, just whatever you want to share about it, share about it so we can hear what it is.
The way you see an object 250 miles away from a ship is you don't fire the radar from sea level on the ship. You put something up way high in the air that has that amount of range.
Oh, so you're saying that something high up can see around the curve of your ball. That's what you're saying.
Oh, he's catching on. He actually almost understands the shapes.
Yeah, he's saying it, but I don't think he understands.
2 weeks ago.
Well, yeah, there's a limit. There's an atmospheric occlusion limit to where you're not going to be able to penetrate down certain distance.
I'm done with that conversation.
You would have to send it at altitude if you're going to send it beyond a certain distance, because at the ground level you've got rainstorms and clouds and particulates and moisture and way too much.
Radar sees right through that shit most of the time.
Yeah.
Well, it depends on the distance.
So you're saying radar? Hold on. So you're saying radar? First of all, how did he pick up the enemy from 250 miles away with a drone, right?
He went up in it. Okay, I'm sorry. I'm tired of this. They sent up a drone. It went up high enough and far enough away from the ship that it was able to see it.
Yeah.
With
250 miles away. Now, hold on. For all
Yeah,
you
from not sea
Globers,
level.
or for all you Globers, what is the drop of curvature from 250 miles away?
Totally pointless
There's
in an
an
altitude
airplane you can
elevated
see
thing.
visually from altitude. If that drone was at 38,000 feet, you can see about 250 miles visually.
Welcome to Flat Earth.
Yep. Yeah, Jay
That was how
Dolan,
much-
33,000 feet. You can identify objects 215
Welcome
miles
to
away,
Flat
no
Earth.
further.
Welcome to Flat Earth.
Now, with approach radar at airports, that approach radar's got a setting on it that you can see a plane 250 miles away, but that plane has to be above a certain altitude for you to do that. Now, in 1972, when they launched Apollo 17, all right, I could clearly see it from my house. I was 153 miles away, but I didn't see it for the first 30 or 40 seconds after it cleared the tower. Why was that?
Because the curve, right? Because the ball,
Absolutely.
right? No, motherfucker. It's because it's the angle resolution. Because you cannot see something so far away
I saw it very
a
clearly.
certain distance.
No, I saw it very
Or
clearly.
height.
And at 10 years old, I was able to recognize the curve of the Earth by my own eyes.
Oh my
Now,
God.
the question is why is a grown-ass man like you struggling with that concept?
So wrong. Listen, why are you... Hold on. So you think the sun actually sets, right?
Oh my God.
Right? You think the sun actually sets, right? You think
Yeah,
the
it
sun
crashes
goes
into the earth.
down, right?
Go away.
Yeah, we're not going to address the thing that you crash and
You
burned
think
on.
the sun...
fact that there's something that has a
you
high
think the
altitude
sun
can see
goes
further.
beyond the curve,
Obviously,
right?
it makes
Like
perfect
a
sense that
boat?
something that's a higher altitude can
You
see
think it
further,
goes
right?
beyond a boat, like a boat, right? You think you guys are so fucking stupid. You think a boat goes beyond the horizon, even though we can zoom in and see the same fucking boat at a certain fucking distance. You guys are fucking stupid.
Right, but we're not going to address the fact that you crashed and burned and provided a citation that said that something that got high could see farther.
Yeah,
Wow,
I mean, come on, man. Read your own citations.
No, hold on. No, wait.
Hold on. I'm drunk.
I'm not talking about it's all 10 miles further. Motherfucker, it's all 250 miles further, bitch. God damn, you guys are stupid.
At altitude.
You are stupid. You guys are stupid. You're stupid.
Chill, bro.
Do you know what that word means?
Why are you guys talking to this guy? He's a drunk. He said before he's not even a flat earther.
No, you're right. I'm not going to proclaim that I even know the measurements of the earth, because the scriptures say that no man will never know the distance nor the depths.
The Bible uses bad English like that?
It says that in scripture. It says that in scripture.
Were they drunk when they wrote it?
No man will never know.
It's a very drunk Bible.
It says that the day that man knows the distance or the depths, he will pull man from Israel. Last time I checked, there's still man in Israel, Baba. Still man in Israel.
Hey, Gio, I'm done with this guy.
No man knows.
You have a good night, my man.
Yeah. No man knows the distance nor the depths. But you guys claim it. Because you
I
guys
was looking at Bob. Going back for a second.
You guys are liars like the fathers before you, who was a murderer. He was a murderer and a liar for the beginning of time. That's your father.
Let the butthurt flow through you.
Yeah, you guys are liars. You guys continue to believe the lies, just as your father did. Fuck y'all.
I think it's funny though. He's surprised that the distance that the curve calculator predicts you would be able to see something with radar. You can see it with radar. Amazing.
250 miles away? Really?
Well, yeah. Moyak, going back,
when I was in an aircraft.
Going back a little bit in terms of the radar reflection claims from Venus, Bob posted the one from NASA. The other one that Chronic posted, the first sentence says, Radar reflections from the surface of the planet Venus at a wavelength 12.5 centimeters yielded a value of an astronomical unit of 149, etc. Kilometers, or a solar parallax, and has the degree based on an Earth radius of. So there's your assumption. This entire thing is based on a radius of Earth.
Exactly.
By the time that this paper was written.
In addition, even those claims that they are based on the radius of Earth, in addition, this one also claims NASA. So far, you've only presented ones that only NASA has done.
Thank you.
Okay,
God
so here's
damn.
the problem
Who's
that you run
talking right
into, Geo, and this is your problem in logic. All right. Now, it is correct that if we use the Earth radius, we can measure the distance to Venus using parallax. That matches the radar distance, which confirms the radius of the Earth. There you go.
False. It's an assumption. You cannot say fact when it's assumption.
The
radar
radius of
this
the Earth
paper was
is
written.
known.
Right.
Radar
By the time this paper was
it's not
written,
known. It's not known.
by the time that this paper was written,
Listen. They've dug 8 miles deep. That's it. You cannot tell me it's
That's
fact.
irrelevant.
yeah, by the time this paper was written, it was already well established what the. Oh my God, dude!
Get
By
out
the
of
time
here.
by the time this paper was written, it was well established what the radius of the Earth was.
No, assumed, not was.
I've
assumed.
demonstrated 5 different
Wanna know
ways
why?
to measure the
Wanna know
radius
why
of
it's
the
a-
Earth.
wanna
Can
know
you
what-
name 3
No,
of
you
them?
guys are all full of shit.
Right, because Bob, the thing is,
I have
Bob,
measured. I
Bob,
have
you're all
demonstrated
full of shit.
5 different ways to measure the radius of the Earth.
You're all
Can you
full of
name 3
shit.
of them?
You're all full of shit.
because
Name
is where
3
they,
of them.
Bob,
They
But
dug
Bob,
8 miles and that's it. Get the fuck out of here. They dug 8 miles and that's it. Get the
Yeah,
fuck
you've
out.
already admitted that you can find the radius of that basketball by measuring the diameter.
Or
But
circumference.
what? So
Bob,
who
but that was
measured
the thing. Hold on.
the diameter of Venus?
Bob, you were
Who
saying,
measured the diameter of Venus?
Hold on, bro. You were saying, Bob, that you assume the radius of the Earth and then get your calculation. The thing is, if you assume the radius, if you assume the Earth,
I don't assume the
is a
radius of the Earth.
sphere. Hang on, let me just say what I'm saying. If you assume the Earth is a sphere and you make the radius, let's say 10,000 miles, 15, 20, and you're saying that Venus is a ball out there, you could do any calculation, just plug and play.
All right, but we know the radius of the Earth, and I've got 5
we
different
don't.
ways.
No, we don't. No, we
All right,
don't.
look,
It's
look,
an
don't
assumption.
talk to me anymore.
No,
Don't talk to me
no. I
anymore.
stop
I'm putting
you. I
on
stop
mute.
you. I
Yeah,
stop
all you
you.
have
I
to do is
stop
Fundy
you.
mute, right,
Yo,
Apocryphon?
I stop you.
Yeah.
Fundy
We
mute is the
dug
only
8
thing
Yeah.
miles
that you
deep.
can do.
I went
even
ahead
if
and
We
muted
dug
him.
even
I
if
8
the
can't. I'm
person
not
miles
has
going
to
to deal
deep,
with
and
him
that's
anymore.
it.
I went ahead and muted him. I'm not going to deal with him anymore. I've got 5
Yo,
different ways that I can
I don't
measure
give
the
a
radius
fuck if
of
you
the
muted
Earth.
me. I don't give a fuck if you muted me.
Hold on, bro.
Name 3
Other
of them.
people want to maybe speak as well. I know.
Go ahead. Go ahead. Yeah, go ahead. Go ahead.
I vote
Bob,
I
don't
yield
you
all
make
my
it
time
6
to
ways now?
Apocryphon.
Bob, aren't you at 6 now with Venus? 6 ways of measuring?
Maybe he's got you.
I guess you could probably say that as well. Because if you have the parallax measurement to Venus, you'd have to have a certain radius of the Earth, which would give you the chord distance. You could
thumb
calculate the chord
radius.
distance and the
A
angle from
thumb.
that.
A
So that
thumb.
would be
So if we
6.
can confirm that, with radar, then you have a pretty bulletproof radius.
Yeah, I mean, how many
like
different
Moyak.
ways do you want me to do it?
Moyak's
How many
like the
different
hype
ways
man.
do you want me to
He's
do
like,
it?
so with the second one you did, you've just got a bulletproof radius and a measurement to be. That was good, Moyak. You're like the salesman for Bob. You know,
All right,
Bob's
so
like the guy
Gio.
trying to sell the used car, and you're like the
So,
guy.
Gio,
who's
I've got
so you would say this car is really solid for the price, wouldn't you?
All right, now Gio, I've got 6 different ways to find the same radius of the Earth. It comes up to the same answer. So why don't you go ahead and give me one that gives me the size of the flat Earth?
What radius?
Oh.
From the equator to the North Pole?
Is that a radius?
Yeah.
Going
not a
from
radius
the equator to the North Pole is a radius.
It's not a radius of a sphere.
Okay.
Oh my
It's
God.
the radius
we know.
of the planar distance to the center.
So I've got 6 different ways to find the radius of the spherical Earth. Go ahead and give me one that gives me an accurate size for the flat Earth, please.
For what? I'm not talking about a flat Earth. I never said anything about one.
Okay, great.
What are you referring to? Who said something about a flat Earth and who said about a size? What are you asking about?
So do you have
saying
any?
the Earth is a ball
Can you tell
floating
me
in
anything about the
space.
flat Earth?
Nobody about if you're talking about a planar stationary Earth type system. So far in this discussion, nobody has claimed anything about sizes or radiuses.
Okay,
nobody
so
can.
I have 6 different ways to find the radius of the spherical Earth, and they all agree with each other. So do you have anything like that on anything other than a spherical Earth?
Wait, so you're saying because you have 5 or 6 that you think are valid, that somehow that means something in comparison?
Well, you're
to
more than
what
welcome to challenge the math.
You're pitting off against a planar Earth strawman?
You're more than welcome. You're more than welcome to challenge the math, but the math confirms the radius of the Earth 5 or 6 different ways.
Through different mechanisms, also completely different.
Yep. Completely different mechanisms. They all come back to the same thing.
Right.
So
and if
what are
I
you
can
gonna
measure
do?
the circumference of something, I can get its radius.
So what are you going to do with that information?
Move on with my life and
Freak out.
continue to navigate across the beautiful
Okay,
globe.
let's see what happens. Today is April 14th. Will you move on with your life? Using the flat Earth model, I predict no. No.
Yeah, Bob, is this moving on? Because it sounds like you're pretty settled on this one. What do you think?
What a joke.
No, I mean, it's not in question. So,
but it sounds like it is because you're here trying to convince people of something.
No, I'm not actually. I'm trying to
might be
figure
that
out
we
what
can-
the errors in reasoning are.
Yeah.
The errors in reason. Well, there's no errors in reasoning. You may be looking for your own, but
there's
you can
another
go
one
through
right
all
there.
6 of those, and I'll show you the logical failures in them.
Go right ahead. Why don't you just name 3 of them then?
Well, I'm saying if you'd like. I mean, if you're looking.
Well, no,
for,
I mean,
all right.
I have 6 different ways of measuring it. Can you name 3?
I'm aware of all the ones that are claimed. Yeah.
Go ahead and tell me 3 of them then.
But I think we already went over that this isn't condescending quiz live stream.
No, just go ahead and give me
if you
3
have
different
something
ways
to
to
offer
measure
to
the
the
radius
conversation,
according to the
you
globe
could
Earth
offer
model.
it to the conversation.
Hold on.
Okay, so go ahead
We
and
could
tell me
definitely
3
go
different
through
ways
them one
to
by
measure the Earth in the globe
Don't
Earth model,
fall
since
into
you know
his
it.
trap.
We could
He's
go
trying to make
through
you-
them one by one if you want.
He's trying to
Yes,
make
I do.
you
Go ahead.
adhere to the model. Don't fall for the trap. He's trying to make you adhere to
Here,
the
I'll
model.
give you a hint. The first one's Eratosthenes.
There you go. The model constructors. Look at it. If he
So now you only have
would
to
know
think
what
of
I'm
2
saying.
more.
Well, that's definitely the lowest hanging fruit, so we could start there.
Reciprocal
Okay, what's
zenith
the
angle.
second
Is that
one?
one of yours, Bob?
Really?
I mean, that one's
What's
the
the second
easiest,
one?
easiest
Bullshit.
logical. The logical failure in Eratosthenes is the absolute most elementary, simple one to see. That one's very, very. It doesn't require any like validations from NASA's and shit that
Lot of talking.
claim government agencies doing things. That one's very simple because you can do it
Go
yourself.
right ahead and do it then.
See the absolute logical failure in it.
Go ahead and give it to us.
You're waffling.
Yeah, go ahead and give it to us, man.
Black Swan.
We'll listen.
Black Swan.
Eratosthenes. I think this is probably the 7 millionth time we've talked about this. Is it new to you, Bob?
Okay, so let's see. We have the sun directly over the equator. We have Blue
He's a
in Tennessee,
fucking
and we
joke.
have me in
He's
Michigan.
a joke.
And
Yeah, there's 2
we all get
factors
the
that are
same
going to
rate.
affect the shadows. There's 2 factors. Number
Go right
one
ahead.
is the shape of the surface that the sticks are on. That would be, let's say, the shape of the Earth. That's one thing that will change it if there's a shape to the Earth.
Wow.
The other thing is the position and distance of the light source.
Total bullshit. I'm out.
Okay.
Okay, so
Thank
go ahead and tell
God.
me how you would do that then. So you're claiming that you can triangulate the sun on a flat Earth, and I agree with you. And the sun from Tennessee, when you triangulate it from Tennessee, and the sun when you triangulate it from Michigan, would give me the same height of the sun, correct? Yeah, that's a little problem, isn't it?
Are you referring to me? I wasn't quite listening. Go ahead. I had to read a DM, but go ahead. Say it again.
All right, so on a flat Earth, you could triangulate the distance to the sun based on knowing what the sun is directly over and then measuring the angle from another spot a known distance away. So if you measure that from Tennessee, it would give you a height to the sun. If the Earth was flat and I measured it from Michigan, I'd get a different angle, but I'd get the same height of the sun, wouldn't I?
You would get a different angle of declination, yeah.
And that would give me the same height of the sun, right?
No, not necessarily.
Because the sun's only in one place at one time, right?
Yeah,
Can't
that's
You can triangulate it from any position. That's what a sundial does. A sundial is a triangulation device. A sundial literally shows the geometric triangulation of the movement of the sun all the way across the planar surface of Earth.
No, that's not what a sundial does. But the height of the sun.
And it shows the declination difference, which is what you were just referring to. The height of the sun is not
relevant. You can go ahead and show me the height of the sun from any location on Earth, right? Just simply by triangulating it, right?
You can calculate it, but that doesn't mean it's a physical measurement.
Okay, so
yeah, calculates to 3959.
That we haven't used a tape measure. Okay, so what's the next one?
But what I was saying originally about Eratosthenes, what I was saying originally is that if you have, let's say, like a bendy, like a cardboard, like one of those, whatever, 3x3 foot cardboard thing, right? And you have little sticks on it that you glued onto it, and then you have a flashlight or whatever, some kind of bulb or something that that you have. The things that are going to change the angles of the shadows are either bending the cardboard, making it curved, or moving the light source at different distances. If you put the light source at a very, 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 very far distance away to where the light, quote unquote, rays, even though I'm not even saying that's a thing, but essentially the light is coming from so far away, and you make the surface curved, yes, you can get those shadows, but that requires an assumption that the light source is that far away. Now, the 3959 number that you use as a radius for those shadows may be connected to the actual distance of the sun itself and the way that the sky works. I should just put it that way, the way the sky works. So it's just a reification and an inversion of the geometry. Knowing
the distance to the sun,
because I think the sun is actually much closer local. And if you just to finish real quick,
well, that's fine.
Just to finish, if you put that cardboard flat and you put a more close and local sun that would make sense over a planar Earth, then we'll get those same shadows.
All right. So here's the problem that you run into with that. First, you've never done the math on it. Second of all, if the sun was local or the sun was distant, you could predict the shadows on both a flat and a curved Earth. Do you agree with that?
If you did what? If you put the sun at a set distance?
If you put the sun at a set distance above the surface, you could predict the shadows on a flat Earth and a curved Earth.
Yeah, I did that. That's exactly the test I did.
That gets tricky because now you have to try to make a model for how the sun works and how it emits its light and how the distance
that's what science is.
And how the distance would vary due to the inverse square law. There's too many assumptions in my mind.
There's no inverse square law. That has nothing to do with it.
Right.
So
this is called a form of special pleading. You're just saying that the sun does something different than every other known object.
No, what he was saying is that if he fabricated the concept of a sun over a planar Earth and then started changing the distance, you could make a whole model based on that. But what I was saying is that would assume the way that the sun emits its light.
Okay, right, so look right up here. Let's see. Doofus put up a very nice diagram right here. You see the one where he did? Where it starts off at a point, I think it's 0.4 there, and then it's got rays going down to a flat surface. Do you agree that by knowing the distance between 0 and 1 and 1 and 0 and 2 and 0 and 3 and 0 and 4, and knowing the distance, the height of the sun, do you realize that you could predict those angles, correct? Yes or no?
Yeah, you can get angles to celestial objects and build GPs and circle of equal altitudes.
Okay, so if you know the height of the sun,
what that is, yeah.
If you know the height of the sun, you could predict each of those angles 1 through 3, right?
If you assume a height of a sun, you could make a model based on that.
The height of the sun, you could predict those angles. And any of those angles, if you measured them, knowing the distance from point 0, you could predict the height of the sun, couldn't you? That's called triangulation. Yes or no? Do you agree?
We went over. Well, yeah. Do
you agree with the math or not?
It's a sundial. I already mentioned this before.
That's not a sundial. Do you agree with the math or not?
It's the same system as a sundial. That's a gnomon. It's the same shape of a gnomon, the triangular.
No, it's not. So, since you already agree that you could triangulate the height of the sun and that it would all come back to the same point, you could predict each one of those things. So that's not what happens on Earth. So that's ruled out. You cannot have a flat surface in a local sun because the shadows don't match that, period. Now, if you had a curved surface,
you could also predict what those angles would be. That does not match what we see on Earth either. So we can't have a curved surface and a local sun. So the local sun is ruled out for both.
What was the
curved
first
and
one
flat
that you
surface.
said you thought you debunked? What was the planar one that you? What was that again? How are you saying that a close and local sun can't make those shadows? In what way did you claim that doesn't
Because
work?
the angles of the shadows at the known distances are different than what would be required based on a local sun on a flat Earth.
Why? What is your assumption of the distance of the sun in that?
There's no assumption. I'm just saying that if it was a local sun, you could predict those angles. The actual angles we measure are not the same. So, for example, when Blue measures the height of the sun, assuming a flat Earth, he gets a certain height. When I measure the height of the sun, assuming a flat Earth, I get a different height by something like 400 miles out of 3,000. It's a significant 10% plus difference. So that can't be the case. So we've ruled that out. We've ruled out the flat Earth and the curved Earth and a local sun. So now we're only dealing with a distant sun.
It's a lot of words there, which I'm not calling it word salad, but it is a lot with
It's not word salad
with
at all.
nothing really
It's
to back it
very
up. You're just claiming that you and other YouTubers did things, but you haven't actually established what you're claiming.
Have you ever done the Eratosthenes experiment?
I mean, all we can get is angles to
No,
celestial
answer the question, Gio. Have you ever done
those
it?
angles to celestial objects, just like in corpuscular rays.
Okay, so you're not going to answer it. You're afraid
We'll
to.
give those angles. The angles that you get if you do the Eratosthenes precisely fit with the same geometry of the corpuscular rays and sundials.
Yeah, and corpuscular rays are parallel.
It all correlates, and since the dawn of time, humans have been harmonizing.
So you don't know. So
with
you
the
don't
ground
know.
and the
We've
sky.
already ruled. Okay, so we've wrecked that one. Go on to the next one. What's the next way that we can?
No, you've
tell the
anti-wrecked it. You've anti-wrecked it. There's nothing that's been wrecked so far. You claim that you and a YouTuber did something, but you haven't even tried to claim what you did. Yes, you can get angles to the sun, the angle of declination to different positions on Earth based upon your local field of view and the position at which you're viewing the sky. You will definitely be able to get angles in different positions. Like I said, a sundial, if you take a sundial around and freeze frame it at any point in time, you can get the angle of the sun in that position on Earth.
It's not just angles at different positions, though. It's the relationship between angles and distance that really makes the big kicker, because the linear change with respect to position and angle doesn't happen on a flat surface.
Yeah, it's impossible on a flat surface. With a local sun or with a distant sun with parallel light rays, the angles are wrong. They don't match what we measure on Earth. So the only model that fits is a curved Earth and a distant sun with parallel rays, and I've already demonstrated that in a video. If you have any questions about it, you're more than welcome to look at it.
I got a question.
So that's been ruled out. So Eratosthenes is wrecked for you. Let's go on to the next one. What's the next one that allows us to measure the radius of the Earth?
Plant your flag right there.
Well, Bob, I think my internet cut out for a minute, but I don't think that's a fair assessment at all, what you've said so far. I think my internet cut out, but I was talking about sundials and that you get a different angle at different positions on Earth, and that is an angle to the celestial object of the sun in that case. And the Eratosthenes experiment, if you set up, well, it's not even an experiment, the Eratosthenes thing, is if you set up two sticks in the ground, you'll get those shadows. Those shadows will correlate with the same way a sundial works, and a sundial triangulates the position of the sun. A sundial has a planar disk underneath it. I'm not saying the Earth is a disk, but it is planar. So the fact that the sundial has a planar surface under it correlates with the exact angles that you get that triangulate the sun angularly above the flat surface.
You don't triangulate the sun with a sundial.
The sun does triangulate the sun. I'm not saying that it's usually used for timekeeping and for other purposes, but it is a triangulation device.
No, it's
not. All right, let's see if your internet actually holds up this time, and I'll say it one more time. Geo, it's not just that the angles are different at different locations, it's the relationship that makes all the difference. If the sun angles have a linear relationship to the distance to the equator, that doesn't work on a flat surface. There's no way to make that work.
And it's not just one location and the apart from the point on the Earth that the sun is at zenith. You can do it with multiple. Every time you take a measurement with a sextant, you're doing an Eratosthenes measurement.
Yeah,
that's the way that works.
I want to let you know I did that test with 22 other people.
Yeah, these are all similar concepts.
Okay.
What?
So
they're all similar concepts. A sextant has a triangulation device in it.
There's no triangulation with a sextant.
It's a sighting device, whereas a sundial is an actual physical triangulation device.
There's no triangulation with a sextant.
XYZ. It's all XYZ axis geometry.
Geo, there's no triangulation with a sextant, which is another device that you've never used. So Eratosthenes is done for you. What's the next way that we can measure
I might have
the
interrupted
radius
Kosho. Kosho, what were you going to say?
I gotta run. I was just looking. In case I can't talk, but I can. Just wanted to let you know I posted my paper that when I did this test with 22 other people, and I set it up. It's almost exactly the way Bob was saying that you could do, like where I made predictions for simply a close and local sun over a flat plane and a parallel rays, or the sun being far enough away for parallel rays on a globe the size we think it is. I made the predictions for both based on the observations we made for the days leading up to it, and so it's all in there.
I'd also be interested. The sundial argument is interesting. I'd be interested in knowing how you would propose a sundial even works in a flat Earth with the sun's path.
Yeah, absolutely. Well, I mean, a sundial is essentially just a flat disc. It doesn't have to be a disc. It could be a square. It could be anything, but it has to be very horizontally level and planar in nature. And then there's something called a gnomon, which is a little rod essentially. And that rod simply casts a shadow upon the circular range of the dial itself and shows the exact triangulation and position of the Earth above the planar surface. It's just a microcosm to a macrocosm device.
But on a flat Earth, and I don't know what conception of a flat Earth you're going to go with, but let's just use the AE map for convenience sake. That doesn't seem to jive. And any flat surface with a circling sun, the sun will be following the wrong path to give you the right time.
Yeah, it works beautifully, man. I mean, in the northern area, like in the Arctic, you can have a sundial there during the 24-hour sun, and you can literally watch the sun circle you, and you can watch the shadow circle and make precise alignments on the sundial in its exact correlation with the position of the sun.
Right. Get away from the North Pole and let's get down to the equator area.
But it happens everywhere. I mean, the only thing is that in the other areas, you can't see the sun 24 hours a day, so you can't see it make its full rotation. Obviously, you can only see it from sunrise to sunset. But
Gio, have you ever built a sundial?
In the north, you can see it in its entire cycle, and you can see.
Gio, have you ever built a sundial?
It circling the Earth. It circles you. It circles the Earth, and it circles the sundial.
Okay, Gio, have you ever built a sundial?
Built one? Yeah, I mean, you can make them out of anything. Yeah, I have actually.
Okay, how do you build a sundial?
XO did. Made a whole YouTube video of it too.
Okay.
Explain the whole thing.
Well, you have no clue what a sundial does. So Eratosthenes is done. What's the next method of finding the radius of the Earth that you want to try and debunk?
I think the level sundial claim is easy to debunk by the thing I posted.
Yeah, he doesn't.
really
He's never made one.
Yeah, the sundial discussion was about triangulation. It was about the position of the sun.
There's no triangulation.
And angles.
Put that out of your head.
Angles.
Stop saying triangulation.
Angles of light, of shadows on the Earth.
Okay, yeah, but there's no triangulation with a sundial. So stop saying triangulation, please.
Sundials are a triangulation device.
Okay, they're not.
They're clearly not. Look at the thing I posted.
Yeah, they're not a triangulation device any more than a sextant is a triangulation device. That's a basic misunderstanding you get from listening to idiots like QE. Now, so Eratosthenes, what's the next way that we can figure out the shape of the Earth?
Look at this is a guy who gets upset when people talk about him, and all he does is talk about QE.
Yeah, Bob, please stop with the insults, especially people that aren't here. It's very low class and low quality of integrity of human beings.
No, I'm just saying that's where you're getting your information. I'm talking to you, not QE.
Why are you saying that to me? I don't listen to QE at all. So
don't.
Why are you saying that to me?
Okay, sure.
I've listened to a total of about 12 minutes of QE's videos.
Okay, so
you believe that
why are you
randomly assuming other people with other people? It's just pointless.
Do you think that a sundial and a sextant are triangulation devices?
I mean, I have heard QE more on at times back in the day, in the early days when I listened to Nate's show. But
all right, so the
it
sundial
just
and the
seemed like you
sextant
wanted
are
to try
not
to
triangulation
spread
devices.
some random toxicity, so you'll be muted if you continue doing that stuff.
Well, I'll tell you what. Why don't you go ahead and have your own little echo chamber then? I'll see you later.
Well, if you're going to insult people, then yeah, for sure.
Ran.
Once he realized he wasn't going to get away with calling people idiots, he decides to run. How professional! That guy must be some kind of doctor or something, right? A high vocation in life.
Right. Never mind the actual fact that sundials don't have to be level surfaces or that they don't triangulate anything. Ignore that part.
Yeah, if you want, you can look at Stonehenge. Just Google that if you never heard of it before.
Yeah, where's the triangle? Also keep in mind that if you have a sundial that is not equatorial, what you're doing is you're actually tracing a hyperbola. The sun tracing a path of a hyperbola on a sundial excludes a sun circling in a plane parallel with the ground. You may want to brush up on what a hyperbola is in order to understand that statement.
Well, you can.
Yeah, duh.
You could use that as a reason to never freak out about flat Earth ever again.
Okay, you can continue to be wrong too. That's fine.
Good. You know, J. Ace 711 said it best. FE poses zero threat.
Right, and if you guys don't want to learn, you will continue to pose no threat.
Right. We're not. Yeah, we're not looking to threaten anything.
Did you hear, Jerry, that they
Yeah, you're
canceled
preferring to have a religion. That's fine.
That's the claim.
Yeah, you could think that all you want, but at the end of the day, it still poses zero threat.
Cool.
If it was in that framework of religion, it's constitutionally protected. The first freedom mentioned.
Right. If you want to go that way, then there will be a lot of pushback from most flat earthers that will say flat Earth is not a religion.
If it didn't cause a threat, if it didn't cause a threat to your religion, you wouldn't be in chat rooms talking about it like 6 hours a day.
Yeah, that's a useless argument. Thanks.
Yeah, useless. It exposes the most obvious truth of all time. You're just talking about flat Earth every day with flat earthers, but it's no threat. You just spend
But
hour
don't address
upon
the
hour
topic that I brought up.
in
Never mind the topic.
Discord, bro. Hour
Yeah,
after
never
hour
mind
in
the actual
Discord
topic
talking
over
to
what we can measure in reality.
yeah.
Let's talk about whether or not flat Earth is or is not a religion instead.
Your claim. And I met you at your level. I'll just unconditionally accept your claim about flat Earth, and you still get worked up by it. There's no making you happy. Just whatever you want to claim about flat Earth for the next 30 seconds is objectively true. Go.
Well, it can really be seen. It just even in the behavior. I mean, we were trying to go through a couple things with Bob. He wasn't able to kind of even get past the first one without the logic being pulled in terms of the Eratosthenes thing. And then he basically started calling QE idiots and saying that other people. He just started insulting people basically. So it's like he just
never mind the fact that you
to see that
continuously
behavior. I mean, that guy apparently is an actual doctor. Like he's an osteopath. So, I mean, if that's the behavior of an osteopath who's supposed to be, somebody who knows the globe Earth model and whatever else, and he's here doing whatever he's doing.
Right. Never mind the fact that you continuously called sextants and sundials triangulation devices.
Yes, and I have no problem repeating that. You want me to say it again?
Where's
They
the
are all
triangle?
triangulation devices. They triangulate geometry within the physical world. That's what they've done
where is the
since the
triangle?
dawn of time. No matter what way you want to try to add some kind of pseudoscientific religion to try to claim that they're not, that is what they are, and anybody can see that by just studying the devices.
Okay, where is the triangle that they make?
Sextants make triangles from celestial objects to the Earth to the observer. Sundials make triangulations from the azimuth to the apex to the planar surface, the XYZ matrix. They're both triangulation machines.
Okay, demonstrate that for me. Show me a diagram or something, anything. I just need to see where this triangle is.
Which one? On a sundial? I mean, you can see it on a
sundial if you like.
You can actually see them with your eyes with those, yeah.
Yep, let's see it then.
You've never seen a sundial?
I'm looking at one right here. Look at the one on the side of the building. Where's the triangle?
Yeah, there's many different forms. You talk about the one I posted that's from that temple?
For God's sakes, dude.
There's a lot of different ways to make them.
Cool. Where's the triangle? Don't say again, you can just see it. Where is it?
The line of the shadow upon the planar surface, the position of the sun, and the angle of the sun hitting the dial.
Third grade geometry.
Third grade geometry. Really, really simple stuff.
They can't go as simple though. They always try to make it way beyond complexities that you can't even understand. The numbers, the distances, they're so great, and you will never understand them. That's their way of explaining the dumb shit. Real talk.
And it poses no threat, but let's just go into our Discord servers and talk about it for 12 hours a day. No threat posed, though.
This is the
and it's been going on like that, like, 24 hours round the clock for almost a decade now.
So here's your triangle. That's what you're saying, Gio.
I mean, these guys have been on it, like, whew.
All right, so here's your
Well,
triangle,
like I've
right?
said, Anthony, like, what if we created a community called Pigs Can Fly?
You don't have to be a kid
Do you
about
think
it.
we could
that'll spend 12
we
hours.
could get a whole team of people dedicating like 24 hours of their life to telling us pigs don't fly?
Yeah, I think they'd just get
here's
over
your
it because they would
triangle,
know
right?
that they don't
This
straight
is
away.
where your triangle is, right, Gio? That's
No,
your
it'd be
triangle?
on the ground. It's on the ground, dude.
Gio? This is where your triangle is, right?
Hey, how do you know the azimuth? You keep asking questions about the triangle. How do you know the azimuth? Is it just a straight line?
Is Gio busy all of a sudden?
I'm asking you a question. You keep
There's a
asking, and he's
triangle, right?
obviously busy, so I'm going to represent him.
What I'm trying to do
How
is
do you
address
determine the azimuth of the sun
triangle.
triangle? How do you determine the azimuth of the sun triangle?
Oh my God, dude.
It's
Gio
a
said
simple
there's
question,
a triangle
but
right here.
he's
The sundial is
busy,
a triangulation
not
device. What I need is a triangle shown to me. Where is
I'm
the
answering
triangle?
with a question. How do you get the azimuth of the sun holding the sundial?
You don't.
Okay, so you don't, okay? But we could, okay? And how would we do that? I was just going to give you a couple different ways to triangulate. I figured you'd at least go with me on the first one. And now, a sextant. A sextant, you say it doesn't triangulate, right? Is that your other claim?
Doesn't triangulate.
Is
Unless
that
you
your
do
other
a
claim?
horizontal
That the
sextant
sextant
angle
doesn't
measurement
triangulate?
in which
Let's
the
go
surface
over
of the Earth tends to be not used.
Let's go over it. You say the sextant doesn't triangulate, right?
Unless you use it horizontally to get two distant points between the.
And how do they
two
get the
reference
distant points? Is it not horizontal? Let's go over it. How do you get the azimuth? How do you figure the azimuth in celestial navigation?
How do you figure the azimuth?
Yeah,
You're looking at the
how do you
object
get the
first.
azimuth?
You have to identify what object you're looking at first.
Right. No, you ain't got to go through the whole thing. I'm just saying, it's based on what?
Look, you have to identify it first. You have to know where it is going to be in the sky.
Right, and then you get your declination, right? So you triangulate.
And your sidereal hour angle.
Right. So to even find out where your GP is before you can do your trilateralization, you have to triangulate, man.
No, there's no triangle involved there.
Oh my God, dude. Are you kidding me? You just labeled it yourself. You just labeled all three sides your own self with your own
Holy
mouth.
fuck.
Now you deny
What?
Not sides, those are angles.
Yeah, exactly. Okay,
Oh
so
my
how are you
God.
getting, if you are late, how are you going to get the location without a horizontal triangle? How are you going to get the GP to do your trilateration?
Wow. These guys
Because you're
have
using
no.
the angles on a
These
spherical
guys,
coordinate
no.
system.
These guys have no fucking idea.
Oh, he's
how
All they
talking
think
about
about, all they think about is the
What you're
angle off
doing is
the
you're using
ground.
two angular
Look,
measures
all
on a
they're able
spherical
to do,
coordinate system.
all you're able to do is think of the angle off the
a horizontal
ground.
triangle, but you wouldn't actually be following the method employed in the manual.
Dude, you have to. You have to use the code. Look,
Listen,
all you're thinking about, all you're
Don't
thinking.
say, dude, you have to, and then ignore the
turn, right?
manual.
You're gonna interrupt me?
Hold on, bro. Real quick. Let me
I mean, you
speak
gotta
some
lie
knowledge.
first.
I only got a second, man.
some
I only
knowledge.
got a second. Let me explain this real quick.
Okay.
They think that they're the only way to figure shit out is by getting an angle off the ground to the star or the sun. But how are they going to figure out where that object is with just an angle? You can't.
All right,
You can't do that.
Let me speak
You gotta
knowledge.
do a horizontal triangle
In a
with
let me speak
declination
knowledge.
and
system, you
azimuth.
have two angles to find
You
out.
have
Hey,
to triangulate.
Wait.
I gotta go. I only had a second, but thanks, dude.
Wait, let me speak knowledge. Triangulation does not fucking calculate curvature of any sorts. Triangulation,
Thanks, dude.
triangulation is purely based off horizontal lines and angles, not based off
Sextants don't
curvature.
do triangulation. Thanks.
What? What'd you say?
Well, hold on. Brian didn't
Sextants
interrupt.
don't
Can
do
we hear what Brian
triangulation.
was
Thanks.
at? Brian, are you still there, Brian?
I'm just saying, triangulation is not fucking curved. It's all horizontal. Facts.
Okay, and you can keep saying that because sextants don't do triangulation.
I don't give a fuck what you say right now. I'm just saying, there's no curvature involved. Bottom line, facts. So if you want to try to invoke that there's curvature to triangulation, then you're fucking stupid and just it's nonsensical. No reason to talk to you.
Just take another drink.
Do you believe?
Hold on. Is this the triangle that you're talking about?
Do you believe that triangulation is based on curves? Yes or no?
Sextants don't use triangulation.
I'm not fucking talking about
triangle
sextants,
I've pointed
dumbass.
out here.
I'm
Is
not
this the
fucking talking
triangle
about
you're
sextants.
talking about?
I'm not talking about sextants. I'm talking about triangulation. I'm talking about fucking.
There's no point in talking about triangulation since sextants don't do triangulation.
Listen. When my buddies at CIA, FBI, when they triangulate a signal, are they using curves or no?
If you're talking about like cell triangulation, cell towers do trilateration in actuality. They call it triangulation, but it's not really.
Are they using curve? Yes or no?
They're using distances, 3 distances.
Are they using curve? Yes or no?
It's distances. It's straight line of sight
Are they
communication.
using curve? Yes or no?
No, which doesn't tell you anything about the surface because it's trilateration.
Wanna know why? Because there's no fucking curve in that calculation. Wanna know why? Because mathematically, they can't fucking use curve. They have to assume that it's a flat fucking plane. And that's what
that's your assumption.
More and more all the time.
That's actually your assumption because what they do
you're
is they
full of
just
shit.
get 3 distances. That's
You're
all
full
they
of
do.
shit. Distances. Oh, hold on. Wait. Are they based on curve? Are those 3 fucking calculations based on curve? Yes or no? Answer it honestly.
They're 3 distances. It doesn't tell you what the shape of the surface is.
Yes
it
or
doesn't tell
no,
you what the shape of the surface is that you're standing on. Those 3 towers
Okay.
that give you your triangulation can all be on hills of different altitude and still successfully triangulate you Because the shape of the surface doesn't fucking matter.
Clearly, you don't know what you're talking about. Let me
I
explain.
do know what I'm talking about as a telecommunications tech, but you can go ahead and play ignorant.
Let me express some knowledge to you. When they triangulate,
Geo, what I need from you is a triangle on a sundial. Is this triangle that I pointed out here the triangle that you're talking about?
Listen, Linda. When they triangulate, it's a fucking algorithm based off of a horizon, a plane, a flat surface. And they do get a calculated specific point of reference of sorts that they can now know where you're at on 3 points, not curved. Curvication is not a part of it. Is that even a word?
Take another drink, dude.
Shut
Geo,
the fuck up and listen.
I am asking you,
Shut the fuck up and listen.
sundial
Just shut the fuck up and
triangulates.
listen.
What
Fuck
I
your
need to know
sundial.
is where the
Fuck your
triangle is.
sundial.
Is the
Just listen,
triangle that
bitch.
I've pointed out
Just
the
listen,
one
bitch.
that you're talking
Fuck your
about, Geo?
sundial. Fuck your sundial. Just listen. When you take triangulation, there's no fucking curve involved. I'm telling you, because I can't even share this information. I'm so drunk right now, but I cannot tell you how I know this. But triangulation is not.
Can.
Shut up, everybody, shut up.
Maybe you just come back when you're sober, bro, because it's kind of wild.
Or not,
it's kind of wild right now.
I'll come back.
I'm gonna say this: triangulation is not has. There's zero. There's nil point of curvature to find out someone's position. It's all based off a zero zenith. You know what zenith is? Anybody?
Zenith.
You're right. I'm drunk. Zenith, and the angle. Zenith.
A 0 degree zenith angle is straight up.
Yes. So zenith is horizontal, right? Yes or no?
No.
Get the fuck out of here.
Zenith,
I'm done with you.
0 degree zenith angle is straight up. Zenith is not horizontal.
Zenith is horizontal. Shut the fuck up. If you want to say that's curved,
Oh my god, dude. Just take a break.
You're
Go
full of shit.
Sober up. Go take a break right now.
Zenith is not
curved. Zenith is horizontal. You have to go take a break. You just have to go. You have to go. You're done, dude. You're done. You're absolutely done.
Zenith is not curved. Fuck you if you think it's curved. Fuck you. Zenith is not curved. Zenith is literally 0 degree, motherfucker. If it's curved, is it curved? That means it's -0.
Does anybody want to mute him? Because this is completely useless. If he thinks Zenith is horizontal, there's absolutely no point in having him in the conversation.
When you triangulate somebody, motherfucker, and I'm not going to expose my sources, but when you fucking triangulate, you use the zenith and the angle off of 3 points. That's a triangle.
I might want to warn you.
Okay, if there's no moderators here, then I'll just go because you guys clearly cannot moderate this guy.
Clearly, you don't know
your mom just left my place, man. So you might want.
Yeah, I kind of already asked Apocryphon if you could chill a bit, man, because it's kind of at the level of belligerency at this point.
I'm sorry. Is Zenith? You're right. My bad. Is Zenith negatives? Yes or no?
Dude,
just answer it, bro.
Just take a break. You're clearly out of your element.
Just answer it. Fuck you. Is Zenith negative or no?
A 0 degree zenith angle is directly vertical. It is not horizontal. As many times as you want to say that it's horizontal, it won't become horizontal.
So you're saying zenith? If I'm calculating my zenith, you're saying that there is a negative or a positive? Just answer my question.
Doofus, I have a quick question for you, sir, just because I know I keep calling you Doofus, is you're my friend named Doofus, but I feel like maybe it's offensive. I was wondering where your name came from. Why did you call yourself Doofus?
No, don't change it. Don't change the subject. I'm trying to hold him against the fire. I'm trying to hold him against the fire, bro. Is Zenith is not fucking vertical, by the way. Zenith is fucking horizontal.
I would look up the definition of zenith before you continue.
I mean, this guy's, he's had his first beer today, and he's he's obviously not capable of arguing this stuff right now. So. What did you say? What did you say about your name, Doofus? I didn't hear you because maybe.
Oh, it's a joke because it's misspelled.
I was like an inside joke.
Yeah, kind of.
All right, fine, dude.
What's misspelled about it?
Not spelled correctly. That's what's misspelled about it.
Doofus?
Yeah, there are two accepted spellings, and that's neither of them.
Yeah, it usually has a U's in it. But yeah, an inside joke.
So that's why it's funny?
Be part of one day.
And then what's the Manfred?
It's just Manfred.
Hey, real quick. Hold on, real quick.
So you decided to come on the internet with
listen,
Manfred to try to like debunk.
Wait, hold on.
Doofus' name, man.
Please, hold on. I know I'm drunk, but hold on. I want to hold the fire. Is Zenith flat or not? Real talk.
It's vertical.
When there's a fire near your house, do not go near the fire.
Is Zenith flat or vertical?
Is that the chick that you're with?
Vertical, man.
So you're saying it's vertical?
She's horizontal right now.
The 0 degree zenith angle is completely vertical.
Okay, so is it a flat vertical or a curved vertical?
So it's a straight. I guess you would call it a flat vertical, but that would be the same in both a flat Earth and a globe. So that doesn't really help your position at all.
So no, it does help me. It does help me. Wanna know why? It does help me. Wanna know why? Because Zenith is a fucking is flat, right? Yes or no?
It's straight up.
Okay. But is it a flat straight up or no?
Hey man, you got cut off, dude.
Is it a flat straight up or no?
Yeah, it's a straight line going up.
Okay, so Zenith, you're calling it Zenith, is a flat line straight up.
Yeah.
Okay.
Welcome to the conversation.
Does it curve? Yes or no?
No, because it shouldn't.
So speaking about Zenith, how do you correlate that to a curve?
They come out radially.
What?
Oh, he's not going to get that. I know he's not going to understand that.
By your own words, you said it's flat vertically. So how is it now curved?
The zenith comes out radially.
Yeah, that's not contradictory, man. Hey,
radially means curved, right?
No, it doesn't. I was wondering, dude. I drink a lot too. Just wondering how many beers you had, dude.
Does radially mean curved or no?
No.
I'm gonna go with 6.
Yeah, I think that's I would say 6 or something like that. I drink a lot. Me and Jezza drink about the same amount.
Wait, hold up. So hold up. So
radially means it's like a wheel. Radially is like a bicycle, a spokes in a bicycle wheel. That's radially.
Why does Zenith to you
radially?
Why does
and
Zenith
all the lines come out straight?
Hold up. Why does Zenith to you mean north and south? Real talk.
It doesn't.
It does not.
What does it mean to you?
Straight up.
Yes.
Why does Zenith mean? Why does Zenith mean to you straight up?
Why does Zenith mean straight up? That's the definition.
Is that not able to be flipped on the side to where your Zenith meaning horizon?
No. What?
He's really lost, man. I don't know if there's any.
What the hell?
I'm gonna try and interpret what he's trying to say. I think what he's trying to say is like your because it's relative, obviously. Your relative zenith for somebody else could be somebody else's horizontal on our model. This is true.
Thank you. Yeah, exactly.
Yeah, but I don't know. Is that a question? Because that's true. That can happen, but
that was the most generous translation. Thank you, Gosho.
No. Real talk. So listen. So when I used to build satellites, we'd say it's zenith. What do you think I'm saying by that?
What?
I'm wondering what you mean by you used to build satellites.
I can't get past step 1.
Yeah. Okay. So I used to build I used to build satellite. Hold on. Let me correct myself, because when I say satellites, most people think like the ones that are in the sky. When I used to build satellite dishes,
It's big.
they were 4 meters in dimension, which is about 12 feet in diameter here on the ground, and we find our zenith. What do you think I was doing at that point?
Zenith is straight up.
Okay, that's what you were interpreting, right?
No, that's the definition of zenith.
To you, it's vertical.
To everyone, it's vertical. That's the definition of the word zenith.
Okay, so what if my boss was like, find zenith? What do you think that means?
Point straight up.
Isn't Zenith the brand name also?
Yeah. That's like a GPX or a Sharp or something.
Oh, okay. I'm just trying to wonder if there's any like loopholes here. It could be that your boss was not that clever.
No. So when you find something zenith, he's right. You're going up and down, but on your globe Earth, up and down can mean horizontal if you are on the other side of the sphere. Am I wrong or no?
No, that's wrong. Everywhere you are on Earth, your zenith is straight up where you're standing.
Okay. So I see where you're coming from. So zenith by definition, always means up and down, right?
It's local and
yeah.
There's no curve, right?
It's local to your position straight up.
And it's no curve, right? I love where I'm walking. I'm walking you down the park, brother.
It's
I'm
radial.
walking you by the leash. I'm walking you by the bush. Radio? What do you mean radio? What? How's it radio?
RADIAL.
Yeah. What do you mean radio? What do you mean radio? Because zenith,
like the spokes on a bicycle wheel. I told you.
Okay, so now you're assuming that zenith has this curve, even though each spoke is straight. Am I wrong?
Yeah, that's wrong. Zenith itself doesn't have a curve. It just happens to radiate outward. It's radial.
It radials outward. I'm trying to understand what you're saying right now.
It's like spikes on a ball. Like if you have spikes on a ball, or if you have spokes on a wheel.
You know, like those little tomato pincushion things where you just stick a bunch of pins in it in every which way?
Yeah.
Every one of them that is intersecting that pincushion, that little tomato, is sticking out from it. Those are all zenith.
Okay. Now, but each pin individually is not curving, right?
Right, but they're radial.
Okay, I see what you're saying. You're saying that the neighboring pin is radial to the pin at hand, right?
They're all radial to the object they're stuck in.
Okay. And that's what you believe?
I mean, it can be measured. We can go down that road in a minute once you get to your point.
Now, how do we come to a conclusion that the neighboring pin is at a radial compared to where we stand? Other than knowing that the actual pishpun cushion is an actual sphere that we're sticking all the needles in.
Right. So now that we know the word zenith, I'm going to throw a bunch of more words at you. Hopefully you'll pick them up. Reciprocal zenith angles. So when you measure a zenith angle, essentially what you're doing is you're measuring between straight up and down to an object.
So then
if you
why
wanted to determine horizontal, that's a 90-degree zenith angle.
So then why
now if you take two objects or 2 points and aim at each other with like a theodolite or a total station,
okay,
what you're getting is these reciprocal zenith angles. They should add up to exactly 180 degrees on a flat surface, and they should add up to more than 180 degrees on a convex surface. And they add up, the amount of overage is greater the further apart those 2 points are.
Okay, so when you have 2 points, For instance, on a job site, and they are not accurately coming to your dimension you're saying, how do you explain that?
What? No, they add up to over 180 degrees.
But they don't. So what do you say to that?
I would like to see that.
So when we're building something and there's no fucking whatever you believe in, because of the curvature of the earth, quote unquote, when there's no angle away from, meaning a skyscraper will be angled at a different degree where I'm at because we're on a ball. How do you explain that?
The distance involved makes all of the difference. Like I said earlier, the amount that it's over 180 degrees by is greater the further apart those two points are that you're measuring. So,
but here's the problem, though, bro. But here's the problem.
1 degree every 69 statute miles you go.
But here's
69
the problem,
miles away, that's only a difference of 1 degree.
But here's the problem, though. When we build buildings, no one's accounting for curvature of Earth. No one,
right? Because they're not a mile wide.
Even farther than that. No, let's take a long ass fucking road or bridge. No one's accounting for that. What we do account for is how when you set up a theodolite, that the calibration of the instrument does dip off, so you have to move the theodolite a little ways down to reestablish where you're at, only because the tool that you're using is only going to have a certain amount of distance that it can accurately pinpoint. Matter of fact, we could take a line laser. Line lasers are within 1/64th of an inch. Matter of fact, if you spin it a 90 degree when you're trying to like make sure it's good, you can spin it at 90, take a measurement, spin it another 90, take a measurement. If it's off by 1/32, you know that the laser light is off by 1/32. So you have to account for that. And I speak for you from experience because I'm an iron worker and that's what we do. And we build buildings. So when you have something at a 1/32 off, if you want to spread that over a mile, that 1/32 can be off literally by like 9 inches, bro. Because that one tiny fucking, difference over a long distance becomes way greater. And
right, you typically wouldn't use a laser level for that then.
No, a theodolite is the same fucking principle because you have a theodolite that has a certain fucking distance that is calibrated to even accurately give you. That's why surveyors, they will take a theodolite, they set it up, and then they go so many feet to recalculate, and then they go, here we are. We have our measurement, our benchmark, quote unquote, because that's what they call it. We have our benchmark. Here it is. And then we go off of that. And then they go miles and miles and miles based off their benchmark. Want to know why? Because the tools and equipment they use only go so far before the equipment itself fails them in the precise measurement that they're trying to get. That's why, guess what? In construction, we have tolerances. That's why. Because we know that the tools we're using are fucked up and we can never get an accurate measurement. So we have a fucking 1/2 inch tolerance. Oh goddamn, we could be off a 1/2 inch. No worries. Because we know that. Because that shit's fucked up. We know that. No matter it can come out from the shop calibrated to the fine point. We still have to account for that thrown off measurement because that's just what we do.
Right. So now a theodolite actually typically has an angular rate that it's given for how accurate it is. And it's usually within 1 arc second, which is a lot smaller than 1/32nd. That's a lot smaller than 1/32nd on, say, a laser level.
Get out of here.
The
Get out of
theodolite,
here. Get out of here.
Hold on, bro.
Arc
It's not fair to
second.
interrupt him.
Arc second. Get out of here with your arc second. Get out of here.
the
Hold on,
theodolite.
microphone.
No.
All right, hold on, bro. I'm gonna have to mute you for a second, though. You can't just interrupt like that. So yeah, just go ahead, Doofus. It's only a temporary mute, but go ahead, Doofus. You gotta at least let him finish what he's saying.
Right. So when they have these measured to precisions of 1 arc second of angular separation, the ability, the precision of the tool, you can do like a foresight and backsight to try and make sure that your calibration is still good. But it has a bubble when you're setting it up to get it close to where it needs to be, and then the tool itself has a pendulum within it in order to have that level of precision that the tool states that it has. This is something that's going to be way more accurate than, say, a laser level.
Are you done?
Yeah, just the working distance of a theodolite isn't really known to have a maximum. It's an angular measuring device.
Are you done?
Yeah.
Okay. So I'm going to tell you by experience, Bubba. When I step with the theodolite, okay, if I go out about 1,000 feet, I know that I'm stupid off the bat. You can't fucking go off 1,000 feet because the tool that I'm using, the theodolite that I'm using, is not going to give me to the fucking 64 seconds of a fucking inch measurement. So what I have to do is go 500 feet. Okay? Once we get that measurement, we move our fucking theodolite, we mark the benchmark, and then we fucking 90 degree it. I'm sorry, 180 degree it. And now we have a new benchmark. Your whole arc minute, all that that's the bullshit they teach you based on curvature of the earth. There's no fucking arc minute in this fucking explanation. I'm telling you right now from experience. That's my job. But listen,
okay. When you move the theodolite, that's called differential leveling.
Listen, you can believe what you want to believe, but I'm telling you facts. Okay? So once we get a new benchmark, we know that is quote unquote level. That is a position. But you know about ballers? Y'all say level is to the center of the earth. And that's where we all disagree. So
I also disagree with that because that's not what we say.
It is. Oh, what? It is. Where's Zanuck at? Bring Zanuck in the building.
A level surface is perpendicular to plumb everywhere along that level surface.
But according to ballers, level is curve. What are you talking about?
And still perpendicular to plumb.
Exactly. So how am I going to have plumb at? Let's say I have let's say I have a marking at ground zero. Okay, 0. Now I go 100 yards out. Boom, level. That is level. Then I go another 100 yards out. Boom, that's level. You are saying, well, that's level to the curvature. That's the problem I have with y'all, bro. There's no fucking level of curvature.
You're doing differential leveling. You're excluding curvature.
Thank you.
Differential leveling accounts for curvature by the process itself.
No, there's no curvature involved with the measurements, bro. We have
because you're not doing it long enough.
Okay. You know what? Hey, are you a surveyor?
I have worked with surveying equipment before, but not an actual working surveyor right now.
All right, so listen. You are only regurgitating what you've been told and understand and know, and that's fine. No different than some dude from out of school that says that we landed on Mars and have rovers and drone helicopters are flying. You're no different than them, bro. You're only regurgitating the story, bro. That's okay
Don't
though.
address what I said, though. Don't address what I said, obviously.
All right. Well, yeah. I mean, I'm just telling you from facts, bro. When it comes to leveling or surveying the ground, listen, we've been doing that, bro. I have, at least, not you, but I have been doing it, and we never account for curvature. Want to know why? Because
you're doing differential leveling.
Because the reality of it is, you're just trying to get level to the ground, and when you get level to the ground even over a long distance, your guys' example or excuse is that, well, on a ball, on a curve is level. That's fucking bullshit, bro. Like, bro, I'm not gonna fucking set up a pole 20 feet in the air, and then a mile and a half away I'm gonna set another pole a mile and a half away straight, and that doesn't connect. Like, bro, you guys are y'all on something, bro. You guys are all like just distorted, bro. Like, real talk. Hey, in the manuals, they tell you that, but ask a real surveyor, they never go by that. Wanna know why? Because it's fucking null and void, bro. You do not have to. Wanna know why? Because it's not fucking curved. Now, what they're calculating from, let me teach you something. What they're calculating, not the curve, but the fact that the instrument itself will dip down in measurement, in a distance. Want to know why? That's called calibration. That's why once it starts dipping down, you stop. Whoa! If it's dipping, if I'm getting fucking 1/8 off, let me measure it a little bit closer.
So you're saying things drop due to distance.
That's called light. Yo, you gonna disagree with light?
I do.
Are you gonna
disagree with your representation of light.
Perception?
Right.
No.
See, the problem is that now my current job, I actually deal with optics.
Okay.
So you're barking up the wrong tree already. But I will tell you that if you go and take that theodolite out there and you do observe things dropping due to distance, you will note that there is a geometric relationship there.
Not
As
always.
things are moving out into the distance,
Not always.
the angle will increase with respect to distance linearly.
Okay.
And that angle separation from horizontal increasing linearly with distance requires a curved surface.
Let me ask you this. What happens when a mile away, the land actually goes up? The elevation. Then what the fuck do you do, bro? Tell me that. Answer me that. Riddle me this. What do you do when the land a mile away is a higher elevation than your point? Riddle me that. Go ahead. I'll wait. Silence. Crickets. Crickets in the building.
It's a really dumb question.
No, it's not a dumb question. I'm telling you that you are no longer basing off a curvature of the earth. You're still having to fucking calculate it according to the ground you're on. So
this is the whole reason I mentioned this is the whole reason I mentioned reciprocal zenith angles. Because if you have two stations and you aim them at each other, you'll notice that the only way that you can have more than 180 degrees is if there is curvature.
False. That's absolutely false.
Diagram that out for me. Show me how that could work.
That may be that's a theory, and you're believing it. But in reality, what we actually physically can calculate, you're saying that there's a curvature, but what happens when the elevation of the land itself is higher a mile away because of the land itself? Then how do you fucking calculate for curvature? You're fucking full of it, bro. I'm drunk right now, but you're so fucking full of it. I swear to God.
All right, so let me give you a diagram to picture this. No, that's not the right one. There it is. All right. Even if you have two stations that are different altitudes, if there is no curvature, it should still add up to exactly 180 degrees.
That's false. That's an
Why?
assumption.
Why?
I'll tell you why. Because let's say so my boss tells me, hey, the elevation right here is 432 feet above sea level. Okay, I mark it. Now, if the land itself is fucking a mile away, that's 800 feet above sea level, then I'm gonna actually have a climb. And it's not about curvature. It's literally just the land itself, bro. Has nothing to do with curvature. So
All right,
I'm
check
going
the
to
diagram one more time. Check the diagram one more time.
I'm looking at it. You have your A and B, right?
Yeah, and they're at different altitudes, just like you described.
But why is one higher than the other? I'm talking about one lower than the other. So what are we
Okay,
talking
one
about
is
here?
lower than the other also.
Okay. So what are you talking about?
Right. If there was no curvature, you would still get exactly 180 degrees.
What the fuck? What do you mean? Why does it have to be 180? What if that slant is only a foot above? That's not gonna give you 180 degrees. What are you talking about, bro? I'm talking about physical land, bro. Like real talk. The land itself, the dirt, the ground. It doesn't have to be 180 degrees. That's a non secular over here. What are you talking about, bro?
Okay. The two vertical lines at B and at A,
Yeah,
those are the zenith lines.
that is an example, but not a
Right.
reality. That is an example of what you are trying to impose, but that's not
Hold on, you know
reality.
zenith exists. Okay. You're already aware that zenith exists.
Okay, yeah, okay.
All right. If those two zeniths at those two locations were parallel, aka there's no curvature, then the result of doing reciprocal zenith angle measurements would give you exactly 180 degrees.
No, you're wrong. No, you're assuming that
They're
the
supplementary
altitude.
angles, dude.
You're assuming that the altitude on this is going to give you that dimension. But I'm telling you, in real life reality, you do not have to put such a fucking exaggerated example, because guess what? How about I'm on a job site, right? You're 400. No, the last one. Hold up, the last one I was on. Let me think about the Ram Stadium. Do you know the Ram Stadium?
Not familiar. No.
Okay, so are you not from California?
No.
Okay. So over here in California, let me just tell you, California, we're taking fucking benchmarks. Okay, listen real closely. We're like, all right, this fucking piece right here, this elevation, it's fucking 300 fucking feet above sea level. All right, cool, great. Now, about 400 yards away, our buildings are measuring 400 feet above sea level. Not because it's fucking curved, it's because the land itself goes up. Okay? Guess what? Go another 3 miles to LAX. You know what the fucking elevation of LAX is? 100. So how the fuck is it a curve if the fucking LAX and the fucking Hollywood Retail Park and the stadium are all 3 different fucking altitudes, bro? It's not a fucking curve. It's just where the fucking ground is, bro. I get frustrated with you, bro. Like, people like you, because y'all don't even know the fucking half of it, bro. This is shit. This is reality. I'm telling you real fucking measurements. I could show you blueprints right now. Like, prints. Hold on. Matter of fact, Let me check my phone real quick. I have fucking
All
prints.
right, Apocryphon, while you look for that, can we get like a little bit of a break? It's been pretty intense.
Yeah, I'm sorry, bro. I'm drunk. You're right. I'm just a drunk. I'm sorry, bro. Yeah, you're right. Go ahead.
No, it's all right. It's all good, but there's other people in the chat too.
Yeah. Chat it up. Go ahead.
Right, Gio, I was actually trying to get this triangle out of you before. Is this the triangle you were talking about? You said it had to do with the gnomon and the shadow, and I didn't know what else you were talking about.
No.
I mean, that's a triangle. Where is the triangle that you were mentioning?
I mean, that isn't a sundial.
It is. It is actually a sundial. It's on the side of a building, but it is also a sundial.
It's not a sundial because a dial is 360 degrees. It's like a sun.
It is a
It's
sundial.
like
It gives you the time based on the position of the sun.
technically it isn't, but so yeah, no, I wouldn't go with
Fuck.
that. It's not very
I
solid.
deleted it. Fucking shit.
The gnomon needs to be in the center of a dial, and the dial is the rotation of the sun around Polaris, around the Earth. And the right angle is as I described it.
Okay. So you would actually be closer to describing an equatorial sundial.
There's a lot of different types. This one I posted earlier. You have a gnomon and you have a dial and you have a planar surface.
So real quick,
this one, like I posted before as well. This one is on a wall, but it's an actual dial. It's a real sundial.
Hey, so Neil, is that you talking, Neil? Who's talking right now?
Yeah, it's Neil.
Gio,
I'm sorry. Yeah, I'm on my 27th beer. I'm sorry, I'm drunk.
That's not true.
But
27th.
Kosho's
like on his 60th, and he's like super chill.
Yeah, my bad. I'm not.
About to go
I'm not
Uber
cool
driving.
as him. But all I'm saying is like, I don't have the. I guess I fucking deleted from my photos, but I had the fucking the blueprints like printed because when we were fucking building stairs at LAX, it's called the All People Mover. And we're fucking building like 5 stations there at LAX, if you want to Google it. And then compared to that, to the fucking Hollywood Retail Park elevations, compared to the Rams Stadium, SoFi Stadium, like all the elevations are different, but LAX elevations are lower than the elevations at Hollywood Retail Park. So it actually like represents not a ball, and I don't have it, but
Right. I would check the elevations against what they're actually referenced against, what datum they use.
the
Elevations you'll
elevations
typically find are against WGS 84.
sea level. It's going to sea level. It's going to sea level.
Right, but there's a datum for any sea level. WGS 84 is one such.
Yeah. So what I'm trying to tell you is that it doesn't make sense on a ball because the elevations don't make sense. Like let me tell you something. So
Elevation is not curvature also.
So the stadium is at one elevation, and then our Hollywood Retail Park is at one elevation, and then the LAX All People Mover is at another elevation. That itself is not a ball. It actually goes up and then comes down. it literally like negates your argument, because it, like, technically you would think that the all people mover should be a higher elevation because it's a curve. So anyways, like,
that's not how elevations work, though. They're
no,
against a
you're
datum.
wrong though. You're wrong though. That is exactly how elevations work. Like, don't try to spin it, bro. Don't try to spin it.
Not a spin. Elevations are against a datum. The datum that's typically used is WGS84, which is a curved surface.
So can you agree with me? Can you agree with me then that land being surveyed can be up and down in elevation and not
Of course
represent
it
a
can.
spherical?
It can do that on a ball too.
Well, is it safe to say that can be also on a flat surface?
It can be either if your datum is flat, but in this
Thank
case,
you.
it's
Thank
not.
you. Done. Thank you. You just said it. Thank you. Enough said.
Right, but
Welcome to
if
Flat
your
Earth.
datum is
Hey,
flat,
welcome to
that
Flat
would be
Earth.
the
Thank
case.
you.
However, your datum
Thank you.
isn't.
No, you're good. You're
Your
good.
datum
Thank
is
you.
actually a curved surface.
Thank you. Welcome to Flat Earth. Thank you. Welcome to Flat Earth.
I mean, if you want to say a curved surface is a flat surface, that's your
No,
fault.
you're good. You're good. No, thank you. You just said it could be either or. Thank you. Welcome to Flat Earth. That's enough. We're good. We're good. We heard enough. You just admitted that it could be a sphere or flat, and
Yeah,
it works.
depending on your datum, except you're using the wrong datum.
The datum that we're
You need
using.
the one. You need the one given by the government. Is the one he's saying.
Yeah.
It doesn't matter who gave it; it's still a curved surface.
Yeah, that's my philosophy with flat Earth girls.
Hey, so if
you're walking over my joke, dude.
If it's curved, wouldn't it not have a higher elevation away from the dip? Yes or no?
No, because that's not how elevations are measured.
Because do you understand that the ground is based upon the elevation according to sea level, correct?
Right, and the sea level datum is a curved surface. I can't really make this any more clear to you.
Right, dude. I think it's kind of at an impasse. He's just assuming a set of coordinates that he's given, and then just claiming that on a larger geodetic system they fit on that coordinate. And it sounds like you're just talking about the actual planar construction, because that is what it actually is. Yeah, he's just asserting that one.
Hey, riding on eggshells, are you here?
He didn't actually use the benchmarks all the way from Ram Stadium to LAX.
But Doofus, by the way, you do see the triangle on the one, just to finish that. You see on the first sundial I sent there? That shows the triangle quite nicely.
Right, the gnomon is in the
Of
shape of a
course
triangle.
I am.
But what the path that the sundial, the path the shadow traces on a sundial is a hyperbola under those conditions.
That's not what's being referred to.
Okay, but it's not
It's the triangulation
anything.
of the angle that the sun is hitting the gnomon.
The gnomon is in the shape of a triangle, but the gnomon itself is not triangulating anything.
In that case, it is, and it's just showing that geometry, and it is
Why?
showing
Where's
it is
the-
triangular,
okay.
and it's showing. It's obviously only showing one angle, but it is showing the triangular structure of it.
Right. Again, the gnomon is in the shape of a triangle, but the device itself is not triangulating anything.
It is doing both.
Where? Where's the rest of the triangle?
From the ground, it's similar to a sextant. From the zenith to the position of the sun to the ground.
From the zenith. So the triangle's in the sky. Okay.
The triangle is on, yeah. Well, it is. It's in the environment, yeah. I mean, it's showing, like, if you had that right at the equator, at the equinox, versus if you have it in the north, et cetera, you're going to get a different triangulation to the sun's position and a different pattern on the sundial, which is how a
Right, but where
sundial
you
can
want
actually show
your-
you. If you really know, if you're really skilled with a sundial, you can actually figure out where you are on Earth from just
Are
knowing
we
the
still
sundial
talking
is.
about sundials, bro? Like, really?
Right, but where you want your 90-degree angle would be straight up to the altitude of where you think the altitude of the sun is, and then over to the sun.
No, it's just to the celestial object to the ground. That's all it is.
Well, now it's to the ground. Well, hold on. So now what you're saying is that there's a baseline and that it has to be flat because the Earth is flat.
I didn't say that, but it is a planar geometry, yeah.
So you can't use a sundial on a hill, for instance.
Can a sundial be curved?
It can be on a curved hill.
But is it going to give the same measurement?
Right, so the baseline's not the surface of the Earth then.
So since when do we fucking take horizontal measurements and then curve them to give us an accurate measurement? I don't get it. I don't get what you're saying right now.
Even on a spherical Earth, horizontal isn't curved because you're not saying it is. Nobody says it is.
There we go. That's the fucking kit and caboodle right there. That's
Nobody
hey,
says horizontal is curved, though. If
I'm
you were to say
I will
horizontal
admit,
is flat,
I will admit,
well, you're not telling us anything new because
I will
both sides
admit,
already agree that horizontal is flat.
I will admit, we cannot argue with that fucking statement. Horizontal is curved. I cannot argue with that. That's your belief. That's what you
No, I didn't
stand
say that. In
by.
fact, I said exact opposite of that. What I actually said was that horizontal is flat, and both sides already agree with that, so that's not new information.
Horizontal is flat. Okay, so
A
then
level surface is curved.
okay, so level surface is curved. So how do we get a horizontal level surface? Go ahead.
From zenith.
Yeah, same way you get a tangent line.
There we go. There we go. Back to zenith. I knew it. Okay, so zenith is horizontal in the vertical position, correct?
No.
Zenith is horizontal, but in the vertical.
That doesn't make sense, brother.
Okay.
I don't think you're going to be capable of making much sense, though.
Because they have their sphere thing, they need it to be locally
listen.
vertical. Locally vertical and locally horizontal with lines that shoot off into outer space.
Yeah, just listen to what I'm saying. Zenith is vertical in a horizontal sense, meaning
no,
it's straight. Am I wrong?
Horizontal doesn't
mean
specific,
straight up.
man.
Horizontal doesn't mean straight.
It doesn't mean straight up.
There we go. No, means no. Hold on.
You can say straight up is
hold
zenith.
on. If I went to fucking AutoCAD and I made a straight line, okay, straight line A to B, and then I flipped it at a fucking 90 degree, would it be the same thing or no?
They would be straight. You wouldn't say it's horizontal in both cases.
Okay, but does
well,
straight
actually,
mean
you could
horizontal?
because you could have two horizontal lines intersecting at 90 degrees in
It's
a horizontal plane.
It's called perspective. It's called perspective. It's called perspective. Is horizontal straight? Yes or no?
Yeah, it's straight. Horizontal is straight.
Okay, exactly. So is zenith straight? Yes or no?
Yes.
Okay. Is there curvature to the zenith? Yes or no?
No, it doesn't make any sense.
Thank
the
you.
globe
Is there
has
curvature to
straight zenith
horizontal?
angles.
Yes or no?
Say again.
Is there curvature to horizontal? Yes or no?
Is what?
Is the curvature horizontal?
Is there any
curvature is there curvature to horizontal? Yes or no?
A horizontal line is not curved.
Thank you. Is vertical?
You just asked that same question, man.
You're gonna ask the same things over and over again.
Ask this question. Is tangent curvature? No, tangent's not curvature.
Thank you.
But
Thank
it's
you.
referencing a curved surface.
That's more accurate. That's more accurate.
No.
Thank you. So with that being said,
okay, let's try to make this exactly clear. Level is a curved surface. Horizontal is straight. Vertical is straight. Those are all true statements on a globe.
Okay. So how do you get a curved line when you're dealing with horizontal and vertical lines? That's the fucking question.
When do you?
What the fuck, dude?
Come back when you're
can't
sober,
explain
man.
this over and
There's
over again.
no point.
Is that too difficult? I don't get
Yes.
you.
You're just fucking it up, dude.
Okay, so that's fair. You guys can't answer that. That's fair. I get it. I get it.
Well, the answer was already given. You're just having a hard time comprehending it.
So once again, I'm gonna ask it. You answer it.
Yes, horizontal is straight.
Horizontal.
Yes, vertical is straight. Yes, level is curved. Got it.
Level is curved. Oh my god. Hey, check it out. If I ever told my boss that this fucking beam is leveled but it's curved, I'll get fired. Okay?
No,
Thank
because
you.
what level means is that either end of that beam is at the same altitude above a reference level surface.
Meaning it will have to stretch out over a horizontal line. Now let's retract. Let's retract.
It doesn't
Is
mean
horizontal straight or curved?
Horizontal is straight. Level is
Thank you.
curved.
Hold up. Stop. Ding, 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 ding. Winner, chicken dinner right here.
Yeah,
okay.
you made up
Horizontal.
you made up a random rule
Horizontal is straight, right? So
there.
if
Yeah,
I told my boss,
you said level is referencing horizontal.
This beam is fucking straight or level. But then I said, oh, but at the end, it's curved. Am I wrong or not?
This isn't that hard of a concept.
No.
I don't think we should keep giving
You're indoctrinated, bro. You're indoctrinated. Real talk, you're indoctrinated. You're brainwashed. Real talk. I no disrespect, but we're trying to pull you out of it, bro. Real talk. We're trying to get you out of it.
Right. So in my actual line of work, we do actually have issues with curvature. We also
Why is that?
We also have extensive optics knowledge in order to
Okay.
determine how something can be seen but cannot be reached by line of sight radio transmissions.
Thank you.
Because line of sight radio transmissions refract less.
I love this.
Because line of sight radio transmissions refract less than visible light.
Yes. Yeah. You're right.
Okay.
You're right. I agree.
So if the line of sight transmissions from radio signals refract less and cannot get to the end result, the receiver,
welcome to Flat Earth.
But we can see it, which visible light refracts more.
Exactly.
Okay.
Yeah.
I mean, if you would protest as soon as you actually understood what I was saying.
No, I totally, hey, bro, I totally understand what you're saying, but I know where you're going with it. But the fact is that I'm telling you, welcome to Flat Earth, but you hold on to your bollard so you will never accept what you're actually physically seeing. And that's funny to me, bro. That's funny. Go ahead.
I want to ask Goofy a question.
So I can
You don't
see
mind.
an object in the distance that I cannot get a radio signal to. It's blocked. What's going on?
Yeah. Okay.
Is the fact that the radio waves refract less than visible light because they carry less energy, or the wavelength is bigger?
The wavelength is
why?
bigger. Technically, yeah. The energy is also lower. The larger wavelength causes them to refract less. Yes.
All right. Hold on. Let me share something with you guys. Okay, you're talking about correct me if I'm wrong. You're saying you send out a signal, but
the radio signal, yeah, you can see the end result, but you cannot get the radio signal to it.
okay. How about this? Have you considered the output power?
Have I considered the output power of my line of sight transmitters? Yes.
Yeah. Okay. So the line of sight transmitters does
Transceivers,
not
really.
reach it, or yes or no?
Say it again.
Hey, I'm not being stupid. I'm just trying to follow along with you. You're saying the line of sight signal is not seeable? Like you can't, you don't recognize it? Like you don't see it, or no?
It's a radio wave. It's not visible light. I mean, I can see the transceiver at the other end before it becomes unreachable by radio signal.
Okay, so once, like for instance, now I'm gonna share something with you. I'm in a naval ship, and I send out a radar, and it goes so far, but finds nothing. It bounces back to me, yes or no? Answer that.
It wouldn't. I mean, the point of a radar is for it to render what it got bounce backs from.
Now, what happens if I send a radar out with a certain strength, and I send it out, but I see nothing? Is that possible? Yes or no?
Certain strength. The yeah. I mean, I don't know why you would have intentionally made it really, really, really low strength, but you could do that.
You get what I'm saying, right? You could only, in other words, you add this you add this what the fuck is the word I'm looking for? You add this for lack of better words, let's just say strength, and you send out the signal. Okay, velocity, whatever you want to talk about. You send it out, and it comes back to you, and you see nothing. But what if that is only because my output power is low? Meaning, my signal's only going to go so far because that's all I could shoot it out. But I increase volume, and now I can see the enemy's ship abroad way further because I increase the volume. Is that safe to say? Yes or no?
Not really, because when you have a radar system, the output power is usually not that variable. Like you wouldn't have like a 50 milliwatt radar. That would just be silly.
Okay, so let's go with the most strongest radar capacity. Is there an actual distance it can reach? In other words, is radar infinite, or is it infinite?
You said infinite and infinite. Okay, so radar, there's two typical technologies employed, which is either line of sight or over the horizon radar.
Correct.
If you're doing line of sight radar, that's a higher frequency, and that's not going to reach past the horizon very much. It's a very tiny amount that it can. But the over the horizon radar is using ground wave propagation, and it does the same over the ocean as well. It's just called ground wave propagation. That can actually get a return signal beyond where you can visibly see it. But that's a much, much lower frequency than the frequencies that I'm using for my transmissions.
Now, technically, the line of sight radar should be, let's say the vessel's 50 feet in the air. It should be about 7 miles, 8 miles out. Am I wrong?
50 feet. I mean, it could be longer.
Okay. So what happens when you're seeing something 200 miles away? Explain that, please.
Oh, are we back to that again where the drone is doing the spotting?
No, not even a drone. Matter of fact, there's a naval ship with what's the fucking weapon they have? It's the rail laser. I think they could shoot up to
Not a
100.
laser.
I think they shoot up to 180 miles away, or maybe 170 miles away. But let's go 170 for the lower side. Let's go lower. How does a ship see 170 miles away?
It doesn't on its own, typically. There's spotter
No,
planes,
no,
there's
no,
other
no, no,
ships.
no. Let me correct you. It's line of sight. It's line of sight.
Radar
170 miles.
is it typically on a higher frequency line of sight, but they don't have to use the same
No,
ship
the
that's
laser.
firing.
No, not radar. No, Bubba. No, Bubba. Not radar. Laser.
They're not
Laser.
firing.
Line of
They're not
sight.
firing a laser.
They do.
Railgun. A railgun is not a laser.
No. The thing I'm talking about. Oh, God damn it! I gotta fucking look. You're forcing me to look. I gotta find it for you and put it in. I'm too drunk for this right now. But listen.
Well, they do have a laser system that's anti-air, and that's going to be a totally different scenario.
No, anti-air. No, that's way different. I'm talking about a line of sight on fucking some surface to surface, and they can see that motherfucker. I'm sorry, I stand corrected. 123 miles away. So they see something 123 miles away physically because that's laser. That's line of sight. Okay. Now,
Right, radar can typically be line of sight, but the targeting system and the firing system don't have to be the same vessel.
all right. Well, I'm just telling you that 170 miles away, line of sight, laser. They pick it up, they shoot the fucking rocket, it hits the fucking target.
Well, now it's a
121
rocket and
miles.
not a laser.
What?
Well, now it's a rocket and not a laser.
No, the rocket hits what the laser fucking sees. The laser is line of sight. Like, look, okay, put it this way. If I shot my fucking little laser that I own personally, if I shot that shit 100 yards away, and
That's
then
not collimated enough to do that.
just
I mean, you can see the emitter, but it's not collimated. It's not collimated enough to hit a point at 100 yards away.
what I'm saying is that the Navy ship that we have today in America. Are you from America?
Yeah.
Okay, we have a Navy ship that they use line of sight on their fucking laser guided fucking missile. What they do is they shoot it, and once it's on a target, a fucking ship or whatever the fuck they want to do, it's fucking 123 miles fucking away, and they line of sight. LOS is key, bro. LOS, line of sight. When they see it, they fucking shoot the fucking line, and they shoot off a missile vertically straight up into the air. But that fucking missile is programmed to follow where the laser fucking lands. Hey, let me ask you something. Like, I no disrespect. Have you been in the fucking armed forces?
I have, but I'll just mention real quick, like I said before, the targeting system and the firing system don't necessarily have to be on the same vessel.
Okay, that's fair. I agree with you. But on this particular vessel that I'm speaking of, this is what I'm talking about. So,
Right, it's firing the missile. It doesn't tell you whether or not it's the targeting system.
I'm just saying that there's a fucking vessel, line of sight, and they shoot the missile from that vessel. Okay, just to clear you up. Now, let me ask
Just
something.
ignore what I said. I know. Just keep going. Just
I'm
ignore
sorry.
what I said.
No, I hear what you're saying, bro. You're saying there's two different vessels at the point. You're saying there's two fucking entities going on right here. One sparks it, one shires it, right? That's what you're saying, right?
Pretty much.
Yeah, but I'm not saying that. I'm saying
Why
one
not?
marks it and the same one shoots it. That's what I'm saying. Maybe that's where we're at a disconnect. So listen. So
Right. I need an example though of that
okay,
actually occurring where it's the same vessel that's lighting it up and shooting it.
Okay, so there's a particular fuck. Do you want me to go into like bring it up to you? Like, okay, there's a particular vessel has line of sight. They shoot 123 miles out. The same vessel launches the fucking sea to sea missile or whatever, fucking rocket, whatever. It hits it. That's not explainable on a globe Earth.
Right. What you're doing is you're just saying that the same vessel that lit it up hit the target or shot
Yes.
the missile.
Yeah.
But that's all. That's what you're doing is you're just saying that's what happened.
You know what? I mean, fuck. Let me. Like, I guess I'll look for it, bro. Like, maybe I'm just being lazy. I'm sorry. Hold on. Let me look for it. I'll look for it. Don't trip. I'll look for it. For you, I'll look for it. The USS Portland. Can you Google that?
Say that again.
USS Portland.
USS Portland.
Yeah, go ahead and Google it. You'll see it. Oh, I'm fucked up, bro. I'm so drunk right now. I'm like, it's all bad. And I have to go to work like in 5 hours.
Probably take a nap.
Probably, yeah.
Amphibious transport deck.
Yeah. Yeah.
Okay.
No, but go ahead and look into it. Like, I mean, I'm pretty sure there's multiple fucking art.
30 megawatts of power. Oh.
You got that? You get it?
Yeah, I'm looking at specs. I don't see what you're. You got. Yeah, that's nice.
What's up, Riding? What are you getting into tonight?
Yeah, the bottom line. Just go ahead and look into it, bro. Look at
I
whatever.
was just calling out Riding because I thought earlier when he came in.
Look at all I'm saying is this, bro. Like, go ahead and look into it. You're gonna see that I'm not just pulling this shit from my asshole, bro. Like, I looked into it, bro. I'm not. When I talk to you fucking ballers, it's not because I don't know what the fuck I'm talking about. It's because I look into it. And now I'm trying to just tell y'all, like, bro, this shit don't fucking make sense. But I'm glad that you give me the opportunity to share it with you. You feel me?
All right. Well, have a productive day at work and stay safe, at least.
Of course. Hey, I'm gonna tell you right now. All I do is just fucking sit in the truck, bro. My best friend that runs the job at LAX, so he just fucking has me drive around, and just fucking tell people what to do, bro. I have an easy job. I'm an iron worker, but right now, it's an easy job, bro. I just tell people what to do.
Drink some water, man.
Nah, hey, beer has water, bro. Don't get it twisted.
All right.
I'm just saying, we good, we good. It's fucking 11:20 where I'm at. I have to wake up 11, 12, 1, 2, 3, 4 hours. We good, bro. Don't even worry. Matter of fact, hey, guess what? Tomorrow is? It's fucking Good Friday, bro. So my boss, I'll set up the early at his house. I was setting up the fucking barbecues. We spent like $400, bro, in meat and fucking good ass prizes and everything. We're gonna get the whole crew out to you know what a VFW is?
Did you say VFW?
Yeah, you know what that is?
Yeah.
Yeah, the veterans shit. Fucking yeah. We're gonna fucking barbecue at the veterans fucking place over there, and we're gonna just celebrate, bro, because it's Easter fucking weekend. And guess what? I'm gonna only work fucking 4 hours tomorrow, but my nigga gonna pay me for 8, bro. So we good, bro. We good. I'm getting drunk now because I already know, bro. We good. You know what I mean?
I got some slow roasted beef coming my way at some point.
Oh, what? Really? That's
Potatoes and carrots and all that.
oh, I love it. I'm salivating already, bro. That's good shit right there.
Yep.
Hey, everybody. I wish all y'all fucking happy Easter, happy Friday, whatever, bro. Like, look, I get deep in this fucking dumbass flat earth bullshit, but at the same time, bro, I know I'm drunk, but I'm a good guy, bro. I wish everybody love, bro, all the time, bro. Like, stay true to your family. Family comes first. If you're a father, be a father. If you're a mother, be a mother, bro. Like, real talk. Everybody. Real talk. Wow, I'm drunk.
Cheers.
Cheers. I just drank our 28th beer, brother. Yeah, we going good tonight. I just wish that all y'all fucking ballers would realize that shit ain't fucking measuring up, bro. Like, for real, it's not measuring up. Look it, by default, we were as kids, we were all ballers, bro. By default, but it just takes a special click to knock you out of the fucking programming, bro. To make you realize that a lot of this shit don't make sense. It don't make sense, hands down. But ballers will stay by it, bro. Like you're defending your life for it. And that's okay. That's okay. You keep doing that. I'll still help you fucking change a tire on the side of the road, bro. Real talk. Hey, eggshells, you there? Eggshells. Eggshells. he's muted. Yo, eggshells. Unmute yourself. He's probably gone. Whatever. All right. Let me see. 11:30, 12, 1, 2, 3:30. Yeah, about 4 hours of sleep. All right, I'm out. Y'all have a good night.
Good night.
How do I close this shit?
Jay Doherty. Is that the one and only Jeff Doherty? Christian whistleblower, is that you?
drag him up here. Here we go. Move to Livestream 1.
Okay. Am I here?
Unfortunately, you are. So anyway.
See how you talk to me differently all of a sudden.
All of a sudden, exactly right. Now,
Okay,
no more respect. All right.
I know now it's hostile. See
exactly.
See what Geo has done. Geo, see what you have wrought.
So now you have.
Okay, wait. We're making it simpler, and I was about to make the request of how to make it simpler.
Okay, go.
So, I want us to just for a little bit, no stars. Let's get a strand of Christmas lights and hang them up on the fence.
No. We're talking.
Why can't we do that?
Because we are talking about spectroscopy in looking at stars. All right.
Okay, but can we back for a minute? I've humored you quite a couple of times. Can you humor me? Really?
No. Because we're talking about a funnel on the
Yeah,
end of
I still want to.
Fine. Go to your Christmas lights.
So we can hang them up on the back fence.
Okay. Yep. They're hung.
Can we get your cell phone out? And
fine.
Can we take a picture of them?
Yep.
Can we look at the picture? Is it possible for us to count how many lights there are in the strand?
I would presume so, yes.
Why? Why didn't it all get mixed together into one blobby, blurry mess?
Why would it?
So then we can keep the light from individual things separate.
No,
and you don't actually have a problem with that.
No, well, you've taken a picture of some Christmas lights on a.
Okay, sure. But now we're going to take a picture of the Christmas lights in the sky, and we can still keep it separate.
Has some of that light from the left-hand light or the right-hand light got into the middle light?
And we can keep it separate enough to count how many lights are in the strand, right? Even if there's a little bit of mixing, we can still count the number of lights.
No, we are not talking about counting how many lights that we can see in a picture. What we are
Why not? We're talking about keeping light separate enough that we can do stuff with it.
No. Calm the farm. We are.
I can't, dude. I can't calm the farm.
No, we are talking about isolating the light from one particular light. Now,
right, enough to be able to do something useful with it.
No, because now
it doesn't have to be perfect isolation. It just has to be isolated enough that we can do useful things with it, like count how many lights are in the strand. We can isolate it enough to count the number of lights in the strand. You agreed with me on that.
100%. And I agreed right at the very beginning that we can count the number of lights on the strand. I didn't disagree with that.
Okay, so look at this. Look at it this way. Suppose that your cell phone, the CCD that's in that camera, it's sensitive to visible light, right? It's not sensitive to all electromagnetic radiation. It's just sensitive to some radiation, right? That's how CCDs work.
Okay.
Now, suppose that you and me, we go and start a new engineering company and we make a new CCD that's only sensitive to red light. That's it. Just red light. And we put that into a cell phone and we take a picture of the night sky. And we also make a CCD that's only sensitive to green light, and another one's only sensitive to blue light, and so on. And we keep taking pictures of the night sky. You see how you can still count the number of stars in the sky. The light is all separated. It's all landing on the CCD, not mixed up. It doesn't look like a blurry blob. It is possible to keep the light from getting so mixed up that you can't do anything with it. We can count the number of Christmas tree lights on the strand in your backyard.
Has white light, green light, blue light, yellow light, purple light, rainbow light, has all that also too got into the particular device that we are only taking a picture of red light of?
It can, because your
Obviously
regular cell phone, if you just point it up at the night sky, it's going to be sensitive at least to basically all visible light and a little bit beyond visible light. So your cell phone is already going to take all those wavelengths and keep them like isolated enough that they land on the right pixels, so it doesn't just look like a blurry blob of light. You could still sort of count the number of stars in a picture.
But all the other light has got in there, hasn't it?
Yeah, but it doesn't mean that it got mixed up and confused.
But all the other light is in there, yes?
Right, separated
Okay,
and landing in its right
fantastic.
spots, not confused.
Fantastic. So all the other light is in there. Okay.
Right, landing on its appropriate pixels and not confused.
Right. And we're just taking we're taking an image of red light, but all the other light has got in there. And
Okay, yeah. So you're saying that we didn't put a filter on it; we just made a CCD that was sensitive. So there's a difference. We could filter the light, in which case only some of it would land, or we could let all the light in, but our sensor is only sensitive to certain wavelengths. Both things are possible.
You haven't stopped all the light getting in there at all. All you're doing is now having
a filter
in
would.
there.
A filter would do that, right?
Okay. Yeah, but the light is still getting in there.
Not if we put a filter there.
It filters it, right?
Right, but that means the filter means block, stop, end. It doesn't get in.
The only way you can block something, right, is by completely stopping it, right?
That's not true.
Cutting off. All you're doing is filtering it, so it can still purge. It can still let other bits of it through.
That's how all filters work. All filters are imperfect and let little bits of things through. The water filter lets little bits of dirt through.
Exactly.
But it doesn't let enough dirt through to hurt you.
It is not perfect. It's not
Right, but like the water filter doesn't let enough dirt through to hurt you. Likewise, the light filter doesn't let enough light through to mess anything up.
Right.
So you're right; it does get through,
of course,
but it's not. But it's not enough. It's not enough. We can still count the number of bulbs in the strand on your back fence.
Yeah, but we're not talking about counting. Right, how many bulbs are on the strand, or we're not counting how many stars are in the sky. This is not what we are doing with this machine. We're not counting, right?
I don't know. In some sense, we are. I mean, it's one of the things that we could do. It's a thing that we could do.
No, we are analyzing what that light is. That's what we're doing with this machine.
A spectrometer specifically is designed to separate the wavelengths of light and tell you how much of each wavelength is present. Quantized into certain bins, mind you. It doesn't have infinite precision of wavelength.
No, and I would question what sort of precision that it has. Anyway, this is what I said.
The user manual happily discloses that to you.
What the precision of this tool? They have a tolerance of accuracy of something that is 100 trillion light years away.
Well, see, so that number doesn't matter, right?
It does matter.
No, it doesn't.
100% it does matter.
0% doesn't matter.
Oh yes, 100%.
It doesn't matter how far away your back fence is either.
What that light is traveling through and how long it travels through that particular medium definitely does matter.
Definitely doesn't matter.
Yes, it does, because when we are analyzing what that light is and what that light has picked up and what that light is constructed,
light doesn't pick anything up.
What it is up. Well, then, really?
Yeah, light doesn't pick anything up.
So then, how are we using a spectrometer, right, to point at a star, right, and tell us what that star is made up of?
That's That's a question for real, but light doesn't pick anything up while it travels. It's not like a car that gets a lot of bugs on its windshield.
That light has to be affected by its either A, its source, right? And
It is affected by its source, for sure. I agree on that. A, check.
B, right? And B, it is affected by the medium that it passes through.
And B, check. But affected by doesn't mean picks things up.
Well, affected by, right? It is traveling through a medium, and whatever that medium is constructed of, right, is going to affect what the reading is at the point of where that machine is.
Well, sort of. You could fire a laser. Yes, sort of. Yes, sort of.
100%.
Listen to the whole sentence. You could fire a laser through a piece of quartz and then out the other side of the piece of quartz into a detector, and there's nothing to detect that tells you that the light traveled through quartz. Like it didn't acquire anything from the quartz. Zanuck says, "Hello, Zanuck, my nemesis." Zanuck, if your detector is on the other side of the quartz, you can't. The light doesn't have little bits of quartz stuck to it, and now you can like figure out that it went through quartz.
That's right. That's why to them it's like whoop. We didn't think that one through, did we, guys? Back to the drawing board.
Wait, who are you? Zanuck is maligning somebody, but I can't tell who.
Let's find out what Ether could have done then. Since he's right, he got us. Let's figure out something else to conjure up here.
Hey, Bandsaw.
That's a good one, though. No one's ever brought that up. That's actually pretty good.
No one's ever brought what up?
There's no way of detecting that the light has ever gone through something. If it's gone through a medium, you'd be able to tell that it actually has.
You can't tell that.
Some hints, yeah. I know. I'm agreeing with you completely.
It's not like the photons have little flecks of quartz stuck to them on their way out. I mean, if they did, I don't know. The world would be a different place.
That's a truism.
Zanuck, if we have a big get-together or party someday, I would suggest when we hang out that you just rock your guitar more than debate. You know what I'm saying? Like, let's just... I would like to hear you sing songs at the bonfire.
You got it.
Oh, man. If you got in a debate in person, dude, I bet there'd be fucking arms swinging.
I'm not. Let me finish. Let me get one word out, please. God, shut up. Why are you talking over me? I had a flat earth argument with a friend, with a buddy I played guitar with the other day. He would not shut up. He would keep. It had to be his way or the highway. He was right. I'm wrong. I'm in charge. Very similar to what we have with going with me and some of the guys here. I had to laugh.
All right, I've been on a like humoring other people, but I have a question that I want to ask tonight, and now I've got Zanuck and Geo, two skilled people in their professions, flat and globe as they were. I heard, and I'll just full disclosure, I heard this in the Dave versus Dave from the other night. Did you guys watch that?
No. How do I see that? That sounds interesting.
It's on. I saw it on YouTube. This is Dave Weiss versus Dave the would-be professor.
It's under Dave versus Dave on YouTube. I could probably find it easy.
I feel certain that.
Zanuck, you haven't heard of this? It was Professor Dave debating with David Weiss. He calls himself Professor Dave. He's not really a professor, but that's his YouTube.
Yeah, I've seen him before. I'll find it.
That's why
I'll do
I
that
called
later.
him Dave Would-Be Professor.
What's his other channel? Doesn't he have some other channel too? It's
I don't know of that. Gio, did you watch? Did you watch them argue?
Do I have to go find it and look at it now? Or can you
No, don't go look at
I'm
it.
just surprised you haven't heard of it, Xana, because it's been.
No, I've heard of Professor Dave for sure.
I'm just surprised you didn't hear they did a debate. That's what I'm saying.
Yeah,
'Cause we've been
Xana,
talking
don't go look at it right now. It's
No,
an hour.
you got my attention. You have my full attention.
It's an hour long, and Gio. But I'm asking if Gio watched it already or not.
I watched like the last third of it and the first third of it. I think I missed the middle third. I kind of did it backwards and skipped the middle. But
Fair enough. I don't know.
still had it open somewhere that I was maybe going to watch the rest of it, but it was.
I picked this up from Professor Dave, and I offer that freely because generally I don't like bringing arguments from sources like Professor Dave. But this particular thing that he said, I liked it a lot. I don't know if it's his idea or if he got it from somebody else. Flat Earth, a major tenet is water doesn't curve. Water finds its own level. And I think it was in the very end of the debate. Professor Dave asked Dave Weiss if he believed tides were real. Dave Weiss said that he did. And they both sort of acknowledged that the water level goes up and down during the day, but at different times in different places. Therefore, on a flat Earth, you'd have to have little mountains or hills of water moving around, like because the water level's going up and down at different times in different places. And if you can have little mountains or molehills or whatever of water moving around for whatever reason, whatever's causing it, if that's happening,
and it ain't flat,
then water's curving. And I was like, well,
that's not curving in the way that they're talking about with an 8 inches per mile squared.
Right, but I brought that up a few times.
Waves with a level baseline. Waves with a level baseline is very different than the concept of water curving over long distances, conforming to some kind of a curved Earth.
Right, but tides aren't waves. Tides and waves are very, very different things.
Tides are an influx and an outflux of liquid within a particular region. So, yeah, I mean, in terms of the concept of a planar Earth, in terms of that geometry, if all the water was completely still, that would be one thing, but we know it's not. So, yeah, you definitely have the tides. Now, one could start to talk about like the median point of the tides, because every tide is on a cycle, and everyone has a midpoint or a median point, a center of its frequency. And in that center, that would be very interesting to see how that actually maps out. And I've actually talked about this. I think it's actually slightly convex. So there is a slight bit of curvature, but it's not because water curves. Water finds its level in large bodies of water. It's simply that the median point of the tides has a slight convexity. So it's a little higher here, a little lower there. That median point overall is slightly convex, and that has to do with the electromagnetic field of the Earth.
So it's not flat. So
well, no, I would still say it's a planar geometry with a magnetic field that causes that midpoint of the tides to have that. And then you have all of the water coming up out of it, and any still water is absolutely planar, yeah.
Okay,
so where is still water, Gio? Where do I find still water? In the ocean, no lakes, but open ocean. Where do I find still water?
Well, there's no still water in the ocean. The oceans have their tides, but there's only still water in lakes, river. Some like river basins.
Well, let's say we got a high.
So wait, Xana, hold on, Gio, the black swan, the black swan with the oil rigs.
Ponds,
that water doesn't have to be level. The black swan picture, that water doesn't have to be level at all. It can do whatever it wants because it's open ocean.
No, water finds its level, and it's correlated with the tides.
The black swan picture's in the open ocean, and you just said in the ocean the water's not still, and only still water finds its level. Is that true?
No, that's not what I said.
Okay, then fix it.
All water finds its level. All water does.
Okay, so even in the ocean with the tides, the water is flat and level and doesn't have any bulges or curves or anything. Except for the waves. Like there's waves, but other than the waves, there's no weird shapes. It's flat except for waves.
Yeah, like I would say the oceans, like if it's pretty calm and you only have little rolling waves, then yeah, that planar geometry is there. But it's slowly moving throughout time, for the tides to change, very, very slowly. So it's sort of, you'd have like level water with waves. And then as the tides come in, that level water would start to rise a bit in your
Okay,
local
so
region.
suppose that like in France, on the coast of France, it's like 10 meters above sea level. There's a place where the tide is rather extreme, and it's 10 meters above sea level. And at the same time, off the coast of Africa, it's 5 meters below sea level. So it's like same moment in time, noon on Friday, you've got this 10 meters above in France and 5 meters below in Africa. What's the shape of the water between those two places? It's not curved, it's flat, but how can that be?
It's different elevations.
It's not the same elevation in the two places, so it's got to do something.
It's at different elevations compared to mean sea level.
The water's at sea level, right? It's the sea. How can it be at a different elevation?
It's not at mean sea level.
Hey, pick me.
If you use like a midpoint,
who's saying "pick me"? Is that Xander?
I'm raising my hand. I like the teacher.
No, that's
okay. Xander, I yield the floor to Xander.
So yeah, you got your 18. I don't know if it's 3 meters, 1 meter, 2 meters in France, and 1 meter or 2 meters in Africa negative, and then in Jamaica it stays zero the entire time. It doesn't even move. There's no tide. So how between those 2 points do we have like a downhill run? Like it's downhill because it has to be, right?
It's very slightly, yeah, because the elevations are different. If you were to like travel in some kind of hyperspeed boat or something that quickly, because if you were to actually travel it, I mean, the tides are going to change within 6 hours. So, I mean, you're going to be,
right.
It's going to be way different by the time you got there. But yeah, in theory, if you could do a speedboat or something, then yeah, they are at different elevations because it's like in a bathtub. If you kind of like suck water, to put a pump or something, something like that, where you can get different elevations of it, which is essentially what waves are, which are all like, sine wave frequencies compared to a level baseline.
Okay, so in the Black Swan picture, which is in the open ocean and subject to tides, is it level for sure, or is it maybe not because it could be doing the stuff that you're talking about?
It's locally level at every region, only different compared to elevation changes.
How big is local? Is that 10 square miles, 50, 100, 1,000? How big is local?
I mean, when I'm referring to it, we're talking just being at a beach and at an ocean, the water's level. But the elevation will be slightly different.
It's like colloquial. It doesn't have
level water, but the elevation will be different at different areas because it's like sucking in and out, basically. It's like breathing in and out.
Okay, but when you say like locally level, you just mean sort of colloquially what I see. It's not a specific thing that it's not something that I can translate to my location where you've said this many square miles is locally level. It's just convenient to say.
I mean, in this way, like if it depends, how the actual tidal system works, but in a way it is curved water. I mean, you could say the waves are curved water, but of course, when they're talking about 8 inches per mile squared, they're talking about a consistent. It doesn't have that, but it only has wavy, like larger waves is essentially what it is. Because like a wave is a high point and a low point within a cycle. And so if you have tides, like imagine like, let's say the entire earth, like something like a Gleason's map. And if you had, let's just say for the moment, there's like drains in certain areas and then there's faucets in other areas. So it's like filling and lowering different areas. Then you would have different elevations. It would just slowly, it would be sloping to some degree and it would slowly be breathing in and out, but all compared to the level.
So it's like waves, but they're bigger and slower than regular beach waves.
Yeah, like if you get in like a bathtub and you kind of, you start like making waves in one area and then the whole thing, there's
so
like
how do you
different elevations. But I mean, if you were to make that
out
Earth,
in the
and
Black
those
Swan?
waves would be so huge, it would be like thousands of miles long.
Is that the reason why the Black Swan has in one day it's hidden, the next day it's not hidden?
No.
Okay.
Is there any way to measure the 8 inches per mile squared?
Sure.
But wait, Gio, how do you know?
One that I've ever
how
seen.
do you know in the Black Swan picture that water is flat and not subject to a local faucet or drain? Like, how do you know for sure that
you keep going over this? Let me interrupt for a second. When we say water's flat, we mean we cannot measure it at 8 inches per mile squared.
Until we do. Like the bottom picture of Doofus's twin picture, the bottom one is showing an 8 inches per mile squared relationship, because you would look at the object behind that oil rig and see even more hidden to the tune of 8 inches per mile squared. Or you can look at horizon drop at different altitudes. That equates to 8 inches per mile squared as well.
A single picture is not measuring it. And where else can we find 8 inches per mile squared?
And hold on, Zanuck, 1 second. One slight second.
Well, let's let Zanuck respond. It is a
that.
direct question, and Zanuck sounds like he has a measurement of 8 inches per mile square, which, if he does, be the first I've ever seen. So, what do you got?
But Jay said something that I've never heard before. Flat doesn't mean flat. Flat means not 8 inches per mile squared. Is that what you said?
In this case, in this particular example, yeah. I mean, where is 8 inches per mile squared?
Okay, I didn't know that's what flat meant.
In this case, yeah.
This case, what is this case?
When we say the water's flat, we can't measure it at 8 inches per mile squared.
So in any time that somebody tells me water's flat, they mean not 8 inches per mile squared.
If it's something other than 8 inches per mile squared, that's okay. Like 2 inches per mile squared.
Well, I suppose it could be said that, like, okay, like, where is the 8 inches per mile squared? If it's not there, it seems to be a level, flat, planar baseline. So that's kind of the question, like, where is that measurement of the 8 inches per mile squared? Because if you don't have it, then we're just seeing the continued level, the actual horizontal level with no curvature.
We see the 8 inches per mile squared until we don't see the 8 inches per mile squared. And we don't see it when we have optical effects such as refraction. Particularly downward refraction, because upward is very rare.
Right, but you don't have any geometry of at 8 inches per mile squared that you have measured or in any way validated. It's just
we do. The 3
just have
degree
like assumptive refraction theories that involve an assumed radius value, and that's
personally through all my measurements and calculations throughout any discipline I was a part of, I stay away from errored measurements. So when I look across the water and know how refraction works, regardless of flat or curved, and I know I have errors, I go, well, how do I remove the error? Well, the errors are related to how close I am to the surface, so I get an angle, some kind of increased angle to this with respect to the surface, regardless of its shape, and then I can reduce that factor. And by the way, if I know distances to objects in the distance, I can actually triangulate and determine where they should be in my field of view, and then where they are. And then regardless of the surface, again, because I'm going to have a dip angle still regarding not only based on curvature, but also based on just basic trigonometry. And I go up even further, and I can plot out the shape of the surface and the refractive value as I go higher, based on knowing the distance and the size of the object in the distance. I know it's a lot of words, but you can that independent variable can actually determine quite a bit as you change the measuring height. And when we measure 30,000 feet and see a 3 degree drop or a 2 degree drop, that comports with the 8 inches per mile squared relationship.
Yeah, so JD, I think what he's basically saying is that he has these like heads-up display units from airplanes, and there's a little bit of a dip angle, and he claims that that's 8 inches per mile squared, which I'm sure you've probably even heard him say it. He's got the little image of it.
Correctamundo.
So let's see what JD thinks of it. Do you want to post it?
Yeah.
We'll see if this validates as a measurement of 8 inches per mile squared in your viewpoint. But yeah, while you find that, Xanax, so the one that Doofus posted that has the little windmills blocked by water, you see that?
Yeah.
Or I don't know if Xanax, because I was going to... Xanax, are you there or listening as well?
Yeah, I was just trying to keep my clicking from bothering you guys.
Oh, I just wanted to see you were still there. So, I mean,
Yeah.
essentially, like what you think is happening there is that is the curve of the Earth. That's what you're going to say. Like that, the reason that the bottom of those propeller things are cut off, that is the curve of the Earth. However, when you think refraction comes into play, you think that essentially you're able to see around the curve in a way almost like a periscope, where you're seeing kind of around the curved Earth, and then all that stuff is displayed for you. Is that, and then the horizon goes further back, which is that what you think is happening? And then that explains the black swan.
Well, yeah, of course, because you can actually prove you can prove that by the angular position in your field of view, and one small element of proof. I mean, it's not the best.
Oh,
but
no,
it's
but
one-
just okay. Well,
yeah,
go ahead.
one small element of proof is the fact that when we see these comparative photos, that the foreground and background objects that we're looking at with respect to horizons and things, they're moving with respect to each other, and that movement comports also with curvature and
All right.
refraction.
Well, I don't know about that. I mean, at the end of the day, like you're able to see further in certain climates, certain conditions. At the end of the day, and I'm
Yes.
kind of like you're kind of taking like a slinky. I'm imagining, kind of stretch it out and look through it, and make the slinky, planar, like you're just looking straight. And then if you kind of curve it, that's what you're claiming is happening. So your viewpoint is now curving over a hump of an Earth. It's somehow bringing it up, kind of like a hacksaw, and what are those like big like wood saws? You kind of bend it, boing, boing, boing. You're kind of saying that it's like boinging around, as it were, and then all of a sudden you're able to see over the curve, and then it makes all that shit visible, as if it's a planar extended plane. You're saying it's just this bending vision thing.
Not exactly, but yeah, you can now see around the curve like you can when you do that over. You can do that. We talked about the gas, liquid butane, and dropped over a spherical object, and you can see things on the other side of it because it's being loomed up. We're not saying those windmills will ever be seen in their entirety, ever.
Okay, so let me ask you this.
Last thing. The most amount of refraction we ever will see will be sub quarter degree, tenth of degree. So very, very small changes over even longer distances.
Okay, well, the thing I was going to say there is that I have a full understanding and explanation for what I think is going on in terms of this phenomenon, when things are quote unquote cut off, obscured, whatever you want to call it, whatever word, obstructed, even though I don't think it's obstruction, but I know on a globe Earth that's more on that side. The word obscure kind of could fit to both because it's visually unable to be resolved. Anyways, I have for myself, I'm saying, a full understanding and an explanation for how it's working over planar Earth. What ideas could you come up with as a way to validate which it actually is, which one is correct in the physical world? A test, a way to measure water, and how would you validate? Because, like I said, we can explain the optical phenomenon in different ways. So,
I have a question.
How would you? Yeah, go ahead.
I was wondering if there's any videos of like maybe a helicopter rising and comparing what we should see and not see. Well, I guess there is. There's a couple mock-ups, but I haven't seen a video of like a helicopter rising and maybe explaining what we should see and not see.
Yeah, we have those too. We actually do have that.
I have a question for Geo and others. I guess Zanuck as well. I was in 24/7 a couple days ago, and they asked me, this is exactly what you guys are talking about. They asked me what would make me a flat earther. What measurement would like sway me? And I was kind of on the spot, so I threw something out like, if you gave me a line of sight measurement of like something 2,000 miles away. And everybody was like, well, that's impossible, and you're just asking for a thing that can't happen, and so you're dogmatic and religious glober. And so in the time between then and now, I thought about it some more. And I was like, I wonder what the sort of minimum thing. Well, like, is there anything that I know could happen that I don't expect to happen? And this is what I came up with. So I'm kind of curious what you guys think. I want to see something about 200 miles away. And I say 200 because I've been in an airplane, and in an airplane I can see 250 to 300 miles away, depending on which airplane and how high we happen to be. So I know that I can see through the atmosphere about 300 miles away. So I want to see something on the ground 200 miles away. And that seems fair. That seems fair. If I saw that, I would be really persuaded towards the flat Earth.
You could definitely see that far. Absolutely.
Where?
Yeah, but
not like 6 feet off the ground. I'm talking, not up in an airplane.
You know what's funny about that is you can see maybe not 200, but maybe close to 200, maybe 180, 200, and from the airplane from 30 or 40,000 feet, and see what angular position that is in your field of view, and you'll see that instead of being where it should be, you'll see it about 3 degrees. Now, 3 degrees.
Well, 3 degrees, Zanuck, is hard to say, but what I did get out of the whole thing is that 250, 300 miles, there's no problem with being able to see that far if I'm high enough.
But the angle for trigonometry.
Have you seen Jay Tolan's high altitude? Hold on.
Yes.
Have you seen Jay Tolan's high altitude? He has ones that are 1,200 miles.
No, they're all live.
Yeah,
live.
So
Doofus
just.
Can I respond to that? They're a prime.
I would like to hear Geo finish.
Let me respond to that real quick. Let me respond to that real quick. Geo, I know for a fact because I know the Texas area and the Gulf area. I've been a part of the Baja 1000 and stuff. He's got a major problem, Kate. I love his videos because they're so funny, and I love listening to him talk. But they're such great photography. But it's a case of mistaken identity. You are not seeing Cabo San Lucas from the airplane when he's looking to Cabo San Lucas 1,000 miles away. And he points at it and it looks like there's a gulf there. But the key point is so obvious to me and many other people that looked at it is water through infrared will look black. And that's not black. That's a desert there. And he's only seeing through Texas. He's not even seeing into the Gulf. That's what's so funny about it. He thinks he's seeing all the way to Cabo San Lucas. Look, I'm seeing 1,200 miles. Amazing.
Zanuck, this does sound like textbook.
Yes. Textbook what?
It's like textbook damage control.
No, it's complete utter nonsense.
The tone of your voice, how you're trying to cover it all up. It's like you're gatekeeping.
No, not gatekeeping. I've watched the video many times.
That's the vibe. I'm just telling you it's the vibe.
Okay. The vibe is that, but I've watched the video and you cannot see Cabo from people that fly there. In fact, if you're flying from Dallas to Cabo, which is a flight there, you think the pilot's up at 30, 40,000 feet. Oh, there I can see the airport from here. No.
Well, he did one of the Great Lakes, and I know the Great Lakes quite well because I grew up around there, and it was striking. Like, it was absolutely the Great Lakes at that distance.
Yeah, 200 miles. It's all you're going to see.
For me, it's some of that breathtaking footage of like, wow, this extended planar Earth is profound.
Yeah, but then he's at Colorado and he's saying, I can see Mount Shasta. Here's Mount Shasta. No, that was not Mount Shasta. He was only seeing through Colorado. He was still stuck in the Rockies. He wasn't seeing the Sierras or anything.
I don't remember seeing that one. I haven't seen all of his, but I have seen
one last thing. He picks things that are clouds in the distance, high cirrus clouds and other cumulus clouds, maybe way off in the distance, calls them mountains. These are it's just ludicrous type claims. The photography is phenomenal. He just makes, it's just a case of mistaken identity. I'll just leave it at that.
I agree, Gio. He doesn't like it.
He put a lot of time into that conclusion.
He did. I God bless him for it too, because I think some of the best video I've seen of even the stuff in California.
You. I said you put a lot of time into that.
Oh no, because he did, and I've looked at them. I've watched all of them. They're amazing, and I debunk them by using a critical logic and maps and identity to certain structures in the geography.
So you think you've debunked it because you think that he's not looking at what he's saying he's looking at?
Zanuck, you're
Because
just
I can
wonderful.
identify the angles don't add up either. The angles from level.
I'm so glad you know every single thing. You can just debunk
No, it's
every
so
single
easy.
thing
This,
for
this,
us.
you know,
Oh my God.
having flown and knowing how to judge how far things are away, there are certain things you can do. And 3 degrees is a pretty easy thing to look as far as dip angle. I mean, you can look down 3 degrees and
All
know
right,
about
so
where you're at.
that's not what he's doing, though. Okay, so you're claiming here essentially that he is basically at high altitude. He's doing very good, video, film, pictures, etc., and taking footage. He is then pointing out his location, where he was flying, and the distance to these particular things, like whether it's the Great Lakes or these
Cabo San
different
Lucas.
things. Yeah,
Easiest Cabo.
yes, and he's pointing those out and correlating that with the distance that it would be compared to the rest of the land as it stretches out. Now, whether he's right on all of them, whether he's right on some of them, or whether he's wrong on all of them, it sounds like you, going only off pixels that you're able to, are somehow coming to a conclusion that you're saying every single one of what he's saying they are, what you're seeing, are wrong. Is that what you're saying?
Okay, so every single mountaintop I was able to identify for a distance on a map for in Texas, and they were exactly where they should be with respect to where he was flying, and he showed his flight path on there as well. And and every single one of them was where they should be. I had like 10 mountains that are exactly where they should be in Texas, and he was calling them Mexico. One, even in Cabo San Lucas, the angular size, strictly the angular size of a mountain, I forget the name, Azul, or the mountain that's right on the peninsula there. That size of the mountain that you could see from that far away would not be that size. It couldn't be, because it's that far away, Gio. It doesn't work. It just does not work at all. Not even close. It's not being so smart. It's me knowing how angular size, like your guys' word, perspective. Every angular size goes down directly proportional with.
All right, so you're telling me on that one I just posted that's not Lake Superior and that's not Hudson Bay?
The Hudson Bay ones, like I said, I don't have much.
You said water shows up black, etc. You're telling me that that's not what those are?
No, that is not infrared. That's just a wide angle lens looking across the horizon.
Yes, but I'm asking you. I mean, the water does show up black in both, but
no, it doesn't. It shows blue. It's blue here. It's blue here.
So you're saying that's not Lake Superior and that's not Hudson Bay?
Oh, well, maybe I'm looking at Doofus. Oh, I see. I see what you're saying. I was looking at Doofus.
The one I posted, 1,200 miles. 1,200 miles. So I'm saying you're such an expert at quote unquote debunking that you're claiming, and I'm not trying to like roast you for it. I'm just asking. You're claiming that in your opinion, that's not what those are.
Yeah, that's not Hudson Bay.
Okay, because at the end of the day, obviously everyone can make up their own mind. So
look at the angular position. Look at the zero angle.
And somebody may want to do more research before even making a conclusion. I get that as well, because it's only one.
Well, I like the fact that he has the zero angle there, and you'll figure out where the distances are, where they should be for angle dip, and you'll find that's not correct. 1,200 miles would not be at that angle.
Okay, remember, now let me ask you this: if somebody in Lake Superior launched a massive fireworks at the time of this filming, and you could confirm that they were in Lake Superior, and then you had also people in Hudson Bay doing big fireworks, and you could see it in the footage, would you then be convinced that
I'd be convinced,
Lake Superior?
Yes.
You would be. You would be. Well, that's not that hard to do. I mean, we got it, Zanuck. All right, we got it. That's all you would need then.
Well, he's. This one I can't.
How much you want to bet? Now let's get a bet. I'm kidding. I don't really want to bet, but let's get a bet on the table, because that's not that hard to do, dude. I mean, it depends on how big the fireworks would have to be. It depends on what kind of visibility you could get with the fireworks, but that definitely seems possible to do.
Well, it shows 600. It shows.
So if you saw those fireworks, you would say, okay, the Earth is actually planar. Is that what you would do?
Yeah. Depends how high they were going, obviously. But if they're, high fireworks can only go, a couple hundred feet, so it's not going to be a big a deal. So even a couple hundred feet is not going to be, we're looking at, 30,000 feet of drop over, what is it for 1,000 miles? Probably 20 miles, 30 miles of drop. I mean, it's something pretty massive. So no, I'm not going to do it. Yeah.
Right. So being 30,000 feet in the air, you would definitely not see that on a globe.
Yeah, you aren't going to see. Yeah, you can't. You only can see. You see at a 3-degree drop, you're seeing about 220 miles. And by the way, another key indicator of this is that if you look out and you see something like say a airport, green light. If you can see it with your binoculars or whatever you got on board of the airplane, and you look at this 180, 200 miles away, and you'll see it's a 3-degree drop. That 3-degree drop should be at 100 miles, but yet it's 200 miles away. See what I'm saying? If you look down 3 degrees at 30,000 feet, you should see only 100 miles away. 100 miles. You can see that from my rooftop, in the hills here in the Bay Area. 100 miles, not hard to do. I can see 70 like every day. It's Mount Diablo from my location. So 100 miles, all you can see from 30,000, but yet we see 200 miles. Why is that? You don't see any further than that, by the way, because you can see the light. It's the farthest you can see. But somehow Jay Tolan is able to see 1,200 miles. I mean, the reason it's so easy to debunk is that he's made himself so preposterous. Because not only is it's not 300 or 400 or 500, it's 1,200.
Yeah, but dude, that is Lake Superior and Hudson Bay. I'm just telling you, man.
How do you know?
I grew up. Well, I have not physically. Okay, like
show me an airport. Show me something clear. The reason I like the Mexico
picture. I was
pictures.
going to say real quick. Hold on. I was just going to say that I haven't made that observation myself. I'm only going off of his footage of it, and I'm coming to my own conclusion based on that. I'm not trying to prove it to anyone or do. I'm just saying yes. I think that is what they are, and like you said, there are ways to prove it.
Yeah. And by the way, if you're flying, which I used to do quite a bit, and flying over that part of the country, I would look and identify, lakes and streams and rivers and cities from my window, and I'd identify them and then see if that was them as I approached them. So in this particular situation, even though he's not traveling to Lake Superior or Hudson Bay, he's going east. He's going probably westward. You would see in your field of view how those objects in the distance, if it's Lake Superior, how they would move with respect to you, and it wouldn't be correct. That's not Lake Superior. That's not Hudson.
Well, I'll tell you this: if you went to another body of water or another spot on Earth, let's say that's much, much closer than Lake Superior, and you launched fireworks, like you found whether that's a body of water that's closer, because okay, you would agree that that's probably land and water. Would you agree with that?
No, it looks like clouds.
Okay, now we're on clouds. Is what
I can't tell. I can't see. It looks like that's cloud cover. Looks like it's cloud cover. I can't. And then the dark area could be breaks in the clouds. I can't really tell.
Well, you may want to see. This is just a screenshot from it.
I know.
You want to see the whole footage.
I like that one. He did talk about this, and I didn't pay much attention because
that's a very zoomed in, part of it.
I know. I get it. But the thing with that is there's not the landmarks that I have with the Mexico. Mexico is very discreet. Even the Colorado one which was claimed to be Mount Shasta, has landmarks.
Hold on. Let's not jump to others. Sorry to interrupt, but let me just finish what I was saying about that. I'll tell you that in terms of me thinking this is Lake Superior and Hudson Bay, if you could find a closer area of land, whatever it is, or find clouds, whatever you think that is, and shoot fireworks there, and you can prove that you're not in Lake Superior, then I would then agree that it's not Lake Superior. How's that?
That would be easy to do too, like you said to me. Exactly. I don't know if that's I don't know how close he's Lake Superior or not. I can't tell. But I know for sure the distance between Lake Superior and Hudson Bay, you ain't going to see that from 30,000 feet. Sorry. It just won't happen. And he's even got the angles on top there, where how far it would be. And what he sees, the top, the snowy peaks, it looks like you have on the top there. He's making that seem like that, like 2,000 miles away. And those are mountains. It's high clouds.
Why would you go on the side of that instead of just using your same bendy, warpy refraction thing to just bend your vision? Is it just because it's 30 miles of curvature at that point? It's just
because
too ridiculous to even hold that still.
Do not have it. Well, that's a great question, and there's a really good answer for that. The answer is you don't have, which is key necessary for the black swan type of effect. You don't have a temperature inversion when you're flying at these altitudes ever. There's the most amount of inversion you can have between 0 and 10,000 feet. Once you're up at this altitude, no inversion. Can't happen. It's impossible. And the air is very, very thin too. There's very little air up there. So you're talking about 5, 6 psi rather than 14 psi. So
yeah, and that's why it bends so much.
No, that's not why it bends. It bends a lot less because there's less atmosphere.
Exactly. Yeah, but you're looking down through that
you can look
gradient. At some point, you might be above it, Danny.
No.
But yes, at 10,000 feet or however high you are in the plane, I will grant you that you are above this. But at some point, you are actually looking through it.
Sure. You'll be eye level, right? And that's close to this 200 miles we're talking about, and that's going to be at a 3-degree drop. But still a 3-degree drop, not a 0 drop or a 1 degree. When we look at the Black Swan, we're at near a 0 look, a 0 drop. In fact, it's actually higher than level. It's higher than level. Here, it's always going to be down. Always going to be down. You'll never be. Hold on. You'll never, ever, ever, ever see a horizon like I showed you from the HUD displays, ever anywhere near changing, let alone near eye level. It always will be below eye level. Always.
Well, you've got to work out
Because
with
there's no.
all your trigonometry
Because hold on.
all that sort of stuff.
I know. There's no temperature. You know what temperature inversion means? There has to be a very high rate of temperature inversion because light will bend to the denser medium, and the denser medium is going downward.
Well, I don't know if you have or Ruhif has all these different variables on hand to even analyze that particular picture anyway. But you have to work out with all your trigonometry and all
But
that sort of stuff.
Hold on.
I hadn't paused, so just let me finish my
Okay.
sentence,
Okay.
and then
Sure.
you can jump in, right?
Sure.
Right. At some point, you start to look through, right, these gradients. The denser these gradients get, at some point you are actually looking through them from a long distance away, and how long you are looking through these gradients, right? You can work these things out. To say that it is that you don't at all is actually incorrect, because you have that angle of incident, and that angle is getting narrower and narrower and
Yes,
narrower,
you're right.
and at some point, maybe halfway along, I don't know what the mathematics works out to be, you are starting to actually be in something that is what you say is insignificant to something that is significant.
Yeah, and as you get further away, you will start getting to the point where there'll be that increasing angle of incidence, and you'll have a density gradient that is proper for looming. However, it's below eye level, so it makes your problem worse. That means, if anything, it's higher than it should be, but it's still well below where it should be if the surface was flat. It makes your problem worse. It's like the picture I just posted regarding Mount Rainier and Mount St. Helens. You cannot have a object twice as high, twice as far away that is not in line with you. If it's below the foreground mountain, the background mountain being twice as high, then the surface has to be curved, because light would only make that problem worse. It would loom it up, if anything, but we're seeing it below. That means light has to bend upward for that to happen. It has to sink. That kind of temperature inversion is impossible. And even if it was possible, it wouldn't, even if you could have a dramatic change in temperature the wrong way, it still wouldn't matter, because it wouldn't affect the density enough to do that. The density has to change. Even though the density is related to temperature in some ways, it goes down exponentially with density, and only linearly with temperature.
And what is the light actually doing through this curved spherical density gradient?
It would be bending downward slightly.
I don't know. Have you tested this? Have you got any
Well, it's
tests?
just one of the basic principles of refraction. And yes, so I have tested it. So one of the ways I've tested it is be able to see this airport that is 200 miles away, and you see it at a 3-degree drop, and know that should be only 100 miles away. If we're using the instruments we have in the airplane, we'd say, hey, that airplane's only, based on the instruments, we only 100 miles away. But no, we know it's further because the Earth is curving.
So you have scientific experimentation to actually back up what light does in a spherical or curved density gradient.
I have it backed up even with the Black Swan, with knowing.
No, you didn't listen to my question. Obviously, I'm not talking about the Black Swan. I'm not talking about a photo. You have actual experimentation to back up what light does, right, through a curved or spherical density gradients, do you?
No, I've not compared a spherical effect to a planar effect because we don't need to. We see the effect of the spherical nature and we validate it. Hold on, we do. This is somewhat scientifically. We validate it with our altitude change. The independent variable becomes the altitude change. And with the altitude change, we'll see a position in your field of view change. And that position in your field of view change relative to how far these objects known that are away from you, that will actually tell you what the refraction is as you go up. So that's a key thing to remember. We know how far something is, not saying the horizon, just saying some object at the horizon. And we see how it changes in our field of view as we go up and down, and that will tell you what the refraction is.
So you actually have no experiment or
I do.
experimentation to back up what light does through a curved or spherical density gradient gradients. You only got what?
I told you we've done measurements with different altitudes.
No, experimentation.
That is experimentation. That is experimentation. Don't say no. Don't say it is. I've changed the independent variable. My dependent variable is. What do you mean? You can't just say no and I'm telling you I've done the experiment and I've changed the independent variable. That's part of the experiment.
What really, you've done experimentation to see how light actually performs over a curved or spherical gradient.
Yes.
You've actually done that, have you?
Yes.
Where have you done that?
Mount Baldy and Huntington Beach Pier. Yes.
So in something that you already presume is spherical.
No, we measured it. We wanted to see if it's sphered or not. If it's a spherical surface or not. We have the altitude 5,000
I'm gonna call
feet.
bullshit.
We measured the altitude above the city, which is 5,000 feet in Mount Baldy. And we look to the pier. You can see with binoculars and telescopes, see the pier. You get the angular position. All you need to do is a theodolite or any kind of rudimentary angle measuring devices. And you can see what that angle should be, 1.7 degrees. We measured 2 degrees, and that's what we measured. So why wasn't it 1.7? Why is it 0.3 degrees off? No,
You've got absolutely zero experimentation to show the difference.
I just told you I had experimentation.
Hold on, I didn't finish my sentence, Sanik. There was no comma.
But you're accusing I didn't do it.
You have got absolutely zero experimentation to show the difference what light will do in either a planar environment or a curved / spherical
Correct.
environment.
I did not do it in a planar environment.
You've got absolutely zero to back up your words or your diagrams. You've got no.
No, I told you we verified.
You can tell me all you want, Zanik, but you
of
need
course
to
I
bring
can,
the
and I will too. By the way,
experimentation to the table. Otherwise, your words are just like a hot density gradient. They just float up into the atmosphere, and they mean nothing.
Why does a hot density gradient float up in the atmosphere? Now you're just throwing words out there. So anyway, we did detect that there is curvature based on what we measured through a high altitude measurement. Yes. We also can do other tests. You can do things like at the Black Swan. That's easy to change the altitude of the measurement and see the position change of objects in the distance.
I think you're in the penalty box.
For what? What I do? He just told me I can't do it yet. I've done it. Now I can't do it for planar.
You've done it, and now you're in the box.
Okay. Well, the other way we can do this is the varying non-parallel plumb lines in Slack, and that's also something you can visit and see for yourself. And non-parallel plumb lines are only possible if the Earth is round.
You know what? You guys say you can't see so far because the Earth is curving. I say it's because the light is curving. That's it. And you can't prove either way. You have no idea what's going on.
You can, because I just told you when you're flying an airplane, you see the airport, which is 200 miles away, yet it angularly in your field of view, if the ground is flat, is only 100 miles away. It should be 100 miles away, yet it's 200 miles away. Then you know the surface is round.
You don't see the path of light.
Well, it has to do. What is it doing? We see the path of light because we see its results. We see the object in your field of view. That is the path of light. Would you agree? Okay. So if we see the path of light for an object, and we measure that object is in our field of view, and it's at 3 degrees, and we know it's 200 miles away, but we know the trigonometry tells us if it's flat, it should only be 100 miles away. How does that work?
You fly an airplane and you see it's round.
There's no reason to think that the ground is curving. So of course the light is causing that effect.
No, we already measured the
Not
light.
inductive.
See, you're missing the entire point. We're matching
You're
what
wrong,
it should.
Panic. You don't understand.
No, you don't understand. We are trying
You
to
don't
match the
understand.
Stop it! I'm talking to Jerry. We are trying to match.
Oh, you don't
our
interrupt
height.
anybody.
We know our height above the surface. We know the angle to this known airport. We know how far it is away because there's landmarks that tell us this, as well as radar and other things, and our checkpoints. So we know this.
Don't
Yet
tell me
it
to do
is
something you do to people all day long.
quiet. I'm talking
Don't
to
be
Jerry.
starting that kind of stuff with me.
Stop it. I'm talking to Jerry real quick. I'm almost done. Last sentence. So when we see the object twice as far as it should be, we know that only reason that can happen is not because light is bending, because we're already seeing what the light is doing. We're measuring it, and it doesn't comport with the trigonometry. So we know the surface is the only thing that could be changing here. That is a surface that is curved, not the light.
Zanuck, how far away is the geometric horizon in the Black Swan?
Depends on the viewer's position, and the viewer's position is not 1 foot. But if it was 1 foot, it'd be 1.22 feet, 1.22 miles rather.
What do you mean the position is not 1 foot in the Black Swan?
Well, they think that when the tide rolls up onto your feet and the bottom of the tripod gets wet, that's sea level. That's not sea level. That probably is maybe a foot or two below sea level, or above. Excuse me, above sea level.
It does also pose the question that, like, I mean, I was trying not to be an ass about it, but a few weeks back, it was playing on my mind again. Somebody said, water always finds its level. Water's always level. And I was like, I've just never seen level water. And we got into, like, the intricacies of it is a ripple on a lake level, that kind of stuff. And one of the things I ended up asking was, like, how do you, if you were to draw a diagram of the tides, can you show me that with flat water? Because if tides go up and down in even cycles, seemingly has something to do with the moon, but what do I know? Then you are drawing a curve, right? It's got to be curved. Water must be curved. Flat or round, water must be curved most of the time, right? Because you can't get from high to low and back again with straight lines. Otherwise, you've got corners. Has anybody ever seen a corner of tide? Right? It's clearly curved.
Well, if you have
that to me is like the biggest kick in the whole water's always flat and level.
And that's pretty. It's also true.
All right, if you have a swimming pool, right, and it's like, decent size, mid-sized swimming pool. Let's just say it's indoors for the moment, so we're not including extreme amounts of wind or weather. If it's, you turn off all the pumps, you turn everything off, and it is as still as it could possibly be. That is pretty darn level. It's like a massive water level, spirit level.
Yeah, I mean, it's not level on the point. Yeah, sorry, go on.
Well, just to finish my thing, if you then kind of put your hand in it, again, we have perfect kind of glass calm water. Put your hand in it and kind of start going up, down, up, down, up, down. It's going to then create, waves across the pool, maybe 6-inch waves, whatever that would be. The level is still there. The water is just not in the status of being able to measure it in terms of absolute horizontal like that, because now it's waving. But I still consider that they're like, I guess in my mind I can understand how there's still the level there. It's just that the water's in a different state. It's just not showing its actual level state because there's waves. So you now have to incorporate the wave. But I hear what you're saying. It is kind of bendy water in that way.
You got to be honest too.
And that's all I mean. Yeah, I think sure, like bathtubs, glasses, they look mostly straight. I mean, some of the intricacy I would get into with it is even then they're not straight. There appears to be a lip at the edge almost all of the time.
Got the meniscuses, the menisci, and on the edge where the surface tension.
Well, forget about the meniscus. We have two different pictures. We have two different pictures.
2006.
We have two different pictures, and we're looking at the foreground, the closest platform, 4.6 miles, in the same position with respect to each other in the two pictures, but the background platform is loomed up and down. Now, look at the horizon, look at the water. I mean, there's no hump. It's not moving. If there was some kind of shoaling or movement of the water, you would see that over time in the video. The video showed it's flat as a pancake, flat as still as you can be. And notice that the day that has the looming qualities of that day. Qualities being the water's kind of still, the air is still, you see smooth and rough.
chop, rough as it goes out. And in the one where there's no looming, where the object, where the platform is actually sunk for some reason, there's chop on the water, and it is dropped exactly the 8 inches per mile square expected position. So why would the bottom that is prime for refraction, in temperature inversion, why would that loom only not the foreground object? Why the background object? Why does it move up in your field of view? And on the other day, it's lower. So only the background was moving. What's causing that to happen?
It's wibbliness. If there was,
it's a wibbliness.
Well, I mean,
by the way, you have got to
that there's problems with, or you'd question, or particularly in video of it. Video is a really good way to see it because one of the qualities of wibbliness that we've all seen when we've seen miraging on the road is that it is like almost animated. It sort of flutters and looks super weird.
This won't show that. This will actually be, you see a little bit of the we want to call it wibbliness, jitter or whatever. You're looking at an object the next day where it's clear as day, not moving around, and is lower in your field of view, whereas the foreground object platforms are at the same height, the same position in your field of view. Why did only the rear object, the background object, why did it move up and down? That's my question.
Atmospheric conditions?
Why
make up something?
Why would it move down though?
Lensing can have that effect.
No, things in the center of the lens aren't going to change position. The same camera, same position.
Yeah,
obviously,
lensing can have that effect. It's atmospheric.
No,
conditions.
you can't. Lensing does not hide objects in the background. No.
Of course, if something
we
were below
know,
where the heat changed, then it would. Zanuck, yes, it would.
We can watch the video. You can see that object clear as day. It's right there.
My question to you is, how does this come up?
It moved. The same camera. The next day, it's lower.
How much curvature is supposed to be in 10 miles?
It's in the same field of view, same position field of view. The next day, it's lower. The foreground object is still in the same position. I showed the lines. The lines go all the way across from rooftop to rooftop. Yet the background oil rig goes down. The only reason it can go down optically, the only reason is if you have a density gradient that's going up, and that's not how atmosphere works. You cannot have a density gradient going up.
What's the curvature?
And density goes down. Density goes. You can measure.
You've got to take a breath at some point, bro. You have to.
I know you can measure that with your phone. Density always goes down.
Zanuck.
Density always goes down when you go up.
Zanuck, dude, how much curvature is there at 10 miles?
At 10 miles, probably about 60 feet, 70 feet.
And it's bringing that up. It's bringing that image up, all that amount.
The refraction would, of course.
Can I ask you, J-Dog?
When you look like to the left or to the right or something, like a mirage image is not perfect. How come we're not seeing like mirage artifacts and stuff?
Miraging is different than the looming characteristics, which are basically which are those factors which are towering. That's not miraging, or sinking, or looming, or stooping. These things are all, artifacts of refraction. Miraging is something different. That's when you start seeing things like Phantom Regatta or Inferior Mirage or Superior Mirages. Those are different. That's when you actually see objects above and in duplicity of those objects.
I just think that's quite a bit to loom up 60 feet or 80 feet or whatever. I don't
know.
No,
it's exactly, if you do ray tracing, that's exactly in the calculations.
Well, then you're going to see a change in the image. So
we do, and we do. When it's loomed up, look at
it's not going to be like that. It's going to be like a mirage or a reflection.
No, it's
reflection.
It's
even
not.
a reflection would be backwards.
No, that's not what
some kind of artifact.
You're saying that.
That's
what you're saying. You're saying that, but one of the things you see here is look at how the object is actually narrower and taller. That is a characteristic of looming. When you loom things,
I disagree. I disagree.
Really, everyone in the world that understands refraction would agree with me, and you don't. That's okay. You can have your difference of opinion. When things are loomed, they tend to stretch a little bit, and that's what we're seeing here. And you can see in the picture that when it's above and the horizon is further away, and you're seeing the object narrowed and stretched upward. That's a characteristic of looming. And that's caused by downward refraction. You can disagree all you want, but this is standard textbook reasoning and logic.
Therefore, Earth is globe.
I would tend to use the mountain. I would tend to get rid of some of the errors. Yeah, this would be enough.
Because of all of your solid logic, it's all glob.
Well, yeah. Horizon drop of 4 degrees at 47,000 feet is pretty conclusive proof in my book. That's for sure. You can't get a horizon drop.
This is all based on how you think light is working. There's nothing physical on the ground that is necessitating this curvature. You're just looking at something and then using induction and saying, "Oh, that's because the Earth is curved."
Okay, so why?
I could do the same thing and just say that
you can't.
light is curving.
No. So tell me why the horizon drops 4 degrees at 47,000 feet.
Because the light is curving.
Which way is it curving?
Upwards. From
why
you.
Would it curve? Why would it curve? Can you show me any experiment where light bends upward to a less dense medium?
No.
Okay, so it doesn't exist. You're making it up.
No, same as you.
No.
There is a GIF of that.
We know light bends down. In all cases, light bends down to the denser medium. Always.
Light
always bends to the denser. Light always bends down to the denser medium. Always.
As Banshaw said, you don't have any experiments of how light works in a spherical gradient.
Lack of evidence is not evidence.
Exactly. So I could use induction.
Exactly. Induction.
The light is curving.
The light is curving. You said it's curving. How do you make light curve upward? What mechanisms would be in place for that to happen?
Why wouldn't it?
Because light bends downward to a denser medium.
Sure, you can
makes no sense for it to bend.
Spherical environment is because I can't tell the difference between doing it inside a sphere, doing it with a sphere in the room, or doing it on a sphere. I don't understand what it'd look like. What's a spherical environment?
Go ahead, Vandy.
Oh my God! You haven't isolated anything, and you haven't put any of these so-called theories to the test, right? Zanuck will say, "Oh, you asked me a question, and I'll try and get around to answering it in a roundabout way." Okay, then I'll give it my best shot. Like Zanuck can say we can take these measurements in, outside. We can take this angle and that angle and this measurement and that measurement, and thus it works out to be curve or sphere or whatever the case may be. Right. My point is, and always will remain, that we haven't actually put to the vigor the tests of what we think light does in a spherical gradient or a curved gradient. Right? We haven't put those to the vigor at all. We can shine lights through a fish tank of sugar water, which is a planar environment, and show that it bends a particular way and acts a particular way, right? But once you affect the angle, right, of that density gradient, just a little bit, it will affect the way the light is refracted or reflected or mirrored. Right, it has to because the angle of incidence at which the light is hitting something is going to be directly affected by the angle of that thing, and we haven't put these things to the vigor whatsoever. We've only tested these things in a planar type of environment. And I've been looking to see if these things have actually been tested in a curved environment. Let's put the spherical environment.
I'm not unaware of the argument, Bandy. I've heard you make it many times. This hasn't been tested in a spherical environment. I'm not. What I'm asking you is, if I did it in a room with a hump in it, is that a spherical environment? What is a spherical environment?
No, it's not. And if you've heard the argument, you know exactly what I'm talking about then. Having the density gradient, right, itself. Right? And we're not talking about a hump in the middle of the room. We are talking about the gradient, the medium at which the light is traveling through or which we are viewing an object through. We're talking about that medium itself. And that medium that we are viewing through is curved. not necessarily spherical. It is curved, and we haven't put those to the vigor of experimentation at all.
I'm asking what curve like what? Describe to me how you make this curve.
Really?
Yeah.
Really?
Isn't
Really?
that seems to me to be a reasonable question? Is it not?
Okay. Well, just off the top of my head, which I did the other day, we could get various densities of jelly, for argument's sake, of jelly, right? And lay them on top of each other and shine lights through that, or view things through that, and see how the light is affected through these curved density gradients.
And so the jellies are laid out in a curved fashion?
Yeah.
Right. Okay. Okay. Yeah, sure. So what's wrong with the one that Zanuck posted? Because that appears that density gradient, I would think, starts at the surface of the propane tank and therefore is curved with the propane tank. And that appears to be a gradient created in a curved fashion in similar to how you're describing.
Okay, so firstly, we don't know if that gradient is completely evenly curved all the way over that propane tank. For starters, it's been poured down the middle of it like the line down a skunk, for argument's sake. All right, and it is viewing plasticine on the other side. All right. Now, all these people like Andrew Thomas Young and all these people that you want to, not necessarily you, but the royal you writing, that want to sprout as the godfathers of refraction and what refraction does and all this sort of stuff. They have words, they have lots of pictures of what they say it may or may not do, which is fine. And Kosho himself can do computer simulations of what they think it may or may not do, right? But taking it from words to diagrams to a computer simulation to actually something in real life to see if your words, diagrams, and computer simulations even slightly stack up, right? That's where everything falls short, in my opinion.
Short in what way?
Because I don't think it's been tested, obviously, writing. It has not been tested.
Who should test it?
Well, the people that want to make these claims. Why wouldn't you? Why wouldn't you actually writing? If you were a scientist making these claims about what something is doing, why wouldn't you actually want to test your theories?
Sure. Why wouldn't you want to test your theories? Is the question. I don't know whose theory this test would test except yours. This is only your theory.
I am not making claims about how light. I'm not making claims about how light does or does not perform. No, I am questioning what they know.
You're essentially saying in a curved environment this will be different. Right? Well, why haven't they tested in a curved environment is essentially saying, I'm not sure that this effect it works in a curved environment. And your question is exactly really profound. If this is their claim, why not test it? If this is your claim, why not test it?
I'm not making claims that it will or won't do anything at all. I'm just saying that if it hasn't been backed up by experimentation, all you've got is a claim. And that's where it stops. That's all you've got.
You've got is a claim, and that's where it stops. Like I don't know why somebody else would have to do your experiment. Is the bit I'm having confusion with.
Look, if you are happy writing yourself, go with what they say with actually no experimentation to back it up and go, yep, that's because they say so. That's fine. Right? You can actually accept that writing, right? That is your prerogative to actually accept that, right? It's my prerogative.
No experimentation is accurate or haven't done.
It is my prerogative to actually not accept that what they say happens. I can think that, well, you know what? I can actually see flaws because it actually hasn't been proven to be so.
Sure, yeah. I mean, I think it's entirely possible to look for flaws and feel that you found them. I think that's fine. If you feel that you found some sort of gap in the understanding of the current model. I think that's great. Like test it or challenge it, maybe, and as you're doing, encourage other people to do it. But the bit, I guess, the bit I'm confused by is I wasn't quite clear on what a curved environment is, but I'm more generally not confused by why this, like, they should have done this like this to meet my satisfaction, because the rationale for doing so is never quite clear to me, if you know what I mean. Like, they should just want to show us is mostly the answer, and it's like, well, that's not why they do science. They do science to, like, figure out how to make new jet engine parts or cure an ugly disease or something. They're not.
It is not my
Going, how can we
satisfaction.
recruit more flat earthers? Oh, I haven't seen it in a curved environment. Get onto that, jet.
Writing. They don't have to do anything to fucking satisfy me. I don't give a shit what they do at the end of the day, right? But if this was my profession, right? If this is what I was studying, right? It might be something that I'd want to follow through a little bit more. If this was what I was into, if this was my thing, all right. So you can say it's irrelevant and not important and all the other things, or I have a feeling. You can throw all that out there. I don't really care at the end of the day, right? But if I can see an obvious flaw in something that actually hasn't been put under the rigors of experimentation, I'll call it out. Now, it doesn't mean I have to go prove or disprove anything, but I'm going to identify the flaws, recognize the flaws for myself, and you guys can go along and go, yeah, but it's not really, because they don't have to do anything for you little flat earthers and blah blah blah, all this other little backhanded comments that you want to throw in, right? I don't really care at the end of the day.
I guess, yeah. I guess the purpose to me is the bit that I'm confused by. The sort of, is it to get people to do it, or is it to critique that it hasn't been done yet?
If I'm developing a new rocket engine, right? Do you think that instead of building a full blown scale size of it, that I might try and start it off in smaller stages, or if I'm building a formula, if I'm building the aerodynamics for next season's Formula One car, do you think I'd want to do that in a slightly smaller scale and test these things in a wind tunnel before I go and make radical claims about how something may or may not perform, and spend money on this and that and the other thing? Do you think I would want to actually test things and put my theory to the vigors of tests, or do you think I just go, you know what, this is what's happening, and we're just going to go with it regardless? Because I think if I was actually going to be making claims, I'd want to back up my claims with some sort of practical experimentation, if that was my field.
Right. I don't do any experiments really. I do little tests here and there, but I still make many claims in my day to day. So I don't hold people to that same standard that if they make claims, they've got to have proven it with a series of experiments to meet a variety of different requirements of them. To me, it's like, okay, that's your claim, and I'll take it with a grain of salt. And I look for flaws in it. I think looking for flaws in things is bang on. I just think for a lot of those things, like how do they test rockets? Like, my gut feeling is they do test rockets, but rockets scale very differently. You don't need gimbaled exhausts on a small rocket. You just point it roughly upwards and set off a solid rocket, and up it goes. But if you need to be able to direct it, it's got to be gimbaled. That's vastly different if you're doing it with thousands of tons. That I would be surprised if they're still like, let's get a little solid rocket. Remember the ones we used to play with when we were in school, guys, and set it off inside the vacuum chamber? I imagine they do scale some things down, but for other things, it might not scale very well. I don't like. Tell me about that. You said you built a house. Can you explain a bit about the process or the intricacies and the craftsmanship and the insight that needs to go into building a house? Because I've never done anything like that. No single achievement anywhere close to something like that.
Well, you want to do your homework before you go about it.
So you got to do your homework, as in, if you don't read up or learn certain things, you'll, I'm guessing, fuck up a bit.
Of course you'd. Or trial and error. You'll learn by your errors very, very quickly.
You're right. But you don't want to make errors with a house that you've got to live in, right? You're like, oh yeah, those stairs collapsed. I don't know what happened. What kind of errors do you make? What are the errors that you've made?
I made a couple. I made a couple of errors, but anyway, it's neither.
Go on, tell us about one. The disasters are the best stories.
Well, It was with the brickwork itself. I was trying to get a particular effect with just laying some blocks, and look, it doesn't matter what errors I made in building the house. It doesn't really make any difference whatsoever. But I made the errors and I rectified them right through trial and error, plus research as well. I learned if it wasn't my expertise, that it's probably best to either A, talk to someone, or B, read up on something to give myself, a better bank of knowledge on what I was about to undertake. I learned that very, very quickly, instead of just presuming what I thought was going to be the case, because I did presume with a couple of things, and it thankfully it wasn't they weren't costly mistakes, but nonetheless they were mistakes that were able to be rectified, which is what I did. And then I learned very, very quickly that instead of undertaking something that I had zero to little experience in before I do it, just to read a little bit more, talk to a few people, make a couple of phone calls, just to back up what I was going to proceed with, and then go for it. But you've got to arm yourself with knowledge if you're going to
Yeah, you don't want to be stumbling, I'm guessing, like just bumbling your way through it.
Not at all. You don't want to be guessing. You don't want to be guessing.
And is that down to like, because I wouldn't know the first thing, like, are all hammers virtually the same, or will you get a certain kind of hammer that if you weaken the head or something, it'll come flying? Like, I don't know. Like, is it down to like the nails you choose, or is it more macro than that? Like getting the, I don't know. Like, I don't know anything, the first thing about it. Tell me about a disaster. That's how I'll learn. Doesn't need to be your disaster. Some other fuck up somebody else made. Excuse my language.
Just look, there are plenty of disasters out there riding, right? And you soon realise when the disaster has happened, okay? And then you stop, right? You stop doing what you're doing because the disaster has happened. And then you have to undertake rectifying that disaster if you can rectify it at all. And hopefully you can. But like I said, you've got to arm yourself with knowledge, right? And this knowledge, right, has come through other people's experience, right? Other people's practical experience and experimentation of what they have done, right? It might be something as simple as a mortar mix, right? How do you mix the ratio of your mortar or your lime mix, or whatever the case may be? Well, you can guesstimate it, but thankfully there are people out there that have actually done this and experimented with the different ratios of lime, and sand and water and all this sort of stuff to get the right consistency, the right strength values, and whatnot. So it is practical for that particular application. So you go on that, right? But it has been obtained through practical experience and experimentation of some shape or form.
Yeah, so like we all do our own kind of science. We might not be as always using all the variables, but yeah, you sort of yeah, it's that experience is
And
just
yeah, and even
substitutable.
if you didn't have anyone else's experience to fall back on, say you're on a stranded island, but you happen to have available, and you need to make some concrete, right?
Yeah.
And you have cement available to you, and sand and water and these sorts of things. You can find out for yourself through experimentation what is going to work the best, right? Might take a bit of time, but you'll get to that conclusion eventually, if that's what you want to do. You want to put a concrete path in front of your hut that you've just built out of palm leaves or whatever the case may be. But thankfully we can fall back on other people's experience and knowledge with a lot of things. What you know about motorbikes riding, and how they operate and whatnot is both through other people's experience and knowledge plus your own, right? And you've built that knowledge, and you've built up that knowledge bank over a period of time. Okay, and you fall back on that, and even though you know is what you do at the moment about motorbikes, I'm sure there are probably many things that you don't know about motorbikes as well. And if you came across that situation, you know what you would do now with Google at your fingertips, you'd type into Google, bang, and you'd come up with a myriad of answers, and through your experience, you could filter through those answers and come up with the best solution or the one that seems most logical to you.
Yeah, that's the thing. Like, one of the things that sprung to mind was the moment you said you probably know a lot about motorcycles. I was like, yeah, but only compared to people who don't do motorcycles. So the moment you said some people who know more, and I was suddenly struck by a feeling that, like, you're aware of your own. It's the Dunning-Kruger, isn't it? And the Dunning-Kruger is that we all suffer Dunning-Kruger, except on the topics we're good on. Because the moment we know a bit about it, like, you've probably worked with builders or plumbers who are just like extraordinarily knowledgeable. And it is like getting better is often a process of learning how little you know. Yeah,
but how is this leading back to what we were talking about with light though?
Because I am that ignoramus that somebody else is when they talk about motorcycles. Here's one time I had a ride in London on a nice bike with a girl on the back, and the next day I was like, oh my god, it feels like I've been doing push-ups. I had like an ache in my pecs, in my boobs. And I was like, oh my goodness, that's from like riding and slowing down, right? To ride fast, you got to be able to stop quick. So you're doing a lot of stopping, and she would be pushing into my back, and so it's like I'm doing push-ups when I'm braking. And I tell this to my housemate who doesn't ride motorcycles, and he's like, that doesn't sound like a thing. And I was like, what? And he's like, well, I had a mate who rode motorcycles and he never talked about that, so I don't think that's probably not what it's from. And I'm like, it's just like, what a weird thing to think that you know about. Do you know what I mean? Like, whether I got an ache in, it was weird, but it was like, if we have this
relate this back to what we were talking about.
I don't think we're expert enough to know what light does in these kind of things. I think that if our job somewhat relied on it, I would, you know, if there was a survey here, or like when there's pilots, I perk up, but like it's when somebody on their home turf, I perk up. But when it's somebody being like, I reckon I get that from the outside, I think that's just like my mate telling me he knows why my boobs hurt.
Maybe so, right? And when it comes to light, I'm an ignoramus as well, right? And I know writing there are many articles, right, and many diagrams of how light performs, right? And I've got no problems with any of those articles or any of those diagrams or pictures, right? What I've got an issue with is that it has not been taken from the computer simulation and tested to see if it actually confirms what they are saying or what they are simulating. Period.
And what's the main claim, or what's the sort of, when it sounds like you're asking for a point of like indignance, or like they owe this to me?
They don't owe me anything. No.
So
they do not owe me anything, right?
So let me ask you then this way: what is the sort of, there's a cost benefit analysis to doing everything, including science. What's the benefit of the cost of making this spherical environment?
Well, let's just go with a curved environment, because I'm probably not going to be able to do the spherical one, right? Because we aren't talking about seeing all the way around the so-called apparent globe. That's not what we're talking about, right? We're talking about how we view things at a distance far, far away, and how light performs right through that medium far, far away. That's what we're talking about, okay? And so how this light is actually performing in a curved environment, right? I haven't seen the experimentation to back up what they are claiming it actually does.
But if they assert that they're testing it on a globe, aren't they testing it on a globe?
I do think that is kind of the answer, right? If you took globe for granted, then you wouldn't see a point for this, right? There's an important truth behind that joke, Gio. At least I think there is.
The truth is that they haven't tested their theories or their simulations. That is the truth. Well, not that I have seen.
Or that we haven't been able to find it.
Now, Chronic is looking into it, actually, because we actually had this discussion yesterday or the day before, and he thinks he may be able to come up with something. So, he's gone away to do whatever he's going to do, and maybe he'll come back with something that will actually prove me wrong, right? Or actually satisfy my curiosity, if nothing else, to see that it actually has been tested, right? Experimentally, right? And not just with words and not just with diagrams. Because to shine a light through a singular lens, right, is not the same, right, as shining a light through a curved density gradient at all. It's not the same. And it actually mystifies me a little bit too that a lot of you guys kind of just like hand wave dismiss that notion in the first place, that it hasn't been actually experimentally shown that it does something the same or the same as what we predicted.
Could do. Yeah, it's just I'm just more curious as to like what the benefit you feel for them would be, for somebody who's investing the time in doing it. Because like, as you well know, I'm not going to do it.
No.
Seems nobody here's going to do it.
Well, I would say they're going to have to, or else eventually this won't hold up.
There you go.
I don't. So is what you're saying? If they want to keep the flat Earth truth at bay, they better show us this thing in a curved environment. Is that kind of the gist of it?
I'm not saying anything about the term flat Earth. I would say the truth. Yeah. We'll just go with the truth.
And if they do show this, then they're right, and they'll keep the.
Well, if they could prove or validate a globe Earth, then I wouldn't see very many people continuing to think it's a planar Earth. No, I wouldn't think.
Would this curved light experiment prove a planar Earth to you, a globe Earth to you?
Which one?
The one Bandsaw was talking about, with the curved environment, with the density gradient and the jello and stuff to show how light works. Would that convince you?
I wouldn't say that would do too much for the shape of the Earth directly, but it would indeed give some potential insights into the nature of the claims that are being made as to how these observations work on a globe.
So there's no benefit in doing it because it's not going to convince you. You're saying they better do this, otherwise the truth's going to get out. But if they do this, that doesn't change much for you. Would that be accurate?
Well, what I would say in general is that at this point, the globe is on trial and has been. Now, we could talk about whether it's a lot of people know about it, a huge amount, small amount, whatever it is, but it still is. And it's still, so in terms of the globe claims, a lot of people, I think in our current day and age, in terms of the 1960s, 1970s, 80s, 90s, have really kind of just swallowed all the globe stuff. It really hasn't even been put on trial because everyone just kind of went with it, and NASA and JPL and rah, let's go America. So people have, so I mean, in terms of that, yeah, I mean, all of this will continue to be looked at, and when something in science or just in the world in general is not verified, that it can be gotten away with as being incorrect for some amount of time, but that can't last forever. So yeah, I
I'm
think
I'm more trying to get at the purpose for this particular experiment seems to be when I keep asking what's the benefit, right? Because if you say what's the benefit in finding a genetic component to a particular disease, we all immediately go, oh, no need to tell me what the benefit is. I already know what it is. It might be gene selection for people who might get that. You
Well,
can
here's what
explain
I would
for
say.
them. Right, I've got the advantage. I now understand why you're getting my taxpayer funding. I now understand why we should care about it when it pops up on the news, and why you get your Nobel Prizes or whatever. For this one,
Well, hold on,
I'm
let me
trying
jump
to ask, what is the advantage? And it sounds like you're simultaneously saying, well, if they want to keep this globe thing under wraps, they better, service up this curved environment thing. And then when I say, is it going to mean anything to you? The answer seems to be, well, take a look at it. We'll find it interesting, but it's not. It's not really the center point of the globe, isn't that?
That's not. Hold on. That's not what I said whatsoever. But I do want to just jump in and just finish what I was saying as well, which is, I would say these two things. If the globe Earth were to be proven, I would say the two things. One is measurement of the physical curvature. Two would be, I mean, if you had that, you wouldn't even need the optical, because at that point we would just know that the optical is somehow, because we've measured the curvature. However, if you were able to do something like Banslaw is suggesting, to actually replicate and scientifically validate how light is actually traveling through the environment, then you would have to do something like he is suggesting, especially over the curved surface. And if you could do both, then you would have it pretty close to being finalized and definitive.
Yeah, and what is being claimed, writing, is how light is behaving. All right, so all it's going to do is back up your assertions of how light is behaving. Okay,
I'm trying to be super clear about the benefit of it. That they go, ha, we told you this is the way light behaves. I don't see the benefit at the end of that. I don't see that putting somebody's name in the newspapers or earning money for funding or something like that. I'm trying to ask, what's the benefit for somebody to do this, to go to this cost? When they're making a cost benefit analysis, what are they putting in the benefit column?
When you make claims of how refraction is, all right, when you make claims that it is this, that, and the other thing, right, your claims will fall short, right, when you don't have the experimentation to back it up, because all they are hollow claims.
But we do.
But if you
There's
had,
so much
if you had,
refraction
if
is
you had,
refraction is one of the most well-known parts of optical science that there is, and so because you don't know a lot about it, it's a mystery to you, and I get that. It's always very daunting to go into a subject about it where you're not an expert or even educated on it. Now it's known how it works, and you have to use a little bit of differential calculus, a little redundant, but calculus, to understand this varying angle of incidence over a surface that has causes of a density gradient that is also curved. And you can see how that calculus can be used to show how the varying angle of incidence will cause light to bend downward toward the denser medium. And in some cases, with temperature inversion, that happens. But it's very rare. It's not really a common thing you see. You see it occasionally, not all the time.
all you got, Zanny, is calculus, which is fantastic. Right?
No, but we back the experimentations back it as well.
I am not disputing your calculus whatsoever, right? I am taking issue that you haven't taken your calculus, right, and tested it experimentally, right, to see
We have,
if it
though.
actually backs up.
But
No,
we
you
have.
not.
Of
No,
course
you
we have.
not.
Of course we have.
There is nothing close to what I am suggesting.
Really, we have okay. So we have ray tracing. We have simulation of that ray tracing based on a characteristic of the atmosphere on the water over long distances, and then we have pictures. And you know what? Those pictures match the simulation. I mean, that's about as close to an experiment as you can get.
Do you need calculus to know if the Earth is round or flat?
You don't need calculus. You can do it simply, very rudimentary techniques to determine that.
You could look at the South Celestial Pole. You don't need any calculus for that.
Right. You can just do horizon drop with altitude. That tells you Foucault pendulum tells you it's rotating. Horizon drop with altitude tells you that that's round, and it has 8 inches per mile square roundness, and it has a circumference of 25,000 miles. All these things point to one thing, and nothing can dispute that. There's not one bit of evidence that shows that it doesn't, other than the black swan, which is a crappy measurement. It's what we talk about it being scientific. Well, the black swan day is one of those where you have not controlled the control variables.
A lot of shit.
You cannot control the control variables in that one. That's not a good experiment, and it gives you erroneous output. That's what bad experiments do. They give you erroneous outputs.
Saying like, do you not just have like one piece of pie, but you eat the whole pie, or you eat like 40 pies?
I eat 40 pies.
I'm just joking, dude. But your energy is just like all output.
No,
I guess with eating 40 pies, it's all input, but somehow it just reminded me of that for some reason. Just this insatiable, constant barrage of.
Well, I guess when you go through this, as long as a lot of us here have, and to hear people that just are in denial, it's a challenge that is unlike. And I'm so motivated to not convince, but just to debate. I mean, it's just such a spirited sporting event, because people are just deny, no matter what the evidence says. No, that can't happen. So it makes you want to go deeper and deeper and deeper, so you can catch them. You want to be able to catch them, but you can't, because they always have the I don't believe you. That's not possible. You're making it up. You don't know enough.
And what would you think? What would you think if I told you that was a projection?
I'd say you're wrong, because I'm always providing evidence on demand, without objection. So no. And I don't just say it looks flat, feels flat, round, whatever. I give here's my example. Horizon drop with altitude. Boom. That's not good enough. What if we can't see through the atmosphere? Then I show you with the moon in the background. That's not good enough. I show you the sun in the background. Then I show you different types of observations with water bottles and mountains and snow-covered hills that are twice as tall, twice as far away. I mean, I keep on providing. I give and give and give, and it's never good enough. It's never going to be good enough. I know that. That's why it makes it fun. Because if it was good enough, it would end and it'd be over with, and we wouldn't have to do this every week, every day.
Sucks to be you.
That was.
You are like the gift that keeps on giving, Zanuck.
Right.
I mean, I do think the broad point is fairly fair, though, which is do you get what the general gist, even if you might not agree with it, Bandy, that it feels like it's a fairly endless string of demands to be shown X, Y, or Z.
Look, I personally have only ever asked for one thing myself, just one. I'm not interested in anyone else's claims or
They're great.
demands.
Is the only one you've asked for.
No. Damn, I think I've asked for rockets in a vacuum. Bugger you, writing.
I mean, I don't think it's that bad. Like, the point being, like, the goalpost. You would see in these.
I've asked for two.
But you would agree in these conversations generally, not specifically with you. It'll be like, we want to be shown X, and it's like, oh, here's X. 24-hour sun was a good example. We spent hours going back over that. We're all like, there's hundreds of videos in the chat, and everybody's going, I haven't seen any. It's like,
we're yet to see the 24-hour sun, but you
exactly,
digress.
This is how you're yet to see the 24-hour sun. You were the only one willing to watch it. Everybody else is like, well, I don't want to watch that. That's going to be a 24-hour sun. That'll totally ruin my model. But yeah, it's a lot. It's a fairly I think the demands that lined up with some sort of motive would make more sense. So like the flights, that is a better argument, because you go, well, they're going to want to divert. They've got a motive, so now I can go, now I can get on board. Whereas if it's just like, here's an experiment that may well exist, might be physics departments in things that don't write papers about it, but do it as a standard test specifically to show this. I don't know, and it's highly possible, even if it's not plausible. No, the other one. Yeah, they could do it. It's just, otherwise it becomes like, I want to see this. Now I want to see it in a vacuum. Now I want to see it on a Tuesday. Now I want to see it without somebody touching it, with somebody touching it, with magnets, without magnets, and even still, it could be ether. Even after we put it in a bismuth chamber, you know, like the goalposts sound like they're moving at speed of sound sometimes.
Well, at the end of the day, to get to the truth of something is not always an easy matter. But to easily accept something that's presented that may not be the truth is easy to do, but is not necessarily the most effective truth seeking.
Sure, we both think that of one another. I think that you have accepted a easy truth, and you haven't questioned it, or you haven't applied correct questioning to it. I think you have.
You know what the most difficult
probably
thing
think the
is?
same thing about me. This is a
The most
wonderful
difficult thing, do you know what I think it is?
Go for
Is
it. Tell me what you think.
human pride. Because some
Human
people
pride.
cannot admit they've been fooled, because then they would feel stupid, and they cannot take themselves there.
Yeah.
What extremes will they
That's
go
the
to?
biggest thing. Human pride.
And what extremes will they go to?
All the way down. Go down with the ship. It's in the Bible. The biggest sin is pride.
So you think, Godric, it's like if for some, and I'm not saying on anyone in particular, but you're saying it could be like an ego structure in their psyche that they just can't surrender to.
That's right, and that's why mostly men are in the argument, because men have a lot more pride than women.
On that,
yes.
I would agree. Yeah.
It's like Neo in the Matrix. No, it can't be. No. I say that to be fair to both sides. To be fair, that happens on both sides.
Yeah, but we went through stuff.
Can you name one thing?
What do you mean?
You said you went through stuff. Just name one thing. We can talk
the Earth
about.
was flat. What do you mean?
We're all intelligent.
Okay.
Can you be more specific?
I learned other truths too along the way.
Like what? Give me something to discuss.
Okay, something about I don't know. I can't think of something. 9/11.
Right, we blew ourselves up. Is that your point?
I learned about 9/11.
Did we blow ourselves up and say it was somebody else?
I don't know.
What do you think?
I don't think so.
You believe the narrative we were told that
that's silly.
We're playing for hijacks.
No.
We can't recover 4 black boxes, but we can recover the passports from each of the assailants.
Right, that fell out of the sky. Yeah. Okay.
What else you got?
What point are we getting back to?
Some topic for discussion.
So then, Godric, let me ask you this: how did it happen that, how did this system, whatever it is, it's just kind of an open question. How is it set up in a way that what they tell people is connected to their ego? How did they accomplish that?
Well, this happens whether it's a lie or not, right? Like it doesn't have to be a lie. Okay, you can just say education. Let's say someone took a class and they feel righteous. I had to take this class. I know about this stuff, and they go to the social group and they're like, yeah, I'm bad. I know about this. I'd like to talk about it, and they don't like to be proven wrong. And if they are wrong, then they're going to argue about it, and they're not going to admit that they're wrong. And this is why people have arguments, because one person doesn't want to give in, even if they are wrong. And this is the same thing with the flat Earth, round Earth. It's like a lot of pride, a lot of not too many. I mean, I don't see too many intelligent discussions. Most of them are just talking past each other because a lot of pride. How was it accomplished? It's not that it was accomplished. It's that people have so much pride they just don't want to give in. They don't want to admit they're wrong.
Okay,
It's a personal thing that happens to people, especially men.
Okay.
You know, bullheadedness, stubbornness. You know, this kind of thing, and that is taking a toll on the whole argument. It really is.
Okay, my question is, it goes like this. Okay, the flat earthers have already been through the indoctrination and all that stuff.
Yes, go on.
So that's the difference between the Globers and the flat earthers? Like, I think it's indoctrination. You're trying to say what now? What?
Right. Well, like we're all indoctrinated, right? From birth, right? All of us, right?
Okay.
For good or bad, because we were told things when we were children. Before we can critically think, we were told stuff, and we believed it because we were told by a teacher or by our parents.
Right, but later in life, like if that person is defending it out of pride, then they would be defending a globe Earth. So you know what I mean? So in terms of somebody who already doesn't think the Earth is a globe, where's the pride there? They're just getting it from just the fact that they changed their mind versus the pride of growing up with it and being taught since we were children.
To be fair, let's just change reality for a second. I'm a flat earther, right? But let's just say it was a globe. The flat earthers wouldn't want to give in because then they would have to eat their pride.
And they would have to admit that it was a globe in that case or whatever. They would have to admit that they were wrong or what in that way.
Yes, and that's not going to happen. Especially the I guess the big flat earthers, you know, and it's also the big globers, you know. They've been in it for so long, so many years, you know.
I've thought, like, how many globers do you think, like, you know, as this all comes to a head in the coming years, like, how many globers do you think are just going to leave the community once they find out? You know what I mean? Like, just never show their face again. I think about that. I wonder how many will just leave and we'll never hear from them.
I don't know that it will ever come to surface because what I think are people are really gullible and people just, you know, believe shit. And I don't think it would ever come to surface because you're always going to have this, you know, what I think is the enemy is a corrupt government. And they're always going to try to stay in control. And they're always going to push propaganda. They have the money. They print the money. It's a whole system that needs to be changed before it can really come out. So I don't know that it will come out in our lifetime. I really don't. Because we got we're at 3%? What are we at? 4%? And they call us crazy. Right? So how is it going to just one day just appear, you know?
Our media in the US has just become
government is control, is mind control. Govern your mind. Media, the television, the social media is basically a mind control device. They tell you what to think. They give you a narrative. And if you weren't paying attention, if you don't follow the narrative, you'll get banned or canceled.
Oh, that TV thing. I mean, they show black screens for a certain length of time and they relate other things to the refresh rate and they show, like, you know, military stuff after a touchdown. I mean, they do so much with our television. You could spend a college course or more.
Geo, for it to come out, I think you'd have to have Darrenism. You'd have to have Eric Dubay on Channel 2, Channel 4. You know, that's what it would take. You'd have to have... Well,
I don't think that's how it's going to come out. That's
people doing TED Talks. on flat Earth. You have to have in colleges. They would have to invade the colleges education, which I think is corrupt. We have to get in there and teach real science. How does that even work? The whole thing is hedged on this. This is why they made education. This is why they made the colleges, so they can indoctrinate people with theories and math, which they think is real.
Yeah, I mean, I guess kind of part of the question I was getting at before a little bit is, you know how so many people support this thing, the globe, whatever? How did they get that many people rooting for them? You know what I'm saying? Like when you have like a football team and everyone's like, yeah, go whatever the team name is, It's
Because
like
they control education, they control the military, they control political, they control the government,
the media,
social media, the government.
And they get everybody up on this
very prevalent
patriotism. Yeah, I was like linked in with patriotism in the military too.
Yeah, don't we just champion our own worldviews? So yeah, patriotism, football team, a moral position you might hold for your family, for sort of an idea or an ideal. Like some people go nuts for political systems and shit.
Right, I agree with you. But how did they get like almost everyone in the world? I mean, obviously there's countries and different things, but how did they get like all the major countries like all rooting for the globe? Like
The
you do,
psychology
like
of
you're in
identity.
Australia. Yeah, in Australia, in the
Look,
UK.
it's a reality, right? Like
That's a really good question.
The first question I had for Flat Earth, I was like a year and a half in before you gave me your answer, Gio. I'd been asking that question for years. Like some of why I root for it is because the first and most fundamental question that I asked is still, the giant problem for the flat Earth. Had that been explained, like yours
About
was
what?
the first explanation. When I said,
About what?
What about the Southern Cross?
Oh, okay. You're talking about that.
Yeah. What about the South Celestial Pole? And you were the first person to say maybe there's a quadrupole. Everybody else just kept being like, "Oh, why are you looking in the sky for? Don't look up there." Like, well, I want to. Thank you. They seem like objects, and you were the first person that gave an answer to it.
Well, it took me a while to figure that out as well.
I want to say that do you know who, as far as I've been checking, who does believe in the flat Earth? You can look into it. The Amish.
Oh yeah.
So look into that. But I believe that they didn't get to the Amish because they weren't a part of that society. They were their own society. So that's why they got to everybody. They got everybody that was in school or watches TV, grows up in this society. They get to everybody, basically.
Yeah, I mean, my like one answer to that is history. World War I, the sinking of the Titanic, and the establishment of the Federal Reserve, and then the Great Depression, everything that happened at that point, and then right into World War II. Right out of World War II, they had everybody so just propagandized and controlled within this kind of new scientific sort of tyrannical system. There was another word I was looking for, but like just like the entire process of what came together. And then World War II, I'm not finding the right word in my head right now for it, but and then after World War II, and then boom, then the creation of NASA. Clearly they had a position on the whole world government structure after World War II. They created the United Nations, and so all of the major, the main nations were all teamed up and buddied up. They did the Antarctic Treaty, created NASA, and then they really pushed the globe with the moon landing being the peak of it, like getting the first pictures of it. Because really, like that was the first time they ever got a picture of the globe. That was it. Was the moon landing. Before that,
1946.
People were told stuff before that, but they didn't know what they didn't know what the globe was. It was just some idea. People told them it was something.
1946.
Yeah, there was an antique globe in my house growing up that definitely predated the moon landings.
No, what I'm saying is that was the first time that humanity got what they thought was a picture of the globe Earth, and therefore
1946.
Was it in 1946? What happened in 46?
They converted a V2 for holding a camera and taking a picture of Earth.
Oh wow.
But anyways, I'm just saying, like, yeah, I mean, if you think you have a picture of the entire ball, the globe floating in space in 1946, like, send it to me. I've never heard of that. Or are you just talking about some little half curvature thing, like a little?
He said he had a
It's just a
globe in his
hemisphere.
house, a physical globe in his house, which predated 46.
Oh yeah, that's irrelevant. Yeah, I mean they had that.
Here it is. This is the first one I've found. I haven't watched it yet, but it's very short.
I'll be right back.
But it's not a whole picture. Yeah, I know this one. Right. It's just a high altitude little snippet. That's not the globe. That's not. I was talking about the whole ball.
Oh
Right. They got
Is that the
about
first ball? They never had a photo before that from a satellite, I guess.
they got about 140 degrees of the curvature of the horizon.
That's not the whole
140
globe.
degrees is a very significant portion.
That's not the glob.
It's a very curved flat Earth then.
I mean, whatever it is, but it's just a little high altitude local, little thing. But I hear what you're saying. That they claim that's what it is. But I mean, the thing is that we know in the 1800s there was a lot going on with people questioning the globe Earth on multiple levels and layers within the science at the time, all the experiments that were going on, the Bedford level, all kinds of stuff that was going on. The history is there for that. And then boom, World War I completely screwed up the world on multiple levels into the direction they wanted it. And then the Titanic situation, the establishment of the Federal Reserve, now they had more control. And then they just slowly over time started bringing in the globe model idea into the science at the time. That's why they brought in Einstein in the 1920s to really do that whole deal. So they brought in Einstein, and then the Great Depression was a huge financial reset thing, and then right into World War II. Then after World War II, they come out of that. They bring all these Nazi scientists over. They create NASA. They do the rocket thing, and then they claim that they're going to space, and the whole, the rest is kind of history. So it's really a pretty recent sort of takeover of this scientific kind of propagandized tyranny.
You actually have a very biased view of the history of the topic. In the 1800s, they were teaching the globe in all public schools, except for a very small number. It was notable in the 1800s when there was a school that was teaching flat Earth, specifically because it was unusual.
That's not my understanding whatsoever. And for you to actually believe that people back then would have believed this glob theory where they had no measurement of curvature, no measurement of movement. Nobody knew that it was in a vacuum. To think that humans were walking around in 1831 being like, I'm on a spinning ball in outer space. No way. I don't believe that for a second.
That's a problem because of the first sort of geodetic surveying that occurred in the European countries across meridians. They did actually have measure of the Earth's oblateness in the 1800s.
Who was Robotham, wasn't he? Robotham, wasn't he a famous flat earther?
Well, he started his stuff after all of the measurements were taken.
Yeah, and he's in 1865. How could he have been famous, Geo, if everybody was a flat earther back then?
I don't think he was famous. He's just somebody who stuck out because the mainstream. I mean, I think there was a lot going on with the churches. There was a full takeover. See, back then they didn't have a homogenized way. Like now they have these education acts where they homogenize all of the education. So when you get your textbook for the school in California or in Florida and these different states in different areas around the world, it's all homogenized. Back then that was not the case. There was church. There was a lot of schools that were done through this church systems. And they absolutely were not teaching any globe idea. But the globe people, the Rockefellers and all the rest of it, as they were doing their complete takeover on multiple levels, they began doing their education thing and funding and doing what they were doing and implementing that. And so, yes, certainly in that system, they were absolutely teaching heliocentrism. And the whole thing, that has led up to the schooling system now, as they say, the winner of wars are the ones who write the books and write the history.
Right. Catholic Church, the most rigorous schooling system known to exist back then, taught the globe. They fully embraced a spherical Earth.
And the suggestion is that people, the general public, got into the 1800s thinking flat Earth, and then at some stage later than the 1800s, everybody switched. And no records of that, no book burnings, just they snuck it into school. But parents and kids now
they control history. They control history.
They controlled that much history. Like your great great uncle couldn't have written about it and handed his book to his daughter. They were even sneaking into your bedroom and digging up granddad's diary. Come on, that's a bit of a stretch, guys. That within the 1800s we switched globe to flat to globe, and nobody mentions it.
Well, I mean, I
Harry,
do think that what you're saying is a complete straw man, because I just technically didn't say that. I'm not trying to call you out for it. I'm just saying that isn't what I said. But I mean, it wasn't.
What is the necessary part of that? The necessary part of saying, if you believe in the 1800s that people all were wandering around clear that they were living on a flat Earth, then what necessarily goes with that is within the last 200 years we have switched and nobody wrote about it. Or every mention of this switch in the schooling system was somehow purged.
Well, Jerry was going to say something. Go ahead, Jerry.
Yeah, I was going to say, did you know that the Bible started with like 500 books, and it was like so many books were taken out and edited, and like so many people today think that the King James Bible is the inspired word of God. Nobody even questions that.
Yeah.
17th century English.
Apocryphon, right? There's the entire Apocryphon that the Council of Nicaea kicked out. How do we
Yep.
know they didn't kick out globe books? How do we know that some of them didn't describe celestial navigation and the shape of the Earth, but they deliberately selected flat ones because that matched with the current consensus? What if there was a conspiracy, but it was just at the Council of Nicaea because it was a bunch of intelligent men in the room who were pretty much the only people who could read? Much easier time to pull off a con.
I'm just saying that it's not out of the realm of possibility.
Yeah, I'm with you, man. I think 100%. Not just possible, but probable. Like, you're going to have a small selection of people in the room and a vast selection of texts. There is no way anybody's going to select a text of those small group of men. They're going to select a text they disagree with. So you're just asking their bias. Like, they're not going to go, I think that's a terrible age of consent, but we better include it. So you're just asking a bunch of old men in the sort of dark ages almost.
Well, yeah, I mean,
moral way to be.
Like anything, they brought in a new system, and they brought it in and pushed it, and they had funding and finances, and they were genocidal, so they used the world wars to push it. I mean, if you had a school called, Riding School of Life, and you got a bunch of people together, you started creating wars and killing people and doing all that stuff, eventually Riding School of Life book would be taught in every school, if that's what you wanted to do. So in the same way, that's my understanding of it, is that the Earth just was what it was. I mean, before, when there wasn't a globe concept, that was, it was the Earth, and there was connections to spirituality and religious systems in the Bible and in different structures in the Vedic, in India, the Vedas, and everything. So they just had their understanding of just Earth, as humans have always. Well, I mean, there's slightly different conceptions on it, and then the globe idea came in, and they pushed and pushed and pushed it, and slowly did get people convinced that the new science or whatever that they were told that this Copernicus and all the rest of it, was the correct one. And they pushed it so hard. And then they simultaneously kind of brought, their religious systems in as well, the kind of fake religions.
The Vedas are real?
Like a lot of the kind of fake religion,
text.
the fake religion stuff, which is based upon the actual real thing, but they kind of did a whole takeover there too. Yeah.
Because for a long time, it is referred to the Earth as a goli. We know that, right? And a goli is how you buy opium if you want it, or sometimes also charis.
Wait, what now?
It is
For what?
also golimaro is like shoot a bullet at him, and bullets like
you just want to talk another.
Yeah, I want to talk to you
Go
about
off
the
here.
history of Hinduism.
It's good though.
Which
Go for it.
describe the Earth as a gol or a goli, which is specifically a sphere-shaped thing. There is one in the many sphere-shaped ones. I think there is one that it says could be a circle, but if I find goli Hindi or we really want Sanskrit, right? Because that's what it was written in, and it's just always sphere, sphere, sphere.
Yeah. Before we get too far from the
Hey, let me respond to
how
that.
they
Let me
taught it
respond
in
to
the
that.
previous
Let me respond
schools
to
and
that.
stuff like that. In 1866, this book here was teaching a spherical Earth. Just pointing that out.
Okay, before you get into that,
Yeah, they
eggshell.
pushed in the globe into the spirituality and religious systems that are. Yes, that's what they've done. They pushed the globe
This is
into it.
thousands of years ago is what I'm saying. The
What you're
Vedas
talking about? No.
Can you hear me?
The Vedas they call it Bhumandala. Bhumandala is the Earth system, and it is a planar system. I don't know what the Gali thing you're talking about, but it's Bhumandala, which is the
Mandala I haven't heard of. My understanding of the description in Hinduism of the earth is a gol or a goli, and that is almost always referring to a sphere.
Testing 1, 2, 3. Can you guys hear me?
So go for it, Godric.
Okay, look, eggshells. There is a concept of a sphere. Okay, and they drew pictures in the Renaissance period of spheres, but it's not the sphere you think. If you look at the picture, it's a snow globe. You live inside the sphere, and the Earth is flat. You don't live on the outside of the sphere. You live inside the sphere, like a snow globe. That's the difference. Look at the old Renaissance paintings. They do have spheres. You don't live on the outside. If you look at Atlas, who was a concept he was holding the world, look at the actual Atlas. Look at the globe sphere. It's not a sphere you live on the outside. You live on the inside. Okay, so just look into that. Okay, that's what I wanted to say.
Yeah, no, exactly. And I just posted this is the Vedic cosmology. It shows the Bhumandala, the planar Earth, just like he was saying, surrounded by the sphere. It has the layers of the ether, and there's actually a lot of complexity. That they actually have entire temples that are built like the Earth, and it's a planar Earth. They have Mount Meru at the center. The whole thing is based on a planar system.
Sure, yeah, probably got planar parts. So it looks also slightly spherical, wouldn't you say? Hemispherical?
Yeah, but yes, it's a plane inside of a sphere.
That is correct, Theo. There's something else I want to say. Like, let's say there are this black hand conspiracy, right, that are in charge of everything. Well, there could be good forces that fight for us. So maybe they can't do everything they want to do because we have, protectors. We have also people fighting for humanity, right? So you have the evil and you also have the good. So it's not just like evil always wins. Sometimes, the good wins.
Yeah, I think the good always wins in the end, but the evil can certainly cause a ruckus for a while.
Absolute power corrupts absolutely. In the old days, they had kings and queens. They rule the people. They want to stay in power. They suppress the people. They control the people. That's how they stay in power. If the people get out of control, they get over the kings and queens, and they lose power. The same thing's happening now. It has not changed. They just use different motives. I mean, the same motives, just different tools. Technology, for example.
That one I just posted is funny because it sort of like shows the original Bhumandala, but then they put some planets out there. They just put some CGI balls. See, they've kind of fused these. Like they pushed the globe in and then tried to make people think that the actual roots of their spiritual and religious systems were lost without the globe or whatever. So they kind of try to bring the globe in, which is why most people now they believe it and they think that it's somehow been validated.
There's lots that seems to stack up with it. Like as many flat earthers say, it all stacks up. It all fits so perfectly. Like, yeah, it does. The 1 degree per nautical miles measures a circumference. Like it fits that neatly. You can get R from.
But that's of your field of view. It's the circumference of your field of view.
Sure, but it also happens to measure a circumference to a ball of the given size. So if that works, then ball blah.
No, it's because the sky has a correlation to that radius value that they've hijacked and inverted.
In a way that makes it seem like you're living on a ball, yes, with a south celestial pole that you use for navigation.
Yeah, like my understanding of it geometrically, if you had, like, let's just say that we were God right now, we could absolutely just create anything we want, like any world. If you create a planar type Earth, you know, with the tides and everything, and then you envelop that within a sphere, as you know, as it were, and then that sphere is rotating, the sun, moon, and stars, and wherever that sphere ends. I mean, I'm not even getting into all that. I'm just saying in general. So then you'd have kind of that hemispherical, you know, dome, just like we have the dome of our head and our brain. But anyway, so you have your kind of dome and then the larger dome. But if it was built like that, you could, and also you have your field of view and everything, you could definitely convert that theoretically into a globe idea, meaning instead of being inside of a spinning globe, put humans on the outside of the spinning globe, and then make everything stuck to it. And then, you know, put the Mercury, Venus, you gotta, you know, especially put the sun in the middle. And, you know, by doing all that, and there is enough overlap. There is a fair amount of overlap. I don't think it's 100%, but I've often said like about 80, 85% overlaps.
Where the overlap ends actually ends at the geometry because it doesn't work geometrically.
I mean, I think without that similarity, they never would have been able to do this at all. So there has to be enough similarity for them to have even done this. To pass off enough to people who haven't really kind of fully looked into it, essentially, or done any measurements, or kind of further verified it. It's going to take us a lot of work to even verify it as well, and to absolutely get like 100% undeniable physical measurements. It's a task.
Yeah, I mean, the undeniable's the question. Could you get anything that would be undeniable?
Well, I guess anyone could deny anything, but if there was physical measurements, tangible physical measurements upon the Earth, you'd have to use some kind of profound psychological self-deception to, especially if you actually went to that site and verified it yourself. I mean, that's to the point where it's like, it's sort of like if I say my table's 10 feet long and you say, oh, I'm not sure if I believe you. It's like, okay, fine. But if you come over with a measuring tape and you measure the table's 10 feet long, like what else could you deny at that point? Like, do you think there's any possibility that if you had hundreds of people coming through your house and they're all measuring it, how many of those are going to say, you know what, that table's not 10 feet. I think it's a conspiracy, even though they came in and measured it?
Right, you guys already have a problem because you already have to deny geometry like angle side angle in order to make that flat Earth make sense. You have to deny that that is a relationship that still holds true on the surface of the Earth. Geometry, which of course is named after measuring the Earth, you guys have to deny that works on the Earth.
The geometry of what?
Can you show
Earth
us the geometry that doesn't work on a flat Earth, please?
Sure.
Azimuths between three distant locations have internal angles of greater than 180 degrees.
Can you tell me more about that? How do you show that?
That's it.
That's the nav ball in my game. It
So
measures north,
I
south,
went
east,
from-
west in
I
degrees.
went from Los Angeles to New York to Florida and made a triangle. That triangle would be more than 180 degrees. What are you saying?
You typically would only want to actually do this on three things that you can see.
Are you saying you can do it in a short local area?
Not too small. It needs at least 75 square miles to have 1 arcsecond worth of difference. It needs to be bigger than that if you want to actually have it above the error level of your instrumentation.
Okay, 70.
So
okay, listen to what you're saying. 75 square miles, and you can measure 1 arcsecond. Do you see a problem with that? How can you know that
because that's what you're supposed to be able to measure on an Earth that size.
How do you know you're measuring accurately for 75 miles? Don't you think you'd make a mistake by then? By mile 10 or
It's not
20?
75 miles in a line. 75 square miles is not a linear 75 miles.
So how do you measure it?
Say that again.
How do you measure it?
You get 3 points. You get the azimuths between the three.
And how do you do that
A
without
network of 3 points.
how do you do that without making a mistake? Without being off?
Being careful. Ideally, do the thing correctly. What do you mean, how do you not make a mistake? Don't make a mistake. That's the point.
Well, I don't see how you can verify an arc second in 75 miles. That makes no sense to me.
It's not 70. It's not a linear distance. It's an area.
So what does that mean? You mean like a 75 square miles? Is that what you're saying?
Yeah, 1 arc second for every 75 square miles.
So how long is that then? The distance
Depends on how much of precision you want. So in this first example, they've got 185 kilometers by 230 kilometers by 133 kilometers. Those are 3 distances.
And how do you measure those distances? With a protractor?
No, not with a protractor. Yeah, ideally, you would just like an odometer would do.
Like to go in the car? Start the car this direction?
Straight enough road to do it. Yeah, you could probably do it in Australia.
That'd be a good example, yeah.
And you don't think you'd be off by 1 arc second at the end?
The main goal is not the precision in the distances. The main goal is to have at least a long distance, because what you're actually going to measure over those longer distances is that the angle will be greater than 180 degrees.
I'll have to see it. I just can't imagine that. You'll have to show me it being done. I don't see how you can even.
These are the figures right here.
You're posting something?
It's the most recent. Well, it was. Let me check and see if it still is. Yeah.
When was this done?
1897.
Right. So we have current measurements of flatness. So do you have something a little more current that we can confirm?
Your current measurements of flatness don't have any measurements in
All
them.
the guys who did this are dead.
Which is the measurements of flatness? Because F equals pretty shit. What's the strongest one?
I mean, I have one, but it's 8.1 miles. It's supposed to be
Right, with a non-zero observer altitude.
19 feet curvature, 8.1 miles. The Rampion windmills, south of England. You can see the line on the water. 8.1 miles, no curvature. I can show you
with a non-zero observer altitude over a body of water of unknown temperature compared to the air above it.
I'm glad you said temperature, because we did it when it was the coolest and the driest. So we got refraction down to a minimum.
Driest doesn't reduce refraction.
Yes, because wetness does decrease the visibility.
I would love to see how that changes refraction, though.
Moisture decreases visibility. You do it when it's driest and when it's coolest, like in the morning, certain times of year. That would get refraction down to a minimum.
Okay.
That way you don't have to.
Let me just make this clear one more time, since you didn't seem to listen. Here we go. How does moistness change refraction?
It doesn't change refraction.
Okay.
Dryness, rather than moistness. Dryness increases your visibility and increases. It gives you a more accurate measurement from A to B, observable measurement from A to B.
All right. And so would it surprise you that depending on the time of day, consistently, the body of water and the air above it will be different temperatures at that same point of day on most days?
Yeah, during the days, the temperatures fluctuate. That's why you want to do it early in the morning when everything's nice and cool. If you did it
Right.
in 12
Nice
noon,
and
for
cool
example,
is nice and cool
you
air.
can't
Did
see
you
anything
happen to
past 3
actually check
miles
the
because
water?
it's so damn hot and the refraction is at a maximum like at 12 noon when the temperature heats up.
That's actually not true. It's in the early evening. But let's go to the water, because that's what I was trying to get to. Is yes, you have nice cool air. That's one thing. Did you happen to also check the water?
I don't know. I didn't do it myself. I borrowed it from people who've done it. I don't know if they checked the water. What would you find if you checked the water?
Right. Okay, so early in the morning. Let's see how this would work out. The air would still be slightly cooler than the water at that point, which would cause. No, it wouldn't. Hold on. Early in the morning. I got to work from the other direction. So in late evening, the surface cools faster than the air, so the air will be warmer and the water will be cooler. And then over the night, the air will cool.
You agree you would
And then in the morning, the air will
control.
heat up faster than the surface.
You agree you would control for optimum conditions. Get refraction down to a minimum. You agree. You can do that. Nothing's
You're not
perfect,
doing that
but you can
though.
get it
You're
down
you're
to a
you're
minimum.
not you're specifically not measuring the temperature difference between the water and the air. If you want to actually control for it, you have to measure it. But the key point I was trying to make here with this particular set of measurements, this is immune to that style of refraction. Refraction up and down isn't going to change these azimuth measurements.
This measurement you posted is ridiculous. You should never use this in an argument. The people who did this are dead. And there's no way, and here's a challenge
How
for
does
you.
that change the
There's
validity
no
of what
way
they
you
measured?
can confirm that this is not complete horseshit.
Okay.
100
Their
years ago.
measurements are
Seriously?
publicly published that you could go to the places where they very publicly listed what they are and verify that those azimuths are still accurate.
Let's verify it. Let's do that. Let's do it together. Let's go. That's what we need to do. And you're relying. You basically have a failure. You have an appeal to authority fallacy. It's all you have.
That's not an appeal to
100-year-old
authority. An
bullshit.
appeal to authority is when you appeal to a certain person just because of their credentials.
100-year-old. No, genius. It's in the name. Appeal to authority. You're appealing to something that somebody did that has a white lab coat that you trust. That's not okay.
Listen to the words I said one more time. An appeal to authority is an appeal to a person just because of their credentials.
No, it's not.
That's exactly. Jesus Christ! Don't have to make me go Google shit for you.
It's in the label. Appeal. You're appealing to authority, not. That means somebody else that has a white lab coat. That's what it's in the name of it.
Yeah, Doofus is correct. There's also the appeal to authority fallacy is when you appeal to someone who isn't an authority. But appeal to authority, like everybody does that.
Dude, listen, whatever bullshit Google puts in Google doesn't matter. What I'm saying.
Yeah, the definitions of
It's
things
in the
don't
name.
matter.
Appeal
I know.
to authority.
Jesus Christ, dude. The definitions never seem to matter.
And here's the thing. I'm challenging you to confirm it. That's all I'm doing. Let's confirm some shit someone did 100 years ago. Let's go. How do we do that? You can talk about it, what you've done, but I want to see someone really do it. And then you won't be appealing to authority. Then you can actually say, hey, I did this thing. We did this thing.
I'm already not appealing to authority, as has already been explained by the definition of appeal to authority.
I heard that the Google definition about the person has to have credentials. I heard that. Okay. That's fine. Okay. You are still appealing to an authority.
Oh my God, dude.
And by the way, you got to do better than 100 years. Come on, bro. 100 years old? 120 years old. Jesus. We have current measurements that debunk the globe. Let's do some
the current measurements that you currently have involve no controls over refraction.
I just explained to you. We did the experiment with optimal conditions, controlling for refraction to get
Right,
refraction.
and you don't actually have a measurement of the water and the air, which means
By the
you
way,
didn't control for refraction.
It is early in the morning, by the way.
Okay, great. That doesn't change what I said.
I don't personally know what the degrees of the water is to the air.
Okay, then.
But refraction
There's
is
a
down to
problem.
the minimum, so we can
Just ignore the problem.
We can
Just pretend
exclude
that problem
refraction.
doesn't exist.
We can exclude refraction.
What do you mean exclude it? You can't, as making an optical observation, exclude optics from your observation. That doesn't make any sense.
We control refraction to get it down to a minimum, and then we make observations.
You're just saying it's at a minimum. You're just saying it is. You have no idea.
I mean, nothing's perfect, right? I mean, it might be, I'm sure there's a little refraction, right? This would be fair. But you're trying to claim, or you can't actually claim. You're trying to claim, oh, it refracted exactly 19 feet, so it looked flat, but it's really curving. That's ridiculous. I can show you the pictures, but I might do it another day. I'll dig it out right now.
Right, and
here, let me
typical.
Let me show it to you because maybe somebody here cares. Hang on, so let me pull it up.
Right, typically what will often happen from flat earthers from these types of observations is they will use 8 inches per mile squared, forgetting that formula cannot be used when the observer is not at 0 feet or 0 anything altitude.
5 feet observer height.
Right. But that doesn't negate the fact that 8 inches per mile squared does not work because 5 feet is not 0 feet.
Do you have a better flat Earth? Do you have a better globe Earth measurement?
Walter Bislin's got one.
I'm not sure how much I can post in the live stream, but let me see how much this will take. I'm trying to copy and paste it with my phone. It's going to take a minute. It's a nice read. It's only about a 5-minute read, if that. I'm going to go to pick 4. Okay. Let's see if this will post. Hang on. You can say my measurements bullshit. I'm saying your measurements bullshit. I'll give you that. 120 years. Come on, bro. Oh shit! Just didn't even copy. Hang on.
The phones are not great with clipboards, unfortunately.
Yeah, it's not. It's not letting me copy. Hang on. Copy. Let me do this. To be fair, we both have to, on both sides, we have to improve our observations and our measurements. Okay, let's see. This should work now. I gotta post it like in three frames. It's not doing it. I gotta show you the pics now. Pick 1 and pick 2. And pick 2. I think you've seen this, GL. I've posted this before. And pick 3. We're just basically zooming in. It's a little other thing. Not perfect, not great, but simple, easy. The thing about this is anybody should be able to go and do this themselves. 4, 5.
That bird's straight chilling.
Yeah, I got the bird. We got the bird because that was it proves it's the same spot. Six. Seven. The truth is we can't control for a fraction 100%. That doesn't mean that you can say it does what you want it to do. 8. And of course, for you to say refraction makes it bend around a ball, of course that's going to be an unsatisfying answer, or unsatisfying explanation.
Well, I don't know if I've mentioned it to you before, but anytime we induce a gradient, any kind of gradient where the highest density is below, light bends downward through it, making distant objects appear higher.
So you say.
Oh, that's any induced gradient.
What if I ask you to show that in reality, in a natural observation, without fish tanks and sugar water?
In air, yeah. No, that's what I always bring up
That's
is air.
happening in real life.
In air, yeah.
Too long. The last part is too long. We're gonna go with how many characters can I get?
2000, I think.
I think I have to delete this whole thing. Oh, I see. It was 137, too many.
Or you know what? It would actually been probably a lot better and less clutter if you posted where this is actually coming from.
The government would never. Hang on. Give me a second.
Oh, and of course they used the least functional curvature calculator possible.
Well, that's what I said. You better provide a better one.
Yeah, Walter Bislin's got a better one.
Walter Bislin, huh? All right, red flag's already going up.
Why?
The guy's full of shit.
Well, the code is open source. It should be able to stand on its own as code. regardless of who wrote it, the code is still the code.
Try this. Okay, got the radius. Let's give it a fair read. It's real simple. Build your arguments. What do you have against the Earth curve calculator? It's a parabola. Right. Maybe next time I do this on my computer.
Yeah.
Let's go on a little bit left. Let's see. So what kind of temperature do you want to minimize refraction? The same temperature as air?
Yeah, the air and the water should be about the same temperature if at all possible. But that's, that's a nebulous area. It's right around, like 10 a.m. local time or something like that. It depends on the day, depends on the time of year.
So that's the remainder of it. Earth is life. 15 miles. What is it showing me? The bottom's hidden.
Yeah, basically the buildings are up close, and then he looks at them from far away. The bottoms are gone.
He basically just spam posts the same stuff almost daily. But yeah, he thinks that that's Earth curve, I think is. And he'll post this one, yeah.
The water is in the way.
He thinks that's Earth curve as well.
I think part of what's happening is like sea mist.
That's not sea mist in the way. That's the ocean.
The atmosphere is thickest at the surface, and that begins to occlude distant objects. I mean, that would make sense. Even on your
No, that's not the atmosphere that's in the way. That's the ocean that's in the way.
Well, the bottom of the waves would lap up and start covering the objects that are more distant. That makes
if you're 6 feet tall and the waves are 6 feet tall, then the most that the distant objects can be occluded is 6 feet.
No.
Why not?
Because you're forgetting that distant objects vanish on a flat plane. Distant objects vanish into the horizon. They mesh with the horizon on a flat plane.
So the waves are not a good excuse then.
Meshing with the horizon means the bottom comes up as your ability to resolve the objects. As that diminishes, the bottom comes up.
The amount of
includes the object.
Right, the surface details visible on the distant objects are smaller than the amount of the object hidden. So the angular resolution is not going to cut it.
Smaller and shorter on the bottom, yes.
Right, but the details that are visible are smaller than the amount that's not visible. We can clearly resolve angles that are smaller than the amount that's hidden.
Smaller, and the object diminishes from the bottom, not from the top, from the bottom.
Right, but it's not angular resolution. That one can be thrown out too.
Well, I think you're saying that. let's use common logic, right? Take street lamps, right? Line them up and just, let's say 3 blocks or 4 blocks. With no curvature in 4 blocks, we agree, 5 blocks, right? What angle do the top of those street lamps head towards? They head towards the earth, yes?
Right. And it all shrinks equally.
And what's the logical conclusion of those street lamps? They're going to go right into the horizon, they're going to vanish.
They're going to shrink equally in all dimensions to a point before they, yeah. But
And
they
the
don't do that.
And the bottom will vanish first because that meshes with the horizon, with the earth, with things in the way. And this, you can use water, earth, cement, whatever. Not the
Right, but
top.
not due to perspective.
The top is not occluded. The bottom is occluded because that's where the objects they mesh with it meshes with the ground or the horizon.
Right, but then that's not perspective. Now you have another cause. What's that cause?
That's perspective.
Perspective doesn't cause an obstruction or meshing. That's not in the definition of perspective.
Let's say we use an example of 6 blocks, a half a mile. So we know half a mile is not much curvature. Okay, not enough for street lamps to vanish into the ground, right? But they are. Okay, and you're saying it's not perspective. Okay, I'm saying the things on the ground are occluding the things on the ground that are in front of the street lamps are occluding the street lamps, and you'll start to see them diminish from the bottom up.
Right, but then it's not flat.
I think that's what happens.
Right, but then that's not
You know
flat.
how you can prove it? Can I tell you? Because you can do it. You can see this happening within 6 blocks, where your globe doesn't get a chance to have its curve yet. That's how you know it's true. You can call it anything. You can call it whatever you want. Resolution, perspective. Make up your own fancy sciencey word for it. The thing's vanishing from the bottom.
But what's the cause?
When you get a chance to make your own observations, I want you to remember what I said, because you're going to see this, and then you're going to have to, I don't know, figure out why it's happening. Even though you're taller than, let's say, a car. Let's say a standing car is what, 4 feet, 4.5 feet. You're taller than that car, but guess what? When it gets to the point where the horizon is meshing with the object, because you're losing the ability to resolve it optically, that car or those things in front are meshing and covering those distant objects, in this case, street lamps. And if you zoom in, right, is this Doofus?
Yeah.
Doofus. If you zoom in with like P900, what happens? Oh, you can see it again. So it's really just optical.
We don't actually have footage that exists where an object that is partially occluded by the horizon is zoomed in on, and the amount that we see by proportion is more revealed. That footage does not exist.
You can do it in 6 blocks.
You can't. That footage.
And now,
if you had that kind of footage, that would be killer. Why don't you go ahead and get it?
You know how I gave you a challenge to get something that's not 120-year-old bullshit, to do it yourself without appealing to authority? I'm going to challenge myself to get you, if you think that's so important, doesn't exist, to show you within 6 blocks, objects meshing into the horizon. Visibly, with your optics, then you can use, I don't know, binoculars, and you can use P900. We can do 3 separate observations. And you will see that they do vanish into the ground bottom up.
Right, but you're suggesting that zoom brings them back.
We already discussed it. It's within 6 blocks. There's not enough room for your Earth to start curving. You agree to that, yes? So it's not Earth curve. Okay. So you have to explain what's happening if I can bring these objects back after we've lost their resolution.
Right, so if it's not the amount of zoom employed, we can throw that one out too. We're already whittling down these excuses one at a time. Angular resolution won't cut it because we can resolve smaller details than the amount obscured. Zoom won't cut it because we don't have footage where that actually happens. There's a myriad of excuses that have been presented by Flat Earth up until this point. None of them pan out.
You're just saying that.
I don't have any footage. There's no
Did you,
footage where if you zoom in on something, the proportion of it that is obscured does not change. It doesn't exist.
Did you see the sun that had been set? It popped up over the water when you zoomed in. You saw that one, right?
It was the glare. I mean, if we want to
Okay.
use the sun, you
This
have to
is
use a
good.
solar filter.
This is good. This is good. It's glare, right? Here's the thing. It's all optical, doofus. It's all optical.
Right.
So
Nope.
you can say you're gonna get a glare. You're gonna get refraction. No, I won't say refraction. I just say that this an object start to be unresolvable optically.
Here, hold on. Just look real quick at the last thing I posted.
Yeah.
Glare is not really a complicated thing to deal with.
Is this you?
No.
It's a TikTok.
The size of the sun is not really something you can go by unless you have a solar filter.
I don't believe that solar filter.
What?
All they're doing, that guy doesn't know what he's talking about. All that he's doing is taking a light object, let's say the sun, and he's putting a filter on it, which is filtering the light, but no determination of the sun's actual size. That little dot that he has is you're just taking a lot of light and you're cutting out most of the light, but there's no way to determine if that's the actual volume of the sun without the light. So
That's what the solar filter is made for, is for you to look at the sun.
Right, if it's made so it's made for that, so that means it's true, it works, right? You can make something and not know what the hell you're doing with it.
Right? You can look at the sun directly with that filter and observe surface details on the sun.
Yeah, but that doesn't mean the sun is that small, or that doesn't mean that you're removing the light and you're just looking at what's left. That's where you're making your error.
No, that's not an error. If you can see surface details moving across the sun, you're looking at the sun. That's what the sun is, and that's how small it is.
No, it's not.
Why not? It's
Because
not CGI. The filter
all a
doesn't have a
filter
computer
is-
in it. It's not some
all
made
a
up
filter
bullshit. It's
does
just a
is it
filter.
filters out shit. All a filter does, it filters out shit. That's all it does.
Right.
I
glare.
Well, to be fair, I've never used a solar filter. But if you looked at a person through the filter, would they be the same size?
Yes.
So if you show me that, then maybe I'll believe it. I have to see it. Anyways, why did you show me that? By the way, you were trying to show me a filter.
Well, you brought up the sun supposedly being separated from the horizon as you zoomed in on it. The problem is that while a person is zoomed out, that's not actually the size of the sun. That's glare.
Okay, but see, here's where you're wrong. Listen to what I'm saying. The glare is the object meshing with the horizon. Okay.
It's bigger.
If you use a solar
Before they
filter,
zoomed in, the sun is bigger.
yes. If they use a correct solar filter, it would take longer and it would take longer or more distant for the object to mesh with the horizon. Because of that glare, the glare would be gone, right? It doesn't prove it's not meshing with the horizon. It just takes out some of the glare, some of the refraction, so you can see it better.
Not some of the refraction. Don't get
Right, it's
weird
like
with it
zooming in
now.
with the P900. You can see it better. That's all.
And when you're
the
zooming
glare
in with the
of the sun-
P900, you're reducing the light input into the lens or into the sensor.
The glare of the sun is an example of what happens to everything at a distance. It meshes into the horizon. That's all.
Right. Except when he's zoomed out, That's when the light coming into the sensor is the most. When he zooms in, the amount of light from the sun is reduced, so the glare is
Well,
reduced,
to be fair,
which shrinks the sun and makes it appear to rise up from the horizon. But that's not actually occurring.
you actually said it. It appears it's optical, doofus. It's just optical.
Great, so then we can throw out the example of the sun apparently being raised up from the horizon, since that's not what was actually occurring.
It is happening because it's optical. We
Oh, for
optically see.
God's sakes, dude.
Yeah, if you were if you were close to these street lights, they wouldn't be falling into the ground. It's an optical thing that's happening where they fall into the ground. You lose sight of them from the bottom up. They fall on the ground before the Earth can start curving to cover them up. So we have to do these observations within 1 mile, and then that would hopefully prove something. And then if I was right, you'd have to rethink your I don't know, your answers or your reason why it's not happening for you. It's right. Yeah, the object is not actually measured into the horizon. It's not actually falling into the ground. It's an optical thing. It looks that way, right? And I do believe you can get a P900. If you zoom in, you'll see not perfect, but more of it. You see more of it you can with the naked eye. You agree with that
Okay.
about that, right?
So far,
You see
to date,
more
that
with
footage
the
does not
P900
exist.
than you can see with the naked eye. We do agree on that.
Right. To date, that footage does not exist.
Oh boy.
It's never been presented.
I'm just asking a logical question. You can see more with a P900 than you can with the naked eye. Yes or no?
Proportionally, no. You wouldn't see more because that's never been demonstrated. You can see finer
Here's
details on
where,
the stuff that you can see. You can see finer details on the stuff that you can see, but proportionally, you cannot see more of a distant object.
doofus, I can put a Lego on the ground from one side of your high school gymnasium, basketball court. You can't
Basketball
put your head.
courts are typically made for drainage.
Hang on.
They're
Put your head on the
typically
ground.
not flat. Right. They're
Put your head
typically not
on the
flat.
ground.
Your example already sucks.
Hang on. Put your head on the ground. You can't see it.
Right. They're typically basketball courts are typically not perfectly flat. They're made for drainage.
What if, doofus, you put a P900 or a nice camera and you zoomed in and you could see the Lego? Then what? Then I'd be right? Then it wouldn't be drainage. It would be Godric was right. You can't see it with your naked eye, but you can see it with the P900.
Right. That'd be great. That
Lego
footage does not exist.
across the high school gymnasium basketball court.
Right. That'd be great.
I'm giving you an
That footage does not exist.
where I'm trying to challenge your example you just told me. It doesn't exist.
Okay.
Well, I'm gonna have to make some measurements then. I mean, yeah, tell me you're gonna have to explain it then. The whole point of that sun rising when you zoom in is it was glare, but that's what you see at a distance. You see glare at a distance. That's how it looks. That's the whole point. The objects aren't actually falling into the ground. They appear that way because of the potential of your optics. That's why. That's why you can see farther with binoculars. You know what? You got to rework your answer because you're kind of saying that binoculars don't work. This place does not exist. It's kind of what you're saying.
I'm not saying binoculars don't work. I'm just saying
Explain
that
it,
the proportions of the distant objects don't change.
doofus. What if you can't even see the object with your naked eye, but you can see it with binoculars? Then what happened?
Right. Then the proportions still didn't change.
It went from not seeing it to seeing it. That's not a change. It went from not seeing it with your naked eye to seeing it. Let's say looking at a lady in the window across the way. Can't see it with your naked eye. Oh, look, binoculars, I can see her now. The proportions have changed. Not in real life, optically.
Right, that's not how proportions work, because if you can't see it, there are no proportions. As soon as you begin seeing it, you have the entire object in view. And then if you see it in more detail, you still have the entire object in view. So the proportion did not change.
Difference. You're looking across the way at a lady in the window. Okay, here's the thing. But with your naked eye, you can't see it. Okay, this. Let's just say this is the fact. But
Right, there's no proportion when you can't see the object.
this is what I'm talking about. You're going from seeing something to not seeing something because of a zoom in or an increase in optics from binoculars or from P900. And this
What
is what
does
happens.
proportion mean to you, dude? All right, hold on. Let's make it very simple. If I can see half of a distant object, the proportion is 1/2. One part I can see, the other part I can't see, 2 parts total. So 1/2. If the entire object is invisible, there's no proportion or 0.
So the proportions have changed.
No, because there's nothing to compare to. You can't see the thing. And as soon as you see it, the very first instance that you do see it, the entire thing is there, and you keep zooming in on this thing, and it's still all there. The proportion doesn't change.
Okay. Well, it's getting late. We made a few points. I really want you to consider that this 120-year-old document is just you need to prove that. That's what you need to do. You need to actually be able to do it or get someone that can do it. You can watch them. Because this is what we're challenging.
The evidence presented would need to be falsified, essentially, if I was actually going to go by the way that
because
the
it was
rules
never
would
true
actually
to
make
begin
sense.
with. It was never true to begin with. Period.
Well, that's your claim.
You're just saying shit. Oh, it just makes a triangle. Yeah, this was done. Look, it's posted. Someone did it. Come on, dude.
The methodologies, the equipment, and the entire workup for this particular set of observations are published publicly.
Methodology. It was fucking. I can publish the thing about Bigfoot, dude. I can put a whole chapter on methodology.
Right, you wouldn't,
challenging
because that's not how that works.
I'm challenging what you submit.
Analogy.
I'm challenging what you submit and saying that there's. I don't want to. You know how I feel about it. You need to confirm it. I mean, I would try to falsify it, but honestly, I don't know how to do that. That's why I kept asking you. I don't know how to do arc seconds over 75 miles, or what you say, 75 square miles. And then you don't know how to do that.
Second per 75 square miles.
Without knowing how to do that myself, it would make sense that the margin of error is much more than an arc second. That's what I would just guess.
Devices used in this particular case had sub-arc second accuracy.
Oh, the accuracy is sub-arc second. It's
right.
Do you see the problems we're having with this?
No, because that's the accuracy of the tool.
Why? It's the tool. The tool proves reality, right?
The tool measures reality.
Right.
Don't say tools are not a valid thing to use.
But a real person has to observe it. A real person has to determine what the tool is doing.
Okay.
A real person can lie, they can make a mistake, or they can make an error. And all I'm asking you to do is you need to confirm it. Don't just say shit. This happened 10, 20 years ago. There's the tools, the methodology, bro, was so crystal. Before I was born, it wasn't there. But shit, at least we're doing measurements when people are there, like current measurements. You can't use that. I'm just trying to help you out. You cannot use that 120-year-old bullshit. Come on, bro.
I mean, you don't like it, so I can't use it. I got it.
I want you to get out there yourself. Let's both go out there and try to do a triangle and however many square miles you need. And that would be much more meaningful to me than just some old paper document. Basically, you're saying, what you're saying is, hey, look, someone did this, so it's true. That's all you're saying. There's methodology, there's tools. Listen to me. There's tools, man. The tools are sub seconds. You have never touched that tool that they used. You were not there. Can't confirm it. You heard a story, which is okay. I mean, honestly, like we learned about this shit in school. Someone did it. They found America. They found, Captain Cook. We weren't there. We had shit. They could have made that story up. I just want to confirm it. That's all. That's why I really know if that really happened. Some stuff is hard to confirm. Okay, meaningful discussion. Gotta go. Good night.
Yeah, good night.
Thank you.